and welcome to the Python full course, your step-by-step guide to learning one of the world's most popular and powerful programming languages. This course begins with the fundamentals including Python syntax, variables, data types and control structures, and gradually progresses to more advanced topics including functions, object-oriented programming, file handling and working with libraries. You will also explore how Python is utilized in various fields including web development, data science, machine learning and automation. Whether you're new to coding or looking to sharpen your skills, this course will give you the hands-on experience and practical knowledge needed to write clean, efficient Python code. So before we get started, please like, share and subscribe to Edureka's YouTube channel and hit the bell icon to stay updated on the latest content from Edureka. Also, check out Edureka's Python Developer Masters program designed by industry experts and helps you build deep expertise in Python and its powerful libraries. Through hands-on projects, you will develop practical skills in data science, machine learning, deep learning and natural language processing. This program offers you the opportunity to upskill, advance your career and unlock new possibilities. So enroll today and take the next step towards success. So check out the course link given in the description box below. So now let's get started with our first topic, that is Introduction to Python.
Python has been ranked the #1 programming language in TOP Index and has been used by some of the largest companies in the tech industry like Pinterest, Spotify, YouTube, Instagram, etc. So you looking to learn Python might just be the best decision you've ever made. What is Python? Python is an easy-to-learn, powerful programming language. It has efficient, high-level data structures and a simple but effective approach to object-oriented programming. Python's elegant syntax and dynamic typing, together with its interpreted nature, make it an ideal language for scripting and rapid application development in many areas on most platforms. And with that, we can see why we use Python, right? The #1 point would be the applications. Python is a very versatile programming language ranging from application development to web design, game design, UI/UX development, data science, machine learning, automation, etc. There's also the point of simplified syntax. If you usually work with languages like Java, C++, etc., you'll get me. Python is one of the simplest languages you can learn, and this fact doesn't impact any of the features. It is just as good as all the other options that you have, and the only thing is it's a lot simpler. The third point is well-built packages. Now don't worry if you don't know what packages are. I'll cover that later. The only thing that you need to know right now is that packages have the ability to replace hundreds of lines of code with just a single line of code. I'll show you how to do that later in this video. And the fourth point that I want to stress on is the highly supportive community. Look, I get it. Programming is not always easy and you get stuck sometimes. But with Python's community, you get a lot of support for the issues that you face, and I'm telling you, it's one of the most engaging and interactive communities that I've ever come across.
Now let's get started with the Python installation. So first let's go to Google and type Python download. Over here click on the first link and you can see the download option there as well as the latest version 3.12.4 for Windows. Just click on download and below are the options on whether you should download it for Linux, Mac or others. And once it's downloaded, click on it and you will be able to install Python and the version. And over here, you will have to click on the option which are user admin and add the Python path. And then click on customize installation. And over here, just check if all the check boxes are clicked and then click on next. And over here in advanced option, just make sure the install Python 3.12 for all users are clicked. And this is your location. Then click on install. And then the setup process will start. So let's wait for it. Now that your Python installation is successful. And now if you want to check, you need to open the command prompt. So just search for the command prompt. And over here, let's type the Python version. So Python -version and click enter. And as you can see the screen, you will get the version of Python displayed. So now let's move on to download PyCharm in Windows and how to run a simple Hello World Python program in our PyCharm IDE. So let us get started. Just go to Chrome and type PyCharm download. And over here, just click on the first link. So now we are on the official site of JetBrains. So there will be an option below like to install it for Windows, Mac and Linux. So as we have Windows, let's download it for Windows. And you can see it is for PyCharm Professional, but it is a paid version. So if you scroll down, you will see a PyCharm Community Edition. So we will download this as it is an open source. So just click on the download button and the download will start. And let's wait for it to download. So once it's downloaded, just double click on it and open it. So now let's do our PyCharm setup. Over here, click next and it will show the installation location and keep the same location as it requires 1.7 GB space. Then click next and you will have an option to create a desktop shortcut. So click on that and click on the update content menu too so that you can open any folder as a project. Then make sure to click on Py and the updated path version. Then click on next and you will get the start menu folder. So there you can see the installation. So click on that and after completing the PyCharm setup, the setup will begin. As you can see the screen, the setup is completed. So just click on finish. So now let's search for PyCharm and connect Python with PyCharm. So open PyCharm and you will get an option below as I confirm. So click on that and continue and then you will get data sharing. Then click on send and then the PyCharm will open for the first time and you can see projects. So click on the new project and if you want to change the name of the project, you can change it in the location bar now. So let's name it as a new project. And over here, we will set the environment. So for that, select the virtual environment and then in the base Python, you will get the Python version to check if you have the new version. If not, click on the three dots and go to the program file where you have saved Python. Click on that and then you can see python.exe file. So just click on that and click OK. Now you can see that you have connected Python with PyCharm. So then click on create. As you can see the screen, now you can see the project. So click here for the menu and then you can see our project and the environment. Now we can run our first Python program. And over here, right click on the new project and go to new and select Python file directly. Now it will take you a while to file an extension. And over here, just give a name as a demo and go to Python file and press enter. And you can see it's saved as a demo.py. Now you can directly run your first project. So let's print hello world program. So simply type print function and inside the double quote, just type hello world. And let's run the code. Go over here and just click on it. And as you can see the screen, the hello world is printed successfully. Now let's move on to print some numbers. So just type print and give any random number like 2, 4, 6. So let's run it. So as you can see, the numbers have printed successfully on the screen. Now let's take up a simple program. So now let's print a floating point number. So just type print and give a floating point number that is 3.14. So let's run it. So as you can see, it's printed successfully. Hope you all have got an idea on how to install Python and PyCharm by now and running your first Hello World program.
So first of all, let me just give you a brief overview about how we use it and how it has come into existence. So Python programming language is one of the most popular language. Much of the popularity has been through the data science application that it comes with, the implementations using machine learning and artificial intelligence. It was founded in late 1980s by Guido von Rossum, and Python is a high-level interpreted language which can be used for both procedural and object-oriented programming language. So first we are going to talk about the variables, guys. And variables are nothing but exactly the same as any other programming language. If you have worked on any programming language like Java or C++, so a variable basically is storing a value that may change in the future, which the name also suggests, guys. So let's try to understand variable using an example. Let's say, so I have certain commodity, let's say, which keeps changing because for that, let's put the commodity as a bunch of apples I have at home. So I'm going to use a variable, let's say apple, and it is basically storing the values of how many apples I have. So after each step, we'll take these steps as the steps of the execution of a program similar. So let's say in 1 hour, I'm eating one apple and I have 24, 25 apples. So the variable that I have put the value in is kept changing for 24 hours. But it's not necessarily true that I will be only eating the apples. I might add value to that variable as well. So this is just a simple example, guys. I'm just storing a particular value inside a variable. Not necessarily the apple one. We can think of a complex one as well. So let's say a bank account, like how money keeps coming in and coming out. But account balance can be that variable which stores the value of how much money you have in your account. That is also one variable, guys. So let's take it up to Jupyter Notebook, guys, and we'll see how we can work with variables in Python. So I'm going to show you how you can declare a variable and discuss a few naming conventions. Rename this. And just to be clear, guys, this is beginner's tutorial. So if you already know how these basic concepts work, you can move further in the video where I have discussed exception handling, and there are file handling concepts and multi-threading, classes and objects as well. All right, so the very first thing, let's take a variable. Okay, we are going to use variable only. So this is my variable. I'm using this is equal to sign. We're going to discuss this in about a minute, guys. So I'm giving it some value, and I'm using these inverted commas also, so I'll talk about this as well. So this is how simply I have given the variable name. Now I can use a method. This is a predefined print method that I can use to return the value. So this is how we get the value from the variable. We are using this print method. Method is basically a function. I will discuss this as well. And so let's talk about naming convention. So naming conventions are nothing but certain rules that you have to follow while declaring a variable. So these are some of the conventions that you should follow to write clean code, right? So the very first rule or convention that you have to follow is the variable name cannot start with a number, right? So it can only start with a character and underscore letter. So I'll just show you guys. So let's say if I want to write it like this and give it some value, I have a syntax error which says invalid syntax, because this is written in the naming convention. You cannot declare a variable like this. All right, so let's try with an underscore and we're good to go. Double underscore, we are also good to go. Any other symbol? All right, so we will have a syntax error. All right, guys, after this, the second convention is variables in Python are case sensitive, which means is if I have a variable like this, which is starting from an uppercase letter V, and we have this variable which starts from a lowercase letter v, what happens is these are two different variables, guys. All right, so I'll just change this value so that we have a clear picture. So I have variable which is giving me the output some value, and now if I write uppercase letter V, I have different variable, guys. So which means variables in Python are case sensitive. So this also you should always remember, because while declaring a variable, sometimes you might miss these certain points while declaring a variable. Let's say you start with uppercase letter, and then again when you're calling that variable, you might not remember that you have basically declared the variable with a uppercase letter or lowercase letters. That you should always keep in mind while writing the code. And after that, there is one more convention, which is they can only contain alphanumeric characters and underscores. All right, so we have variable. If I write it as this, it's good. If I write it as this, it's good. We have a syntax error, guys. So alphanumeric characters only we can use. And after that, there is also one more rule which says no special characters are allowed. So this is all about variables, guys, and I've told you about the naming conventions as well. So now what we'll do here is we will talk about operators in Python, guys. And so operators in Python are used in order to perform a task between variables or any two values, or it could be one value as well. So depending on the operation, that the output will vary, and depending on the operation also, we are going to use specific operators. There are different types of operators in Python that we have. So let's talk about those operators, guys. First of all, we have assignment operators, which is basically used to assign some value, just giving an assignment to any variable or any value. So when I say variable is equal to some value, I'm actually using an assignment operator, guys, which is basically because I'm using this particular operator, assign a value to a variable. So that is how it works, the assignment operators. Let's say I'm taking a variable value 1 over here. So if I write variable is equal to variable plus 1, this I think most of you must be aware if you have come from programming background. So I can write this particular sentence because variable will now become 2. So instead of using this, I can write it as plus is equal to, and it will give us the same value, guys. The whole program, it will give us the value 3. Now if I run it again, and this will become 4. So similarly, this is for addition, for subtraction, for division, for multiplication, for floor division, and all those operators that we can use. So alright guys, so the next in line is the arithmetic operators. So the very first one is, get any operations running, arithmetic operations. So the first one is very easy, guys. We can write 10 addition, two numbers, and a is equal to 12. And instead of addition, we can do subtraction, and instead of subtraction, we can do division. So just look at the difference, guys. Now when I do the floor division, we do not have a float value. So that is the difference between division and floor division. And we can multiply, do the multiplication using asterisk, and if I use double asterisk, it will give me the exponentiation of 10 to the power 2. And yeah, these are all the arithmetic operations for now as a beginner, these aware of. After that, there are operators like comparison operators, which are basically used to compare two values. And then we have logical and, or, and not. So these I will discuss when I am talking about the conditional statements, because these two operators are basically used there only if we have to establish a point we are comparing to the program. Okay, so we'll discuss that, these two operators there. And then we have membership and identity operators also, which are used to check if the object is same for identity operator, and the membership operators are basically used to check if particular data type is actually present in an object or not, or the object is present in another object or not. That is how it works. And bitwise operator is again same. We have bitwise and, or, and not. So talking about the bitwise and operator, it basically sets each bit to 1 if both the bits are 1, which basically means that if both the bits are true, then the answer would be true as well. If one of them is false, then the answer would be still true if you're using the bitwise or operator. And let's say if we have one of the bit is 1 when one of the bit is 0, which means one of the bit is true and one of the bit is false, then it will basically change all the bits to 1 only. And similarly for not, basically inverts all the bits, which means if the answer is true, it will change it to false. If the answer is false, it will change it true. And then we have the zero fill left shift and signed right shift. So in the zero fill left shift, the bits are shift left by pushing zeros in from the right, and let the leftmost bits fall off. And for the signed right shift, the shift right is happening by pushing copies of the leftmost bits in from the left and let the rightmost bits fall off. Basically looks like something like this, the left shift and right shift. If I want to basically do the left shift on 10 by 2 places, the answer would be 40. And if I do the right shift, the answer would become 2. So now that we have also discussed the operators and we have established how we work with variables and operators, let's move a little ahead and talk about various data types that we have in Python. Alright guys, so collections in Python basically are some of the data types that we're going to discuss. Before that, I'm just going to discuss integers and strings for a while. So integers are just numbers, guys. So any number or numerical value is considered as a number data type or numerical data type. It could be an integer, it could be a float value, it could be a boolean, or it could be a complex number as well. Strings are a data type in Python where we store the values with alphabetical values, and we enclose them in single inverted commas or double inverted commas. And they're basically the same also. We do not have any distinction between a single inverted comma or a double inverted comma. And yes, I have shown you like how we can declare a variable, guys. So this is how I declare a variable. Let's say yes, so this variable is I can check the type of the variable. So this will show me that this is a string data type. And similarly, if I have another variable, which has some integer value. I can check the type of the variable again, and it will show me that it's a integer variable. Right, so this is all about integer and strings. So the next data type that we have is a list in Python, which is basically declared in square brackets, mutable. So a collection in Python is basically, a container data type. Namely, we have list, sets, tuples, and dictionary, and they have different characteristics based on how we declare them and how we use them. So coming back to list again, it is mutable in nature, which means you can change them, unlike strings. So strings are immutable in nature, guys. So let's say if I have a name is equal to a scene. So if I want to access some values, I can use the indexing, guys. All right. So indexing is nothing but, the index values that we have over here. So I'll just explain what indexing in strings is. So basically, if I write name and in the square brackets, I've written 2 over here. So the index value is 2, which I want to access. And at index number 2, we have the third alphabet from the string. So which means is the indexing order is starting from 0 and going until the end of the string. So this is how we use strings. So if I want to reassign the value at index number 2, if I write instead of S, I want to write a capital S. So it says type error, which is saying that string object does not support item assignment. So basically it's immutable in nature. But in the case of list, I'll show you guys. So let's say if A is equal to a list, you just declare it in square brackets. And to access the values inside a list, we use indexing again, guys. So it can also store duplicate values as well. So let's say if I have 1, 2, 3, 4, and 5, and we'll add 1 again. So just to be sure that we have in duplicate values as well. So this is how a list is declared in Python, guys. And if I want to access, I can use indexing, and I can use slicing in the indexing as well. This is how slicing is done in indexing, negative indexing as well, which can be used to, get reverse of a list. So here what I've done is I've used the negative step and I've iterated from the back. So that is how you do it. So if I say write it from 4 and -1, we have an unexpected end of, right? This is a syntax error. So as you can see, guys, this is how it's done. All right, so from index number 4, we are going until the end of the list, but the step is a -1. So we are starting from here, 0, 1, 2, 3, 4, starting from here, going in the opposite direction, because the step over here is negative step. That's why you're going in the opposite direction, and that's how we are getting the values. All right, so this is all about list, guys, and list also comes with a lot of methods that you can use. So basically, these are the methods that we can use for a list, which are reverse, remove, pop, insert, index, extend, count, clear, copy, etc. So if you want to know more about these methods, how we can use them, we have a full tutorial on list in Python that you can use. So I'll just show you how you can insert a value inside a list. So let's just check. So index number 0, we have added the value 1. So this is how you insert a value. And if I use the pop method, I am actually removing that particular value from the end of the list. All right, so this is all about list. Now coming back to dictionaries, guys. So let's say we take dictionary and we declare it in flower braces. And so we use the flower brackets here, and we have to use key value pairs. So let's say 1 is the key, this is value, 2 is the key, and we'll get another value. So these are two value pairs, key value pairs. And when I print my dictionary, I have somewhat like this. So if I access one, we can use the get method to get the values from the dictionary. So if I want to get the value which has the key 1, I can use the method get. Similarly, for all the keys, I can use this, or simply I can get the value using indexes as well. So in the indexes, instead of indexes, I'm just using the keys. And similarly, it also has a lot of methods that you can use, which is clear, copy, from keys, get, which I've just shown you, items, keys, pop, and pop item. Right, so this is all about dictionary that we're going to discuss, and after that I want to discuss a tuple, guys. So a tuple is ordered and immutable in nature, which means you also cannot change the value inside a tuple. And declare a tuple, again you use round brackets. So let's say I give it some values, right? So I use the indexing to access the values, and if I want to reassign some value, I have a type error which says tuple object does not support item assignment, which is same as a string, guys. So if you want to save something in a data type that you don't want to change in the future, you can use a tuple, guys, and it's ordered, so you can access the values again. And one more thing, so if I, let's say, give it some duplicate values, it is allowing the duplicate values as well. So this is all about tuples again, and it also comes with a few methods, that is count and index. So basically I can count the number of values that one has. So one has occurred thrice over here, and I can check for 2. Similarly, I can get the index value for, let's say, 1. I'm checking, it's giving the index value as 0, but it also has a value at index, that is second last index and the last index as well, but it will just fetch me the value which is which occurs the very first time for the method. So since it's in the beginning, it's giving me this value. Let's say if I write 2 over here, and if I check it for 2, I'm still going to get the value 1. So if I remove 2 from here, I'll get the value index as 5. So I hope you understand this. And after this, we have one more data type, that is a set data type, guys. So set is unordered, guys. So let's say if I have values 1, 2, 3, 4, 5, 6 and 7, print over here. So we have declared a set using the flower braces, and it is unordered and not indexed, so we cannot just access values from the set using index, right? So but we can have all these methods that comes with the set data type, which is basically implement the set operations that you must have heard about or learned when you must have learned about when you were learning set theory. So it's basically it gets subset, superset, or okay. So we will have one more set, and now we will do a union, guys. So let's see if it works. All right, so let's change a few values here. 9 and 10 we'll add. So we have just done a set operation, do the union of two sets available to us. So that is how we can use the these data types, and these are the basic data types that we have in Python. Now after this, I want to talk about a few advanced data structures also that we have in Python. So these are general, Python's general purpose built-in container data types, and we all know Python always has something little extra to offer. It comes with a Python module named collections, and which has specialized data structures. So I'll mention a few data structures that we have in collections Python, but before that, we will have to import from collections, import all. Whenever you're using an external package or a module, this is how you import using an alias. You can use an asterisk to import everything from the package, or you basically import specific modules that you only want for your project. So I'm just going to import deck. Right, so we have deck, default dictionary, there is name tuple, we have chain map, we have counter, there is user dictionary, user list, and user string. So these are the collection advanced data structures. So I'll just briefly tell you about what exactly are these data types and what they do. So talking about name tuple, it returns tuple with a named entry, which means there will be a name assigned to each value in the tuple. It overcomes the problem of accessing the elements using the index values. And with name tuple, it becomes easier to access these values again, since you do not have to remember the index values to get a specific element. Now, see, basically what happened here is with data types, whatever problems that we had in the basic data types, advanced data structures are actually solving those problems. So if you take a look at the tuple, when I discussed, there was only 2 methods. One was to get the index of the number, and second was to count. Name tuple is basically assigning a name to a tuple so that you understand or you basically remember the value that you have to fetch from the tuple. Then again, we have deck, which is pronounced as dex, even if it's written as DEQUE, is basically an optimized list to perform insertion and deletion easily. So it comes with a bunch of methods that we can use, or we can also use deck to implement stacks and queues in Python, which is basically a way to implement a linked list in Python. So we'll be talking about that in a while. After that, we have chain map. So it is a dictionary like class which is able to make a single view of multiple mappings. So what happens here is it basically returns a list of several other dictionaries. Suppose you have 2 dictionaries with several key value pairs, and in this case, chain map will make a single list with both the dictionaries in it. So that is how you can use chain map. Then there is a counter, guys, which is basically a dictionary subclass, and we can use it to count hashable objects. Now you must be wondering what exactly are hashable objects. So hashable objects are nothing but in Python any immutable object, such as integer, it could be boolean string or tuple, is hashable. So basically whatever value that is immutable is actually hashable object. So counter is also, basically a subclass which is used to count hashable objects. And then we have the order dictionary. So it is basically a dictionary subclass which remembers the order in which the entries were added. Basically, even if you change the value of the key, the position will not be changed because of the order in which it was inserted in the dictionary. So this is a very good advanced data structure, guys, which is an order dictionary. And basically you can remember, or it keeps track of which value came first, even if you have changed the value of the key. So that is one advantage over there. And then we have the default dictionary, guys. So which is basically a dictionary subclass that calls a factory function to supply missing values. So in general, it does not throw any errors when a missing key value is called in a dictionary. And after that, we have user dictionary, which is basically, a class that acts as a wrapper around dictionary objects. So the need for this class came from the necessity to subclass directly from a dictionary. And it becomes easier to work with this class as the underlying dictionary becomes an attribute. After that, we have user list. So this is basically acting like a wrapper around list objects, and is a useful base class for other list like classes which can inherit from them and override the existing methods or even add a fewer ones as well. So now, even if I have discussed these advanced data structures, as a beginner you should only stick to a few of them and basically focus on the inbuilt data structures. First of all, the basic ones like list, dictionary, and tuple, set, integers, strings. And I forgot to tell you about the range, right? So let's take a look at the implementation of deck as well, because it basically provides a lot of methods that can be used to implement linked list in Python. That's why I want to discuss this. All right, guys. So what we can do here is, so first of all, let's create a list, guys, and we'll call it as stack because we're going to implement stack over here. So 1, 2, 3, 4, and 5. And now if I have a deck over here, let's call it as stack again, and we are going to use deck. Inside this we'll pass stack, and now we have the deck. So what we have to do here is, now we'll use this stack, and let's see what methods do we have. So we have append left. There is extend left again that we do not really need, and we have pop and pop left. So these are two methods that we actually need, because let's say if I want to remove something from the beginning of the list, what I will do is I will write pop. So it is popping 5, which is at the end of the list. Now if I want to remove something from the beginning of the list, I can use pop left, and again I can use append and append left. Alright, so if I want to append, I will write 1, and my stack would look somewhat like this. Alright, so it's actually adding a particular value at the end of the list. Alright, so I'll just change it to 5 because we had 5 in the beginning. And then again, if I want to add something in the beginning, I will write append left and 1 over here. Now my stack becomes the same, and I can remove 1, let's say. Now the stack looks like this. I will remove 1 again. Now the stack looks like this. Stack dot append 5 and stack dot append left. Alright, so we'll remove 5 again. Now, so how will we get the implementation of a stack or a queue, guys? So this is quite interesting. So for a stack, we have to follow the principle of last in, first out. So whichever value is inserted last in the list has to come out first. So that is implementation of a stack. And to implement a stack using deck, what we have to do is we have to remove the element that was entered last in the list. So let's say if we have an empty list, and if we use a loop, which we'll discuss later on in sessions, so we keep inserting the values inside the list or the deck, and after a point there will come a point where we have reached the end of the list and the last element has entered. So now comes the part where we have to get the last element out. So in this case, the first value is 1. So this will come out last from the deck, and this is the last element. So we have to use append in order to get the value, and we can put the whole logic inside a loop so that it goes forward, imitating the order of a stack. So it's a very simple example, guys. And after that, now comes the necessity to introduce functions to you guys, because the functions in a Python are a classic example of reusability, guys. How? To serve a wide range of applications from, let's say, GUI and mathematical computing to web development and testing, Python's interpreter already comes equipped with numerous functions that are always available for use, which we'll discuss in the Python standard library, guys. And you could also bring in other libraries or modules to your program, and that basically contain predefined functions, and they're ready to use. You will just really have to do is download required packages or according to their documentation, and freely avail its useful functionalities by importing them over to your code, like I have done over here, which I have imported collections module. From there I'm just using deck. It's basically a function from this module that I have imported. What I can do either way is define a function, guys. So how do you actually declare a function? So that is the important part here. How do we declare a function in Python? So you have to use keyword here, which is def, and after that you have to write the function name. So let's go with function name. So I'll pass. So this is my function, guys. I have created a function instead of pass, because we have not discussed the control statements. I will write return none. So this is how I have created a function, guys. So let's say if I want to print something, I want to print hello world. So now when I call my function, which is function name, I'm getting the value as hello world. And now let's give it a parameter as well. Okay. Now when I call it, I will have a type error which says function name is missing one required positional argument. So what we can do here is add a over here, and this is how I've just used a parameter. This is a very basic example of how I can use a function in Python. The advantage is simple, guys. So let's say I want to calculate something. All right, so I have two numbers which I will take the input from the user. I'll show you that as well. And I want to calculate the sum of those two numbers. Very simple example. Even though we have a predefined method for that, we will create a custom method for our own usage. So the first thing that I would do is I will use a return statement which will return the addition of these two parameters that we will get from the function call. All right, so now what I'll do here is I will get the input. So we'll use x and y. So input is one method that can be used to get the value from the user during runtime. We are taking int as input because we want summation, so we do not really want integer there, and that's why we are doing that. And after that we will call our function and pass x and y over here. So let's see what the output is. So the first number is 10, the second number I say is 20, and I have a type error, guys, which says function name takes one positional argument but two are given. So I think we have made a mistake, so it should be working now. So we have the summation of number using functions. So this is a very basic example how we can define functions and use functions. And there is one more function concept that I want to discuss, which is lambda function, guys. So we will take the keyword lambda and we will pass the arguments, and after that we will have the expression. All right, so let's call it as function. Now to call the function, I provide the values again, 10 and 12, and gives me the sum, which is 22. So this is the example of using a lambda function, guys, where you can just simply define the expression and the parameters then and there inside the definition as well. All right, so this is all about functions that I wanted to discuss. Now we are going to talk about the conditional statements, guys. So when I talk about conditional statements, we really have if, else if, and else that I want to discuss. So these are the conditional statements, and apart from these we are going to discuss the control statements, which is break, continue, and pass. And now we are going to discuss the comparison operators as well. Okay, so let's say we have these two numbers x and y. So let's first of all check if x is greater than y. We will print greater. Alright, guys, so when I execute this, we are not getting any output. The condition is basically false here because x is not greater than y. So if x is less than y, we have this particular output, and let's go for this. So what we will do is we will check for another statement using else if. Now if first statement is false, it will check the other statement. So it will check if x is less than y. It will basically print smaller, and we have the output, guys. So now I want to change this to is equal to. So we have, again, we do not have any conditions. Now I will print smaller again. Everything else is failing. We are reaching the last statement, which is the penultimate statement, which is whatever that we give over there, it will print for us. So I want to talk about the control statements again. So let's say if x is equal to y, and we want to break, it's saying that syntax error, which is saying break outside loop. So basically what we have to do is we have to use break or the control statement inside a loop. So we'll do that while discussing loops, and let's just call it as equal. So to test it out, to check if your conditional statements are working or not, what you can do is get these values from the user. So A, we have 10, let's say. B, we have 15, and we have smaller. Okay, let's just put this inside one single block and run. So let's say 12 and 6, and again let's say 10 and 10 equal. So this is how we can use the conditional statements in Python. Now I want to talk about loops in Python, guys. Alright guys, so think of an analogy where your teacher has punished you and told you to write "I will not forget my assignment" 10,000 times. Okay, that's a bit harsh. She has told you to write it 10 times. So what you can do is, so using Python, what we can do is make this task very easy for us. So I'll just explain how we can use a for loop for the same task. So let's say we have to print "I will not forget my assignment." So we have to print this 10 times or 20 times or any number of times. So what I will do here is, I'll take a for loop for I in range 11, because we have to print it for 10 times. So as you can see, guys, this is a very practical implementation of how we can use a loop. So two things to actually see here, observe here: the number of iterations that we want and what exactly is the output that we want from the loop. So this is a very simple example. So we have used for I in the range, which is basically the number of iterations we want, right? So for the current iteration, it will start from the number 0. So range 0, then the range will become 2, the range will become 3, 4, 5, and when it reaches 11, the execution will stop. So this is how for loop works. We give it a statement, we give it an ending, already know the execution will end at this particular iteration, and we have the output. And in this particular section or the block, we can have any code that we want. We can have a function here, we can have a class, we can have any code that we want to iterate over and over again. So that is how loops in Python work. Now we have another kind of loop which says we have a statement, and as long as is it true, it will keep on going and going. So for the same task, what I can do here is get a count variable, and as soon as count is equal to 10 or 11, let's say, and we'll have count is equal to 1 or 0, and we will print "I will not forget my assignment." And after that, we have to increment the value, because that's how we will increment the value again, right? So I actually forgot to mention here, the condition has to be true all the time. So as soon as it becomes greater than or equal to 11, it will stop the iteration. So we have our task performed here exactly as we want it to. So these are the two loops that we have. So the only difference between for loop and a while loop is, in the while loop, you have to give the statement and the loop will run on until or unless the statement becomes false. So you have to keep in mind that you are actually incrementing the value, or you're providing some sort of closure to the loop so that the condition will become false eventually. Otherwise, the loop will run on forever. And for the for loop, we already know how many executions will happen. So that is the difference, the main difference between while and for loop. So now we'll talk about the iterators, guys. So a Python iterator is a container containing a countable number of values, and a value in a container can be traversed using iterators, which is particularly list, guys. And apart from traversal, iterators also gives access to data elements in a container but does not itself perform iteration, which is not without some significant liberty taken with that concept or with trivial use of terminology. An iterator is almost similar to a database cursor in behavior. So let's see how a database, this actually works, the iterators. And after that, we will talk about Python iter tools, guys. So let's say we have a list, right? So it has some values 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now iterable is exactly an object which one can iterate over. So right now, a list which we have declared over here is an iterable. An iterator will be an object which is used to iterate over the iterable object using iter and next method. Now to make this list iterator, what we have to do here is, okay, I'll write a is equal to iter a. Now this is an iterable object, guys. Now what I can do here is, using this iterable object, I can use the next method and get the value, right? So using this next method, we can get the values or iterate over this iterable object. So every time I execute this next, I'm getting the next value, and when I reach the end value of the iterator, it will stop the iteration, or it will throw an error because we have not specified the stop iteration over here. So it's, yes, the stop iteration is there. And so that is exactly how we use iterators in Python. Basically, we have iterables which we can convert to an iterable object using iter method over here, or we can use iter tools, which I will discuss now. So what exactly is Python iter tools? Iter tools is a module that has a lot of functions and tools that can be used to create iterators in Python. So there are a few methods that iter tools comes with, and let's just talk about how they work. So the tools are the methods that can be divided into subcategories. So there are infinite iterators, and then there are the iterators that will terminate on the shortest input sequence. There are combinatoric iterator as well. So let's just talk about the infinite iterators first. So we have three tools for infinite iterators using iter tools. So first of all, let's just import. We will import count. So count basically has two parameters, start and a step, and the iterator will return evenly spaced values starting from the start. So let's see how this works. Let's say a is equal to count. We have two parameters, which is start and a step. Let's say starting from 0, give it a step 10. All right, so now each time I use the next method, I'm getting the values. So basically what I'm doing is I am getting these iterators from these methods. Basically this is an iterable object which I can iterate over using next, or I can put it inside a for loop. Since it's an infinite iterator, if I do not give it stop iteration condition, it will just go on forever. And similarly, infinite iterator, we have count, we have cycle, and we have repeat. Cycle basically returns a copy of the elements from the iterable and takes only the iterable as the parameter. Then repeat basically returns the element again and again. So the repetitions are determined according to the parameter that decides the number of times the object will get repeated. And to check the exact syntax, we can go to Python iter tools, the official documentation. So here we have all these how you can use the infinite iterators, iterators terminating on the shortest input sequence. There is accumulate, chain dot from iterable, compress. So all these iterators, they have also given the examples. So you can use accumulate. So let's say you have iterable over here, it will give the values again like that. So this is how you can use the iter tools methods. And then again, we have combinatoric iterators, which will give the product, the permutations, combinations, and combination with replacements. So this is a very important module that we have in Python, which is inbuilt, guys. It's basically giving us these iterable objects which we can just use wherever we want. Wherever we want to iterate over an iterable, we can use these objects. This is why it is an important concept that I wanted to discuss. So as you move forward, once you learn how you can work with loops, and then moving forward, you will come across complex questions. And for the very similar reason, I discussed the advanced data structures also, because as a beginner, there are a few things that you will get spoon fed, and some things you will have to eventually discover. So I didn't want to keep you into dark, because advanced data structures are something that you will eventually use working in the complex problems. So similarly for the iter tools also, you will have to use these iterators some way or the other in complex problems. That is why we're discussing this. And after that, we have generators in Python, guys, which is also a very interesting topic. So generators are basically functions that return traversable objects or items. All right, so how is it different from a iterator? We'll discuss that. So these functions do not produce all the items at once. Rather, they produce them one at a time and only when required. All right, so whenever the for statement is included to iterate over a set of items, a generator function is run. And generators have a number of advantages as well. So we'll discuss these advantages first. So without generators in Python, producing iterables is extremely difficult and lengthy. And generators are easy to implement as they automatically implement iter and next. So in order to create an iterator, we have to use iter and next. But using generators, we can just implement them automatically. And stop iteration also is implemented automatically, which we have to use otherwise. And memory is saved as the items are produced as when required. So whenever you're requiring that, then only the items are produced. So it's actually saving a lot of memory as well. And this fact becomes very important when you need to create a huge number of iterators. And this is also considered as the biggest advantage of generators. It can be used to produce an infinite number of items as well, and they can be used to pipeline a number of operations. So these are all the advantages of using generators. Now the question here is, what exactly is a generator? So we have talked a lot about generators. What are the advantages? We know that it's actually returning traversable objects or items. So generators in Python are created just like how you create normal functions using the definition, that def keyword. And the generator functions make use of the yield keyword instead of return. So that is the only difference between a normal function and a generator function. And this is done to notify the interpreter that this is an iterator. So when you're using yield, the interpreter already knows that this is an iterator. And not just this, generator functions are run when the next function is called and not by the name, as in case of the normal functions. So you can just call next and the generator function will run. So we'll take a look at, a little implementation of how generators works in Python. So let's take it up to Jupyter Notebook and we will see how generator works in Python, guys, how we define a generator function. So we are going to use the keyword definition. Let's call it as generator, because this is going to be our generator function. And after this, let's take a number is equal to 1, or let's take that as 10. After this, I will yield this number a. So when I call next on this, I'm getting a type error, which is function object is not an iterator. So I have to create an object. So this is my object now, and if I write it like this, I'm getting as 10, and the iteration is stopping because this is not exactly an iterable. So let's take it in the range 10. So we'll have 1, next is 0 to 10. Okay, so we basically forgot to convert it into an iterable. Now it should work fine. So if we take one element, all right, so we'll define something so that we only get one value at a time, a of 0, and then a of 0 is equal to this. So let's call it as b, and now we'll yield b. Just defining the logic. All right, so instead of this, what we can do here is, let's just take a number first. All right, guys, so this is just to show you how you can define a generator function, and this is a very basic generator function that we can use. So right now we're already done with iterators and generators, and we're left with decorators. But before discussing decorators, let me just discuss a concept, which is class and objects. So as you already know, guys, if you are from a programming background, so a class is nothing but a collection of a lot of variables, objects, functions, basically a lot of things, and that you can wrap inside a class and use it for later, or you can inherit from those methods or something like that, and you have objects to take values from them. So now to fully understand this, let's consider an analogy. So let's say you have a class, and your class is basically your complete college. Your institution is the class, and you have different variables there. So for each branch of the university or the college is a member function. And whenever you want to call, let's say, School of Engineering or School of Architecture, you have separate member functions. And all of that is enclosed inside a class, which is the university. And inside those member functions, there are variables, which is basically the number of students and the details of those students. So what you can do here is create an object, and to pinpoint exactly to the particular student that you want from the School of Engineering, what you will do is you will call the method, the member function, which is containing the values of all the people from the School of Engineering branch, and then find the particular details using that particular member function without disrupting others. So this is how the analogy works, and this is a very basic example. Also, I'll just show you how you can create a class. Let's say we create a class like this, and we have a function. Let's call it as School of Engineering. So let's call it as SOE, and it has some values, and it returns sub.name is equal to name, and we'll write branch is equal to this thing. All right, so we'll call it as engineering, and we will return name and branch. So let's see if it works. So now let's create an object. To create an object, what we have to do is we'll just create an object called uni. Now using this, we call the memo function, provide the name, let's call it as this, and we are getting these values. So now what happened here is I had a class university. Using the parameter, I'm providing this name particularly, but with that name I can add values, guys. So let's say if name is equal to, write computer science engineering, else we will write branch is equal to let's call it as mechanical, just to show you guys. This is a simple example. So now let's say this is an example. So we have computer science engineering. Now let's say I write it as somewhat like this. Let's say I write Omkar. Okay, we have an unbound local variable branch reference before assignment. So I'll just remove this. I think this is the error, right? So now I think it's be fine. All right. So what I've done here is, even if I remove this now because I was making a syntax error, a slight syntax error, so I'm getting this value, guys. So this is how we can use classes and object easily in Python. And after this I want to discuss decorators in Python. And before that, this is just a very basic explanation of how classes and object is used. What I want you to do on your own is, after you're familiar with classes and objects, I want you to do it as an assignment to look into how inheritance works, how the object oriented concepts work, and how you can implement multiple inheritance and all these concepts. So we already have tutorials on our YouTube channel that can help you, but as a beginner I want you to try it on your own to implement using basic implementation of all these concepts that I'm talking about. So moving on, let's talk about decorators. So decorators in Python are very powerful, which modify the behavior of a function without modifying it permanently, which means is it basically wraps another function, and since both the functions are callable, it returns a callable. So in hindsight, a decorator wraps a function and modifies its behavior. Let's take a look at the example to understand this better. As I've already told you, a decorator will wrap another function and modify its behavior. So we will understand this with a basic example, guys. So we'll take a function first of all, and using this function we are going to pass the function as the argument. And okay, let's call it as function1. This will be the argument that we are passing. Function as an argument, guys. You heard me correctly, guys. You can also pass a function as argument. Now we will have another wrapper function, and inside this we will have a statement. Let's call it as hello. And after this we have a function that we have passed as an argument. And after this, let's print something else, right? So we'll write welcome to Edureka, and we will return wrapper. So now we'll have another function, function2, which we will pass as argument in our function1. And let's just keep it simple, print learner here. Now we will call the function1. All right, so now we'll call the functions or make the function call. So function2 is equal to call the function1, pass function2 over there, and call function2 now. So as you can see, guys, we have basically used a decorator. So this is a simple implementation of how we can modify the behavior of the function. And instead of doing this, what we can do here is write this, and we will remove this. All right, guys, I think we're making a mistake here. So function has to be there, and now we're getting the same output, but instead of making that call over there, we're just writing it with an @ symbol. And that's how we use the decorators in Python. And now we will move on to Python standard library, guys. So this is the official documentation of where you can find the Python standard library. But what exactly is there in the Python standard library is the built-in functions and the built-in types, or the built-in exceptions, all these values that we have. So we have date time, there is a calendar, collections. All right, so we basically use the collections module, which comes from the standard Python library. So it is a very important concept that we have in Python, where we can just learn about all these inbuilt data types first of all, or inbuilt functionalities that comes with it. There is IT tools, there is func tools as well, which is basically a higher order functions and operations on callable objects. So this is also one of the very important concepts that we have in Python. Also, so there is CSV and all the file formats are there. So Python standard library plays a very important role when you're learning Python, and I will suggest you to explore all these values that we have. all these functionalities that we have in Python standard library. So we have built-in functions. So let's take a look at the built-in functions that we have. There is ABS, the all, ASCII, there is a list, all these constructors, checking the length, and in the documentation they've given how it works as well. So as a beginner, I would suggest you to check out the Python standard library. It will help broaden your perspective about what exactly is possible with Python. So that's why I wanted to discuss Python standard library, and not just the built-in functions. Let's take a look at built-in types as well. So there are truth value testing and comparisons and etc. These are something that if you read about them in documentation, you will understand. And there is text processing services as well, string, the regular expression, text wrap, Unicode data, and all these things. Read line is one of the things that we are going to use while doing file handling. Get to that. Now that we're done with the standard library also, let's talk about the exception handling, guys. So what exactly is exception handling? So in Python, the try and except block is used to catch and handle exceptions. Basically what happens is when you are executing a program, there are errors and there are exceptions. So exceptions usually happen during runtime, and you have to take care of them unless repeat, or they will cause execution problems. So Python basically executes a code considering the try statement as a normal part, whereas the except statement acts as the program's response to any exceptions that may occur. And exceptions are convenient for handling errors and special conditions in a program. So if you're working with a code that can produce an error, then you can use exception handling, and also you can raise an exception in your own program by the raise exception statement. And raising an exception breaks current code execution and returns the exception back until it is handled. So there are a few exception errors. So these are different types of errors, such as IO error, which is if the file cannot be opened, you will have an input-output error. When an unrequired key is pressed by the user, there is value error when the built-in function receives a wrong argument. There is end of file error, which is hit without reading any data. And there is import error if it is unable to find the module. So let's do one thing, guys. Okay, so let's say if we have not installed a module in Python, so we will basically have an import error, right? So I'm going to use, so let's do this cv2.read, and we have a name error which is saying cv2 is not defined. All right, so let's take a look at try print xyz and catch block, try and except print exception. All right, so now I will try to import something that I have not really installed here. So we'll do, all right, so we already have PyAudio. So we'll try to import something that we do not have. So let's do this, and it's calling the exception. So as long as whatever code that you have over here, okay, we'll remove the whole try block and except block. So we are getting the output as exception, which is in the except block, because it's not able to import PyDodge. We're basically getting an error. That's why it's going to the except block. So that is how exception handling is done in Python, guys. So wherever you can find any errors in your program that you want to handle, you can just put it inside a try and except block, and whichever code that you want to execute will be executed in the try block. Or if at all you come across any exceptions or errors, it will be handled by the except block. So that is all about exception handling. Next up is multi-threading, guys. So a thread is basically an independent flow of execution. A single process can consist of multiple threads, and each thread in a program performs a particular task. For example, when you're playing a game of, let's say when you're playing FIFA on your PlayStation, and the game as a whole is a single process, but it consists of several threads responsible for playing the music. There'll be a thread for taking the input from the user. There'll be a thread running the opponent synchronously. There'll be a thread, and all these threads are separate and responsible for carrying out these different tasks in the same program at the same time. Every process has one thread that is always running. That will be the main thread, which will make sure that the game is running, of course. And this main thread actually creates the child thread objects, and these child thread object is also initiated by the main thread only. So when you open the game, which is the main thread, these all child threads are also initiated and they're running simultaneously. But there is a main thread that is making sure that each of these threads is running as well. And let's take a look at when we actually use multi-threading in Python before moving on with an example. So multi-threading is a very useful for saving time and improving performance, but it cannot be applied everywhere. And in the previous FIFA example as well, the music thread is independent of the thread that takes your input, and the thread that takes your input is independent of the thread that runs your opponent. So these are all independent threads, and they run independently because they're not interdependent. So therefore multi-threading can be used only when the dependency between individual threads does not exist. So how do we achieve multi-threading in Python? Multi-threading in Python can be achieved by importing the threading module first of all. So you have to import threading module. So let's see if we already have threading. So we're going to import everything from threading. Now the next thing that we have to do is we will perform multi-threading, which we can accomplish without creating a class as well. So we have created or imported everything from threading. So now we are going to print current thread dot name. So we'll get the name of the current thread, which is the main thread. And now after that, we will create a main thread function. Let's call it as function. And inside this, we will have all the child functions, right? So we'll have, let's say, this is a child thread, and let's call child is equal to thread, and we'll get target is equal to function, and yes, and we will start the thread. Now we will print current thread dot get name again. Let's see. Okay, function attribute has no name. Okay, so we are still getting main thread. Okay, let's see what we are doing wrong. Actually, we have to keep it outside the function, and let's print something here. All right, so in this output we have the current thread, which is main thread. After that, it creates a child thread and it runs, and whatever we can run it inside this thread basically. And after that, we have the current thread again, which is the main thread. So this is how we implement or achieve multi-threading in Python. This is a very basic example how you can do it, and this is by not creating a class. So this is a very basic example. Also, we have a tutorial on multi-threading that you can refer, where we have other implementation methods as well that you can follow. So what we can do here is we can do the multi-threading by extending the thread class as well. And after that, we can do one thing also. We can do this without extending the thread class as well. Basically, advantages of using threading is it has a better utilization of resource, it simplifies the code, allows concurrent and parallel occurrence of various tasks, and reduces the time consumption or response time, thereby increasing the performance as well. So this is all about multi-threading in Python. Now let's talk about importance of file handling in Python. So the question must have stuck your head, isn't it? Why so buzz and stress about this simple thing? Well, for that, let's take an example. Suppose you want your Python script to fetch data from the internet and then process the data. Now, if the data is small, then the processing can be done every time you run the script. But in case of a humongous data, repetitive processing cannot be performed. Hence, the data process that needs to be stored. This is where the data storage or writing to a file comes in. And one thing to note while writing data to a file is that its consistency and integrity should be maintained. So that is why file handling is a quite important concept in Python programming. And as a beginner, it's easy to learn this, mastering the basic concepts so that you'll be able to understand this in a better way and don't have to come back to it later on. So once you have stored your data on a file, most important thing is its retrieval also, because in computer it's stored as bits of ones and zeros, and if its retrieval is not done properly, then it becomes completely useless and data is said to be corrupted. So writing as well as reading is also important aspect of file handling in Python. And now we're going to learn about how we can open a file, or appending or writing to a file and closing a file. All right, guys. So now what we'll do here is we will open a file using file handling operations, write something in a file, and then we'll try appending a few values there, and then we'll close the file. So I'm going to take this. Okay, so just create an object here. Let's call it new file. Using open, I will give the file name. Let's say this is my new file.txt. And after that, I have to give the mode here, which I am going to give it as X and T. All right. So we have created a new file. Now what will happen here is we will write something to the new file. and let's just write this is a new file, right? And now we will read from the file. Alright, so we'll do one thing before we can read it again. Let's close it, and now we'll create another object, and we will call it as read file, and using this open again, we will read the new file, and now the mode will be RT. As you can see, guys, using this readline method, we have just read the file that we had just created. So let's close it, and after this we will create another object, call it as write file is equal to open, and then open the new file again, and now we will write into this file. So we will write w. So if I want to write the complete file, I will use wt, and if I want to append something, I will use at, right? Yes, now I will use, right guys, so we will write again. Okay, and now we will close the operation. Now again we will use another object, and using this we will read from the file, just new file dot txt, and we are going to read, right? So read new file dot, now since there are too many lines there, you're gonna get all the lines, and so this is a new file and I'm appending this in the file. Also, if I, instead of using AT over here, if I had written WT, this will be the new line rewriting the whole content of the file. So this is all about file operations, guys. A simple basic operation of how you can open a file, create a new file, read from the file, append new values, write new values there, and ultimately you can close the operation again. So we're good to go. Now we are reaching the end of the session, guys. So I'm just going to tell you about a couple of programs that you can write after mastering these concepts. So I would suggest you to check out our Python projects tutorial. We have uploaded 10 projects there, starting from the beginners perspective. There are intermediate projects as well and advanced projects as well, so you can check it out. Also, we have a Python programs blog, and there's a lot of content that you can find online on our YouTube channel. So I'll just show you two programs, guys. Palindrome checker, and the second program will be a simple basic guessing game. So in the first program, we're going to make a function, guys, right? So okay, this could be anything, and so first of all, what we'll do is there'll be a new number which is equal to number, and we reverse the whole thing, because since we can use indexing with strings as well, so it doesn't matter if it's a number or if it's a string, we can just change the values there. So I hope everybody knows what exactly is a palindrome. So palindrome is a number or a string which is same if we reverse it. I mean, the spelling would be same, like madam. If you reverse it, it will still be spelled like M-A-D-A-M, right? So now what we want is we want certain conditions here. So if number is equal to new, we know that it's a palindrome, so we'll print palindrome. And else if number is not equal to new, we know that it's not a palindrome. And in any case, if we do not have any values, we'll print enter again, right? So now we call our function here, which is palindrome. Let's give it a palindrome. First of all, let's just check it's a palindrome, guys. So if I change it to, let's say, Edureka, not a palindrome. And now let's switch it to a number here. So int object is not subscriptable. So what we can do here is we can probably change it to a string, and let's see if it works. Yes, it's a palindrome. And let's check for another number. Oh no, it's not. Then again, let's try it for this number. It's a palindrome. So basically we have just made a function to check if a number is a palindrome or not. Similarly, you can do that for calculating the factorial of a number. There you will be making use of loops in Python and other concepts like conditional statements that we have used over here. Now the next program that I'm going to show you is the guessing game. So basically we are going to import random over here. All right, so okay, we'll just take a number which we are going to guess. So random dot random range. We'll take the range from 0 to 100. Let's take step 2. So we'll have only 50 values that we can calculate. Now we take a value from the user, right? So we take input and enter a number, all right? So basically what our aim here is, right, this is invalid syntax. Our aim here is whatever the random generator is generating over here, we have to guess that correctly. So whatever value that I enter over here, I have to check if that is equal to number or not. So what I'll do is, if number is equal to guess, we'll print you win, else we'll print keep trying. Okay, right, so it's saying keep trying because it's a number that we did not really guess correctly. So I'll put this over here. All right, so let's generate a number, new number again. Okay, we'll remove this. Now we run this. Now I'm entering a number. Let's say I enter 50. It says keep trying, and now let's get number also. So it's 70. So let's say if I enter 70 over here, it says you win. So now a game has to be, you know, in a fun way. So we'll add condition here and we'll run a loop. So while we say, so we can give as many conditions here, like we can give condition until you guess the number. You can keep on going guessing, or you can do one thing, or while count is less than, let's say 5 or less than 6, we will keep running this program, right guys? Yes. And after this we will do a count plus is equal to 1. So each time we go to the else block, the count value will be increasing. And let's give count a number here. Let's give it a 0. Now run it again. So we know that the number is 70 already. So we'll just check it for the program. So let's say we get 10. Okay, it says keep trying. We give it 20. It says keep trying. Let's give it 30. It says keep trying. 40. Keep trying. So we have 4 values. Now the count would have become 1, 2, 3, and this is 4. This is 5, and yes. So we have got out of the loop because the count value became 6. And if you give it the value that it needs, you win. So even if you win, the program still keeps executing the numbers, right? Again and again until the count reaches 6. It exactly does not have any other value, right? So we have made a mistake over here. So what we want to do here is, let's keep the count out of the if block, right? And after this, if we win, we want to give a break, right? So we'll run it again. Okay, we'll have to restart the kernel to, you know, bring it to life because we did not stop the program over there. So restarting the kernel now, right? So if you guys do not really know how Jupyter Notebook also works, so it's a part of Anaconda Python. So you can download Anaconda Python from the official website. And if you want any assistance there, we have an Anaconda tutorial as well, which you can follow. Right. So if we have 70, let's say, okay, the number is not defined. So we'll have over here. So our random number right now. All right. So we'll have to probably execute this as well. So random number is 12 now. So we want to check if we guess it correctly, is it okay? So we win and the execution stops. So this is how you create simple programs.
What are comments? No, they are not something there just to increase the size of your code. But guys, they are indeed very meaningful. Comments are programmer coherent statements that describe what a block of code means. And they get very useful, especially when you're writing large blocks of code. Say, for example, you've developed some software previously, and now you're working on something that's new and completely different. At this point of time, you find that your previous software is throwing some error. You would have completely forgotten what you did and how. So this is where comments come into picture. A good code actually consists of relevant comments. These comments actually increase the readability of the program, not just to the programmer, but to the others as well. Now let's move on towards a Jupyter notebook and write some comments. All I'm going to do over here is, I'll open a new Python notebook and I will rename this notebook. To rename your notebook, guys, all you have to do is click on the title, give whatever title you want, and use rename. Like I've told you before, comments start with a hash character in Python. So here I'm going to write a comment preceded by a hash. As you can see my output, there is nothing related to the comment line, and whatever I have printed in the print statement has been returned as my output. Now this is how comments work. They do not show up in your output. Now let's get back to our presentation and see how they are interpreted, which is exactly what is our next topic. Whenever the interpreter encounters a hash symbol, it omits whatever is present after that. The hash character actually tells the interpreter to stop reading whatever is present after that until the end of that line. So when you're writing comments, whatever is present after your hash character is going to be omitted by your interpreter. Now what if the hash character was present inside a string? Let's go to our Jupyter notebook and see what happens. I'm including a hash character within a string and I will run this. As you can see, when I run this, the string is returned, which means a hash inside a string means a hash itself and nothing else. So you cannot write comments within a string. Okay, so I hope you've understood how to write comments. Now let us move ahead and see what are the types of comments. Comments can either be single line or multi-line. Single line comments can either appear individually or in line with some other code. Multi-line comments have to be preceded by a hash character in every line they appear. Now let's see a small example of single line comments. Like I've told you before, single line comments can appear either in an individual line or in line with some other code. Now let's move on towards a Jupyter notebook and write some single line comments. I'll just create a heading over here. To create a heading, all you have to do is go to code, select heading, give whatever heading you want as your heading and prefix it by a hash. A single hash tells that it's H1 level heading. 2 hashes tell that it's H2 and so on. You can use the heading level of your choice. Here I prefixed my heading by a single hash, which means it's of level H1. Now let's write some single line comments. As you can see over here, my first line of code is a comment line. I've prefixed this line by a hash character. And in my last line, I have an inline comment. This inline comment is present with some part of the code. As you can see in the output, none of the comments have been returned. Now let's get back to our presentation and see how multi-line comments work. Like I've already told you, multi-line comments can appear anywhere in your code, but each line needs to be prefixed by a hash character. For example, as you can see on your screens, I have a hash character present in the first 2 lines of my code. After that, I have some code followed by it. You can see in the output that none of these lines have been returned. Now let's go to our Jupyter notebook and write some multi-line comments. As you can see over here, I have 3 initial comment lines and all 3 have been prefixed by a hash. After that, I have some code. And you can see in the output that none of the comment lines have been returned, and whatever code is present after that, an output is returned based on this code. Now, typing a hash everywhere might be a problem, and many of us would not like to do so. Let's look at some shortcut methods of how to comment multiple lines at once. All you have to do is type your multi-line comments first. Hold the Control key and left click wherever you want to insert a hash character, just like how I'm showing you all. And then type it once and it appears wherever I have inserted the cursor, as you can see on the screens. Now, in case you want to remove multiple hash characters all at once, do the same thing, hold the Control key, click on wherever you want to remove the hash character from and press the backspace key. As you can see, from 2 lines, I removed a hash character in a single go. So these are some shortcut methods to comment multiple lines. Many of us think that comments and docstrings are same. Now let's move ahead and see what are docstrings and whether they are actually comments or not. Docstrings are not actually comments, but they are documentation strings. These strings are written within triple quotes. They are not assigned to any variable, and many a times they are used as comments as well. Now you'd be thinking, what is the difference between docstrings and comments? Docstrings are not omitted by the interpreter, unlike comments. Comments are omitted by your interpreter, and nothing present after the hash character is going to be read by it. On the other hand, docstrings are strings that describe something about the code. Docstrings actually tell what some function is going to do, whereas the comments will tell how it is going to do. So this is the difference between docstrings and comments. Now let's go to our Jupyter notebook and see their functionality. Like I've told you before, docstrings are written within triple quotes. As you can see in the output, when I execute this, it returns the string itself. Whereas in case of a comment, when I execute a comment, it does not return anything. Which means the interpreter does not omit docstrings, whereas it omits the comment. Now these docstrings are efficiently used when you want to describe something about a class or a function or something else. Now these docstrings can either appear in your output or they can be omitted based on where you're going to place them. Let's try to place a docstring initially before the code starts. As you can see in my output, the docstring has not been returned. Whereas when I use the docstring individually without any code and I executed it, you could see that it had returned the string itself. But when I include the docstring before the code and after that I've included some code lines and I run this, you can see that only the output for my code is present and nothing related to the docstring has been returned as my output. Now let's try to include a docstring after some code. As you can see over here, when I included the docstring after the code, it has returned the output for the code as well as the string itself. So when you're making use of docstrings, just be specific of whether you want it to be returned in your output or not. Many a times, these strings are called rather than writing it again and again. So I hope you've understood what are comments and docstrings as well.
So let's try to understand what exactly is an operator. An operator is used to perform operations between two values or variables. Now we can call the operators as constructs or special symbols that are used to manipulate the values of the operands. Now you must be wondering, what is an operand? So the value that we use in an operation are known as operands. These operands can be variables or any data type that we have in Python. So let's take an example here. So we have two operands, operand 1 and operand 2. Now when I add an operator between them, we can get the result according to the type of operator that we are using here. So before moving on to the types of operator that we have in Python, let's briefly discuss variables and data types in Python. The purpose of discussing variables and data types is to get an idea of what exactly is variable and data types. Because while explaining the different types of operators, we are going to use these variables and data types as well. So variables are nothing but the memory locations where we store a value, and these values we may or may not change in the future. According to the properties they possess, there are 6 data types in Python, namely numbers, string, list, dictionary, tuple, and a set. Now let's take it up to Jupyter Notebook to understand these data types briefly. Talking about numbers or numerical data types, they mainly hold the numerical values. For example, a variable, let's say x, is going to hold the value that is 10. So this is going to be a number or a numerical data type. Now in numerical data types also, we have 4 types of data types. First of all, we have integer, which is going to hold the whole numbers. Then we have float data type, which is used for declaring decimal point values. And then we have complex numbers, which are used to declare imaginary part values. For example, we use the j as imaginary part over here, and then we have a Boolean data type which is used for categorical output, that is true or false. So when I print the Boolean number over here, it is going to give me the value as true or false. So this was all about numbers. Talking about strings now, strings are used to represent the characters or alphabets. We can use the single or double quotes to declare a string in Python. Also, strings are immutable in nature, which means you cannot change a string once you have declared. And to access a value in a string, you can use the index values over here. So when I use the index number 2, it is going to give me the value at the index number 2 here. So this was all about strings, guys. Talking about list, list is a sequence which is ordered and changeable, which means you can change values in a list. To declare a list, you have to give a name for your list, and we use the square brackets to declare a list in Python. List is also indexed just like a string, so we can use the indexes to access the values from a list, and we can store different values in a list as well. For example, I can use numbers over here, give duplicate values as well, and I can use strings over here as well. So when I print my list, it is going to give me the value like this. Now talking about dictionary, dictionary is a sequence just like a list, but we use the key value pair in a dictionary. I'll show you guys. To declare a dictionary, we use the curly brackets. Now I'm going to give the key value pairs over here. So let's say this is my key 1. I'll give a semicolon. Now I'll give the value over here. I'll give one more key value, let's say key number 2. So when I print my dictionary over here, I'll get the values like this. Now since it has a key value pair, it is not indexed, which is why we can use the unique key values as an index to access the values in a dictionary. So what I'm going to do is I'm going to write the index number as my key value, and it is going to fetch me the value at that particular key. So let's talk about set, guys. A set is also a sequence which is unordered and not indexed, which means you cannot access the values using the index number. So I'll just write a few values over here, some duplicate values as well. So when I print my set over here, it is going to give me the values like I have mentioned over here, and it is not going to hold any duplicate values in a set. Also, we use the curly brackets to declare a set. Now talking about tuple, tuple is immutable in nature, which means you cannot change a value in a tuple once you have declared. And we use the round brackets to declare a tuple in Python. So I can give as many values as I want over here, even the duplicate values as well. So when I print my tuple over here, I'm going to get these values that I have declared in the tuple. So the difference between a tuple and a set is not indexed, and it does not contain any duplicate values, but a tuple can contain duplicate values and it is indexed as well. So we can declare duplicate values in tuples, but not in the set. So this was a brief discussion about variables and data types, guys. If you want a detailed discussion about variables and data types, you can check a video on Edureka platform where we have discussed variables and data types in detail, where we have also discussed various operations that you can perform on a data type. Moving on to the different types of operators that we have in Python. So here is a list of all the operators that we have in Python. So first of all, we have arithmetic operators, then we have assignment operators, comparison operators, logical operators, then we have membership operators, identity operators, and bitwise operators. So we will be discussing all of these operators in detail. So let's talk about arithmetic operators. Arithmetic operators are nothing but the operators that are used to perform arithmetic operations between variables or two values. So these are the arithmetic operator symbols that we use in Python. So we have addition, subtraction, multiplication, division, modulus, exponentiation, and floor division. So let's take it up to Jupyter Notebook to understand the concept of arithmetic operators. So let's say I have two variables, x. I'm going to give this value as 10. And then I have one more variable, let's say y. I'll give it a value, let's say 20. Now to understand the concept of arithmetic operators, what I'm going to do is, first of all, I'll try to perform addition between these two variables. So I'll just write plus over here. And when I execute this, I'm going to get the addition as my output. Now to perform subtraction, I'm going to use the subtraction operator, and it is going to give me the value as the subtraction over here. Similarly, I can perform multiplication. Then I can also perform exponentiation. So I'll use 2 asterisks instead of 1 for exponentiation. It is that easy in Python, guys. Now we will perform division over here. So it is going to give me the value of the division. Now when I do the floor division, I'm going to get the value over here as well. One more operator is left, that is the modulus. So I'll try to perform modulus as well. So it is going to give me the value, that is the remainder. So this was all about arithmetic operators, guys. So these are all the symbols that we can use for various purposes like addition, subtraction, multiplication, division, etc. I hope you are clear with the concept of arithmetic operators. Now let's try to understand the next operator that we have, which is assignment operator. So you can imagine what an assignment operator is by the name itself, that is assignment. So we use the assignment operators to assign values to a variable or any value that we have in Python, right? So we have assignment operators like is equal to, then we have plus is equal to. So all these symbols we have, let's try to understand what all these are used for. For example, let's say we have a variable x which has a value 100. Now when I write this x plus is equal to 10, it is going to mean the same as x is equal to x plus 10. Similarly, we can write x minus is equal to, multiplication is equal to, division is equal to, or exponentiation is equal to. Now let's try to understand these operators or the assignment operators in Jupyter Notebook. So first of all, we have is equal to as our first assignment operator. So I'll have 1, let's say I have x. So I have not assigned any value to this. Let's say what happens. Okay, let's try one more variable. I'll write this. So it is showing me a name error, which is saying name A is not defined because I have not assigned a value to it. So in Python, until you assign a value to a variable, it is not going to be declared in Python. So now when I give the value to this variable, let's say I'll write 5 over here, it is not showing any error, which means I have assigned a value to this variable. Now let's try to understand other assignment operators. Let's see. So what does plus is equal to mean in Python? So when I write this, what should be the output, guys? So let's try to understand this. So when I print A, I get the value as 10. So why I'm getting this value? Because I have assigned the value 5 over here. Then I write one more assignment operator, that is plus is equal to 5. So what is going to happen over here is it is going to be same as A is equal to A plus 5. So we have 5 over here and we have added 5 more to this statement, which means we are getting the result as 10 over here. Now let's try to understand other assignment operators as well. So let's say exponentiation is equal to 5. So let's see what the output will be. So when I print this, I'm getting the exponentiation to the value of 5. Since A is equal to 10 and we are doing the exponentiation until 5 digits, so we are getting the output as 100,000. So this was all about assignment operators. Similarly, we can do the division is equal to, then we have minus is equal to. So these are all the assignment operators that we have in Python. Now let's talk about the next operator that we have, which is comparison operator. So comparison operators are nothing but the operators that we are using to compare two values or objects, right? So we have comparison operators like equal, not equal, greater than, less than, greater than or equal to, and then we have less than or equal to as well. So let's try to take an example over here. So when I use the equal operator, I'm going to write the statement as just I have written over here, x is equal to y. So when I'm using the comparison operator, I'm actually using double equal to. So this is the basic difference between assignment operator and comparison operator. So let's take it up to Jupyter Notebook to understand these comparison operators, guys. So let's say I have two variables, value is equal to 10 and number is equal to 20. So to understand the comparison operators, let me take one more variable. I'll say this will be our Boolean variable. So what I'm going to do is I'll write val is equal to number 1. What I'm checking is or comparing these two values. So what exactly I'm doing is comparing these two variables or values that we have, that is val and number 1. So when I print this compare variable, what I'm going to get is either true or false. So it is going to be false because value is not equal to number. So I can do the similar thing. I can check whether it is greater than, or I can check if it is less than. So when I write 10 over here, so I can similarly check if it is greater than or equal to. I can check if it is less than or equal to. So these are the comparison operators that we have in Python, which we can use to compare two values or two objects. Now let's try to understand the next operator that we have, which is the logical operators. So logical operators are used to combine conditional statements. So what are the conditional statements that we have in Python? So let's briefly talk about conditional statement, guys. So mainly we have three conditional statements in Python. We have an if statement, then we have an else if statement, and we have an else statement. So I'll give you an example for better understanding. So for these two variables only, I'll write if val is equal to number1, print equal. Else if val is greater than number1, print greater, else print smaller. So what happened here is, guys, first of all, the execution will go to the if statement. It will check this condition. If this statement is true, it is going to print this value. If this is false, it is going to move to the next statement. That is the else if statement that we have over here. It is going to check this condition. If it is true, it is going to print this statement. Or if this condition is false, it is going to jump to the next statement. That is the else statement. And I'll give one more condition. So if all of these conditions are false, it is going to jump to this statement and it is going to print not there over here. If all of these conditions are false, it is going to jump to the next statement that we are going to have in the program. But I have not written any other statements, so it is going to end the execution over here only. So this is a basic example using the conditional statements. Now that we are done discussing conditional statements, let's talk about logical operators. So I have told you logical operators are used to combine conditional statements. So what exactly are the logical operators? So we have a logical AND, we have logical OR we have a logical NOT as well. By looking at the example, let's say we have two conditions over here. We have x is greater than 5 and then we have x is greater than 10. So let's try to understand these logical operators in Jupyter Notebook. Now let's say I have two statements. I'll write x is equal to 10, and what I'm going to do is I'm going to check if x is greater than 10. I'll write AND, which is my logical AND operator, and I'll write x is greater than 5. So what is going to happen if I use the logical AND operator? If both of these statements are true, it is going to give the result as true. But if one of these statements is false, it is going to give me the value or the output as false. So let's see what happens if I execute this statement. I'm getting false because one of these statements is false. Now when I write, instead of 10, if I write 8 over here, let's see what happens. Since both of these statements are true, it is going to give me the output as true. Now instead of AND operator, if I use the logical OR operator, let's see what is going to happen. It is showing me that it is true because when we are using the logical OR operator, only one of these statements has to be true. The output will be true. But what happens if both of these statements are false? It is showing me the value that is false. But let's see what happens if both of these statements are true. I'm getting true as well. So one of the statements has to be true when we are using the OR operator. Now talking about logical NOT operator, what I'm going to do is I'll write NOT in the beginning. Now I'll specify the condition. Let's say x is greater than 10 and x is greater than 5. This is the same statement that we have used before, and for this we have got the output as false. So let's see when we use the logical NOT operator, what is going to be the output. I'm getting true as the output here because this statement is negated over here using the NOT operator, and we are getting the opposite value that we should be getting for this statement. So this is the purpose which fulfills by using the NOT operator or the logical NOT operator that we have in Python. So now that we are done with logical operators as well, let's try to understand what are identity operators. So identity operators are used to compare objects. Now you must be wondering what are objects here. So everything in Python is actually an object. So we can use the data types as objects as well. So let's try to understand what are the identity operators in Python. So we have is and we have is not. So these are the identity operators. So what is does is it returns true if both the variables are same object. For example, let's try to do this in Jupyter Notebook. So what I'll do is I'll take, let's say, a list. I'll give it some values, let's say 10, 20 and 30. I'll take one more list, give it the same values, let's say 10, 20 and 30. And I'll write x is equal to list 1. So when I use the identity operators, let's say if I write x is list 1, let's see what is the output that I'm going to get. I'm getting true because x is actually the same object as list 1. Now let's try to write list 1 is list 2. even though when we have used the same values in list 1 and list 2, let's see what the output will be. It is false because these are not the same objects, right? Similarly, I can use list 1 is not list 2. So here I'm going to get the output as true because list 1 is not exactly list 2. Even though we have the same values, it is not going to be the same object. So this is the concept about the identity operators. Now let's talk about the next one that we have is membership operators in Python. So membership operators are used to check if a sequence is present in an object or not. Now to understand the difference between an identity and a membership operator, okay, let's first understand what are the operators in membership operator. We have in and then we have not in. So it is going to return true if a sequence with the specified value is present in the object, and it will return true if the sequence is not present. So let's do this in Jupyter Notebook. We have already specified these objects. So let's try to do if x in list 1. Let's see what happens. It is going to show me that it is false because we have no values in x. So when I do the same thing with list 1 in list 2, now you see we have the same values over here. Let's see what the output will be. It is false again. Okay, let me do one thing. Now to check a particular value or a particular sequence, what I'm going to write is, I'll check if 10 in list 1. So it is going to check if this is going to be present over here or not. It is showing me that it is true. So what if I write like this, 10, 20, 30 in list 2? It is false. So this is the basic difference between is, that is an identity operator, and membership operators. So when I write, let's say, it is going to check if this is present in the sequence or not. It is showing false because it is not there. But what if I add this value over here? Let's say, now when I execute the same statement, I'm getting true because this sequence is actually present in the object. Now to understand the difference between is equal to and the identity operator, let's see what is going to happen. What if I write list 1 is equal to list 2? It is showing false. I have made a change over here. So I'll do this once again. So when I print this, it is showing that it is true. But instead of is equal to, if I write is over here, it is going to show me false because these are two different objects. So this is the basic concept of identity and membership operators, guys. Now let's understand bitwise operators. So bitwise operators are used to compare binary values or binary numbers. So this is a rather difficult concept, guys. So I'll be telling you about what are binary numbers first, and then we'll be moving on to the bitwise operators that we have in Python. So these are the bitwise operators like bitwise and, bitwise or. So these are the symbols used for these operators, guys. So this is actually what happens when we are using these operators. So let's try to understand bitwise and operator first in Jupyter Notebook. So what I'm going to do is I'll just write 10 and 12. So what is going to happen over here? Let's say it is showing me the output as 8, but it is not clear why we are getting this output, right? So let's understand what 10 is in binary numbers. So when I write 10 in binary numbers, it is going to be 1010, and similarly for 12 it is going to be 1100. Now when I use the logical AND operator, what it's going to do is if both the bits are 1, it is going to be 1. So in this case only first bit is 1 over here, so the output will be 1000, and if we convert this to decimal, it is going to be the number 8. So this is the concept between the binary numbers, guys. Similarly, I can use 10 or 12. So what is happening here is I have these values, let's say 1010 for 10 and 1100 for 12. Now looking at first bits here, that is 00, it is going to be 1. So all of these bits in the output will be 1111, which is exactly is equal to 14. So this is the concept of using the bitwise operators, where we are using the values as binary numbers. We are comparing the binary numbers. Now let's talk about left shift and right shift, guys. So this is what I write for doing the right shift. So 10 in binary numbers is 1010. So when I right shift these two bits, I'm going to be left with 10. And when I convert this to binary, I'm going to get the value as 2. So this is the concept of right shift, guys. Now let's try to understand left shift. So when I write this, I'm going to get the value as 40. Now let's try to understand how I am getting this value. So 10, if I write it in binary, is going to be 1010. So when I do the left shift, what is going to happen is it is going to shift two values, and I'm going to get the value as 101000. So what is happening here, if I convert this binary number to decimal, I'm going to get the value as 40. So this is why I'm getting the value 40 over here. So this is the concept of bitwise operators, guys. I hope you're clear with the concept of bitwise operators. It is a bit complicated because we are using the binary numbers. Even though I'm telling you these binary numbers, you need not mention them while using the operators. For example, for these bitwise operators, all these are written over here. Let's say if you're using the bitwise AND operator, it will set each bit to 1 if both bits are 1, as I've shown you. And then for bitwise OR operator, it is going to be 1 if one of the bits is 1. So similarly for XOR, it will set each bit to 1 if only one of the bits is 1. And then we have bitwise NOT operator, which is going to invert all bits. Let's say if we have all bits that is 1, it is going to convert all those bits to 0. And then I've told you about left shift and right shift as well. So this is about operators in Python, guys. A tuple is an immutable data type in Python, and it is almost similar to a list in Python in terms of indexing, which means we can access the elements of a tuple using indexes, and they can also have duplicate members just like a list as well. And it is a collection data type that stores Python objects separated by commas. And let me show you an example which will explain how we can create or declare a tuple in Python. So let's take it up to Jupyter Notebook, guys. As you can see, now we are in the Jupyter Notebook, and I have a file named tuple in Python over here. So I'll just show you how you can declare a tuple in Python. So I'll just take a variable here, and inside this, let me get a few values inside round brackets. So I'll just go with 1, 2, 3, 4, and 5 because this is a very basic example, guys. And when I print A over here, this is my tuple, guys, which is separated by commas and inside the round brackets. But there is one more approach to this where you can actually declare a tuple like this. So you simply have to mention some values separated by commas, and when I print A again, I'm getting the same value as I was getting before. So I can follow both of these approaches to actually declare a tuple in Python. So this is how we can create a tuple in Python. Let's take a look at the next topic that we have, which is accessing elements in a tuple. So accessing items in a tuple works similar to a list, and we can access elements in a list using indexes. And we can specify the index value, and it will return the item that is stored at the particular index value. Now, talking about indexing, it is a data structure technique to effectively retrieve the information from a data structure. And in Python, several data types support indexing like list, a string, etc. So what happens is, let's see, for example, we have a tuple with 5 natural numbers that have 1, 2, 3, 4, and 5. So the indexing will start at the value 0, where 1 will be stored, and it will go until the end of the tuple, that is the number 5, and the index value at number 5 will be 4. So in Python, we can use the negative indexing as well to access elements in a tuple or any other data type that supports indexing. So let me take it up to Jupyter Notebook, guys, and I'll show you how you can use the index values to access elements in a tuple. So we have A over here. So inside the square brackets, I'll just specify the index number. Let's say 4 over here because we have 5 elements. So it should ideally, give me the value number 5. Okay, I have an index error which says index out of the range because we have only 3 values over here. So I'll be getting to this also, like reassigning the values to a tuple. So I'll just write 2. Now I'm getting the value 30 over here because in my tuple, that is the variable A, we have values 10, 20, and 30. So the index number at 10 will be 0. So similarly, at the element number 30, we'll have the index value as 2. So we're getting this output. Now talking about negative indexing. So if I write -1 over here, what will be the value I should be getting? I'm getting the same value as 30. So when we talk about negative indexing, it will start with 30. So the negative index -1 will be at 30. And for 20, it will be -2 and similarly -3. So this is all about negative indexing. Now let me talk about slicing, guys. So slicing is basically a technique in which we use the slicing operator, which is colon, and it is used to get a range of elements from a tuple or any other data type that supports indexing for accessing elements. So let me just show you an example. This time I want the variable to be distinct, and I'll just specify the numbers as, let's say, okay, these numbers from 1 to 9. So when I print this, I have a tuple which has values ranging from 1 to 9. Now talking about slicing, it works similar to indexing only. It's just that we'll have to add that slicing operator. So I'll start at the index number, okay, 0, and then I want to go until the end of the tuple. So when I print this, I'm getting all the values inside the tuple. So in this tuple, the ending index is basically 8. So I'll just write 8 over here. And we are getting the values until the index number 8. So you can see that number 9 is not included here. So when you're doing a slicing operation, the index number that you write after the slicing operator will not be included in the out. Similarly, we can use the negative indexes as well. I'm getting the same values, and I can use values like these also. So I'll just write -8. The output is the same. So this is all about slicing, guys. Now let's take a look at the next topic that we have, which is changing a tuple. So even though tuples are immutable in nature, but a nested object in a tuple can be changed, or in general, a tuple in Python can be reassigned with a different value. So I'll just show you the example how we can do that. So talking about the Python nested objects, let's say I have a tuple which has values 10, 20, 30, and inside this I have a list as well which has values 40, 50, and 60. So this is my tuple. When I print A, my tuple looks like this. So the first 3 elements in the tuple are 10, 20, and 30, and then the 4th element is basically an object which is a list. Now what I'll do is I'll try to reassign the values inside the tuple. So I'll go to the 3rd index, which is the list, and inside the list I want to change the value that is 50 to, let's say, 55. So I'll just specify 1 over here and I'll write 55. And now when I print this, as you can see, I have actually changed the value inside the list, guys. Now let me try to do this with other elements. So let's try to change 30 to 35, let's say. So I'll specify the index number 2. Let's say I'll write 35. I'm getting a type error which says tuple object does not support item assignment. So it's basically a way around this error that we will get, like the type error if you are trying to change an item inside a tuple. But for these objects, the nested Python objects, you can actually reassign the values very easily. Now let's take a look at the next topic that we have, which is concatenating 2 tuples. So it might sound a little overwhelming, but joining 2 tuples is a very easy task. So you just have to assign the addition of the 2 tuples to another variable, and it will return the concatenated tuple with the values of both tuples. So let's say you have a tuple with the variable A, and then you have another variable B with another tuple. So what you'll do is you will just assign one more variable, let's just say C, and inside this you can do the addition of both A and B, and you'll get the resultant as a concatenated tuple. So I'll take it up to Jupyter Notebook and I'll show you how you can do this. Okay, we already have A and B. So I'll just take one C variable, and inside this I'll just do A plus B, no errors, and I'll try to print C now. As you can see, I have both A and B inside one tuple. So I have actually concatenated both the tuples inside one tuple. So this is how concatenation works with tuples, guys. So now let's take a look at the next topic that we have, which is deleting a tuple. So being an immutable data type, a tuple in Python does not allow any changes, and you cannot even remove an element from tuple after the declaration. But there is a keyword which is del, and which will delete the whole tuple altogether. So I'll just show you guys. So we have a tuple C over here, which is the concatenated tuple. So I'll try to delete this. I'll just write del C, no errors. Now when I try to print C over here, it's not there because we have deleted the whole tuple over here. So this is how deletion works with a tuple, guys. You cannot delete just one element from a tuple. Instead, you can delete the whole tuple altogether. So let's just go to the next topic, which is tuple methods. So there are not many methods like list or other data types that we have in Python. There are basically a count method and an index method. So count basically returns the count of the items, and index will return the index of the item specified. So let me show you this with an example. So let's just say I have a tuple named A, and inside this I have values, let's just say 1, 1, 1, 1. I have written 5 ones over here because we can have duplicate items inside a tuple. And let's just say 2, 3, 4, and 5. No errors. Now when I print my 8 here, I have this tuple. Now to show you how you can use these methods, you just write a dot count, and inside this I'll just write 1, and it will return the number of times 1 has been written inside the tuple, which is 6. Similarly, the next method that we have is index. So to check the index value at a particular element, I'll just write 5 over here and it will return the value of the index at that particular element. But what if there is a duplicate member? So I'll just write a.index. I already know that 1 is written multiple times inside the tuple. I'll just write 1 over here. So it's going to return 0 because it will return the index value of the first item that is being encountered. Even though we have the count as 6 for the element 1, it will give the index value as 0 only. So this is all about the tuple methods. Let's take a look at the next topic that we have, which is list versus tuple. So I'll give you a few different points. So first of all, a list is used for homogeneous data types and a tuple is generally used for heterogeneous data types. A list is mutable in nature and tuple is actually immutable in nature, which helps in faster iteration as well. So tuple is basically faster when it comes to iteration, like you're working on for loops or any other loops for iteration statements. So if you're using any iteration statements, tuple is much faster than a list. And a list does not have any immutable elements, but immutable elements can be used as a key for a dictionary while we are using a tuple. Last but not the least, we have no guarantee that the data is write protected inside a list. But if you're using a tuple, implementing a tuple with data that does not change guarantees that it is write protected. So these are a few basic differences between list and tuple. So let's take a look at the next topic that we have, which is the tuple constructor. It is possible to create a tuple using a tuple constructor as well. I have shown you the two different approaches you can follow to create a tuple, but there is a tuple constructor which we can use to actually create a tuple. So let's take it up to Jupyter Notebook again. I'll show you how you can use the tuple constructor. Okay, let's just say we have a list, guys, and I have these values 1, 2, 3. So this is my list, and when I print my list over here, I have the values 1, 2, and 3. So using this tuple constructor, I can actually change the list into a tuple, guys. So when I run this, no errors. Now when I print B over here, it will have all the elements inside the list, but this time it's a tuple. So we can actually use a tuple constructor to change a data type for typecasting, and it can be used to create a tuple as well. So this is all about tuple constructor. Let's take a look at the next topic, which is a few other examples. So I'll be showing you two examples, which is iterating through a tuple and a membership test on a tuple. So let's take it up to Jupyter Notebook. First of all, I'll iterate through a tuple. So let's just say I have a tuple, guys, with a value until 9, and let's say for I in A, print I. So this is how you can iterate through a tuple using a for loop, or you can use any other loop as well. And this is a very basic example. Let's take a look at the next example, which is a membership test. So for the membership test, you can use the membership operator, which is in, and in Python we can check whether an element is present in a tuple or not. So the following example is going to show you how you can check if an element is present in a tuple or not. So we'll use this A only. So let me just try to print this A. Okay, we have the same tuple. I'll just print it basically. So I'll check 9 in A, which is true, and I'll just try to check if 10 in A, which is false, and I'll check if a string in A. And I forgot to tell you guys, it's not necessary that you have to use the integers only. You can use the string or any other data type inside a tuple, like we have used the list data type as well.
A set is basically a data structure, guys, which is a collection of unordered elements. All elements in a set are unique, which means every element is present just once. Now these values can be of any data type, but they are not indexed. And because of this, you cannot perform indexing operations such as slicing on sets. So now that you know what are sets, let's move on and see when to use sets in Python. Sets can be used when the order of data actually does not matter, but the only concern is your data elements need to be unique. So now let's move on to see how to create sets in Python. To create sets in Python, you can use two methods. The first method is to use the curly braces and the second is to use the set constructor. I have a small example where I've created a set A using curly braces and a set B using the set constructor. Now let's move on towards our Jupyter notebook and create some sets in Python. The first thing I'm going to do over here is change the name of my notebook. You can give any name of your choice and rename it. Like I've already told you, you can create sets in two ways. The first to use curly braces and the second to use the set constructor. Let's just create some sets using both these methods. I've created a set A using curly braces and then I've specified some random values to it. You can also notice that all these values are of different data types. After that, I've created a set B using the set constructor. This set constructor has converted a list of values into a set. Hope you're clear with how to create sets. Now let me just show y'all how to create an empty set using the set constructor. All you have to do is give some name to your set, say for example C, and use the set constructor without passing any values to it, and hit run. Now when you print this set, you can see that the set is empty. It has returned an output which is an empty set. So I hope you're clear with how to create sets in Python. Now let me just show y'all what are all the methods you can use along with sets. To do so, you can use the dir method and supply the name of the set as a parameter to it. When I used dir and passed a as a parameter, which is a set that I've already created, it has returned a number of methods as its output. So all these are the methods you can use along with sets. Now let's get back to our presentation and see what are the operations we are going to perform in this session today. First of all, we'll be finding the length of a set and accessing its elements. After that, we'll be adding or updating elements of a set and then removing and deleting elements from it. Following that, we'll perform the mathematical operations that are union, intersection, and difference of sets. Now let's move on towards the first operation of this session, which is finding the length of a set. To find the length of a set, you can use the len method. The length of a set is the number of elements that are actually present in that set. And this len function will return an integer value which is equal to the number of elements present in the set. I have a small example where I've created some random set with the name mySet and I've passed some values to it. After that, I've used the len function and passed the name of the set as a parameter. Now let's go to our Jupyter notebook and see what happens when I do this. I've already created set A, B, and C. I'll just reprint my set A over here so that it's easy for us to refer to it. Now let's find the length of A. When I used len of A, it has returned 7 as the output, which is equal to the number of elements present in my set A. Now let's get back to our presentation and see how to access elements of a set. Since sets contain unordered elements, you cannot use index values to access its elements, but you can loop through it to access the elements of a set. I'll just jump onto my Jupyter notebook and show you all how to access set elements. I'll reprint my sets A and B over here. I've used the for loop to access the elements of set A. All I've done is for every element present in A, print that element. And as you can see in the output, all the elements present in A have been returned one after the other. Now let's get back to our presentation and see how to add elements to a set. To add elements to a set, you can use either the add method or the update method. Now this add method will allow you to add a single element to your set. But the update method will allow you to add a list of values to your set. I'm going to be showing you all how to use both these methods in this session. So here is my Jupyter notebook. When I use the update method, I've passed a list of values to be added to the set C. But here, I've passed 3 again, and 3 has been added just once, and it's not been repeated again. This is because sets contain unique elements and there is no second copy of one element present in a set. So I hope you've understood how to add elements to a set. Now let's move on to understand how you can remove elements from a set. To remove elements from a set, you can make use of the remove, discard, or the pop methods. The remove method takes one parameter, which is the element to be removed from your set. Now, in case that element is not present in the set, this method is going to throw an error. The question is, what if you're not sure if some element is present in your set or not, but you want to make sure that this element is not present and your program does not throw an error? In this case, you can use the discard method. The discard method takes one parameter, which is the element to be removed, and in case that element is not present in the set, this method will not throw any error. Now moving on towards the pop function. The pop method removes a random element from your set. Now let's get back to our Jupyter notebook and use these methods. I'll reprint all the three sets over here. First, I will use the remove method. I've used the remove method and I've specified 2.4 to be removed from the set A. When I print the set A, 2.4 is no more present in my set. Now let me try to pass some value that is not present in the set A. When I use a.remove6, which is not present in the set A, it has thrown an key error, and it's specified that 6 is the key which is not present in the set A. So I hope you've understood how to use the remove method. Now let's use the discard method and see what happens. When I used b.discard3, it has removed 3 from the set B. Now let's try to give some parameter to the discard method which is not present in set B. When I used b.discard90, it has executed but it has not thrown any error. So I hope you're clear with both these methods. Now let's try to use the pop method. When I used a.pop, it has popped some random value from the set A and it has returned it as the output over here. 1 is no more present in the set A. So I hope you're clear with how to add and remove elements from a set. Now let's move on to our presentation and see how you can find the union of sets. Union of sets refers to the concatenation of two or more sets into a single set. But in case you have any common values in these sets, the resulting set will contain just one copy of the common element. You can perform the union operation in two ways. One is using the pipeline symbol and the second is using the union method. I have a small example where I've created a set A and B and then I've used the pipeline symbol and the union method to find the union of these two sets. Let's go to our Jupyter notebook and see how this works. I'll reprint my sets A, B, C over here. I've used the pipeline symbol to find the union of A and B. All the elements that are present in A and B has been returned as a new set which is the union of A and B. But the common element are just printed once. Now let's see how to use the union method to perform this operation. I've used the union method to find the union of A and B. Now let's try to find the union of three sets using both these methods. As you can see in the output, I've used the pipeline symbol to find the union of three sets and then I've used the union method to find the union of A, B and C. So I hope you're clear with this. Now let's get back and see what is intersection of sets. The intersection of two or more sets is the formation of a new set consisting only of the common elements that are present in all these sets. You can perform this operation in two ways. One is using the ampersand symbol and the second is to use the intersection function. I'll be showing you all how exactly to do this on our Jupyter notebook. I've used the ampersand symbol to find the union of A and B. And you can see over here the elements that are common between the set A and B are 4 and ABC, hence the output. Now let's try to use the intersection function. I've determined the intersection of A, B and C using the intersection function, and the resultant is a string which is present in all these sets. So I hope you're clear with both these methods. Now let's get back to our presentation and see what is the difference of sets. The difference of sets produces a new set which contains all the elements that are present in one set except the common elements. To make you all understand this concept clearly, let me jump on to my Jupyter notebook. To find the difference of set, you can use either the minus symbol or the difference method. First over here, I'll be using the minus symbol. When I found the difference of A minus B, I've got all the elements that are present in A, but not the common elements of A and B. When I used B minus A set has been returned which contains all the elements of B except the common elements of B and A. So I hope you're clear with what is the difference of sets. Now let's use the difference method to do the same. I've used the difference method to find A minus C. And as you can see, all the elements present in A but not the common elements of A and C have been returned as my output. You can use the difference method to find the difference of 3 sets as well. When I found the difference of A minus B minus C using the difference method, only one element has been returned which is present in A and not present in B and C. Hope you're clear with this. Now let's move on towards our final topic of this session, which is the concept of a frozen set. A frozen set is a set whose values cannot be modified, which means when you freeze a set, it becomes immutable. To create frozen sets in Python, you can use the frozen set method. As you all know, I've created a set A. Just make a note, guys, that you cannot add or remove values from a frozen set. As you all know, I've created a set A, which is a normal set, and I've been using it to add and remove values from it. Now let's freeze this set. I've created a new set D, which is a frozen set, and I've supplied the values of A as a parameter to this frozen set constructor. Now let's see what happens if I try to add some values to this frozen set. When I used d.add3, it has returned an attribute error, which says frozen set object has no attribute add. Therefore, frozen sets are immutable, and you cannot change the values present in the frozen set. Frozen set helps to serve as a key in a dictionary.
So what is a dictionary in Python? It is a collection data type just like a set or a list, but there are certain features that makes dictionary unique. So let's take a look at the features of Python dictionary, guys. First of all, it is unordered and we can change values in a dictionary as well since it is mutable. Also, it has key value pairs, which is like a map that we have in other programming languages, and it is indexed as well since the keys are distinct and can be used as indexes to access or change any values in the dictionary. A dictionary does not have any duplicate members as well. Now that we know what dictionary in Python is, let's talk about why we use a dictionary in Python. First of all, the reason would be it is unordered and stores data like a map. So it is one unique feature that Python dictionary has, and it also contains the key value pairs unlike any other data type or object in Python. It is almost similar to a real life dictionary where we have distinct values, and corresponding to these values, there are respective definitions. In case of the dictionary, even though there are no duplicate members, we can mention duplicate members in the values, but the keys has to be unique in order to access these members, since there are no indexes. Also, we use the keys as indexes when accessing these elements. Let's try to understand how we implement a dictionary in Python. So first of all, to declare a dictionary in Python, we have to use the curly brackets, just like you can see in the example here. I have the dictionary with the name my dictionary, and inside those I have the key value pairs inside the curly brackets. So let's take it up to PyCharm, guys, to understand how we implement a dictionary in Python. Let's enter the presentation mode, guys. So we will try to implement a dictionary here. Let's take the name of the dictionary as A, So inside the curly brackets, I can give the key value pairs. So I'll give 1 as my first key. So when I am specifying the key value pairs, I have to use the colon to separate the key from the value. Now I'll give one value over here. Now when we are declaring a dictionary, we have to separate these key value pairs with a comma. Now I'll give another key, give it a value, let's say data science. I'll give one more key and give it a value, let's say Python. So this is my dictionary, guys. This is how you actually implement a dictionary. I have declared a dictionary over here. Now let's try to understand how I'm going to access these elements. So I'll just write A. Inside the square brackets, I'll specify the key value. So I'll put it inside a print statement, guys. Now as you can see, when I run this, I will get the value that is specified in the first key value, which is Edureka. Now I can simply just print all of my dictionary, guys. So this is how I'm going to get the output as when I print the dictionary that I've just specified. Now to access these elements, I can also use the get function. And inside the get function, I'll just specify the key value. And when I run this, I will get the same output as I was getting using the square brackets, guys. So this is how you access elements inside the dictionary. Now I can also replace values inside the dictionary, guys, since it is mutable. So instead of data science, let's say I want machine learning. So what I'll do is I'll just specify the key value and I'll specify the value that I want to replace it with. Now when I print this, you will see the replaced value inside the dictionary. As you can see here, I have replaced the value inside the dictionary, guys. Now if I want to add one more value inside a dictionary, what I'm going to do is I'll just specify the key value, that is, let's say 4, because we don't have 4 over here. So instead of machine learning, I'll add the value data science that I have just replaced. Now when I print my dictionary here, let's see what all values I will get. I will get one more value that I have just added, which is data science. So this is how you actually implement a dictionary, guys. And to access these values, you can either use the square brackets, and inside those square brackets you can specify the key value, or you can just use the get function. And inside the get function you have to specify the key value as well. So now that we have understood how we can implement a dictionary in Python, let's try to take a look at the operations that we have in Python dictionary, guys. So as I have already told you how you can actually add an element to your dictionary, just like this. I have specified a key value and given it a value, and then there is a replacing element which I have already shown you, guys. So these are all the operations that we have in Python dictionaries. So we will look at them one by one, guys. So let's take it up to PyCharm and understand these operations, guys. So we'll once again enter the presentation mode. So we have a dictionary over here, guys. So first of all, let's talk about clear. So when I use the clear, what it's going to do is it is going to remove all the elements from the dictionary. So when I run this, so I have a dictionary, guys, that I've already specified. So let's try to print the dictionary first, so you will understand what all these operations are going to do. So I have this dictionary which has these values. All right, so I'll do one thing. I'll use the first operation, that is clear. Let's see what it does to our dictionary, guys, when I run this. Okay, so now when I print my dictionary, let's see what all values I'll get. It is saying that it is empty because the clear function has actually deleted or removed all the elements from the dictionary. So this is what clear does, guys. Now let's take a look at the another one which we have. Also, I would want to declare this dictionary once again, and when I print this, I should be getting all these values again. Yes, I'm getting these values. So it would be fine if I do one more thing. So I'll just use the copy over here. So what copy does is it returns a copy of the dictionary, guys. So let's say when I print B over here, what is going to happen? It is going to show me the copy of this dictionary that I've just specified over here using the copy function. So let's take a look at the next one we have, which is the values. So when we are using the values function, what it's going to do is it is going to return all the values inside the dictionary, guys. So when I run this, it will print all the dictionary values inside a list, which is Edureka, data science, and Python. So we'll look at the next one we have, which is the update function. So what does update function do? Update function actually updates the values of the dictionary with the specified key value pairs. So let's say if I use update just like this, what will happen? We have no updates, which it is showing that we haven't updated anything. So this is what update does, guys. If we have made any updates, it will update the changes into the dictionary. So we'll look at the next function that we have, which is actually get function. I've shown you how to use the get function. We'll just use the get function to get the values, and inside this I just specify the key value, and it will return the value with the specified key, which is actually Edureka. So this is how you actually access the elements using the get function. Next one is the items function, guys. So I'll just use items over here, and inside this I will get the list for a tuple of each key value pair, guys. So let's run this. So when I run this, I'm getting tuple of each key value pair. As you can see over here, I have 2, then I have the value, then I have one more key. So this is a tuple of each key value pair, which we can get using the items function. Now coming back to the next one that we have, which is the keys function. So what it will do is it will actually return all the keys inside the dictionary that we have, which is 1, 2, 3, guys. So this is all about keys function, guys. So let's talk about the pop function, guys. So when I use the pop function, what it will do is it will actually pop the value with the specified key. So I'll just pop this from the dictionary with the value 3. So as you can see, I'm getting that value over here, guys. Now let's take a look at the next function that we have, or the operation, which is pop items, guys. So when I'm using the pop item function, I can actually remove the last inserted key value pair. So I don't have to specify any values over here. As you can see, I'm getting the tuple of the last key value pair I have specified inside the dictionary. So this is what pop item does. Now the next function that we have is set default, guys. So what set default does is it returns the value of the specified key. If the key does not exist, we can insert the key with the specified value. So I'll specify the value over here, let's say 1. Now when I print this, I'm getting Edureka as well. So when I specify the next key, it is showing me, okay, it's a syntax error. I'm getting the next value. So this is what set default is used for, which returns the value of the specified key, guys. So this is all about the operations that we have in a dictionary, guys. There is one more thing to discuss about the dictionary, guys, which is the dictionary constructor. So the dictionary constructor is actually used to declare a dictionary, guys. So let's take it up to PyCharm again. So I'll show you what a dictionary constructor does. So I'll use I'll use my dictionary as my variable dictionary name, and I'll use the dictionary constructor over here. I'll specify the values. So what I'm going to do is I'll just specify the values. I will use the keys as, let's say, key 1 only, and then I'll give it a value, let's say Edureka. Now I can give another key value, let's say 2, and I'll give it a value, let's say Python. Now let's see if I can get a dictionary from this. So using the dictionary constructor, let's see if we have actually implemented a dictionary over here. So as you can see, I have declared a dictionary using the dictionary constructor, guys. So when I run this, I should be getting a dictionary here. So as you can see, I have declared a dictionary using the dictionary constructor. Also, one more thing I have missed over here when I was explaining the operations, guys. So which is the from keys operation. So I'll declare one more dictionary over here. Give it a value, let's say 1, 2. I'm giving it a random values, guys. Don't be alarmed. Now when I'm using the from keys keyword, what I do is I'll just say a dot from. Okay, we don't have a over here, so I'll write a from keys. I'll specify my dictionary over here. So let's see what happens, guys. Okay, I'll just use the print statement, and inside this I will use the from keys, and inside this I'll specify my dictionary. Let's see what happens when I run this. So I'm getting a dictionary with the specified keys and values. So as we don't have any key 1, key 2 inside this, so we are getting the none value over here. So this is what from keys does inside a dictionary, guys. So now that we have actually learned what is a dictionary and how we can implement it in Python and all sorts of operations that we can perform on a dictionary, let's try to understand what are nested dictionary, guys. So for this I have a problem statement, guys. So now that we know that ICC Cricket World Cup is just around the corner, guys, so what we'll do is we will implement a dictionary with the stats of the 15 members from the Indian cricket squad for the World Cup 2019, and we will use the concept of nested dictionary in the use case. So what we'll do is we'll implement a dictionary first, and then we will make the unique keys to access those values when we are actually getting the elements from the dictionary, and then we will store the data inside the dictionary, and we will also import a pandas package and convert those data into a data frame for better display statistics. So let's take it up to PyCharm, guys. So okay, let's exit the presentation mode. So over here I have the value or the dictionary that I've implemented. So let's take it up to presentation mode again. So as you can see, I have this module that I have actually imported from Pandas, and I've given it an alias as PD. So we'll talk about this later. So this is my dictionary, guys, in which I have made 4 more dictionaries, guys, which is actually our nested dictionaries. So first key is batsman. Inside the batsman key, I have all those batsmen like Rohit Sharma, Shikhar Dhawan, and Virat Kohli. And inside those values, I have one more dictionary in which we have the statistics for all those matches, runs, average, highest score. So actually inside this batsman key, I have 2 more dictionary, guys. So this is the concept of nested dictionary. So similarly, I have made it for all rounder, and we have wicket keepers and bowlers as well. So this is my dictionary, guys, that I have actually stored all the data using the dictionary, or as you can say, nested dictionary. And then I have all these statements that I have written in which I have converted the data inside the dictionary into a data frame, guys. So I have this print statement. So first of all, let me print the batsman squad, in which we will get the values for all the batsmen that we have inside the World Cup squad. So as you can see, I'm getting a data frame over here. So I have these values. We have Rohit Sharma, Shikhar Dhawan, and Virat Kohli. So as you can see, we have average, highest score, matches, and runs over here. So for Virat Kohli, we have more than 10,000 runs. Shikhar Dhawan has 5,000 runs, and Rohit Sharma has around 8,000 runs, guys. So let's try to understand more from the dictionary that I have just mentioned over here. We have got all the batsmen now. We will try to get all the bowlers. So I'll just print this statement, and it will show me all the bowler statistics, which is Kuldeep Yadav, Mohammad Shami, Bhuvneshwar Kumar, Yuzvendra Chahal. So we have all these statistics in which we have average, we have best figures, then we have matches and wickets as well. So as you can see, we have Bhuvneshwar Kumar with the most wickets, which is 118 wickets, guys. So this is what you can actually do using the nested dictionaries, guys. As you can see, this is an unordered data, but we have key value pairs, which actually helps in retrieving the data very easily, guys. So let's say inside bowler, I want Jasprit Bumrah, or for all-rounder, I want Hardik Pandya. All these statements, I can use it for getting all those values inside a data frame.
Now, what are loops? Loops basically allows us to execute a statement or a group of statement multiple times. Let me explain you this with the help of an example that is present in front of your screen. Now over here what happens, the control comes here and checks the condition. So if this condition is true, it will go on and execute the conditional code that is here. This is nothing but the statements that are present inside the loop. So it will execute that, and again it will go back and check the condition. So if the condition is still true, then again it will execute the conditional code of the statements present inside the loop. And it will keep on repeating until this condition becomes false. And the moment this condition becomes false, the control will move out of the loop and it will execute the statements that are present after that loop. Now one thing to notice here, guys, is that there can be 2 kinds of loops. One is finite. This is actually the flowchart for the finite loops, and another can be infinite. Now in infinite loops, what happens? The condition will never be false. So at that time, the control will never come out of the loop. So it will keep on repeating and it will never stop. That is what infinite loops are. So basically the condition will never be false, and due to that the loop will be executed infinite number of times. Now there's one more way in order to categorize loops. That is called post-test and pre-test. In post-test loops, what happens? The control will first enter the loop and then in the end it will actually check the condition. But in pre-test loops, the control will enter the loop only when the condition is true. So the condition is checked in the beginning of the loop in pre-test loops, but in post-test loop, the condition is checked at the end of the loop. Now in Python, there are no post-test loops present. There are only pre-test loops. So we'll focus on pre-test loops in today's session. So we'll move forward and we'll see various types of loops that are present in Python. So Python basically supports 3 kinds of loops. One is while, for, and nested. We'll look at all these loops one by one, and I'll explain you with examples as well. So first we'll have a look at while loop. So while loop is basically used when you don't know how many iterations are required. So let me explain you this with the help of the flowchart that is there in front of your screen. Now over here what happens, the control will move inside the loop only when this while condition is true. And when it is true, it will execute the body of the loop. And then again it will go back and see whether the condition is still true or not. If it is still true, then again it will execute the body of the loop and it will keep on doing that until the condition becomes false. And the moment the condition becomes false, it will come out of the loop and execute the statements that are present after the loop. Now this is the syntax for while loop. First you need to write while, then you write the expression or the condition, then you give a colon and the statements or the body of the loop. Now why we use while loop? Basically I've told you earlier as well, while loop is used when you don't know how many iterations are required. So you don't know how many times you need to execute the statements that are present inside your loop. So that is the reason why we use while loops. Now let me show you that with the help of an example. I'll open my PyCharm and I'll give you a very basic example of using while loop, and after that I'm going to increase the complexity of the code. So first we'll see a very small introductory example of while loop, in which I'm going to print the integer values between 0 to 9. That won't include 9, so it'll print 0, 1, 2, 3 till 9, but it won't include 9. So let me open my PyCharm and show you how to do that. Now this is my PyCharm, guys. So over here, as I've told you earlier as well, I'm going to print the integer values between 0 to 9, but that won't include 9. So for that, what I need to do is I need to first define a variable. Let me name it as count, and I'm going to initialize a value to it that is 0. Now after that, I'm going to use a while loop and I'll write while, and then I'm going to give a condition which says that when count becomes greater than 9, it should come out of the loop. Alright. So now what I'm going to do is I'm going to just type in print, let it be number, colon, comma, print count, right? Now I'm going to increment the value of count equal to count plus 1. Yep. Now when I come out of the loop, I want to print, say, goodbye. Yeah, looks fine. Now let me tell you what I've done here. I've defined a variable and I've initialized the value 0 to it. After that, I have used a while loop in which I've given a condition that says that count should always be less than 9, because I want to print values between 0 till 9, which won't include 9. Let me tell you that. So my condition says that the loop should be executed only when the count value is less than 9. The moment it becomes greater than 9, then the control should come out of the loop. After that, it's just a general syntax. I have given a colon, and then I have written a print statement that will print the count value. And after that, I have increased the value of my count by 1. And finally, when the control comes out of the loop, I want to print goodbye. So let us see whether it works or not. I'm going to run it, and as you can see that it works. So we have 0, 1, 2, 3, 4, 5, 6, 7, and 8. And finally, when the control went out of the loop, it has printed goodbye. This is just a very small example, guys. Now let me go back to my slides. Now the example that we just saw was a very simple example. So I'll increase the complexity a bit and I'll give you one more example. So let us move forward with that. So over here, what I'm trying to do is I'm trying to code a little guessing game. Alright. So what happens in this guessing game? So there will be a random number that will be generated between say 0 to 20. And you need to guess that number. So the number that you have guessed is less than that random number, then it will print number is too small. If you have guessed the number that is greater than the random number, then it will print that number is too large. And the moment you guess the right answer, you'll exit the while loop and you have won the game basically. So it's just a pretty simple example, but this is a perfect example in order to show you why we use while loop. Because if you notice here, I don't know how many iterations are required in order to guess the correct answer. So at that time, while loop is a perfect solution to this problem. So without wasting any time, I'll actually open my PyCharm and show you how to execute this. So this is the code here, guys. Let me explain you each and every line that is present here. Now what happens, first I need to import a module that is called random in order to generate a random number. Now over here I've defined a variable n and I've given a value to it that is 20. Because I want the random number that is to be generated should be between the range 0 to 20. Now I've taken one more variable and I've named it as to be guessed. And over here it should be an integer type, so I've written int, and this logic will generate the random number that I'm talking about. And this will be generated between the range 0 to 20. So how it will be generated? It will be generated with the help of random module that we have imported. So it will be n random.random plus 1. This will actually generate a random number between 0 to 20. So after that, what happens? I've defined one more variable, guess, and I have assigned a value to it or initialized the value to it 0. Alright. So now comes the while loop. Now in while loop, I have given a condition which says that the number that I have guessed, if it is not equal to the random number, then enter the loop. Now once you enter the loop, you need to input the new number, the number that you want to guess again. Now if that guessed number or the number that you are guessing is greater than 0, then again there will be one more if condition which says that the number that you have guessed is greater than the number that has been generated or the random number that has been generated, then print number is too large. And if the number that you have guessed is actually smaller than the random number generated, then print number is too small. Now there's one more condition, that is else, which means that when the number that you have guessed is less than or equal to 0, then that means you are giving up. So it'll break, it'll come out of the loop and it'll print sorry that you are giving up. That's when your game gets over and you have lost it. Finally, if you have guessed the correct number, then it will print congratulations, you have made it. So I hope you have understood the code that I was explaining here. So let us go ahead and execute this and see what happens. Alright, so it asks me for a new number. So it has to be between 0 to 20. So yep, I'll type 10 and let's see what happens. So it says number is too small. That means it is between 10 to 20. How about 13? Alright, so I've guessed the correct number and it says congratulations, you have made it. Now over here, as you can see, that it took only 2 iterations for me in order to guess the correct number. But what if it would have taken more iterations? I mean, I'm pretty unclear how many iterations it will take for me. So that is the reason why we use while loop, because we don't know how many iterations are required. Now we can run this program again and I can show it to you once more. Ask a new number, so I'll just type in say 14. It says number is too large, so I'll type in 11. Again the number is too large, that means it is between 0 to 11. So how about 8 guys? Number is too small. So now as you can see that already 3 iterations have occurred, and for the 4th iteration definitely the random number will be somewhere between 8 and 11. So how about 10? So congratulations, you have made it, and the control came out of the while loop and it has printed congratulations, you made it. So we'll move forward and see for loops in Python. So for loop is basically used when you know the number of iterations that are required. Unlike while loop where you are not sure about the number of iterations that are required, in for loop you know how many times the statements that are present inside the loops need to be executed. So for loop provides you with a syntax that will include 3 fields basically, or you can say 3 informations. So first will be the Boolean condition, then comes the initial value of the counting variable, and then the incrementation of the counting variable. So as you can see it from the syntax as well, first you write for, name of the variable, in the range. Then you specify the range in which that variable should be. And then you specify the range, that means from which point till which point it should be executed. So you know the number of iterations required, then only you use for loop. Now over here, as you can see from the flow diagram itself, the control comes to this and it'll see the item from the sequence. It'll execute the statement, go back again, and then from the range it'll pick up the next item. Again it'll execute the statement, again go back, and then from the range it'll pick up the 3rd item, and it'll keep on executing until the range becomes over, or that is the last item from the sequence. So when there are no items in the sequence, it will go on and execute the statements that are present after the for loop. So this is how for loop works, guys. Now let me just give you a very small example of how for loop works. I'll open my PyCharm again and I'll start with a very small example, and then I'm going to increase the complexity of our code like I've done that in while loop. Now over here what I'm going to do is I'm going to first define a list and I'm going to name it as fruits. So what all fruits you like, guys? I'll first type in mango, then I like grapes, and finally I'm going to write and say apple. Yep. So this is my list which contains 3 fruits, mango, grapes and apple. Now I'm going to define a for loop, And over here what I'll write, I'll define a variable, say fruit. For fruit in fruits, give a colon, print current fruit and type in fruit. Now when you come out of the loop, just print again goodbye. So I have declared a list and the name of that list is fruits. Now that fruits list contains elements which are mango, grapes and apple. Now after that I have defined a for loop which says that for a variable named fruit in fruits. So this will give me the range. Fruits will give me the range. As you know that in the fruits list there are only 3 fruits. So I know it will iterate only thrice. First for mango, then for grapes, then for apple. So this is the difference between the while and for loop. In for loop I know that it will take only 3 iterations. After that print the current fruit. That's all. And when the control moves out of the loop, print goodbye. It's pretty easy guys. So go on, execute this and see what happens. So yep, the current fruit first is mango, then comes grapes, then comes apple, and then finally print goodbye. So what I'm going to do is I'm going to increase the complexity now, as I've done that in while loop as well. So I'll show you an example. First, let me go back to my slides. So what I'm going to do in this example, I'm going to calculate the factorial. Now one thing to notice here guys, again in factorial also I know how many iterations are required. Because if you see, if I'm calculating the factorial of 5, and I know that I need multiplication 5 times. First I need to multiply 5 with 4, then 4 with 3, then 3 with 2, and then 2 with 1. So this way I require only 4 iterations. So I know the number of iterations required. So it's a very good example in order to show you where we should use while loop and where we should use for loop. So let me go back to my PyCharm and execute this practically. So this is the code in order to find the factorial of a number. So over here what happens, first I need to input the number that I want to calculate the factorial of. After that I've defined a variable factorial and I've initialized a value to it which is 1. Now I have defined a condition. If the number that I've entered is less than 0, then print the number must be positive, because I can't calculate the factorial for negative numbers, right? And again I have given one more condition which says that if number is equal to 0, then factorial is equal to 1. And then else condition says that when number is greater than 0, then I've used a for loop which says that for I've defined a variable I in range 1 to num plus 1. When I write num plus 1, the range will be between 1 to num plus 1, but it won't include num plus 1, so it will only be including 1 till num. Alright, so after that what I've written, factorial is equal to factorial into I. So factorial was 1 earlier, then it will multiply by I will also be 1 in the beginning, and then again it will go back and it will become 2. Similarly it will keep on increasing until it becomes num. So till that time it will keep on executing the loop, and the moment it becomes equal to num, it will come out of the loop and it will print the factorial value. So let me go ahead and execute this and show you if it works or not. So I need to enter the number. So let's say I want to calculate the factorial of 3, which is 6. So if I want to enter one more number, so what I can do is I can start it once more. So what I'll type, I can type again 4. So it prints 24, which is absolutely correct. So we'll move forward and we'll see what are nested loops in Python. So Python basically allows us to use a loop inside another loop. For example, you can use a for loop inside a for loop, or you can use a while loop inside a while loop. And at the same time, you can use a while loop inside a for loop as well, and a for loop inside a while loop as well. So that is basically what is called nested loops. Now we'll have a look at the example of nested loops as well, don't worry. So let us move forward and see one example of nested loops. Now over here what I'm going to do is I'm going to write a code in order to simulate a bank ATM. Alright, so for that I'm going to use nested while loop. And what will happen, first you need to enter the 4-digit PIN, and then you can perform the following functions. You can check the balance, you can make a withdrawal, you can deposit some money, and you can even, if you don't want to do anything, you can tell the machine to return your card as well. So let me show you how it is done. I'll open my PyCharm once more. So this is the code that I've written in order to simulate a bank ATM. I'll explain you each and every line, so don't worry about that. So first line is nothing but a print statement that says welcome to Iron Bank of Bravo's ATM. Alright. And then I have defined a variable restart and I've assigned a value to it, that is y. Similarly, chances, I've assigned a value that is 3, and this is the balance that I'm going to initialize, that is 67.14. Notice you over here you won't get more than 3 chances in order to write the correct password. Now comes the while loop, which says that when chances are greater than or equal to 0, at that time what it'll do, you need to enter the pin. So you need to input the 4-digit pin that you have. And if that pin is 1234, then it'll print that you have entered the correct pin. Now comes one more while loop, which says that while restart should not be in this particular tuple. That is, the value of restart should not be n, capital N-O, small n-o, or capital N. So it should not lie within this particular sequence, that is n, capital N-O, no, and n. But we know that the restart value is y, so it will enter the while loop. Now over here, what will happen? It will give you 4 options. First option is in order to check your balance. For that you need to press 1. To make a withdrawal, you need to press 2. In order to pay in some cash or you need to deposit something, you need to press 3, or you want your card back, you need to press 4. So these are the 4 options that will be given to you. So when you choose option 1, it will print the account balance. So over here, as you can see that your account balance is and the balance that is there in your account. After that, it will ask you for restart. So you need to input that value. So that will say, would you like to go back? And if your restart value lies in this particular tuple, then it will break and it will print a thank you statement. But if you want to continue or you want to go back, then you can press anything else apart from small n, no, or this no, or capital N. So if you press any other button apart from these, it will actually go back, and in the while statement, as you can see, it says that it is not present here. So it will give you all these 4 options once more. Now after that, what if you choose the another option in which you need to make a withdrawal? So for that, what will happen? You need to enter the amount that you would like to withdraw, which can be a float number. It cannot be an integer number. So that's why I've used float here. So you need to enter that value. And once you enter that value, it will check whether it is in this particular list or not. That is 10, 20, 40, 60, 80 or 100. Now by default, it will give restart y because you need to enter the amount once more. So again, it will go back and it will give you all 4 options. So you can choose that withdrawal option again, and you can choose a number which is present in this particular list. Now when you choose withdrawal equal to 1, at that time, it will again ask you, please enter the desired amount. So this is for option 2. Now when we talk about option 3, it is pretty much similar to the couple of options that we have discussed before. So it is pretty much similar to that. Over here again, whatever the amount that you want to pay in, how much amount that you would like to pay, and balance plus the amount that you are depositing. So it will print the balance that will be equal to balance plus the amount that you are depositing. Again, it will ask you for restart. If you press anything apart from this particular tuple, then it will go back to the while statement and it will give you all these 4 options. Similarly for option 4 as well. Now what happens when you enter the incorrect pin? So there's one more condition in the end which says that if the pin that you have entered is not equal to 1234, then it will print that incorrect password and it will decrease the chances by 1. So earlier you had 3 chances. If you press the incorrect pin once, it will decrease your chance and it will make it as 2. Again, if you write the incorrect password, then again it will make it as chances equals to chances minus 1, which will become 1. And if the third time also you do the same thing, then the chances will become 0. And the moment it becomes 0, then it will print no more tries, break, it will come out of the loop. That's all, guys. So let us go ahead and execute this and see what happens. So please enter your 4-digit pin. So I'll just write 1, 2, 3, 4 and it'll give me 4 options, which is 1 for balance, 2 for withdrawal, 3 for paying, 4 to return a card. So if I want to check my balance, I'll put in 1. So it has printed my balance, which is 67.14. And then the restart value that I was talking about, it is asking for that. Let me just make it big for you. Yeah. Would you like to go back? So if I press N here, it will come out of the loop and it will break. And if I press anything apart from small n, capital N-O, small n-o or capital N, it will actually go back and give me all the 4 options that were there. So if I press Y, it will again give me all the 4 options that are there. You can see that press 1. So again, if I want to make a withdrawal, I'll press 2. How much amount that I would like to withdraw? Say I want to withdraw 10. So my balance has reduced from 67.14 to 57.14. So would you like to go back? So I'll again press Y and it will give me all 4 options. If I want to pay in something, that is I want to deposit something, I'll press 3. How much amount that I would like to deposit? I'll say 10. So my balance became again 67.14. Again, it is asking me, would you like to go back? No, I don't want to go back. So I can type in N. So yep. So it says thank you. And again asking me for 4-digit PIN. So let me show you what happens if I write the incorrect PIN. Say if I write 111, incorrect PIN. If I write that PIN again incorrect, again incorrect. So we have no more tries. It'll come out since I've exceeded the chances that I was given. So I was given 3 chances. I couldn't write the correct PIN in those 3 chances. So it'll come out of the loop and it'll stop. So this is an example of nested while. Now let me go back to my presentation and I'll show you an example of for loop as well. So this is an example of nested for loop. So over here what I'm going to do is I'm going to write a code in order to print the Pythagorean number between a particular range. So what happens is, suppose if I want to enter the number 20, that means I want the Pythagorean numbers between 1 to 20. So Pythagorean numbers are nothing but the integers which satisfy a square plus b square is equals to c square. So at that time it will print all the Pythagorean numbers that are possible between 1 to 20. 3, 4, 5. You can see that 3 square, 4 square is equals to 5 square. 9 plus 16 is equals to 25. Similarly it goes for 5, 12, 13, 6, 8, 10, 8, 15, 17, 9, 12, 15. Similarly for 12, 16 and 20. Don't worry guys, I'll go back to my PyCharm and I'll explain you how you can do that. So this is the example of nested for. So first over here I need to import certain modules in order to use the square root function. So from math module I'm going to import the square root function. After that it'll ask me for the number. In the example, if you can remember in the slides where I've written 20, so it has printed the Pythagorean numbers between 1 to 20. That same number it will ask me and it will print the Pythagorean numbers between 1 to n. So whatever the number n that I'm going to put in or give an input. After that it will run a for loop and it will say that for a, which is a variable, in range 1 to n plus 1. That means 1 to n. That means 1 to n plus 1, but don't include n plus 1. After that there's one more variable b which is in the range a comma n. That will not include n. It will only include till n minus 1. So the square root c square, I've defined one more variable c square is equal to a exponent 2 or a to the power of 2. Similarly b raised to the power of 2. Alright, and then what I'm going to do is I'm going to calculate the square root, and then what I'm going to do is I'm going to define one more variable c and it'll be an integer that will be the square root of c square. So if that c square is minus c square is equal to 0, then print ABC. It's pretty simple logic guys. Okay, I'll explain it once more, Neil. So this is an example of nested for. So over here what I'm going to do is I'm going to first import the square root function from the math module. After that I'm going to input a number. So if you can remember in the slides I've given it as 20. So it will print the Pythagorean numbers between 1 to 20. Over here also it will print the Pythagorean numbers between 1 to n. So whatever the value of n you input, that will be depending upon it. So the Pythagorean numbers will be depending upon the values that you input. So it will be printing the Pythagorean numbers present between 1 to n. After that I'll run a for loop which says that for a should be in the range 1 to n plus 1. That will not include n plus 1 guys. It will only include n. So 1 till n plus 1, but don't include n plus 1. After that I've defined one more for loop which says that for b in range a comma n. It won't include n, it will be till only n minus 1. I've defined one more variable here which is equal to c underscore square. That is equal to a square plus b square. Now after that I've defined one more variable c, and this will be actually the integer of the square root of the c underscore square. Alright, so whatever value that you will get here, the square root of that value will be converted to an integer value and will be assigned to c. Now one if condition I'll be using here which says that if c underscore square minus c square is equal to 0, then print ABC. That means that will be a Pythagorean number. So this is a pretty simple logic, guys. If you have understood it, just give me a thumbs up, or you can ask me any questions that you have in your mind. Alright, so I hope you have understood the code that I've explained to you here. Now let us go ahead and execute this and see what happens. Yeah. So the first number that I'm going to type in, say 5, and it'll give me all the Pythagorean numbers present between 1 to 5. So we have only one Pythagorean number, that is 3, 4, 5 in that range. Now I'll execute this once more and I'll type in 10 here. So we have two Pythagorean numbers that are 3, 4, 5 and 6, 8, 10. Similarly, if I execute it once more and I type in a big number, say 25. Yeah. So we have these many Pythagorean numbers present between 1 to 25. We'll again go back to our slides and we'll have a look at one more example. Now in this example, I'll actually be using a for loop inside a while loop. So what is this example? I want the bulk reservation of train tickets. So I have like group of people who are traveling somewhere and I want to give their details such as name, age and sex. I want that to happen in bulk. I don't want to give it one by one. I just want it to happen in bulk. So for that, what I'm going to use is I'm going to use a for loop inside a while loop. As I've told you earlier as well, you can even use a while loop inside a for loop. But for now, I'll use a for loop inside a while loop and see what happens. So let me go back to my PyCharm. So this is the code in which I'll be using a for loop inside a while loop. So first I have defined a variable traveling, so in which you need to input whether yes or no. So if you're traveling, you'll say yes, obviously, and then we'll have a while loop which says that while the condition is traveling equal to yes, that means if you're willing to travel, enter the number of people who are traveling. So you need to enter the number of passengers that are traveling, and that will be assigned to a variable num. Now there'll be a for loop which says that for num in range 1 to num plus 1, but it won't include num plus 1, enter the name, enter age, and finally whether the person is male or a female, and then print all those values. Now one more thing here is, again it'll ask you whether you have missed someone or not. So you need to input that. Oops, forgot someone. So at that time you can write in yes if you have forgotten someone. Then again it'll execute the loop. Again it'll ask you the number of people traveling and all these details. If you type in anything apart from yes, that means you have not forgotten anyone, and it'll come out of the loop. So it is a very small example, but a very good example to understand how for loop can be used inside a while loop. So let me go ahead and execute this. Whether you're traveling, I would say yes, I am traveling. Number of people traveling, I would say 3. Name is Saurabh. Age is 78. Male. Alright, so again it has asked me for one more name, so I'll say Neil. Age is 90. Male or female? Male. Yep. So one more name I need to type in, say I would type in Jagriti. Age is 98. Male or female? Female. And yep, it will print all those details for me. So now it is asking, have you forgotten someone? So if I type in and say yes, then it'll again ask me the number of people traveling. That means it is again executing the while loop. So if I would say the number of people traveling is 1, and I would type in the name of the person that was traveling, so I would just say Siddharth, whose age is 77 and he's a male. Yep. Again it has asked me, so if I type in anything apart from yes, say if I type N, so yep, it'll come out of the loop, and this is how you can actually use a for loop inside a while loop. So what is NumPy? NumPy is basically a module, or you can say a library, that is available in Python for scientific computing. Now it contains a lot of things. It contains a powerful n-dimensional array object, then tools for integrating with C, C++. It is also very useful in linear algebra, Fourier transform, and random number capabilities. Now let me tell you guys, NumPy can also be used as an efficient multi-dimensional container for data, for generic data. Now let me tell you what exactly is multi-dimensional array. Now over here, this picture actually depicts multi-dimensional array. So we have various elements that are stored in their respective memory locations. So we have 1, 2, 3 in their own memory locations. Now why is it two-dimensional? It is two-dimensional because it has rows as well as columns. So you can see we have 3 columns and we have 4 rows available. So that is the reason why it becomes a 2-dimensional array. So if I would have had only 1 row, then I would have said that it is a 1-dimensional array. But since it contains rows as well as columns, that is, it is represented in a matrix form. That is why we call this as a 2-dimensional array. So I hope we are clear with what exactly 2-dimensional array is. So let me open my PyCharm and I'll tell you practically how to actually create a NumPy array. So this is my PyCharm, guys. Over here, the first thing that you need to do is first install the NumPy module. And how you're going to do that, click on File, go to Settings tab, and you'll see the Project Interpreter option. And on the right hand side, you'll see a plus symbol. Just go on and type the module that you want to install. So I'm going to install NumPy. Just go there, click on it, and install package. I've already done that, so I'm not going to repeat it. So this is my PyCharm. So first thing that I need to do is import NumPy as NP. Now after that, I need to create a NumPy array. So for that, I'm going to define a variable, let it be A, and I'm going to type in here np.array and certain elements inside it. So I'm going to put in 1, 2, 3 and print it. That's all. So this will actually print a single dimensional array. So 1, 2, 3 has appeared. Now if I want to convert this to a 2D array, so for that I'll keep this in parentheses, and after a comma I'll add one more element, and I'm going to give certain values inside that. So I can give, say, 4, 5 and 6. Now go ahead and print this. So as you can see that it is now a 2-dimensional array. So this is how you actually create arrays using NumPy module. So now I'm going to open my slides and we'll move forward and see what is our next topic. Now let us see why are we using NumPy instead of a list. Alright, so many of you might be thinking, why are we using NumPy when we have lists? Alright, so basically we use NumPy because of 3 main reasons. The first thing is it occupies less memory when compared to lists. Then it is actually pretty fast when you compare it with list, and at the same time it is very convenient to work with NumPy. So these are the 3 major advantages that NumPy has over lists. And that is the reason why we use NumPy instead of lists. Now don't worry, I'm actually going to prove it to you practically by opening my PyCharm. So guys, this is my PyCharm again. So first thing that I need to do is import NumPy as NP. And now what I'm going to do is I'm going to import a couple of more modules. I'm going to import time and I'm going to import sys. Alright, done. So our first step is to actually define a list. And the name that I'm going to give to my list is, say, S, and I'll type in here range 1000. So what this will actually do, it'll actually take all the integer values between 0 to 1000 and it will give it to a variable S. So this list will contain the integer values between 0 to 1000, but it won't include 1000. It will be only there till 999, that is 999. And now I'm going to print the space occupied by this particular list. So for that, what I need to do is I need to type in print sys dot get size of any one element. Okay, so you can give 3, 4, 5, anything. I'm going to give it as 5, any one element, and multiply that with the length of my list. That's all. So this will actually give me the space that has been occupied by the list, because sys.getSizeOf will actually give me the memory occupied by one element, and when I multiply that with length of my list, I get the entire memory that has been occupied by my list. Now the same I'm going to do with my NumPy array as well. Let me give a name to that. I'm going to type in d np.aRange, and the range will be 1000. Now aRange function is pretty much similar to the range which is there. So the same thing will happen here. The integer values between 0 to 1000, but it won't include 1000, will be present in my variable d. So we have created a NumPy array. Now let us print the space occupied by it. So the first thing is I'm going to type in here d.size. So this will actually give me the space occupied by one single element, and when I multiply that with the length of my NumPy array, I get the entire memory that is occupied by the NumPy array. So I'm going to type in here d.item size. That's all. Now go ahead and print this. So this actually shows the memory that has been occupied by my list, and this shows the memory that has been occupied by my NumPy array. So as you can see, there is quite a lot of difference between both of them. So we have proved our first point that it actually occupies less memory. Now when I talk about NumPy array is faster and more convenient than a list. So the next step is I'm going to prove it to you that NumPy array is actually faster and more convenient than list. So I'll remove all of this, and so now I'm going to show you that NumPy arrays are faster than list. And at the same time, it is easier and more convenient in order to work with NumPy arrays when compared to list. Let me show you practically. So first what I'm going to do is I'm going to define a variable, say size, which is equal to say 1000, and then I'm going to define two lists. Now what I'm going to do is I'm going to add those two lists, as well as I'm going to add two NumPy arrays, which I'm going to define now. And then I'm going to compare the time taken in order to find the sum for list and the sum for NumPy arrays. So first let me define two lists and two arrays. So my first list will be equal to range size. Same goes for my second list as well. Just change the name to L2. And now I'm going to define two NumPy arrays. A1 equal to np.aRange size. Go ahead and do the same for the second NumPy array as well and change the name as A2. So we have two lists and two arrays, and we need to compute the sum of both of these lists as well as arrays. Now before that, I'm going to define a variable, say start, which is equals to time.time, and now I'm going to calculate the sum. So I'm going to save that in result, and first I'm going to calculate the sum of list, that is L1 and L2. So for that, what I need to do is I need to run a for loop, because if I directly write L1 plus L2, it is going to give me a result which is nothing but the concatenation of both the lists. So in order to calculate the sum, I need to use for loop. Let me show you how to do that. First I'm going to type in x comma y, and we have already studied loops in detail. For x comma y in zip, and the name of the two lists, that is L1 comma L2. That's all. So what will happen here, it will first take the first element of list L1, and then it will take the first element of list L2. It will calculate the sum and it will store in result, and it will keep on repeating until the range has been exceeded. Now this is how you calculate sum in lists. But when you talk about arrays, what you need to do is you need to just write in A1 plus A2. That's all. That's why I'm saying that it is more convenient in order to work with NumPy arrays when compared to lists. Now our next step is to define the same variable start and initialize it with time.time. And now I'm going to find the sum of my two NumPy arrays, which is nothing but A1 plus A2. That's all. And now print the time taken. So print time.time minus start, and then multiply it with 1000. Because by default it will take it in seconds, and I need to convert it into milliseconds. Now I forgot to actually print the same thing for my list, so I'm going to do it over here. So this will actually give me the time taken by my list in order to compute the sum, and this statement will give me the time taken by my NumPy array in order to compute the sum. So let us go ahead and execute this, and we'll see what happens. So it gives me 0 milliseconds because the size is small. Let me just add a couple more zeros. Let's make it 1,000,000. Now go ahead and execute this. Now you can notice the difference, that there is a significant change. Lists took 208 milliseconds, whereas NumPy array took almost 67 milliseconds. So there's a huge difference between the compute time of a list as well as NumPy array. That's why I say that NumPy array are faster, convenient, and at the same time they occupy less space when compared to list. So that is the reason why we choose NumPy arrays over list. So let us go ahead and move forward towards the next topic, that is NumPy operations. So let me go back to my slides. So now is the time to see various operations that you can perform with the NumPy arrays. So you can find the dimension of your array, whether it is a two-dimensional or a single-dimensional array. Then you can even calculate the byte size of each element. It is pretty easy. I'm going to tell you that practically. You don't need to worry about that. And you can even find the data types of the elements that are stored in your array. So if you want to know what is the data type of the elements, you can do that as well. So let me show you these three operations first, and then we'll move forward to the other operations. I'm going to open my PyCharm once more, guys. Let me remove all of this. So we have imported the NumPy module. Now what I'm going to do is I'm going to define a NumPy array. I'm going to name it as A, and I'll write here np.array 1, 2, 3. Put that in parentheses. Now add one more element, say 2, 3, 4. Alright, so it's a two-dimensional array. Now if I want to know whether it's a two-dimensional or a single-dimensional array, so I'm just going to type in print a.endim, and it'll give me the dimension. So let me show you that, and I'm going to run this. So it says 2, that means it is a two-dimensional array. So what if I move this part and make it as a single dimensional array? It should give us the result as 1. Let's see if it does that or not, and yep, it gives us 1 as a result. So this is how you actually calculate the dimension of your array. Now if you want to find the byte size of each of the elements, so what you need to do is, instead of endim, you can call a function called item size. Go ahead, execute this, and you'll get, so each element occupies 4 bytes. After that, if you want to know the data type that is stored in the array, so you can just type in here dtype. Go ahead, execute this. It should give us integers 32-bit. Alright, so this is how you can actually perform these 3 functions that I've told you in my slides. So let us proceed with the presentation. Now let us move forward and see what are the other operations that you can perform with NumPy module. So by using NumPy array, you can actually find the size of your array. How you can do that I'll show you practically. You don't need to worry about that. So when I say size of the array, that means the total number of elements that are present in the array. So if this is an array, so the total number of elements become 4. 1, 2, 3, and 4. Now you can even find the shape of your array. Now what do you mean by shape? So basically the total number of columns and rows. Now over here we have 3 columns and 4 rows. So our shape is actually 3 columns and 4 rows. Now let me show you practically how you can do that. Again, I'm going to open my PyCharm and show you. Let me remove this print statement from here. Now if I want to find the size of my NumPy array, I just need to type in print a.size. That's all you have to do, and it'll give the size of your array. So there are 3 elements. So if I go on and add some more elements, say 4, 5, 6, 7, then if I execute this, you'll see that 7 elements have appeared. That means the total number of elements in my array is 7. Then comes the shape part that I was talking about. So in order to find the shape, what you can do is you can just type in here a.shape, and it'll give you the shape. So let us see what happens. So it has 7 columns, but there are no rows, so it has given 7 comma blank. So what I can do is I can close this in parentheses, and I can define one more element, say 8, 9, 10, 11, 12, 13, 14. Go ahead and execute this, and you can see 2, 7 because we have 2 rows and 7 columns available with us. So this is how you can actually find the size of your array, as well as you can find the shape of your array.
Now let's take up the quiz question. What will be the output of the following Python code? For I in range 2, 5, print I. And the options are option A 2, 3, 4, option B 2, 3, 4 and 5, option C 1, 2, 3 and 4, or option D 3, 4, 5. So if you know the answer, please leave it in the comment section below.
Now let us move forward and see what are the other operations that you can perform with NumPy module. So we saw how to find the size and the shape of an array. So we can perform reshape as well as slicing operation using NumPy array. Now when I talk about reshape, what do you actually mean by reshape? Geography? Alright, fine. So that is absolutely correct, guys. Now over here there is an example. So we have 3 columns and 2 rows, which we have converted to 2 columns and 3 rows. Now let me show you that practically how you can do it. In a variable, and I'm going to start a NumPy array, and I'll have 2 elements in that. My first element will be 1, 2, 3, 4, and my other element will be, say, 3, 4, 5, 6. So I have a 2-dimensional array that contains 2 rows and 4 columns. Now I can convert that to 4 rows and 2 columns. Let me show you how to do that. You're just going to type in a is equal to a.reshape, and I want to convert it to, say, 4 rows and 2 columns. Go ahead and print this. So it has converted that to 4 rows and 2 columns, as you can see it in front of your screen. Now let me show you that earlier this is not the case. I'm going to type in a print statement here as well in order to show you that how it has reshaped. So earlier we had 4 columns as well as 2 rows, but now we have 2 columns and 4 rows. So this is how you can perform the reshape operation. Now let us talk about slicing. So slicing is basically extracting a particular set of elements from your array. And the slicing operation that happens here is pretty much similar to the one which is there in list as well. So suppose if I want only this particular element, that is 3. So for that, what I need to print, I'll show you, print A and the index value of 3, which is present at 0, comma, and the index is 2. Let me tell you how indexing happened. So this element will be 0, this element will be 1. Now if I want 3 from here, from the 0th element, I want the index 2. Indexing starts from 0, 1 and 2. So that's why I've written 0, 2, and it should print 3 for me. Let us see if it does that or not. And yep, it prints 3. Now say if I want to print 4 and 6. Now for that, what I need to do is I need to remove this 2 here, and I'm going to put a colon that says all the rows including 0, and in that row I want only index 3. So we have only 2 rows, so if I would have written 0, 1, then it wouldn't have included this particular row. So if I have one more element here, so I can actually write here 2, so that won't actually include the element which is present at the second index. So when I say 0, this actually means all the rows that include 0 as well. So we have only 2 rows, it will include both the rows, and at the same time it'll actually going to print the third index from both of these rows. So let me show you if that happens or not, and yep, it happens. We have 4 and 6 available with us. Now just to remove confusion, what I'm going to do is I'm going to add one more element and I'm going to give values to it, say 7, 8, 9 and 10. So now if I want 4 and 6, I can't just write 0, because if I do that, it'll print 10 as well. Let me show you that. Yep, it has printed 10. Now in order to avoid that, what I can do is I can write in here 2. So as I've told you, this is the 0th element, first element and the second element. So when I write 0, 2, it won't include the second element. It'll only include 0th as well as the first element. Now inside that, we have index 3 from both of these rows. That is why we'll actually get 4 and 6. Let us see if that happens or not. And you can see 4 and 6 is now available. So this is how you can perform slicing when we in NumPy arrays. Now what I'm going to do is I'm going to type in a equal to np.line space, and now over here first I'll write 1 comma say 3, and I want say 5 values between 1 comma 3. What this will do is it'll actually print the 5 values which are equally spaced between 1 to 3. So let me print this first. I'm going to type in print a and go ahead, execute this, and you can see that we have 1, then we have 1.5, then we have 2, 2.5 as well as 3. So if I would have written here 10, it will actually give me 10 values between 1 to 3. And yep, you can see we have the 10 values between 1 to 3. So this is how you can perform line spacing as well. So we saw how to perform reshaping and slicing. Now let us see what are the other operations. So we are now going to find out the minimum, maximum as well as the sum of our NumPy arrays. So let us go ahead and execute that practically. Let me remove all of this, and now I'm going to define one more NumPy array, np.array, and I want elements in it, say 1, 2, 3. Now if I want to find the element which has the maximum value, so what I can do is I can just type in here print a.max, that's all, and it'll give me the maximum value in my a NumPy array, which is 3 obviously. If I want to find minimum value, so I'm just going to type in here min, and it'll print the same for me, which is 1. Now if I want to calculate sum, it is pretty easy. Just go on and type sum and it'll give you the sum. That's all guys, it's that simple. Whatever I'm telling you, these are all the basics that you require. After that, whatever your requirement is there, on that basis you need to use those basic knowledge that you have and implement it. Now the best way to do that, the best way to understand any programming language is to play around with it. So you know the basics. With the help of those basics, just install PyCharm first, then try out new things like how should I get that, how should I get this, and if I'm not getting it, what is the reason behind it. So go on and try to discover new things. So the conclusion is you need to actually perform things practically. You need to make sure that you are not only getting the theoretical knowledge, you need to perform it practically. That's why I always say that side by side when I'm executing these practicals, you need to do that as well. Although you might find it pretty basic, but with the help of this knowledge, you can perform a lot bigger tasks as well. Alright, so Janice looks happy now. So let us move forward with our slides. So now comes the axis concept here, guys. It is pretty similar. We have a NumPy array which looks like this, and the rows are called axis 1 and columns are called axis 0. Now you must be thinking, what is the use of this axis? Suppose if you want to calculate the sum of all the rows, then you can actually use these axes and you can do that. Now let me show you practically how it happens. I'm going to open my PyCharm again and I'm going to show it to you. Let me remove this and let me add one more element here. 3, 4, 5. Alright. So if I want to find the sum of axis 0, it's very easy. Just go on and type print a dot sum and type in axis equal to 0. Go ahead and print this and you can see 4, 6 and 8. 1 plus 3 is 4. 2 plus 4 is 6. Similarly 3 plus 5 is 8. If I make this as axis 1 and print this, so it gives me 6 and 12 because 3 plus 2 plus 1 is 6. Similarly 4 plus 5 plus 3 is 12. So this is pretty easy, I know. Now let us go back to our slides and see what are the other operations. So there are many mathematical functions that you can perform with NumPy. That is to find the square root of each element. You can even find the standard deviation. So these two operations can be performed with the help of NumPy. You can find the square root, you can find the standard deviation. Now let me show you that how you can do it. This is my PyCharm again. So now I'm going to remove this print statement here. And I want to print the square root of each of the elements that are there in my NumPy array, which is actually assigned to a variable a. So I'm going to type in here print np dot sqrt, that is square root of my NumPy array a. Go ahead and execute this and it has actually printed the square root of each of the elements. The square root of 1 is 1, for 2 it is 1.414, for 3 it is 1.73, again for 3 it is 1.73, then for 4 it is 2, then for 5 it is 2.23. This is how you can find the square root of each of the element. Now when I talk about standard deviation, so you can find that by typing here. So now if I want to find the standard deviation, what I need to do is instead of sqrt, I'll just type in here std and it'll give me the standard deviation, that is how much each element varies from the mean value of my NumPy array. And this is the standard deviation, guys. It's that simple. So this is how you find standard deviation. Now let us go back to our slides and see what are the other operations that are still left. Now these are the basic mathematical functions that you can perform with NumPy arrays like addition, multiplication, subtraction and division, and that will actually happen element wise. So basically you are performing matrix addition, matrix multiplication, matrix division as well as matrix subtraction. Let me go ahead and show it to you practically. It is very simple, guys. So similarly I'm going to define one more array and let me name it as B. Let me remove this print statement. Now if I want to calculate the sum, so what I need to do is I need to type in print a plus b. That's all you need to do. But when I talk about list, again I'm telling you that when I talk about list, if I do that, it will concatenate both the lists. So if I want to print list, that is the addition of two lists, I need to use for loop. So that is where NumPy array stands apart and it is pretty convenient. Go ahead and execute this and you'll see that element wise addition has happened. 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6. Similarly 3 plus 3 is 6, then 4 plus 4 is 8, 5 plus 5 is 10. Alright, so this is how you can perform addition. You can perform subtraction by using the subtraction operator. Go ahead, execute this and you'll find all zeros because 1 minus 1, 2 minus 2, 3 minus 3, 3 minus 3, 4 minus 4, 5 minus 5 will be 0 only, right? No rocket science. Now go ahead and multiply it as well and see what happens. So you have 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9, again 3 into 3 is 9, 4 into 4 is 16, 5 into 5 is 25. If I go ahead and divide this, it'll give me all ones. And yep, it does. So this is how you can actually perform addition, subtraction, multiplication and division using a NumPy arrays. Now let me go back to my slides and see what are the other operations present. So now guys, let me tell you one more thing. If I actually want to concatenate two arrays, I don't just want to add those two arrays. You can say that if my one array is a box, then I want another array on top of it. So let me show you how you can do that. Actually, there are two ways to do that. One is called vertical stacking and another is called horizontal stacking. Let me show it to you one by one. First, I'm going to show you vertical stacking. For that, what I need to do is print np.vstack and a comma b. Let us see what happens when I run this. So we have 1, 2, 3. 3, 4, 5. Then again we have 1, 2, 3 and 3, 4, 5. So this is called vertical stacking. If I want that horizontally, I'll just write in here hstack and I'm going to run this now. And you can see that we have 1, 2, 3. Then again 1, 2, 3. That means these two are present added horizontally. And we have 3, 4, 5. Again we have 3, 4, 5. So this is how you can perform stacking as well. Now there's one more thing that I want to show you. If I actually want to convert this particular NumPy array, that is A, to say a single column. So how I can do that? Just type in here print a dot revel. That's all you have to do. Go ahead and execute this. So you'll have 1, 2, 3, 3, 4, 5. So you have 1, 2, 3, 3, 4, 5. Let me go back to my slides and see what are the other topics that we are going to cover. Now come certain NumPy special functions. Now I'm going to talk about sine function and cosine function first. So what I'm going to do is I'm going to use this cosine and sine function and I'm going to plot sine and a cosine graph. So for that I'm going to import a module called Matplotlib. So you don't need to worry about that module because I'm going to discuss about Matplotlib in the upcoming sessions. So there'll be a detailed session especially on Matplotlib, so you don't need to worry about what exactly Matplotlib is and how it works and all those things, because that'll be covered in the upcoming session. For now, what we are going to do, we are just going to use sine and cosine function in order to print their graph. So for that, I'll open my PyCharm and let me remove this and import matplotlib dot pyplot as plt. Now we are going to define two coordinates, that is x and y. First, x is equal to np dot arange 0, 3 into np.py, 0.1. Now I'm going to define y. So for that I'll type y np.sin x. Now I'm going to use plt in order to plot the graph x, y. Now finally show the plot. For that I'll type plot.show. You must plot.show to make a graphics appear. So plot.show and here we go. Go ahead and execute this and you might be able to see a graph and yep, it is here. Similarly, what if I change the sine to cos and should give me the cosine graph? Go ahead and run this and you can see we have a cosine graph as well. Similarly, if I write in here tan, that is any other trigonometric function, and I print this, so I get the graph for tan as well. So I'll open my presentation once more and we are going to see what are the other special functions that we can use with NumPy. Now NumPy comes with two very good functionalities, I would say, that is called exponential function and logarithmic functions. Now exponential, this e value is somewhere equal to 2.7 and we all know log. So when I talk about log, it is actually log base 10. And when I'm talking about natural log, that is log base e, I will write it as ln. So instead of that, I've written log, that means log base 10. So you can perform these operations with the help of NumPy. Let me show you how you can do that. So I'll open my PyCharm. Let me remove this. And I'm going to define a NumPy array. Let it be AR equal to np.array 1, 2, 3. Now I want to calculate the exponential value. I'm going to throw in a print statement and I'm going to write in here np.exp ar and this will calculate the exponential value for me and let us see if it does that or not. So yep, as I've told you earlier as well, value of e is 2.71. So e to the power of 1 is actually equal to e, so it has returned the e value, but e to the power of 2 will be somewhere equal to 7.38. E to the power of 3 will be somewhere equal to 20.0855. Now, in order to calculate log, what you can do is you can just type in here log. Now, this will give you natural log. So when I talk about natural log, it is nothing but ln, or you can say log base e. But if I want to calculate log base 10, so I need to type in here 10. First, let me show you how you can find the natural log. Just go ahead and execute this. All right. So when I talk about 1, so e to the power of 0 will be equal to 1, right? So log or ln ar equals to 0. Similarly, the other values as well. Now, if I want log base 10 instead of ln, or you can say natural log, I can just write in 10 and go ahead and execute this, and you'll find log base 10 values. So obviously when answer is 1, that means anything to the power of 0 is equal to 1. So the answer will be 0 here, and similarly we have other answers as well. If you're unsure about it, you can open your calculators and do that.
So Pandas is a Python library which is used for data manipulation, analysis, and cleaning. And Python Pandas is well suited for different kinds of data, such as we can work on tabular data with heterogeneously typed columns. We can work on ordered and unordered time series data, arbitrary matrix data with rows and column labels. We can work on unlabeled data, and we can also work on any other form of observational or statistical data sets. Now I'm going to tell you how you can install Pandas on your systems, guys. It's very easy to install Python Pandas. You just go to your command line or terminal and just type pip install pandas, or if you're working on an IDE such as PyCharm, you can just simply type in pip install pandas in your terminal over there, or you can just open the project interpreter and add the library over there. Since we are going to work on Jupyter Notebook, I'm going to tell you how you can install Python Pandas on Anaconda. So you just have to do one thing. So I'll just show you guys how you install Python Pandas on your system. You open the Anaconda prompt. We'll wait for the prompt to set up. So you type conda install. It's already there in my system because I've already installed Pandas, since I've already worked on various data analysis projects, and it's a very integral part of it. Because to work on a data set, to read a data set, you require Pandas, and it's just that you cannot work without Pandas if you're working with any data related project. So this is how important Python Pandas actually is. I'm going to tell you a few applications of Pandas as well. So first of all, you can just say that Python Pandas is an integral part of data, whichever project you're working on. So you can work on economics. You can use Python Pandas for stock prediction. You can use it for recommendation systems. Then you can use it on neuroscience and statistics also. You can use it for, and then there is advertising. So many data coming from different platforms. You can just analyze the data using Pandas, clean the data for irrelevant, inconsistencies in your data. You can do that using Pandas. And then you can use it for analytics as well. That's the very basic use of Python Pandas that I can think of. So right now that we know how Pandas actually is in Python programming and what it is used for, let's go ahead and take a look at the very integral part of Pandas, that is data frames and series. We'll wait for this to install, guys. Meanwhile, I'll just tell you what are data frames and series, guys. So data frame is a two-dimensional, and the size of the data frame is mutable, potentially heterogeneous data, or we can call it heterogeneous tabular data. So the data structure, which is data frame, also contain labeled axes, which is rows and columns, and arithmetic operations align on both rows and column labels. It can be thought as a dictionary-like container for series objects. Now, what exactly is a series, guys? So a series, or a Pandas series, is a one-dimensional labeled array capable of holding data of any type, which is integer, can be string, float, Python objects, etc. And the axis labels are collectively called index, and Pandas series is nothing but a column in an Excel sheet. So let's just take a look at a few examples, and then you'll be able to understand this better, what I'm talking about, like Pandas and series, what exactly they are. We'll be working on an example now. So I'll just take it to Jupyter Notebook, guys. So we have already created a Jupyter Notebook. If you are not familiar with Jupyter Notebook, guys, we have a full tutorial on how to use Jupyter Notebook, all the cheat sheet and everything. So you can just refer to those in our Edureka YouTube channel. And make sure you subscribe to Edureka for more exciting tutorials, because we have a lot of content on Python, guys. So if you want to learn Python inside out, or any other technology for that matter, we have a lot of content on YouTube you can refer. Also, if you are at it, be sure to check out our courses on edureka.co, and we have a full Python programming certification program that you should also check out. So since I have already installed Python Pandas, I'm just going to import Pandas as PD. Run this. I'm not going to face any problem running this command because I have already installed Pandas. Okay. So what this command will do over here, it's going to install the package, the latest release of Pandas for me. I think that's why it's not running. Okay, we have our first statement over here, and we have successfully imported Pandas as PD. So I'm using the alias as PD. I hope you guys know what alias is. So let's just say I'm importing this library. So alias is going to be this one, that is PD. So for importing, I'll tell you why I'm using this. Now if I want to create a data frame, I'll just use df as my variable name for data frame. So I'm going to use the alias. Now when I type tab over here, okay, so this is how I can use my alias to create a data frame. So this is just to tell you how you use an alias. Now I'm going to show you how you can create a series and a data frame. So first I'm going to, I'll have to import NumPy as well, because I'm going to use it to create a null value. All right. So df is equal to, I'm going to make a series, so I'll just write it as s. All right. Series, and I'm going to pass a list of values. Let's say 1, 2, 3, 4, 5, 6. And I'm going to use my NumPy now to create a null value like 8, 9, and one more value, let's say 10. So it's going to create a series. Now when I print s, so we have a series which has indexes which are already there, and all these values that I passed inside a list. So this is how you create a series in Python, guys, using Pandas. After this, I'm going to tell you how you create a data frame. So for that also, I'm going to tell you how you create a data frame using a dictionary object, and how you can create a data frame using series as well. So now what we are going to do is we are going to create a data frame by passing a NumPy array with a datetime index and label columns. So I'll take one variable, let's say date or dates. I'll just type it as D, and I'm going to take pd dot. So we're going to take the date range. And after this, I'm going to pass a few values, let's say 2020, and I'm going to pass values like we're in the month of March, so I'll just write it as March. And after this, I'm going to take periods, which is equal to, let's say 10. So this is my date range, guys. Okay, I have an invalid syntax, right? Should work fine now. So when I print D over here, so I have all these values in a date range format. After this, what I'm going to do is I am going to take one data frame, which I am going to take as df for obvious reasons to make it clearer. And I'm going to take data frame, and inside this I'm going to pass a few values. So first of all, I'm going to take a few random values. So I'm going to use np.random number, and inside this I'm going to pass 10, let's say 4. And now I'm going to get the index values as D, and I'm going to have to pass a few more values, which is columns. So I'll pass the columns as a list, and I'm going to take, let's say 4 columns. So I'm just going to take, okay, wait a minute, A, B, C, D. All right, do we have any errors? No. So now I'm going to print my data frame. So I have a data frame, guys, which I have created using, passing a NumPy array, and I have a datetime index with labeled columns, which are A, B, C, and D. This is my index, guys, and I have all these random values using NP array. So this is how you create a data frame, guys. Just a simple example, and I'm going to show you how you can create a data frame by passing a dictionary of objects that can be, converted into a series also. So I'll take, let's say again, df is equal to pd dot data frame, and I'm going to pass a dictionary over here now. So I'm going to take a few values first of all. So first value is, let's say A. Now after this, I have to pass something, right? Okay, I'm going to write, let's say a list of 1, 2, 3, and 4. After this, my next value is going to be, let's say B, and I'm going to pass a timestamp, let's say. And for timestamp, I'm going to use the same I have used over here, 2020 0301. I have to use the right. And after this, I'm going to pass one more value, let's say C, and I'm going to use a series now, a series object. And inside this, I'm going to pass 1, and the index is going to be, let's say, a range. All right, index is equal to a list with a range of 4, because we have only 4 values over here. We don't want any null values. And after this, I have to type in the data type as well, the data type of the series, guys. So for that, I use dtype is equal to, let's say, float 32. All right. After this, I provide my next value, which is d. Now for d, I'm going to use an NumPy array. And for this, I'm going to pass a value, let's say, not 3, let's say 5 multiplied by 4. And let's take the d type is equal to integer 32. Yes. All right. Now I take my final value, which is going to be e. And inside this, I'm going to pass a data frame, or we're going to use the categorical object, guys. We're going to talk about this later on in the session, so don't worry. I'm just showing you how you can create a data frame using all these objects that we have at our disposal, guys. Now, instead of test and train, we can just call it as true or false. It doesn't matter. We are taking categorical object, so it has to be either true or false, or it can be 0 or 1, but it has to be decisive in a way that there are only 2 values. So I take another value, and for this, let's just say I give the value Edureka. All right, so our dictionary is done over here. So we have created our data frame, guys. There's no error. Now when I print this, so we have our data frame, guys. So A, B, C, D, E, and F. So we have all these values using different data types, or we can call it objects as well. So for that also, we can check the data frame, and we just write d types, and it's going to give us all the data types that we have. So we have date timestamps over here, integer, float, integer, category, and an object, because I have used a string over here. That's why it is giving us an object. But in the new release, that is Python 1.0.0, it's not going to be an object. It's going to show you it is a string. So don't worry, guys. And we have already made a video on Python Pandas 1.0.0 with all the features that have come with the new release, the new stable release released last month. You can check that out as well to check for the new features that we have come across. So now that we have done this, let us take a look at the next topic that we have, which is how to view data. So viewing data is basically, how you actually look at the data, or how you're going to look at the data using Pandas library. So we'll just jump right to Jupyter Notebook, guys. And I'll tell you what kind of functions or all those things you have at our bay that we can use to view our data. So we'll do one thing. First of all, we have data frames already that we have over here. So I'll do one thing. I'll just change it to df1 so that we have different data types, or I'm sorry, different data frames, guys. I'll run this, and this as well. Now when I check for df.dtypes, it should be different, guys, because we have already made a data frame using that. All right, it's not. So I'll run all the, wait. So I'll do one thing. I'll restart and run all the cells so that we have 2 different data frames. So first of all, the first very basic thing that you can do for your data frame is to use, I'll just tell you guys, you write df.head. So what this function is going to do is give you the first 5 values inside your data frame, or the first 5 rows. And similarly, for the last rows, you can use the tail method. So this is how you get the first and last values inside your data frame. So it's going to display all the 5 values that you have at your beginning and the end of your data set. After this, we have df.index. So what this will do is it will give you all the values from your index. And similarly, we have df.columns, which is going to give you all the columns from your data frame. So this is how you view your data, guys. And then we have dataframe.toNumPy, which is going to give you a NumPy representation of the data. So I'll just tell you how you can do that. So I'll just write df.toNumPy. Wait a second, guys. Yes. So I'm going to create a NumPy array using this. I actually created a NumPy array. And for df, our data frame of all floating point values, dataframe.toNumPy is actually fast and does not require copying the data. So it is a very best deal for we have. And then, okay, I'll just remove this. I don't want this. And then we have dataframe.describe, which is going to give you somewhat like this, which is going to give you the count, the mean, the standard deviation, minimum, 25%, 50%, 70%, and maximum. So these are all values using the describe you can have, which is going to give you an idea or a perspective of how your data actually is and what kind of calculations are already there that you can think of. Then we have sorting by an axis. We can sort our data using an axis. So for that, you have to just write, okay, I'll just show you guys. You just have to write df.sort by index, and inside this you have to give the value of the axis. I'll just give 1, and then let's say ascending, you want it to be ascending. No, I'll just write it as false. So it has given me the data frame by sorting the index. Similarly, I can sort it by the columns as well, or I'm sorry, sort it by values. So I'll write it as values, and I want to give the value as, say, values, and I'm going to give the value as, let's say, by, I want to sort it by C. It has sorted the values depending on C. So this is how you sort your data frame, guys. And now that we know how we can actually look at our data, I'm going to tell you how you select particular values inside your data, guys. I'm going to show you how you select a single column from your data frame. So we'll write df. It's very simple, guys. To get a value from your data frame using only a single column, you can write A, or let's say C. So it's going to give all the values from C over here. It has actually given you frequency. It has given you name, data type as well. So this is how you actually get a single column from your data frame. Now let me show you how you can slice the rows as well. So for that, we're going to use the slicing. If you have actually worked on list comprehension, so we have slicing the data over here. We are going to follow the same principle here as well. So I'll just write df. Now I want my first, starting from my first value to third value. So it has given me only 3 rows, starting from the 0th row, and it has given me third row. And it does not actually include the third row because it starts from 0. So I'm giving 3 values. If I write 6 over here, I'm going to get the 6th value, but it's not going to be at the 6th row because the first row over here is going to be 0th row. I hope you understand this, guys. So I have shown you how you can slice your data, to get particular number of rows. Now let me tell you how you can select the data using the labels, guys. So for that, you have to use df dot, there has to be location, LOC, and inside this you're gonna pass the values by labels, guys. All right, so let's pass D, that is, and 0. So let's see what the output is, guys. All right, so we have got all the values using the label, that is D over here, which we have passed over there in our previous section where we have declared the data frame. And I'm sure this is visible to you guys. Now the next thing is selecting data on a multi-axis by label. So what we'll do is we'll write df.loc, and after this we write hyphen, and we're gonna create, let's say, A, and we're gonna pass C, right? So it's gonna give me the values accordingly, which I passed over here. So instead of A, I can write B, or I can write D. So this is how you can select multi-axis using labels, guys. And I have written this over here, so I can just write, let's say, 0 to 3. Let's see what happens. Oh, we have an error, guys. You cannot do this. So we'll now move on to the next topic that we have is showing label slicing. Both endpoints are actually included. So how do we do that? So instead of this, we can just, let's say, copy this, paste it over here, and copy this, paste it over here, remove this. So this is just to show you guys how you can work with it. I'm very certain that the data that you work on is not going to be like this. It's going to be very complicated. So this is just to give you a perspective as a beginner how you can work with pandas. Now I'm gonna tell you how you can reduce the dimensions of the returned object as well. So for that, you just type one thing, guys. You remove all this, get just one value, and this is gonna give you the column number at over there. And this is how you get the values inside a data frame. So moving on, let's say we want to get a scalar value. So for that, we just write, okay, let's say D0. All right, let's see if it works. We're getting the same values, guys, only from the 0th row. For getting the fast access to a scalar, you can just write as df. Instead of loc, we can just write at. Okay, we have an error, guys. I'll just remove this. And let's see if it works. Yes. So I'm getting the exact value at the 0th row at the column number C. Now I'm going to tell you how you select a value from using the position inside your data frame. So for that, we use df.iloc. All right. So let's say 3. Okay. So I'm getting all the values from third column. And similarly, we can slice the data. You can just get it like 3 to 5. All right. We can add more values to this, like 0 to 2. So this is how you select the values from your data frame, guys. Now we have Boolean indexing as well inside our data frames. So I'll just tell you quickly what it is. So for that, you just write df. Now I'm going to check if df column number A, let's say, this is interesting, guys. So it has given me all the values inside A, where A is greater than 0. If I write it, let's say 2, I have no values because none of the values are greater than 2. So this is how you can get the Boolean indexing. This is actually important when you're applying functions to your data frame, guys. So moving on, let's take a look at another method, which is in method. I'll just tell you how it works, guys. So it's basically is to check if the particular value inside your data frame is in there or not. Now there's one more thing. We can set new values inside our data frame. We can set a new column which automatically aligns the data by the indexes. So for that, we can make the series, and we can set the values by label. We can set the values by position, and we can set the assigning with a NumPy array as well. And the result of the settings will actually align with the data frame, where a new operation with the setting can be followed, where you can simply align the data frame with the existing data frame. Now let's go ahead and take a look at the next topic that we have, which is handling the missing data inside your data frame. So let's jump right to it, guys. We'll go to Jupyter Notebook and we'll work with our missing values now. So pandas primarily use the value np.nan to represent missing data. It is by default not included in the competitions, and we're going to see the missing value right now. So first of all, you have to reindex. You have to do reindexing, which is going to allow you to change, add, delete the index on a specified axis, so which is going to return a copy of the data as well. All right, I'll just take df2 is equal to df.reindex. So this is how I'm going to do the reindexing, guys. So index is equal to, let's say, d0 to 4. Yes, I'm going to get the columns after the reindexing, which is going to be equal to list of df.columns, and I'm going to add one more column, which is going to be, let's say, E. All right. Now what I'm going to do is I'll do loc. I'm going to check a few values. So instead of dates, I've taken D, guys. So D of 0 and d of 1 at e is equal to 1. Now let's check what is df2, guys. We have two null values over here. So this is how I'm going to show you how to handle missing values inside your data frame. So we have done reindexing. So first of all, I'm going to check for null values. So we have true over here, and we can get the count as well. Is null, and we count these null values. All right. Right now we are going to drop a few columns. So we are going to drop the NA, that is the NA values. So as you can see from our data frame, all the values that had null values are dropped. Actually, the whole column has been dropped. Or we can do one thing, fill in the missing data, guys. Just do one thing. Okay, check df2 we have. So we can do one thing, we can fill the missing values, and we are going to provide some value. Let's say value is equal to 2, right? So we have actually filled the value with some other value. Wherever there is a missing value, we have given a value that is going to fill over there. So this is how you get, or check for all these missing values inside your data frame. After this, you can now actually get a boolean mask where values are nan, which is null. So for that, you do pd dot is na df2. So this is going to get you a boolean mask, which I've already told you how you can check using df dot is null. Same thing, but different processes to run this. Now let us move ahead and to the next topic that we have, which is Pandas operations, guys. Pandas operations are nothing but a few operations that you can apply on the data frame or any other Pandas object. So we have descriptive statistics that we can apply. We can apply functions, histogramming is there, and string methods is also there. So I'll tell you what histogramming is when we are talking about it. So let's take it up to Jupyter Notebook again, guys. I'll tell you how you can actually work with Pandas operations. So first of all, I'm going to tell you a basic operation, which is that is a descriptive statistics. So it's going to give us all the mean values. Similarly, we can get one value like df dot mean, provide one value over there. So this is how you get it, guys. Or we can write it as 2, right? All right. So this is how operating with objects that have different dimensionality and need alignment. In addition, Pandas automatically broadcasts along the specified dimension. So for that, let's make a series. I'll tell you just how it works. pd dot series, give it a few values. Let's say 1, 2, 3, np dot nan 5. I'm sorry, 4, 5, and then give the index value. The index is going to be dates, and let's just shift all this 2 places. Right, we have made an error, guys. Length of pass value is 6 and index implies 10. So we have to actually put more values. So write 6, 7, 8, 9. Yes. Now when I print s over here, we have all these values. Now we can do one more thing. So we write it as df dot sub, and we pass the s over here, which is our series, and we make an axis, write it as index. So we have operated with objects that have different dimensionality and needed alignment. So in addition, Pandas actually helped us automatically broadcast the specified dimension. So now I'm going to talk about applying functions to the data. So we already have data frame. Let's see what we have. So we have this data frame, guys. So what I'm going to do is I'm going to apply a few functions. So first of all, I'm going to use the apply method over here. And let's see what all do I have. Let's just check. We have absolute import, all close, a max, a minimum, angle, any append, all these functions that I can apply on this. So let's say we have CumSum. Let's see what this does, guys. All right. So this is how it works. Now let's apply a few more functions, guys. So I'll write Lambda X. So we are talking about Lambda functions here. I'm sure most of you must be aware of the Lambda functions that we have in Python. If you don't have any prior knowledge on Lambda function, guys, there is a full tutorial on how Lambda function works in Python, guys. So this is how we applied Lambda function to get the subtraction between the x max and x minimum. All right. For all the columns, we have the subtraction between all these values. So this is how we apply functions to our data, guys. Now I'm going to talk about histogramming. So histogram is a representation of the distribution of data. So this function we have, which is matplotlib.pyplot.hist, on each series in the data frame, resulting in one histogram per column. So what we'll do is we'll make a series, and it's going to give us value counts for histogramming. How do we do that actually? So we can just write as dot value counts, right? Let's see if it works. Right, we have one value for each. So this is how we get or do the histogramming with our data, guys. Now I'm going to talk about the string methods. So series actually is equipped with string processing methods in the string attribute that actually makes it easy to operate on each element of the array. So let's just move ahead with the example. So I'll make a series, guys, pd dot, let's say series, and inside this I'm going to pass a few string values. So I'm going to start with Edureka, write Python next. Let's write Jupiter, give it a few null values as well to make it a little or slightly different from perfect. All right, so give it a few values, let's say football. And looking at the current scenario, let's write world. So we have a series over here, guys. Now what we'll do, we'll take or use the string methods. So I'm gonna make it all to lower, which are already lower. So I'll make it to upper, guys, upper letter words. So everything we have changed using the string methods inside our Pandas series. These are all the operations that you can perform on Pandas, guys. So let's move ahead to the next topic that we have, which is merging. So in merging, we are basically going to merge two data frames together. So we have two functions, which is concat and join. So concat pandas objects along a particular axis with optional set logic along the other axis. It can also add a layer of hierarchical indexing on the concatenation axis, which may be useful if the labels are the same or overlapping on the past axis number. So let's take a look at the example for this. So we have our data frame. I'm going to use pd dot data frame. Give it a few values, let's say np dot random number from, let's say, 10 and 4. All right, so we have all these values. Now what I'll do is I'll break it into the pieces. So how to do that? So let's say I write it as df2 is equal to df from first to third row. The next one is df from third to, let's say, seventh row, and then we have df from seventh to the end of the data. So this is how I am going to break it into the pieces. Now when I write it as df2, we have 3 data sets. Now I'm going to use the concatenation function using concat. All right, I'm gonna concatenate df2. So this is how I've concatenated the missing pieces, not the missing pieces, the several other pieces together using the pandas concat function. Now let's talk about the join function that we have. So for this, basically I'm gonna tell you how you can do the left and right join. So for the left join, I'll write left is equal to pd dot data frame, and let's see, first value, let's say A, give it a few values, let's say 1, 2, and then say B, we have 3, 4. All right, we make the for the right as well. So I'm just gonna copy all this, paste it over here. Okay, I'm just going to write it as D. This is going to be, let's say, C, and change a few values. So we have left and right, and I'm going to just type left, and then we get the output for right. So I'm going to join all these two using the join function. So for that, I'm going to use the merge function, and inside this, let's say left, we have right, and on is equal to, I'm going to join it at let's say A. Let's see how it works. Okay, it doesn't. So we have a key error, which is A. So I'll change it to A, guys. So we actually joined using the merge function over here. And another example that I can think of is, let's say we have left and right. We can change the values differently, and we can just group them together. Now what I'm going to talk about is grouping, guys. So how you do the grouping of different data inside your data frame using Pandas. First of all, for that, you have to split the data into groups based on some criteria that you have. And then after that, you apply some functions on them. And then later on, you can combine the results into a data structure. So first of all, you have to get a data frame, guys. So let's see, we have a data frame over here. So we can actually group it by, let's say, right, I'll just write group by, say, A, and I'm just gonna sum. Right, we have an error, guys. So we have a key error, that is A, because we don't have over there. So I'll write it as, let's say, 2. All right, we don't have 2 as well. We have a key error, we don't have 2 over there because it's not a string value, it's an integer value. So we have our values right over here. So we have grouped the data using the column that is number 2. Now we can actually group the data by multiple columns and form a hierarchical index. So for that, I'll just copy this, guys, or over here only I'll just do one thing, 2 and let's say 3. So this is how you actually combine multiple columns to form a hierarchical index. But here again, we don't have actually categorical values for these columns. If we had, we'd be able to do that. You know, if we had, like, let's say true and false, it is going to have created a hierarchical index which will have different values for true columns and for false columns. So that's how you do the grouping, or that's where you actually need grouping using Pandas. Now let's move ahead and take a look at the next topic that we have. Okay, we have already talked about operations, then I have talked about merge, where we have talked about concat and join, and then I've talked about splitting the data, how you apply the functions, and then combining the results together. Merging, we have talked about grouping. Now I'm going to talk about stack and pivot table. So what exactly is a stack, guys, in Pandas? I'm sure most of you must have heard about some of the definitions of stack. So I'm going to tell you about this with perspective of Pandas library here. So the stack function is used to stack the prescribed levels from columns to index, and it returns a reshaped data frame or a series having a multi-level index with one or more new innermost levels compared to the current data frame. So you're going to understand this with an example. So I'm just going to take let's say my tuple is equal to, I'm just gonna take a list, and inside this, let's see, we have values, and we provide, or we get 2 lists over here, a list inside a list, guys. So let's take a few values, take 1, 2, 3, 4, 5, and then again, let's say 6, 7, 8, 9, and 10. or we'll add a few more values, guys. Let's say 11, 12 and 13. Over here I will add a few more values, let's say 17, 18 and 19. So we have our tuple. I'm going to create one more variable index. So we'll have multi-index. So from tuples, and inside this I'm going to pass my tuple, pass the names as well. So the names are going to be, let's say, first and second. So we have our index. Now I'm going to create the data frame, guys. So for this we write pd dot data frame, and inside this I'm going to pass a few values. np dot, let's say, random dot random number. So we have 8 values and 2 columns. All right. So and the index is going to be index, and columns is equal to A and B. All right, we have an attribute error, guys. I made a mistake. So there's no error now, and I'm going to make one more data frame. So inside this I'm going to pass this value. Now I check my data frame. So I have reshaped my data frame with this, the first and the second, and all these values. Now we're going to talk about the stack method, guys, so which compresses a level in the data frame's columns. So we're going to do one thing. We're just going to do df2 dot stack. Right, this an attribute error. So this is how we stack or compress a level in the data frame's column, guys. And with a stack data frame or series having a multi-index as the index, inverse operation of stack is unstack, by which default it's gonna unstack whatever you have done with using stack. So we'll do df2 dot stack, and this is how you unstack. Now we'll talk about the pivot tables, guys. Oh wait, let's put it inside a variable, let's say A. Alright, so this is how you unstack, guys. We're getting different values there. Now we're going to talk about the pivot tables that we have in Pandas. So it is nothing but the levels in the pivot table will be stored in multi-index objects. On the index are columns of the result data frame. So we'll take a look at one example, guys, which is going to be pretty clear. So we'll take df again, pd dot data frame, and inside this we're going to take a few values, or we're going to take a list inside a dictionary. So let's go with a few values. Let's say 1, or let's say A. All right, so we write A, B, C, D, we'll remove a few values over here, multiply it to 3. Now we take another value, which is going to be B, and for this we're going to take a list again. So let's say multiply it to 4, take another value, let's say C now, and inside this we're going to pass a few values again. So we're going to pass 6 values. So let's write P, P and P, Q, Q and Q, multiply it to 2 because we want the number to be 12. And now D is going to be np dot random dot random number, and the number we want is 12, and we take one more value e, and we take the same values for this as well. Random number 12. No errors, I guess. So we have an invalid syntax, guys. So we forgot to add a comma over here and here and here. Right, so I think it should work fine now without any errors. So we have printed the data frame over here, guys. So this is how it looks. Now we can produce pivot tables from this data very easily, guys. The very reason of creating this data frame was to get the pivot tables. Now what I'll do is I'll just write pd dot pivot table, and I'm going to pass df over here. All right, df, and the values is going to be, let's say, d, and index is equal to a and b, and columns, let's say, is equal to c. So this is how you create a pivot table, guys. Now that we're done with pivot tables, let me talk about the next topic that we have, which is time series and categoricals. So we have done reshaping, merging, grouping as well. Now we're going to talk about the time series and categoricals. So Pandas has simple, powerful, and efficient functionality for performing resampling operations during frequency conversion, which is, for example, converting secondly data into 5-minutely data. And this is extremely common in, but not limited to, financial applications. So we're going to take a look at a few examples. And for categorical data that you collect can be either categorical or numerical. So numbers often don't make sense unless you assign meaning to those numbers. So for categorical data is when numbers are collected in groups or categories. And categorical data is also the data that is collected in an either or yes or no situation. For example, we have 0 or 1, we have true or false. So that's going to be the category over there. So let's take a look at a few examples to understand this, guys, the time series and categoricals. So we'll take a look at a few examples for time series. So first of all, what I'm going to do is I am going to make a time series, guys. So first of all, what we'll do is we'll convert the data into 5-minutely data. So it's very common, guys. So I'll just take the range first of all. So we'll take the dates. All right, I made a mistake. I'll just cut this. So I'll just run this again. We'll get one more column. And now what I'll do is I'll make one variable using the pd.date range. Yes, and I'm going to provide the range as, let's say, 2020 01 or 03 01. We want the periods is equal to 100, and let's say frequency is equal to s. All right, let's print dates. Okay, so we have dates over here. I'll just remove this for now. So now we take one more variable, let's say ts is equal to pd dot, I'm going to take a time series, and inside this I'm going to use np dot random and random integer, which is going to be 0 to 500, and the length is of dates, and then we have index is equal to dates. So we have, okay, we have NumPy attribute, no random random. All right. So we have an unsupported date time. So I'm going to have to change this over here. So we'll write it as, let's say, 3 1, or we're going to write 3 3 2020. Right. So let's see if it works now. It doesn't. So we're getting the unsupported D type. Okay, so we just mention a few more stuff over here. So we'll write it as 0000 So I think I figured out the problem over here. So I've changed this to this format, and now I'm gonna add one more parenthesis here and remove this one. And now I'm not getting any errors, guys. So I'll run it again, right? So now what I have to do is I will have to make a few changes to that TS, which is time series I've made. So I'll write it as ts.resample, and I want to make it to 5 minutes, right? And I have to sum this. So no errors there, guys. So now I'm going to do the time zone representation. So for that, I'm gonna get one more. Okay, I'll just copy this, guys. This little change to this only. So I'll just copy this, paste it over here. And here, I have to make a few changes. That is 0, 0. The rest, everything is going to be fine. And we'll change this to 5. Alright. So now we make another timestamp and we just use pd.series, and inside this I'm going to use np.random number, and the random number is going to be the length of dates and dates over here. Alright, so now when I print timestamp, I'm getting the output as something like this. So this is how you get the time zone representation, guys. So you're getting the date, the time, and everything. And the data type is float64. And then you can also get the UTC as well. So for that, I'll just write ts UTC, and we just write timestamp dot tz localize, and we get UTC, right? It's UTC. Now I'm gonna print this, so we get the UTC as well. So this is how you create the time zone representation. And now after this, I want to show you how we can convert to another time zone. So for that, we don't have to do anything. We just write ts UTC dot tz, which is time zone convert, and we write US Eastern. So we have converted into the US time zone. And converting between time span representations also, we can do that. Let's just say that's your exercise. So you have to convert between the time spans representations so that you'll be able to understand this better. For that, you don't have to do anything. You just have to take the date range, the period, so it's going to be 5, and then you write the frequency. Instead of S, you write it as M. The rest all is going to be the same, guys. Okay, I'll just do it here as well. Just copy this, paste it over here. Instead of S, it's going to be M. We'll have to remove this. All right. Now I make the timestamp, which is going to be the same, guys. Now print the timestamp. This is how we convert. Or after this, we take one more variable, let's say PS, and I'm going to do period. All right. Now when I print PS over here, this is the output I get. So the frequency is M. I've changed the frequency, and now I can just convert it to timestamp, guys. Let's see where it is. This is how you create it into a timestamp. Now converting between period and timestamp enables some convenient arithmetic functions to be used. So for that, we have period, range, and all those things that you can add. Now moving on to the next topic, that is categoricals. So for that, let me just take one more data frame, guys. So I'll write it as df is equal to pd dot data frame. Now I'm going to take a few values inside this dictionary. The first is going to be, let's say, ID. And now I'm going to pass a list with a few values, precisely 6. So I'm going to use 6 values over here. Now my next topic is, or the next key is, let's say raw grade, or just grade we'll write. So we're going to write A, B, C. Let's say again the guy's getting B and this one's getting A. So we have 5 and one more. Let's say one guy has failed. So we have our data frame. Let's print this. Okay, so we have our data frame. What I'm going to do is I am going to get the grade, right? So we'll get the grade is equal to df grade. Now this is going to be the category I'm going to make. All right, now we print df grade. So we have grades like A, B, C, B, A, E. Now I'm going to rename the categories to more meaningful names. So what I'll do is I'll make the change over here only. So I'll write cat dot categories, and I'm going to write the categories as, let's say, good. Instead of pass fail, I'm just going to write very good, and then there is excellent. All right, so we have very good, very bad, and excellent. All right, we have an error, guys. There's something we have done. So we have new categories needs to have the same number of items as the old categories. So how many categories do we have over there? Let's just copy this. So we have categories 4. So we're gonna have to make 4 categories, guys. So I'm just going to add good as well. There shouldn't be any errors. Now what I'll do is I'll just set the categories. So I'm going to set the categories now. Let's say here I'm going to have to give 6 values, guys. So right, very good. Let's say bad, very bad, medium good, very good. Any sort of categories I have to give over here. So I'll just write very bad, good, and let's say medium. All right, so after this I have set the categories as well. Now I'll just write df grade. Okay, so we have good, very bad, then we have very good, very bad, and good, and then we have NaN because we have not given any other category for that. And we have the 5 objects, so we are getting very good, bad, very bad, good, medium. So that's how you use the categoricals in Pandas, guys. Now I'm going to talk about plotting using Pandas. So that's going to be very simple, guys. For that I'm going to have to import one more library, that is Matplotlib dot pyplot. I'm going to use it as PLT. All right, same thing goes with this as well. All right, this is going to be pyplot. All right, so there should not be any errors now. Okay, so I will close all. Now I'm going to make one series, guys, And inside the series, I'm going to provide a few random values like np dot random number until, let's say, 1000, or let's say 500, or yes, 500. And the index is equal to pd dot date range. I'm going to take the date range as 1/3/2020, and let's take the periods is equal to 1000. Wait, we have to take it as 500 because we have 500 values over there. I hope no errors. Yes. Now I'm going to take the timestamp and we're going to get the sum. Alright, now ts dot plot. So we have a plot over here using Pandas, guys. This is how we have created one series using the random numbers from NumPy library, and using the pyplot we have plotted a graph for random values which we have taken from 0 to 500 and the random range as well. So this is how you take or get a plot using Pandas, guys. Now last but not the least, we have another topic which is reading and writing to files. So inside this, I'm going to show you how you can read from a file and how you can actually create a file over there. So we have our data frame, guys, or we have our TS. This is our TS, guys. So I can just, convert it to a CSV file, guys. Make it or give it a file name as, let's say, ts.csv, and it's going to save the ts.csv file somewhere in my directory. And similarly, I can read from a CSV file. So for that, I can just write pd.read CSV, and I'm going to have to give the file location for that. So I'll just copy one file location from one of my data sets. So this is one data set that I have. So I'm going to check for the properties, or wait, I'm going to copy this, paste it over here. Okay, we have an Unicode error, so I'll just write R over here, and I'm able to read from the CSV file, guys. Look at this. Instead of CSV, I can write Excel, and it's going to create a Excel file or a CSV file it's going to read from. So that's how we actually read and write from files, like a CSV file, which is a comma separated file basically, or we read from a file.
Now it is very important for us to understand as to how Matplotlib works fundamentally. Now it is pretty easy and pretty basic. You have some data, then your computer will draw that data to a canvas of some sort, but it is only in the computer's memory. Now once your computer has drawn that data, you can show that data. So this is so the computer can first draw everything and then perform the more laborious task of showing it on the screen. Very basic. I know you might find it pretty lame, but it is very important for us to understand how fundamentally Matplotlib works. So you have an example in front of your screen. So again, we have that data in which we have country-wise percentage of unemployed youth. And I've done some analysis and I've shown it graphically, the percentage change in the unemployed youth country-wise between 2010 to 2011. So this is how that plot looks like. It is nothing but a bar plot. Now there are various types of plots available. We'll have a look at few of those in the next slide. So we'll move forward and see what are the various types of plots. So I've listed down 6 types of plots. First is the bar graph, then histograms, scatter plot, pie plot, hexagonal bin plot, and area plot. We are going to plot all these things in today's session with the help of Matplotlib module. So we'll move forward and we'll get started with it. We'll write our first Matplotlib code. So here's the most basic code in order to generate one of the most simple graph. So let me explain to you this code. First of all, what I've done, I have imported pyplot from Matplotlib as PLT. Then I'll use this pyplot in order to plot the graph in the canvas. And then finally, I'll use this PLT, which is nothing but pyplot, in order to show what we have got. All right. So pretty basic, guys. So what I'll do, I'll open my PyCharm and execute this practically. Alright, so before I open my PyCharm, we have a question from Brian. He's asking, what are the tools that are used for data visualization? Alright, so I'll tell you, we have a lot of tools available in market nowadays. We have Tableau, we even use R, Python. So for Python, we need to import the Matplotlib library. So there are many tools available in the market right now. So I hope this answers your question, Brian. Alright, so he says yes. Fine. So I'll open my PyCharm and I'll execute this practically. So this is my PyCharm, guys. So over here, I'll first create a Python file with .py extension, and I'm going to name it as first code. Now over here, I'll first import pyplot from Matplotlib. So for that, I'll type from Matplotlib import pyplot as PLT. Now this PLT is pretty much similar to NP that we were using in NumPy array, if you can recall. So it is not mandatory to use PLT only. You can use whatever you want, but a lot of people use it as PLT, and I'll keep it that way. Now our next step is to plot our graph to the canvas. So for that, what I'll do, I'll type in plt.plot, and I'll write in here my X and Y axis values. So for X axis, I'll keep it as 1, 2, 3. Then for Y axis, I'm gonna add values such as 4, 5, and 1. So this will plot our graph in the canvas. Now final step is to show that plot. How we'll do that? I'll just type in here plt.show, and we'll execute this and see what happens. Run first code, and yep, this is how our first basic graph looks like. So with 3 lines of code, you have got this graph. So we'll move forward and we'll see how to actually add title labels to our graph. For that, I'll open my slides once more. So now, of course, there are some problems with our graph. First off, we have actually learned in school that we are supposed to put labels on each axis. And we need to also add a title to our graph. It actually doesn't make sense. Our graph doesn't make sense if there are no X and Y axis labels and a title. So you don't know what is axis, you don't know what is X axis, you don't know what is Y axis, and what is the graph about. Plus, in terms of programming, it is very unlikely that you'll be actually filling in data to the plt.plot function. Now over here, you can notice that we are actually filling in data like 1, 2, 3, 4, 5, 1. Instead, you will be passing variables into it. All right. So it should be something like plt.plot, and you can say X, Y if you have defined variables X, Y. All right. So now let us show plotting variables as well as adding some descriptive labels and a good title. How does that sound, guys? Alright, so I can see a lot of people are pretty excited. So we'll move forward and see how to add title, labels, and plotting variables. Now, the code is pretty much similar to the previous one, but it has few extra fields. Let me explain you that. So of course, I've imported the pyplot from Matplotlib. After that, what I've done, I've defined 2 variables, X and Y, and I have certain values in it. Like 5, 8, 10 and 12, 16, 6. You can put whatever values you want, and this can even contain a data frame, a Pandas data frame that has a data set. After that, what I've done, I've defined plt.plot function in which I have X and Y. Instead of filling the data, I'm putting in variables that actually contain data. After that, I've added a title which is info, then Y label which is nothing but Y axis, and X label which is nothing but X axis. After that, I need to show my plot, so for that I've done plt.show. And the result is there in front of your screen. We have a title, we have labels for X-axis and Y-axis. Now let me open my PyCharm and execute this practically. So before I open my PyCharm and execute this practically, we have a question from Siddharth. He's asking, X and Y contains list. Yeah, X and Y actually contains list. We have list of numbers 5, 8, 10 in X variable, and in Y variable we have similarly 12, 16 and 6. So I hope this answers your question, Siddharth. Alright, so he says yes. Fine, so I'll open my PyCharm and execute this practically now. This is my PyCharm again, guys, so I'll remove till here, and obviously I need pyplot function from Matplotlib. So now I will define X and Y variable. So in X, it'll have a list of numbers, say 5, 8 and 10. And now I'll define one more variable, Y, which again has a list of numbers 12, 16 and 6. 12, 16 and 6. Now what is our next step, guys? Can anyone answer me? Alright, so I've got a correct answer from Theon. He's saying a plt.plot function, which is absolutely correct. So I'll write in here plt.plot, and instead of filling in data, I'll be passing variables. Alright. And now our next step is to add title and X label as well as Y label. So in order to add title, I will write here plt.title and the title of my graph. So I can just write here info. And now I'm going to define X and Y labels. For that, I'll type in plt.y label and I'm going to name it as y-axis. Similarly for X label, I'm going to do the same thing, x-axis. Alright. Now finally, I'll type in plt.show. Now go ahead and run this. So you can see that we have a graph that contains the title info, y-axis as a Y label as well as x-axis as the X label. Now I'll again open my slides and we'll see what next are we going to see. So any questions or doubts still here, guys? You can ask me. Any questions? So we have no questions. So what I'll do, I'll open my slides and we'll move forward. Now this graph is pretty much incomplete or ugly, I would say, because what if I want to change the width of this particular line? What if I want to add some grid lines? What if I want to change the color? So all those things, how will I do that? Don't worry, the next slide will actually tell you the same, how to add style to your graph. So how to add style to your graph? For that, first thing that you need to do is import the style function from Matplotlib module. After that, you need to call it style.use ggplot. So whatever plot that you want to use, I'm using ggplot right now. Then again, I've defined 4 variables, x, y, x2 and y2, and all of these contains a list of numbers. Again, I'm telling you, it can be a data frame as well, which contains a data set. Then what I've done, again, I have used plt.plot function, but over here, apart from x and y, there are many other fields. So don't get confused. I'll explain it to you. It's very, very easy. So this thing G actually tells me that the color of my line should be green. Then this is label. So this label is not for your x-axis or y-axis. It is for your curve, which is line 1. You can give whatever name you want. Then we have line width. I want the width of my line to be 5. So I've put in here 5. Similarly, I've done for the next plot as well. Then I've added title, which you know how to do that. Similarly, Y label and X label. Now after that, I'm using this legend function in order to add a legend to my graph. Over here, you can notice that we have it present in our graph where I'm pointing with my highlighter right now. So we have line 1 and line 2. After that, what I've done, I've added grid lines to my graph, which is of the color K, which is nothing but black. So you can see it in my graph as well. We have grid lines available. And finally, plt.show. Any doubts, questions still here, guys? We are going to execute this practically in my PyCharm. So before that, if you have any questions or doubts, you can ask me. Alright, so we have no questions. So I'll open my PyCharm again and I'll show you how you can do that practically. So this is my PyCharm again. Guys. Let me first remove all of this. And I need to import the style function. So for that, I'll type from Matplotlib import style. That's it. Style.use ggplot. Now define the variables. First will be x, add certain values to it. I'll add in 5, 8, 10. 5, 8, 10. Then y. I'm going to add a list of numbers 12, 16, 6. Now one more variable x2. Again, it will have list of numbers which will be 6, 9, 11. Then I'm going to use y2 variable and I'll add some numbers to it 6, 15 and 7. Alright. So now I'm going to use plt.plot function. And over here first I write x comma y. Then now given a color to it, I'm going to give it as green. Next label line 1. Now line width which is equal to 5. Now again for x2 and y2 I'm going to type in plt.plot x2 comma y2 comma the color, then label. So I'm going to type in line 2, then comes line width. Alright, so now our next step is to add title to our plot. So plot plt.title, and the title that I'm going to give is info again. Then x and y labels, plt.y label, y axis, then plt.x label, x axis, plt.show. Now go ahead and run this. So over here I've not added any grid lines. I can do that as well. So for that, let me first close it. Fine, so I've defined title, x label as well as y label. Now our last task is to actually add grid lines. So for that I'll type plt.grid and just write in here true, comma, give a color. I want it black, so I'll keep it that way. Finally, show your plot. So plt.show, that's all. Go ahead and run this. So you can see that this is our graph. So we have changed the default line width. We have added grid lines. We have added labels, titles, plus we can add legend as well. So let me show you how you can add a legend. So for that, I'll go back to my code once more. Just write in here plt.legend. Go ahead and run this again and you'll see that legend has been added. So here we have line 1 and line 2 as our legend, and we have changed the default line width, title, y-axis, x-axis labels, plus we have grid lines. So this is how you can customize and add style to your graph. So I hope you all are clear. Alright, so everyone says they are clear. So what I'll do, I'll open my slides again and we are going to look at how to plot various types of graphs. For example, a bar graph or a histogram, all those things. Fine, so first we'll look at how to plot a bar graph. So these are all the linear graphs that we have seen till now. Now we'll see how to plot a bar graph. So before I tell you how to plot a bar graph using Matplotlib, let us understand why we actually use a bar graph. So bar graphs are basically used to compare things between different groups. And when we are trying to measure changes over time, bar graphs are very well suited when changes are larger. So this is why we use bar graph. Now let us understand how we can do that using Matplotlib. Now since we know why we use bar graph, let me explain you the code and how you can do that using Matplotlib. So first import pyplot like we do every time. After that, instead of plt.plot, I'll use plt.bar, and I have filled in data here. You can fill in variables as well that contains data. Then I have defined a label, example1. After that, I have one more plot in which I have filled in data plus a label, and I've given a color as well. I don't want the default color, I want some change, so I've written it as green. After that, I've plotted the legend. After that comes legend and then X label and Y label that you have seen in the previous graphs as well. Then I've added a title and then finally show it. Don't worry guys, I'll execute this practically in my PyCharm now. So this is my PyCharm guys. So over here what I've done, first of all I have imported the pyplot function. Then instead of plt.plot, I'm using plt.bar, and inside that I have data filled in. Instead of that, I can even have variables that contains data. Then comes label, in which I am using example1. Then comes label. For this instance, it is example1. Then again, for one more plot, I have plt.bar. Inside that, I have data filled in, then label, and then in order to differentiate between both of them, I'm using a color green for this particular bar graph. Then comes legend, and then after that I've defined X label as well as Y label. After that I have title, and then finally show it. Now go ahead and run this and see if it works or not, and yes it does. So we have legend here, we have X label, we have Y label as well as X label, and we have a title for our graph. So any questions, any doubts guys? Alright, so we have a question from Dave. He's asking what is the difference between histogram and bar plot. Alright Dave, I'll tell you, in histograms we have quantitative variables, alright, and when I talk about bar plot, they have categorical variables. So let me explain you this with an example. So suppose if I want to plot the GDP growth of every city in a particular country, so at that time I'll use a bar plot because it has a category, this particular city, like New Jersey, New York, all those things. Now when I talk about, I'll use histogram when I'm talking about quantitative variable. That means if I'm talking about age group. In that same example, if I want to calculate how much each age group is actually contributing towards the GDP growth, so at that time I'll be using histogram. So I hope this answers your question. Alright, he wants me to repeat it. Fine, I'll do that. So when I talk about histogram, it actually has quantitative variables. When I talk about bar plot, it has categorical variables. Now with an example, if I explain you can take the example of GDP growth. So if I want to calculate how much GDP growth is there for every city in a country, so at that time I'll use bar plot. But if I want to calculate how much each age group is contributing towards the GDP growth of a country, then at that time I'll use a histogram. So over there we had a category in bar plot like cities, but here we have a quantitative variable that is age group. So I hope this answers your question. Alright, he says yes, fine. Alright, so let us move forward and focus on the code that you have in front of your screen. So let me explain you this code. So over here we have population ages. So we have defined a list in which we have multiple numbers. After that we have defined one more list or a variable bins in which we have multiple numbers again. Now instead of using plt.bar for bar plot, for histogram we use hist, plt.hist. Then comes population ages. Instead of data I am filling in here variables that contains data. Then bins. Then hist type, I want it to be a bar type. Now when I talk about hist type, I want it to be bar. Then the width should be 0.8. That's all. The rest all you can understand. It is X label, Y label, title, legend, and finally show the plot. Now I'll go ahead and execute this practically in my PyCharm. So this is my PyCharm, guys, and just to save time, what I've done, I've actually copied it already. So over here you can see we have imported the Matplotlib module. Then we have a variable population ages and bins. Now instead of using plt.bar, I'm using plt.hist for histograms. Then comes the two variables, and then hist type is equals to bar, and then I've defined width. Similarly, I've defined X label, Y label, and title like the previous examples. Then comes legend, and then finally show the plot. So let us go ahead and execute this and see if it works or not. Yep, it does. So we'll move forward and understand scatter plot as well. Now before we understand how to plot a scatter graph, we need to understand why we actually use scatter plots. Usually we use scatter plots in order to compare two variables, or three if you're plotting in 3 dimensions, looking for a correlation or groups. So basically you try to find out how much 2 or 3 variables related to each other. So over here, as you can see, there is one point here and there's another point here. So these two are pretty much dissimilar to each other, right? Now when I talk about these 2 points, they're pretty close to each other. So you can say that these two are pretty much similar. And basically what we are doing here, we're trying to find the relationship between the 2 variables. And that is actually called your correlation. Now let us understand the code. Now let me explain you the code. So first of all, we have imported the pyplot function from the Matplotlib module. Then we have 2 variables X and Y, which contains a certain set of values. Now instead of calling plt.plot or plt.bar or plt.hist, I'm using scatter because I'm doing it for a scatter plot, right? Now inside the parentheses, I have X and Y variables. These variables contain data, and I can even write the data instead of just writing the variables as well. Now I've defined a label and then color. Then rest of the things, we have X label, Y label, the title, then legend, and then show. That's all. Now let's go ahead and execute this practically in my PyCharm. Now this is my PyCharm, and over here I've already pasted the code. So I'll just go and run this and we'll see what happens. So this is how our scatter plot looks like. So here we have our legend, then we have the title, then we have our Y-axis, then X-axis. These two are the labels for that. So let me close it and see what is the other plot that we are going to focus on. Now once scatter plot is done, we'll have a look at the area plot, or you can even call it as a stack plot. So basically these area graphs are very similar to the line graphs, okay? They can be used to track changes over time for one or more groups. Area graphs are good to use when you are tracking the changes in 2 or more related groups that make up one whole category. You can take an example of, say, public and private groups, okay? So before I explain you the code, let me tell you one thing, guys. The problem here is with polygons, we cannot actually have labels for our data. In order to solve that problem, all we did here was plot some empty lines, giving them the same color and the correct labels in accordance with our stack plot. We also gave them a line width of 5, as you can notice here, to make the lines a bit thicker in the legend. Now we can easily see that we are spending our day sleeping, eating, working, and playing. So this is how the code works. Now let me execute that practically in my PyCharm. So I've copied the code already just to save time again. Now this is our code. Over here I've already explained to you why are we defining these empty lines, just to add labels. Now let us go ahead and execute this and see what happens. So this is our graph, guys, and again we have legends, title to our graph, and Y label as well as X label. So we'll move forward and look at various other plots. This is called a pie plot. So let me tell you about pie charts a bit. So pie charts are pretty much similar to stack plots, only they are for a certain point in time. Typically a pie chart is used to show paths to the whole and often a percentage share. You can consider the example of percentage of market share and things like that, right? Now let me tell you guys, Matplotlib handles the sizes of the slices and everything. So all we need to do is just feed it the numbers. That's what we have done here. So let me explain you the code here. So over here we use plt.pie to plot a pie chart. We have slices. We have specified slices. Now slices which are nothing but the relevant sizes for each part. Then we specify the labels and then the color list for the corresponding slices. Next we can optionally specify the start angle for the graph. This lets you start the line where you want. In our case we chose a 90-degree angle for the pie chart, which means the first division will be a vertical line. Next we can optionally add a shadow as well. And after that we can even use explode to pull out a slice a bit. So we have explode that says 0, 0.1, 0, 0. So because of that you can see that eating has been pulled out a bit. Now basically we have 4 total slices. So with explode, if we didn't want to pull out any slice at all, we would have just written here 0, 0, 0, 0. Now if we want to pull out the first slice a bit, we would do 0.1, 0, 0, 0. And if we want to pull out the second slice a bit, what we can do is 0, 0.1, 0, 0, like in our case. Now finally we do an auto pact. Now this auto pact overlay the percentages on the graph itself. So you can see that we have 8.3, 29.2%, 54.2%, all those things written on the graph itself. And then finally add a title and then show it. Now let me execute this practically, guys. Now just to save time, I've already written the code. So I'm just going to go ahead and execute this and we'll see if it comes or not. Yep, here is our pie chart. So we have seen multiple types of plots. We have seen pie plot, bar plot, histograms, area plot. Now what we need to understand is how to handle multiple plots. So at that time, what will you do? Let me open my slides again and we'll move forward with that. So this slide actually tells you how to deal with multiple plots. Now you can notice in the figure as well, we have 2 plots available. Now let me help you out with the code that is there in front of your screen. So in the beginning, we are importing a couple of modules. One is matplotlib.pyplot, which you are already familiar with. After that, there is a NumPy module as well. So we have covered NumPy modules in the previous sessions. If you have any doubts, you can go through it. Now after that, you might find this part confusing if you're not familiar with NumPy. Now let me just tell you what it does. It will create a NumPy array that will have elements between 0 till 5 in the steps of 0.1. Now similarly, T2 will also be a NumPy array that will have elements ranging from 0 till 5 and in the steps of 0.02. Now after that, the code is pretty much similar to the previous examples that we have seen. But there is one new concept that is called subplot. Now let me tell you what this subplot does. It helps us to plot multiple plots, alright? So when we write subplot 211, this means that we have 2 plots. Horizontally, we have only 1 plot present and vertically we have 2 plots. And in that vertical position, this plot will be our first graph. Now you can notice that we have one more subplot that is 212. So vertically we have 2 plots, horizontally we have 1, and this is the second plot. So what I'll do, I'll open my PyCharm and I'll play around with it a bit so that you'll be able to understand it better. So now this is the code, guys. First I'll go ahead and execute this and we'll see the result. So we have a graph something which is like this, right? We have 2 plots which are aligned vertically. Now what I'm going to do is I'm going to just minimize this and I'm going to change the subplot value so that you'll be able to understand better how we are dealing with multiple plots. Now over here, if I make this as 2 and this one as well as 2, so let us see what we get. So we have got the same graph, but it is aligned horizontally, if you can notice. This is our another graph and this is our first graph. So you can notice the difference between both of these graphs, right? So this is why we use subplot. So we have certain values in the subplot, right? 2, 2 and 1. Now what this 2 means that we have 2 graphs available with us. After that, whether I'm aligning it horizontally or vertically. So if I'm doing that horizontally I have 2 graphs. Then among those 2 graphs, this is my first graph. This is what it means. Now similarly, when we have 2, 2, 2 here, this means that we have 2 graphs. Horizontally we have 2 graphs available and this is the second graph that is present. So Similarly, if I make a change here and I make this as 211 and this as 212, this means that horizontally we have only one graph and these both graphs are aligned vertically. So we have, this was the first graph and this is our second graph. This is how it works. So this is what basically subplot is.
Why we actually require functions. So guys, here I have for you a really simple use case. Consider this program, right? So let's say you actually write a program in which you input a Celsius number, let's say a temperature of course, and this must be converted into Fahrenheit multiple number of times. What would you do? We first obviously start with the logic, right? So Fahrenheit is equal to 9 by 5 into the particular Celsius number plus 32. So this is the logic to calculate for Fahrenheit. Well, here's the program to calculate for the Fahrenheit, right? So we collect the input from the user, we enter the Celsius value, again the value in Fahrenheit has been converted and it has been printed. Well, it is really good, right? So this has been done once. But what if you actually want to do it multiple number of times? Well, let's say you have 1 Celsius value, then definitely it is really easy, right? So let's say you have 3000, 5000, let's say you have 1 lakh values that needs conversion in real time as well. So when this happens, you wouldn't want to repeat the same lines of code, right? Well, this is the number one cause of inefficiency and ambiguity, guys. Well, I'm sure you already would have guessed it, right? So Python functions definitely solves this. Let us check out how it can be done. Well, just before that, let me give you another instance. We have something called as dry. Well, dry is don't repeat yourself. In the sense, when you're actually writing your own functions or when you're writing any methods, make sure that the reusability of it is really high. Functions not only reduce the code in your main program, but they also tend to make your code run faster and better. So what does this do? This actually increases the readability of your code and then makes it very easy for debugging and documentation as well. Consider this easy example, right? So every time you turn on or turn off your television, there are certain functions built in, right? So as soon as you flip the channels or say adjust the volume, there isn't anyone in the backend writing a code at every point of time to actually adjust the volume or flip the channels for you. There is a particular code which repeats itself and doesn't create any new instances when you actually adjust the volume or flip the channels, correct? So this is again very good efficiency. So as soon as you change the channel, there is a function which runs which says that the user has changed the channel. So let me do these certain set of codes. Again, similarly for the volume as well. So if you have increased the volume or decreased the volume, the function gets an input of what you're actually doing. And then this function actually works on your input and then decides an action. In this case, it's volume. Pretty simple, right? Well, now that we know why we need functions, right? So let us check out what functions actually are. So what are functions, guys? I'm pretty sure every one of us has an idea at this point of time. So head to the comment section below and let me know what you think of it. I'd love to interact with you guys there. So coming back, what are functions? Guys, functions are actually a way to break problems or processes down into smaller and independent blocks of code. Straightforward, right? So it's basically a block of organized reusable code that is used to perform some similar task. In our last case in television, it was either adjust the volume or change the channel. Well, coming back to Python, it can be called by its name when its tasks need execution. You can also pass the values to it and have return results to you. Do not worry, I'll be walking you through a range of functions so you'll have a better clarity at this point of time. Well, at this time, all I want you guys to do is to know about the def keyword. Guys, def stands for define, and this keyword is actually used before the name of the function. And its name is followed by the parenthesis before a colon. Well, this defines an entire function. Check out this particular example code I have for you. So we have def function underscore name, and this function does nothing and pass. Definitely, right? So we haven't passed anything there for the function to do anything. Well, def is the keyword here. Function underscore name can be anything. It can be my name Anirudh, it can be Edureka, it can be anything that you like, right? It's as simple as that. So let me quickly introduce you to another concept called as docstring. So guys, what is docstring? It's actually called as a documentation string. So it's basically the first string after the function header is called, right? So this particular thing is called as the docstring. Again, as I mentioned, it is short for documentation string. Check this particular example out, right? So we have print greet dot underscore underscore doc underscore underscore. What does this do? Well, this function greets to the person passed into the name parameter. So if there's a name parameter in the documentation, the function actually greets the person which is passed by the name. Simple. Now check out this important flow I have on the left side for you guys. Again, we're going to come back to this, but right now you need to know this. We actually first define a function followed by the function name. We have a certain set of code, right, in the function or away from the function or anything. Well, good, we actually wrote the code until now. Well, later when we actually need to use it, we actually call the function by its name. As you can see, define function name will actually define that particular function and what that function actually should do. To call the function, and by calling the function, I mean to actually make use of the function, we just use the name of the function. So here, instead of def function name in the second line of code, we have function name. So this is where we'll actually be using the code. So this sort of flow is actually important, and I want you guys to note this at this point. So now that we're good with the basics, next up I want you guys to check out the different types of functions available in Python. So guys, there are two main types of functions in Python. First one is built-in functions and the second is user-defined functions. Well, as you might have already guessed it, built-in functions are already available with Python natively, and user-defined functions are something which are defined by the users, right? So there are n number of built-in functions for almost all the users, guys. So for the sake of simplicity in this tutorial, I have considered the built-in functions which are actually part of the native Python package. Well, with Python, as you already know, there are n number of libraries. So each library has multiple functions on its own. So as soon as you go into the depth of one single library, you'll get access to all of their functions as well. And in user-defined functions, again, as the name suggests, you can define whatever you want. So basically, let me give you a quick simple example, right? So consider the example of a calculator. So let's say 3 plus 5 is equal to 8, right? So let's say a plus b equal to c. You've written a function. You're going to pass the values a plus b, and then you have a function which automatically gives you the value of c. And you don't have to write a plus b equal to c all the time. So we are basically trying to reduce the amount of effort put in by the user and increase the readability as well. So there is absolutely nothing to lose when you make use of functions, and its advantages from the start to the end. And it's all advantages from start to the end. So let me quickly walk you through some of the major built-in functions which are available in Python. So guys, the first function I have for you is the absolute function. I am sure many of you can guess what the absolute function already is, but let me walk you through this function, right? So first I have the definition for you. So basically the absolute function returns the absolute value of a specified number. Well, that's confusing. What do we mean by absolute value? Consider this particular syntax and example. Well, the syntax is abs of n. Here abs is the keyword and n is the parameter passed. So n can be anything, right? So it can be 0, it can be 100, it can be anything. It has to be an integer here, guys. That is really important to note. So here all we're trying to do is we're trying to return the absolute value of a number. So consider the example, right? So we have a complex number here. X is equal to absolute of 3 plus 5j. Well, what does this do? So this basically calculates a number for us, which is actually a complex number in this particular case, and then provides the absolute value for it. So let's say instead of a complex number, we had absolute of -7. What do you think was going to be the answer, right? So it's going to be 7, obviously. So in this case, it was -5.83. And since it's absolute, minus has been removed and it's here. So what is the answer to x is equal to absolute of -10.5? Can you guys take a guess? Well, definitely it is 10.5, right? So there is no negative in terms of absolute. Simple and straightforward. Here, the parameter which is n, it is actually a number. So make sure you don't put any string input such that you can avoid all the errors. So the first function is done. So let's quickly move on to the second one. So guys, the second function I have for you is the all function. Well, the definition actually says this: the all function returns true if all of the items in an iterable are true. Otherwise, it returns false. But what are the iterable items that we're talking about, right? So it can be lists, it can be tuples, and it can be dictionaries as well, right? But you need to note one thing about the all function. So if the iterable object is actually empty, then the all function will still return true. So let's quickly take a look at the syntax and the example and the output as well. So syntax, all of iterable, you already know that the all here is actually a keyword. Check out the example. We have a list here, right? So my list is equal to true, true, true. And x is equal to all of my list. Well, it's basically telling us that all of the elements present inside our list is actually true and it matches. So as soon as you check out the output, it says true. Why? Because everything is true. This is the same case for lists, tuples, and dictionaries as I mentioned. So make sure you note that as well. Pretty simple, right? So we already covered two functions in such a short amount of time. Let us quickly jump into the third one. So this third function is a very interesting function, guys. So it is ASCII. I am pretty sure many of you actually know what ASCII is, right? So ASCII actually stands for American Standard Code for Information Interchange. And all it does is it is a character encoding standard, guys. So it is basically used by computers to actually understand. So we understand A to Z and 1 to 1000 or 1 to million, right? So how can computers make sense of this information in their low level language is exactly through ASCII. So what does the ASCII function do in Python? Well, the ASCII function actually returns a readable version of any of the objects. Here objects are strings, tuples, and lists or anything, right? And the ASCII function will actually replace any non-ASCII characters with escape characters. So if it's an ASCII character, well and good. If there is no ASCII character, it will actually escape that particular character, guys. So here's the syntax. Check it out. We have ASCII of object, again ASCII being the keyword and object being the parameter. So what is the object parameter here, right? So it's a string, it can be a list, it can be a tuple, it can be a dictionary, and anything you want in your particular instance. Check out this simple particular example here. So we have an x equal to ASCII and my name is Tale. The A here is spelled very differently and it does not have an ASCII value mapped to it, right? So if it was just stale, then you would actually get the ASCII output. Well, since here it is not a valid ASCII character, Python actually puts an escape sequence there and it actually escapes that particular thing and prints out the rest of the thing. Simple, right? Well, I'm going to assure that all of the functions are actually as easy as this, and then it would make your life easier to know what each of these functions. And at the end of the day, it will make your life really easy knowing what all of these functions do. So on that note, let me quickly move to the next function. So the next function I have for you guys is bool. Well, bool actually stands for boolean. Can you quickly take a guess again? Cool, I am sure you would have guessed it by now. The bool function actually returns the boolean value of a specified object. Well, it will actually return true unless it meets empty parentheses or empty brackets, or if the object is false, if the object is 0, and if the object is none as well. So all these cases are when it can be false, but any other time it will actually return true. So let me quickly walk you through the syntax. Bool of object, bool being the keyword, object being the parameter. So what is the object in this particular case? It can actually be string, it can actually be list, it can actually be number or anything, right? So check out this particular example. X is equal to bool of 1. So as soon as that happens, since it doesn't match with any of our false criteria, we got it as true. Simple, right? And now that we are actually done with the bool function, let us quickly check out our next function. Next function is enumerate, and this is definitely interesting, guys. So the short form of enumerate actually stands for enum. But in Python, we actually use enumerate. So in case you're coming into learning Python from an other different language, say C, C++ or Java or something, you would realize that enumerate here is the same as enum there. Again, let me quickly show you the definition of it. So the enumerate function actually takes a collection. Again, a tuple is a collection, right? And it takes this as input and returns it as an enumerate object. The enumerate function adds a counter as the key of the enumerate object. Let me give you some better clarity on this. Check out the syntax, right? So enumerate, and it has two parameters instead of one. So one is iterable and the other one is start. What is iterable? So we already checked out what iterable objects are. And then we have something called a start. Well, start is actually a number. We're trying to define the start number of the enumerate object. Well, if you don't put anything, it will be 0. Well, check out this particular example right in front of you, right? So we have x is equal to apple, banana, cherry, and y is equal to enumerate of x. So again, the default value is 0. So Python already counts from 0 instead of 1, right? So obviously apple becomes 0, banana becomes 1, and cherry becomes 2. And you can actually play with all of these key mapping values and then operate on them later as well. But at this point of time, all you need to know is this. Python starts from 0 and the first object there, first iterable object there actually starts from 0. So apple maps to 0 and so on from there, guys. Simple, right? And now that we are actually done with the enumerate function, let us quickly check out the format function. So what does the format function actually do? So guys, the format function actually formats a specified value into another specified value. Well, that was a bit complex, right? So let me quickly simplify that for you guys. So check out the syntax. We have format and we have two parameters, value and format. Well, a value can be a value of any format, guys. And then we have something called as format. Guys, I'm talking about the parameter here and not the keyword. So basically we have multiple parameters, guys. So we have lesser than. So lesser than basically left aligns the result, and then we have right align, and this actually aligns the space. Then we have is equal to. So this basically places the sign to the leftmost position. And we have minus. So this is actually used for a negative value, as you already know it. Then we have B. B actually converts it to binary. C converts it to Unicode. D to decimal. F to a fixed point number. G to general point, and so on, guys. And if you want more, it is basically O for octal, lowercase x for hex, uppercase x for uppercase hex format, N for number format, percent for percentage format. But in this particular case, check out this example. We have x is equal to format of 0.5 and percentage, right? So 0.5 in percentage is what? So it is basically 50%, right? So it is basically half. So 50% is your answer. Another function, done. So what is the next function I have for you guys? Guys, the next function is actually get attributes. So basically it is shortly called as get attr. Again, a keyword. So what does this function do? Guys, the get attr function actually returns the value of the specified attribute from a specified object. Again, looking at the syntax, we have get attr, we have the object, attribute, and the default parameter. The object is compulsorily required because we need to know what we're working on, right? So this is the compulsion. And then next we have the name of the attribute, right? So basically it is the name of the attribute from which you want to get the value from. And next we have default. Guys, default is optional here. So what does it do? Basically it is the value to return if the attribute does not exist. So in case there isn't any particular attribute to return to, it returns to this default value. Check out this really simple example I have for you guys. So we have a class called person, name equal to John, age equal to 36, country equal to Norway. X is equal to get attribute of person and age. So at this point of time, what we're trying to do is move into the class person, find me the age of this particular instance. So in this particular case, John's age is 36, and that is exactly what we see in the output. Pretty easy, right? And now that we're done with the get attribute function, let's see what's next. So this is an interesting function, guys. So I have the identity function for you guys. So guys, this is an interesting one, the identity function. Also for short, it's called as the ID function. So what is the definition of this function? Guys, the ID function actually returns a unique identifier for any specified object. So all the object in Python has its own unique identification, right? So the ID is actually the object's memory address, and it will be different for each time you run the program. Check out the syntax and the example, guys. So ID of object, as you can already tell, ID is the keyword, object is the parameter. Here the object can be anything, guys. It can be a literal object, it can be a string, it can be a number, it can be a list, it can be a class or anything as such. Check out the example. X is equal to apple, banana, cherry. Y is equal to ID of X. Well, this particular object created has the identification as this. So when you actually perform operations on this particular object on X, and then Python basically tracks it in the background using this particular identification, guys. So every object in Python is actually mapped to a particular unique identifier. It may not be the same every time, but what is important to note that it actually has a unique identifier. So if I probably ran this program twice and then showed you the same output, it would actually not be the same because another identification number would have been provided. So identification function is as simple as that, guys. So let us quickly move on to the next function. So the next function I have for you guys is the length function, and it is shortly called as len. So guys, the length function basically returns the number of items in an object. So consider this, right? So when an object is a string, the length function actually returns the number of characters in that particular string. Check out the syntax. So we have len of object, right? Again, object is definitely a mandate here because we need to know what we're trying to find the length of, right? So either it must be a sentence, it must be a string, or it must be a generic object, or it can be a sequence, or even a collection as well. So check out the easy example I have keyed for you, right? So my list equal to hello. So we have one word here, right? So it consists of 5 letters. So as soon as you print x equal to len of my list, it realizes that this is a string and it prints the number of characters. In hello, there are 5 characters, and as you can see, the output is 5. Well, length function done. Guys, the next function I have for you guys is the map function. Can you quickly take a guess on what the map function actually does? So guys, the map function basically executes a specified function for each item in an iterable sequence. So this basically tells us that the item is sent to the function as a parameter, right? So we need to know what we're actually doing here. So check out the syntax. Map is the keyword, and we have 2 parameters, which is function and iterable, guys. So function is definitely required because we need the function to execute for each particular item, right? And then we have iterable. Well, in this particular function, again, iterable is also a compulsory requirement because we need to know, right? We need a sequence, or we need a collection, or an iterator object, or something to work on. So you can basically send as many iterables as you make sure that the function has only 1 parameter for each iterable. Quickly check out the example and the code, and I'm pretty sure you guys will figure it out on your own. So basically we have defined my function of n. Again, defining the function name of the function is my function, my func, and then the parameter is n. What we are actually going to do is we are actually going to return the length of our input parameter. Check out the next line, x equal to map of my func, and then we are passing it three values, apple, banana, and cherry, right? So what do you think is the length of this? So each individual object can be iterable, right? So apple has 5 characters, hence 5. Banana and cherry has 6 each, so 6 characters each. Again, pretty simple and widely used, guys. So this function actually helps you a lot when you're actually trying to map something to a key, or when you're practically trying to make use of this. So now that that's done, let me quickly walk you through the next function. So guys, the next function I have for you is the min function, min or minimum, right? So this function basically returns the value with the lowest value, or it returns as an item with the lowest value in a particular iterable. So if the values are strings, then alphabetic comparison is actually done. Let us quickly check out the particular syntax here. So we have min of n1, n2, n3, right? So it can be any number of numbers. And then we can have another syntax actually, right? So what do we do if it's an iterable? So instead of n1, n2, and n3 or so on, we're going to have min of iterable, guys. As simple as that. But check out the example here for simplicity's sake. We have x is equal to min of 5 and 10. So it's as simply as saying what is the minimum of 5 and 10. So which value is minimum here? 5, right? So if I had to give you another example, what is the minimum of 1000 and 10,000? So whatever is the minimum number is output, right? So in that case, it was actually 1000. So it is as simple as that, right? So I don't think I need to explain more about this. And you guys got a pretty good idea about it already. So moving on, next I have for you guys is the POW function. POW stands for power. So it's basically exponentiation here, guys. So the function actually returns the value of x to the power of y. Well, in this particular case, x raised to the power of y, guys. So there are two parameters present, right? So what is the base and what is the power? So if there is a third parameter, then it returns the x to the power of y and the modulus of z. Quickly check out the syntax and the example, guys. So we have 3 parameters in this case, right? So it is pretty simple to pick up 2 parameters. So let's say what is 2 power 3? The answer is 8, correct? So what is 4 power 3 again? It is 64. If we actually require the modulus of this answer, then that would become our z parameter in this particular case. Since we haven't done it, 4 power 3 remains to be 64, and that is the exact output that we get. Simple, right? It is as simple and as easy as that, guys. So next up I have for you is the print function. This is probably the first thing that you would learn as soon as you start Python, and this is definitely not the last thing. And this is definitely not as easy as it sounds. So it basically prints the specified message to the screen or any other standard output device. Well, most of the time it is the screen, but you can actually do it to other devices as well. So print. So print, we have objects, then we have separators, and we have files, and we have flush, and we have so much around here, right? So let me quickly walk you through all of these in a simple way. So objects basically refers to any object, right? You can have any number of objects you want. All of these will be converted to a string before it is printed. And then we have separator, guys. Guys, separator is actually an optional parameter, and you specify how to separate the objects if there is more than one object present. The default separator is actually double quotes. And then we have end. Well, again, another optional parameter. So we use this to basically specify what to print at the end. The default is actually /n because again, we're going to move to the next line as soon as something is printed. And then we have file. All of these are optional, guys. So basically file and flush, everything is optional here as well. So file is basically an object with a write method. That's it. But what if there isn't anything? Well, the default parameter of the file object is actually sys.std out. So it is the system standard out, guys. And lastly, we have flush. Well, again, flush is another optional parameter as I told you. And this is basically a boolean specifying if the output is true or false. Well, here is a computer science term for you guys. If the output is true, we call it to be flushed, or if the output is false, we call it to be buffered. What is the default output? It is buffered. So what is buffered? Buffered is false. So the default output is false, guys. Again, probably the most widely used example ever I have for you guys is printing hello world. So print, our separator is the double quotes, and we're printing hello world. Again, I hope no more explanation is needed for this particular function, guys. So moving on, we have the set attribute function, guys. So this function basically sets the value of the specified attribute of a specified object. Again, object here is required because we need to know what we're working on. The attribute is required because we need to know what attribute we have to set and the value, right? So we need to know what value to what attribute we set. So if you already remember, we actually did the get attr, right? So we actually outputted a function and now we're going to basically set it. So check out the simple code I have for you guys. We have class person and then name equal to John, age equal to 36, country equal to Norway. Same as the previous example, right? So here we're using another syntax set attr of person, age and 40. All we're trying to do is instead of John having his age to be 36, change the age of John to 40. So go into the class person, look for age. So whatever is there, change it to 40. As simple as that. Again, this is a fairly straightforward function, guys. And next up I have for you is the sorted function. What does this do? Well, the sorted function actually returns a sorted list of the specified iterable objects. You can actually specify the ascending or the descending order as per your requirement. The strings are actually sorted alphabetically and the numbers are sorted numerically. As simple as that. But you need to know that you cannot actually sort a list that contains both string values and numeric values. So you either can do it for numeric values alone or string values alone. Got it, right? So check out the syntax. So we have something called a sorted and we have three parameters, right? So iterable, key and the reverse. Iterable is definitely required because we need to know what sequence we need to sort, either if it's a list, dictionary or a tuple. Key is optional, guys. Key and reverse are actually optional here. The key is basically a function which is used to decide the order. Well, what if you don't give any order? Default is actually none. And then we have reverse. So what is a reverse, guys? Again, it is an optional function as I told you, and it definitely is a Boolean function. So false will actually sort it to be ascending and true will actually sort it to be descending. Default is false, so default is actually sorting via ascending method. So check out this particular case I have for you, right? So we have a set of values for A. We have B, G, A, D, F, C, H, E, whatever, right? So X, as soon as we print sorted of A, the default value is false. So in this particular case, what happens is that, so it actually orders it for us in the ascending order. So the values actually went from being gibberish to be neatly sorted as shown here. Again, another easy function, done. So this brings me to the last built-in function for the session. So I have the type function for you guys. So the type function basically returns the type of a specified object. So again, check out the syntax. We have type, which is the keyword. We have object, basis, and dictionary, right? So the first one is required. We need the object here because we need to know what we're trying to find out. The basis and the dictionary are actually optional. So basis actually specifies the base class and the dictionary actually specifies the namespace with the definition of that particular class. Well, it is not that you need to worry about this right now, but then definitely this particular parameter, which is dict, is actually useful later. But for now, since I'm introducing functions to you, let's stick to the basics. So check out this particular example. I have A equal to apple, banana and cherry, B equal to hello world, and C equal to 33. So as soon as you try to find out the type of A, B, and C, you can realize, right? So the first one, as soon as you look at it, it's a tuple. Second one, as soon as you look at it, it's hello world. And third one is definitely an integer, right? So A, B, C respectively. So again, as easy as that, guys. So those were a lot of functions, and I actually recommend that you guys pause the video at every point of time and make a note of all of the important stuff that I've said here, guys. So this will actually take you a long way in learning Python. Well, now that we're actually done with the built-in functions, again, let me quickly give you a recap and then start with user-defined functions, guys. So what are user-defined functions? Again, as I said, we'll be taking the code-first approach here. So here I have for you guys two simple syntaxes. So the first one is how we can actually create a function, and the second one is on how we can actually call the function. So we have actually looked at this when I previously told you, but let me quickly tell it again. So again, define my function. Define is the keyword. My function is the name of the function. So what do I want this function to do? I want it to print hello from a function. So this is actually the body of the function, and as soon as the function has been called, it's going to print hello from a function. Well, instead of print, I could actually make it to calculate something for me or print my name or print Edureka's name or anything as such as well, right? So the body of the function is completely left to your freedom, but make sure you check the number of parameters you require and all that you need, right? So now quickly look at how we can actually call a function. So we have defined my function and then hello from a function as well. To call this particular function, all you need to do is call the last line, guys. So basically we need to type out my underscore function and you're good. So how more simpler can you expect Python to be, right? As simple and straightforward as that. So then again, parameters, guys. So parameters are the information passed to functions that you already know. So let me quickly step up the complexity of our examples to one little notch higher, right? So again, check out. So we have defined my function and fname. Here, fname is actually the parameter of us. So we're printing fname plus refsness. So what we're trying to do, we're trying to pass. So this is our function body. So next, what we're actually trying to do is we're actually trying to print it. So we have my underscore function. We have provided 3 names there. We have Emil, we have Tobias, and we have Linus, right? So as soon as you go ahead and check out the output on the right side, so that is actually concatenated to refsness, right? Again, simple. So you can have any number of parameters and then work on all of these parameters and get whatever return output you want, guys. And get whatever meaningful return output that you want. So what is the default parameter value that we stumble upon all the time? Again, check out the example here. So we have defined my function country equal to Norway. So I'm specifying in my parameters that the country is equal to Norway. So no matter what you do, right? So in case you haven't provided any value, the default value it should actually consider is Norway. So we're printing I am from and then concatenating a value of the country. We've called the function 4 times, in which the first time we have set Sweden. So it's printing I am from Sweden. The second time it's India. So I am from India. Third time we have just called the function without passing any parameter to it, right? So this is the exact case where it moves to the default value. Since nothing is provided, it is actually printing I am from Norway. And then fourth one, my function of Brazil. Again, it is as simple as that. You've already provided the parameter, so print it as it is. So default parameter value, you got all of this, right? And then the important concept you need to know is the return value, guys. Check out the example. We have my function and x is our parameter. We're returning 5 into x. So basically, as soon as we pass a number, 5 is going to be multiplied to that number and we're going to get the output. My function of 3, 5 3s are 15, 15. So next we have 5, 5 5s are 25, 25 is correct. 9 5s are 45. Again, we have 45 as the output. So we're good with that, right? So let me quickly recap on how the function actually works. So we have one set of code and we actually keep using it in recursion. So recursion is basically a function calling itself. So check out this particular example I have for you guys. We have defined a function. We call it try underscore recursion. We have a parameter k. So if k is equal to 0, then add the result to whatever is lesser than the next iteration of this function. I know it sounds complex, but how you can actually analyze a recursive function is to take a pen, a paper, so to write down the values of k at every point of time and then to actually trace what is available in the memory, guys. So if that is the case and if the result in which k is greater than 0, we print the result. Else we print it to be 0 and we return the result. And lastly, we actually print the recursion example results and we call the function by passing it a value of k, right? So k is 6 in our case. So if k is equal to 0, absolutely 6 plus try underscore recursion of 5. Again, come into the function. Is 5 greater than 0? Correct. Again, go back. Check if 4 is greater than 0. Yes. Keep doing it until the result is 0, right? So it's pretty much obvious at this point of time, guys. So every time you actually run this, one value gets added to your program, right? So again, check out the output and you will understand this better. So we have 1 and then 2 values were added, we got 3. 3 values were added, we got 6. 4 values were added, we got 10. 5 values 15, 6 values 21. So all we're trying to do is add one extra value and print it using recursion. And that's about it, guys. So I hope this has been a good introduction to the Python user-defined functions as well. So next, quickly let us check out the Lambda function in Python, guys. So what is the Lambda function? Guys, it is extremely simple. A Lambda function is basically one small anonymous function. So it can take any number of arguments, but it can have only one expression at the end of the day. Check out the syntax here. So we have Lambda arguments and expressions. Well, still nothing is working, right? Check out the example. We have x equal to lambda of a, where the expression is a plus 10. So as soon as we want to print something, all we need to do is we need to print x of 5. As soon as we hit x of 5, a gets the value to be 5. So since a gets the value to be 5, 5 plus 10 becomes 15. And we're printing x of 5, which is now 15. Pretty simple, right? So you basically can create tiny functions all on your own using the lambda keyword here. So do know that the syntax is really important because we have the arguments on the left side and the expressions on the right side. So guys, here is another example I have for you. So we have a lambda function that multiplies one argument with another argument. In our case, it is a and b. And we want to print the result. So check it out. X equal to lambda of a comma b, because a and b are parameters here. So what is the expression you want to perform between a and b? It is multiplication. So a cross b. And we're printing x of 5 comma 6. So a is 5, b is 6. What does 5 6 are? It's 30, right? Again, the output is 30. Pretty simple. Check out this other example. So basically, we're trying to find the sum of 3 parameters a, b, and c and print the result. So x equal to lambda of a, b, and c, 3 parameters a, b, and c, hence 3. And then we have a plus b plus c. So what is the sum of 5, 6, and 2? It is 13, and that is exactly what you've got in the output. So these are tiny set of functions that you can make use of anytime without any dependencies, guys. So that is the important part I want you guys to notice at this point. But when you can have all the regular functions, why would you want to make use of the lambda function, right? I'm pretty sure this was the first thought that came into your head as soon as I explained the concept. Well, the power of lambda is actually better shown when you use them as an anonymous function inside another function. Check this particular thing out. We have defined a function which is called as myfunc. I have one parameter n, and then we're actually performing another function inside our function. And this is basically telling us to return the lambda of a cross n. So whatever n value has been provided, we're going to use the lambda function as in a tiny function there to provide us the multiplication of a value with a particular n value, which is the parameter. Simple. So check out this example, guys. So we basically use that function definition to make a function that always doubles the number that you send in. So we have defined my function of n, lambda of again a into n, right? So it's pretty much the same example. And then we have a variable called myDoubler, which actually is sending the parameter 2 to our n value. So what do you think is going to happen as soon as I print the value of myDoubler of 11? Pretty much simple. 11 gets multiplied by 2 because 11 is passed as a function into the myfunc through myDoubler. So here a and n becomes 2 and 11. So what is the product of 2 and 11? It's 22. Pretty much simple, right? So here's another last example. So basically we can use the same function definition to make a function that actually triples the number that you send in. So what I want you guys to notice is that check out the function definition. It remains the same. So define my function of n, return lambda of a into n, perfectly same. myDoubler, my function on how many times you want to double it. So double is 2, so 2. myTripler equal to myfunc of 3. So I want to triple it, so multiply 3 times. As soon as I print myDoubler of 11, 11 into 2, 22 is the first output that I get. Print myTripler, 11 into 3, 33. That is the second output that I get. So what I am trying to convey to you guys is that you wouldn't have to rewrite all of these functions at every point of time, right? So the definition of the function remained same. How we call it and how we get our output is actually depending on us. And that is what makes functions efficient and one of the biggest concepts that you need to learn in Python, guys.
What exactly are lambda functions? Python lambda functions are functions that do not have any name. They are also known as anonymous or nameless functions. The word lambda is a keyword that specifies what follows is anonymous. Now that you're aware of what these lambda functions are, let's move on further to see why they are actually used. The main purpose of anonymous functions comes into picture when you need some function just once. They are created wherever they are needed. Due to this reason, Python lambda functions are known as throwaway functions. They are also used within higher order functions which take a function as an input or return it as an output. Another very good advantage of using these lambda functions is reducing the size of code. And I'm going to be showing y'all in this session how to do this. So now let's move on towards our next topic, which is to see how to write anonymous functions. Lambda functions are created using the lambda operator, and its syntax is as follows. The first thing that you'll need to specify is the lambda keyword, and following that you'll have to specify the arguments or the inputs. And finally, after the colon symbol, you'll have to specify the expression that needs to be solved. Lambda expressions can take any number of arguments. So as you can see over here, my first example is a lambda expression without any arguments. In the second example, I've taken a lambda expression which just has one argument a1. Finally, I'm demonstrating a lambda expression which has inputs from a1 to an. Just remember that all your arguments or inputs need to be separated by a comma. So now let's move on towards our Jupyter notebook and see how we can actually write these lambda functions. I'll just create a new notebook over here, guys. I'll just open a new notebook over here, guys, and I'll rename it as lambda functions. So guys, now just let me write the syntax as a comment over here. This is going to be good for a referral purpose. So first is the lambda keyword, like I already told y'all. Sorry guys for the spelling mistake. Lambda and the arguments followed by the expression. Okay, so the first thing I'll have to write down is the lambda keyword. Following that, I'll have to specify the arguments. So let me just give one argument to this. And after that, I'll just say I want to multiply this A with itself. So this is my lambda function. But before executing this, I'll require some variable that can hold the value of this. So I'll just specify that x is equal to this lambda function. And after this, I'll say x of 3. And I'll hit run. So as you can see over here, when I used x of 3, it's returned the output to be 9. So guys, if I had to solve the same expression using a normal function, then I would have had to write a larger piece of code than this. Let me just demonstrate this to you guys over here. So I'll just define a function, say new, and I'll pass the parameter as a. Now I'll be using return to return the value of a star a. To call this function, I'll have to use the name of the function and specify some value to the argument that I've already passed. So in place of a, I'll pass the value as 4, or let me take it as 3 itself, like the previous function, and I'll hit run. As you can see over here, using lambda functions, I just required 2 lines of code. Whereas, while using the normal function, I had to make use of 3 lines of code along with this return statement over here. Okay, so guys, I hope you all have understood how to write these lambda functions. So guys, as you all have just seen, I've used lambda expressions in the example along with some other variable x. Now I did this because these functions are nameless and require some name to be called. But doesn't it seem confusing as to why assign a name to a nameless function and what is the need of it? It's a legitimate question, guys, but the point is this is not the right way of using anonymous functions. Anonymous functions, like I've already told y'all, are best used within higher order functions. These functions either take a function as an input or return it as an output. To demonstrate this, let me just move on towards our next topic of this session. The first thing that we're going to study is anonymous functions within user-defined functions. So as you all can see on the screen, I have a user-defined function that takes the lambda function as an input. In this example over here, the normal Python function, which in my case is newfunc, takes one argument x. This argument is then added to some unknown argument which is supplied through the lambda function. Let me just jump on to my Jupyter notebook to explain this in detail. Let me just first create a heading over here, guys. Just remember the number of prefixed hashes tells which heading it is. So if it is h1, it will have 1 hash prefixed to it. If it has 2, then it's h2 and so on. So I'll just create a heading over here of h1 level and I'll give the name as user-defined functions or lambda within user-defined functions. Lambda within user-defined. So I hope you guys know what are user-defined functions. Okay, so as you all know, when you have to create a function in Python, you'll have to use the def keyword followed by the name of the function. I'll just name the function as a and I'll pass one parameter to it, say x. After that, I'll be using the return statement. And within this, I'll specify a lambda function. I'll pass y as the argument to this lambda function and I'll use x plus y as my expression. Now let me just give some value to the variable x and store it in another variable t. So a of 4 and I'll print the value of t of 8 and I'll hit run. So as you all can see on the screen, the lambda function that is used within the function a is called whenever I call this higher order function. And the first thing that I'm doing over here is passing a value to the variable x and then I'm printing the value of x plus y. So I hope everyone's understood this part. Okay, now let me just copy this function and pass a few other values to this as well. I'll just store a new value in the variable u and I'll pass the value for x as say 7 and I'll print 2 of 5 and I'll hit run. Okay, so I hope everyone's clear with this. If you have any doubts, please do let me know in the chat box and my team is here to help you. Now let's move on towards the next topic, which is using lambda functions within filter, map, and reduce functions. The filter method is used to filter the given iterables, which can either be lists, sets, etc. Now this is done with the help of another function which is passed as an argument to test all the elements to be either true or false. After applying the function to the set of iterables, if the value is true, then that value is returned in the output. Now let me just jump onto my Jupyter notebook and use the Lambda function within the filter method. I'll just give a new heading over here again. Just for your reference, guys, I'll create a heading of H2 level by prefixing it by 2 hash characters. So I'll just use Lambda within filter. And since this is a method, like I already told y'all, the filter function needs iterables. Now here I'll just create a list. I'll say my list and I'll specify some elements to this. The filter method is going to check for all the elements to either be true or false in accordance to the expression that is passed within the Lambda function. Like I already told y'all, the filter method is going to check if the expression that is specified within the Lambda function is either true or false for all the elements that are present within my list. And it returns all the elements that satisfies the expression. So as a result, I'll have a new list. So I'll just name it as a new list. And I'll use the filter function. And within this, I'll be using the Lambda function like I already told y'all. Let me just specify the input as A. And I'll give an expression over here, say A. I just want to check if any of these values when divided by 3 will equate to 2. And I'll pass my list. And I'll pass my list as an argument to this. And since the output is going to be a list, I'll just use the list method over here. And one more point I want you guys to note is the syntax of the filter function. And since I forgot to specify this before beginning the demonstration, let me just specify the syntax of this function over here. I'll say syntax. You'll have to use the filter keyword along with some function followed by the iterables. Okay, so as you can see over here, I have the filter keyword, I have the function which is Lambda, and then I've passed my list as the iterables to this function. Now let me just print the new list. And I'll hit run. Uh-oh, sorry guys, I've made a spelling mistake over here. So it's Filter. So as you can see over here, I've passed the elements 1, 2, 3, 4, 5 and 6 to this filter method. And after checking if this expression is true for all the iterables, it has returned 6 as the output. Now let me just cross check over here. So if I divide 1 by 3, I will not get a result which is equal to 2. Similarly, if I divide 2 by 3, I'm not going to get the result as 2 again. Finally, as we all know, if I divide all these elements by 3, only for 6 I'll get the output as 2. So I hope everyone's clear with how to use the Lambda function within the filter function. So now let's get back to our presentation and see how we can use the Lambda function within the map function. Guys, the map function in Python is a function that applies a given function to all the iterables and returns a new list. So I hope you're understanding what exactly it does. It takes a function as the input and some iterables as well. And then it applies this function to the set of iterables that are passed and it returns a new list. So now let's get back to Jupyter and do the same. I'll create a new heading, of course. And it's going to be Lambda within map. And I hit run. So before moving on towards the demonstration, I'll just write the syntax for the map function. So it has to have the map keyword, of course. And the parameters that are passed to it is a function and the iterables. Now let me just make use of the same list, which I was using previously. And I'll copy that over here. And then I'll just store the output in a new list P. And I'll use the list function since I want the output to be a list. Within this, I'll use the map function. And to that map function, I'll pass a Lambda function as the input. I'll just pass one argument to this as A. And the condition I'm going to specify is to check if any element present within my list divided by 3 is not equal to 2. And I'll pass my list as the set of iterables. And then finally, I'll be printing this. Now let me hit run. So as you all can see over here, it has returned a list with some Boolean values. The expression that I wanted to check is a by 3 not equal to 2. Now let me just move on to my list and see what happens when I divide 1 by 3. Of course, I'm not going to get 2, so I have true as the output. Now when I divide 2 by 3, again, I'm not going to have the output as 2, and therefore I have true as the Boolean value for this. Similarly, all the elements present in my list are divided by 3, and it's going to check if the condition is true. Therefore, only for 6, it's going to be false, and I have the output as false. Okay, so I hope you guys have understood how to use the Lambda function within the map function. If you have any doubts, please do let me know in the chat box, guys, and my team will revert to you. Okay, now let me just jump on towards our next topic, which is using Lambda function within the reduce function. So guys, the reduce function is used to apply some other function that is passed as a parameter to it to a list of iterables, and finally it returns a single value. And to demonstrate this, I'll just jump onto my Jupyter notebook again, and I'll create a heading. This is going to be Lambda within reduce, and I'll hit run. So first, let me just write the syntax of this function. It is the reduce keyword, and it takes a function as a parameter. The first parameter is a function, and second is a sequence. Now to make use of the reduce function, you'll have to import the functools library, or from that library, you'll have to import the reduce function. To do this, I'll be using from functools import reduce. You can also directly import the functools library as import functools, or you can also use from functools import star. These are just the alternate ways that you can also use over here. Okay, so now I'll be using the reduce function, and within this I'll specify a Lambda function, and I'll pass two parameters, say a and b, and let me just print the sum of a and b. And finally, it has to have a sequence as its input. So I'll just specify a list over here. I'll say the list of values to be 23, 56, 43, 98, and 1. Okay, so now let me hit run and see what it returns. So as you can see over here, guys, I have 221 as my output. So what this reduce function is actually doing is, it first adds 23 to 56. So guys, the first thing that the reduce function does is add 23 and 56. And the output of this is going to be 79. Now after adding these two values to this output, it will add 43. So to 79, it's going to add 43, and it will produce a new output. After finding the output of 79 and 48, it's going to add the result to 98. And finally, it's going to add that result with 1 and returns the final output, which is 221. So I hope you guys have understood how this function is recursively adding each value to the next value that's present in the sequence. Guys, if you have any doubts, please do let me know in the chat box. Okay, now let's move on to see how you can actually use these Lambda expressions or Lambda functions to solve some algebraic expressions. For this, I'll just go back to my Jupyter notebook and I'll create a heading over here. Sorry guys. I'll just delete these two kernels. And I'll create a heading. I'll just say Lambda for algebra. So guys, first we'll be taking some linear equations. So I'll just create a heading as linear equations. So as we all know, algebraic linear equations consists of variables of degree 1, which means they'll have the power as 1. So now let's just use the Lambda function to solve some linear equations. I'll just say S is equal to Lambda. and I'll pass the argument or the input as A, and the expression I'll specify as A star A, and I'll use S of 4 and I hit run. So as you all can see over here, 4 cross 4 is 16. Now let me take a different linear equation. So let me just write the linear equation over here as a comment. So I just want, say, 3x plus 4y. Okay, so if I want 3x plus 4y, so I'll have to specify some name to this, say d is equal to lambda, and x and y as the inputs. And since I want 3 star x plus 4 star y. Okay, I have 3 into x plus 4 into y. Okay, and then I'll pass the values as 4, 7, and I'll hit run. As you all can see, 40 has been returned as the output when I pass the value of x as 4 and the value of y as 7. Now let me take some quadratic equation. So I hope you all know what is a quadratic equation. It's an algebraic equation with the degree 2. Let me just give the heading as quadratic equation. Okay, so now let me just try to solve the very famous a plus b the whole square. A plus b the whole square. So I'll just say part 2, okay? Now let me write a lambda function that's going to return the value of a plus b the whole square. I'll just save it within a new variable x, and I'll use the lambda function, and the arguments or the inputs are a and b. The expression that I'm going to use is a plus b, and like we all know, we'll have to use double star when we use powers. And then I'll print this x. I'll pass the values of a and b as 3, 4, and I'll hit run. Okay, so as you all can see, I found the value of a plus b the whole square using the lambda expressions. What exactly is an array? An array is basically a data structure, guys, with ordered series of elements. Any variable that is declared as an array can hold more than one value at the same time. All values in an array have a particular address which is specified by its index number. Here, as you can see on the screen, I've declared a variable a as an array, and I've stored values from 1 to 100 in my array, which is a. Also make a note of the index values. Indexing always starts from 0 and not from 1. Therefore, a of 0 holds 1, a of 1 holds 2, a of 2 holds 3, and similarly a of 99 holds 100. When the length of my array is n, the index value will be n minus 1. It is always 1 less than the length of the array. So I hope you're clear with this topic. Now let's move on towards our next topic for this session, which is the difference between Python lists and arrays. Python lists and arrays have the same way of storing data, but there is a key difference that you all have to note. Arrays can store only single data type values, whereas lists can store any data type values. So for example, if I have an array of integer values, all values present in that array will be integers and nothing else. On the other hand, if I have a list, then it can store integers together with float and chars and strings, etc. Now when you try to perform some operations like slicing or looping, it will be similar for both. But when you try to perform different operations, like if you want to multiply your array values by 2 or you want to divide it by 2, you can do so easily when you have an array. But if you try to do the same with a list, it will throw an error because naturally you cannot multiply chars and strings or divide them. So I hope you're clear with the difference between these two. So now let's move on towards the next topic, how to create arrays in Python. Unlike other programming languages, if you want to create arrays in Python, you will have to import the array module. Now this module has all the functions that are necessary for creating and performing various kinds of operations on arrays. To import the array module, you can use 3 ways. First is to import the array module by its original name, which is array. The second method is to use an alias name. This is the most widely and commonly used method as well. In my demonstrations, I'm going to be using this method. The third way is using star. From array import star. What this does is it's going to import all that is present in your array module. Now let's go to our Jupyter notebook and try to do this. Please do it along with me, guys. I'll open a new notebook and I will use the first method to import the array module. As you can see, when I hit run, no error has been returned, which means this is executed. Now let's try to create arrays using this method. As you can see over here, I've created an array A using the first method. So I have used array.array of integer values and I've specified some random integer values. Here, the first array is the name of the module. The second array is the array constructor. And then I've given a type code. This type code specifies what type of elements my array will hold. As you can see, I've created an array. So I hope you're clear with how to create arrays using the first method. Now let me open a new notebook and try the second method. The reason to open a new notebook is because I've already imported array module in this notebook. I'll rename this notebook because I'm going to be using this method in further demonstrations as well. As you can see over here, when I use import array as ARR here is my alias name. When I use this and hit run, it does not throw any error. Now let me try to create arrays using this method. I'm using int as my data type. You can use any data type of your choice. As you can see that an array has been created with some random integer values. In place of the module name array, I've used ARR. Now let's try the third method. I'll open a new notebook again. As you can see over here, when I'm creating arrays using the third method, I've just specified the constructor name and then the type code and the value list. So I hope you're clear with how to create arrays using all three methods. Okay, so now let's get back to our presentation. Our next topic for this session is accessing array elements. To access array elements, you'll have to make use of the index values. Each index value holds a unique element. Like I've told you before, indexing starts from 0 and not from 1. So therefore, A of 0 holds 1, A of 1 holds 2, and so on. This is the normal traversal order which starts from the left-hand side and moves towards the right-hand side. But here, I want you all to note this point as well, that negative indexing also exists. So negative indexing will start from the right-hand side and move towards the left-hand side. Therefore, 100 will be at A of -1, 99 will be at A of -2, and similarly 1 will be at A of -100. So I hope you're clear with negative indexing. Now let's go to our Jupyter notebook and try to access some array elements. As you can see over here, I've created a heading. To create a heading, all you have to do is go to code, select heading, and prefix your text with the number of hashes based on the heading level you want. So if I want h1, I will use 1 hash. If I want h2, I will use 2, and so on. Here I've created a heading of h1, so I prefixed my text with 1 hash. Now let me try to access some array elements. As you can see over here, when I access A of 2, my output is 3. Let's see where 3 is present in my array. 1 is present at A of 0, 2 at A of 1, and 3 at A of 2. So therefore, when I access A of 2, 3 has been returned. Are you guys clear with this? Just give me a quick confirmation before I move on towards the next topic. Shashank says yes. Preeti says, please try to access something using negative index values. Okay, Preeti, let me show you that as well. So here I've tried to access a of -2. A of -2 has returned 5. Let's get back to our array A and see where 5 is present. 6 is at a of -1 and 5 is at a of -2. Therefore, my output is 5. So Preeti, are you clear with this? Okay, Preeti says yes. Now let's move on towards our presentation and see what is the next topic. Our next topic of this session is basic array operations. Here, I just want to tell you all something. Arrays are mutable, which means they are changeable. So in case you want to add or remove elements from it, you can do so easily. Now coming back to our presentation, our first operation under this section will be finding the length of an array. The second is adding or changing elements of an array. And then we will try to remove or delete elements of an array. And then guys, we will try to perform array concatenation, slicing, and finally we will be looping through an array. Now let's move on towards the first operation. To find the length of an array, you will have to make use of the len function. Now this function returns an integer value which is equal to the number of elements that are actually present in your array. The len function takes one parameter which is the name of your array. As you can see in the example over here, I've created some random array A and I've given some random values. As you can see, I have 3 values over here. And when I use the len function and I specify the name of my array, the output is 3, which is equal to the number of elements that are present in my array. Now let's move towards our Jupyter notebook and see how this works. As you can see over here, when I use the len function and I've given the array name which is A, an integer value is returned which is 6. 6 is the number of elements that are actually present in my array which is A. Okay, so I hope you're clear with this. So our next operation is adding elements to an array. In case you want to add elements to an array, you can do so using the append, extend or the insert function. The append function is used when you want to add an element to the end of your array. The extend function is used when you want to add more than one element to the end of your array. The insert function specifically adds a new element to a particular position in the original array. Let's have a look at a small example of these three. As you can see on the screen, I've created some random array A. And then I've used the append function and I've given the value that I want to add to my array. As you can see in the output, 3.4, which is the value I've specified to the append function, has been added to the end of my array which is A. And then I've used the extend function. Please make a note over here that when you use the extend function, you will have to specify the values between square brackets. If you don't use the square brackets, it will throw an error. I've given 3 new values and all 3 values have been added to the end of my array. And then I've tried to use the insert function. Over here, I've specified the index number as 2 and the value to be inserted at that position as 3.4. As you can see in the output, 3.4 has been inserted at C of 2. Now let's go to our Jupyter notebook and we'll do the same. I'll reprint my array which is A so that it's easy for us to refer to it. Since my array A holds integer values, I will give some new integer value to it. As you can see, I've given 8 as the value that I want to insert in my array, and 8 has been added to the end of my array. Now let me try to give some float value to this array and see what happens. As you can see, when I try to append some float value, it gives me a type error. Therefore, I can add only those values which is specific to the type of elements that are present in that array. Now let me try to use the extend function. Like I've told you all, when you're using the extend function, you will have to make use of the square brackets. As you can see in the output, all the values that I've specified within the extend function have been added to the end of my array. Now let me use the insert function. I've used the insert function, and the first parameter I've specified is the index value, and the second is the element to be inserted at this index position. So at index value a of 2, 6 will be inserted. As you can see in the output, 6 has been inserted at a of 2. So I hope you're clear with how to add elements to an array. Now let's move on towards the next operation. Our next operation is removing elements of an array. In case you want to remove elements from an array, you can make use of the pop or the remove function. The pop function removes the element and returns it, whereas the remove function will remove it but it will not return it. The pop function can either take no parameters or one parameter. The parameter it takes is the index value of the element to be removed. If you do not specify any parameter, it will remove the last element from the array. The remove function takes one parameter, which is the element to be removed itself. Now let's have a look at a small example of this. As you can see on the screen, I've created some random array A, and then I've used the pop function without specifying any parameter. As you can see in the output, when I do not specify any parameter, the last value present in my array has been popped and returned as well. Second time, I've used the pop function and I've given some index value. Now this pop function will remove the element that is present at this index position. As you can see, it has removed 3.1 and returned it as well. After that, I've used the remove function. Like I've told you before, the remove function takes one parameter, which is the element to be removed. And you can see in the output that the remove function has not returned any value. After that, I've printed my array. And you can see all the values that are removed using these two functions are no more present in the array A. Now let's go to our Jupyter notebook and do the same. Let me reprint my array, which is A. First, I will use the pop function without specifying any parameter to it. As you can see over here, when I do not give any parameter, it removes the last element that is present in my array. Now let me give some index value to it. I'll reprint my array A because I've removed an element from it. Now let me give some index value to the pop function. As you can see, when I use a.pop of 2, it removes the element which is present at a of 2, which is 6, and it returns it as well. Let me try to use some negative index value for the pop function. A.pop of -1 removes the last element that is present in my array, which is 5. Now I'll use the remove function. Let me reprint my array, guys. As you can see, all the elements that have been removed using the pop function are no more present in my array A. Like I've told you before, when using the remove function, you will have to specify the element that is to be removed. Here, let me remove 8, because there are two occurrences of 8. And let's see what the remove function does. When I hit run, remove function does not return anything. Now let me print my array A and see what is present. As you can see, the first occurrence of 8 has been removed, but the remove function did not return the value. So I hope you're clear with the remove and the pop functions. Now let's get back to our presentation and perform the next operation. Our next operation is array concatenation. Concatenation means joining. So in case you want to join different arrays, you can make use of the plus symbol. As you can see on the screen, I've created some random array A and B, and then I've created some random array C, which is empty. Also make a note that all three arrays have the same type code. And then I've concatenated A and B into my empty array, which is C. As you can see in the output, all the elements present in A and B have been concatenated into my array C. Now let's go to our Jupyter notebook and perform array concatenation. I'm using int as my data type. You can use any data type of your choice. To create an empty array, all you have to do is specify the type code and leave the value list empty. Here I've created an empty array D and I've concatenated B and C into my array which is D. Now let me hit run. When I hit run, all elements present in B and C have been concatenated into my new array which is D. So I hope you're clear with array concatenations. Let me just show you what happens if I try to concatenate arrays of different data types. I'll just change one of my previously created arrays type code and I'll give it as float. Let's see what happens when I change the type code and I try to concatenate these two arrays. You can see that I've encountered an error and it says type error, which means it cannot concatenate two arrays of different data types. So just be careful when you're concatenating arrays. You cannot concatenate arrays which hold different data type elements. Okay, now let's move on towards our presentation and see what is the next operation. Our next operation is slicing an array. Slicing actually means fetching some particular values from your array. To do so, you can make use of the colon symbol. As you can see on the screen, I've created some random array A and I've sliced it from 0 to 3. 0 specifies from where fetching has to start and 3 specifies where it has to stop. So, it will start from 0, it will go on till 3, but it will not include the value which is present at 3. As you can see in the output, I have A of 0, A of 1 and A of 2 that is present in my output. Now let's go to our Jupyter notebook and we will try to slice our arrays. I'll reprint my array D over here and then I will try to slice it. As you can see, I've sliced my array from 0 to 5. So it will start from index number 0, it will go to 5, but it will not include the value which is present at index number 5. You can also see the same in the output over here. Let me try to use some negative index value. My output when I use 0 colon minus 2 contains all the values between 0 and minus 2, but it will not include the value which is present at minus 2. Okay, so I hope you're clear with this topic. Just give me a quick confirmation before I move on. Okay, Anil says yes. Shashank has a question. He asks, what does colon colon minus 1 mean? Shashank, unlike what many of us think, colon colon minus 1 does not reverse my array, but it prints a reversed copy of my array. So let's try to do this over here. As you can see, all the elements present in array D have been reversed. Now let's print our array which is D. The original array D is the same, but colon colon minus 1 has reprinted a reversed copy of my array which is D. This method is actually not preferred because it exhausts the memory. So I hope I've cleared your doubt, Shashank. Just give me a quick confirmation. Okay, Shashank says yes. Now let's get back to our presentation and perform the last operation of this session, which is looping through an array. You all might be familiar with these two loops, which is the for and the while loops. The for loop iterates over the items of an array specified number of times, whereas the while loop iterates until some condition is met or some condition is true. When you're using the while loop, you will have to keep three things in mind. One is initializing your iterator. Second is to specify a condition. Third is to increment your iterator. Remember that if you do not increment your iterator, your while loop will go on forever. Let's see a small example of this. As you can see on the screen, I've created some random array A, and then I've used the for loop to loop through my array A. I've used for x in A print x, which means go to every element that is present in A and print it. Let's try to do the same on our Jupyter notebook. Let me reprint my array D. Now let me use the for loop to loop through this array. For x in A, print x, which means go to every element in D and print it. As you can see, all elements present in D have been returned one after the other. Now let me try to slice this array and print specific elements. As you can see over here, I've sliced my array from index number 0 to -3 and I've printed only those specific values using the for loop. Now let's go to our presentation and have a look at the while loop. Like I've told you before, when you're using the while loop, you will have to do three things. One is initializing your iterator. Second is to specify the condition. And third is to increment your iterator. Let's try to perform looping on our Jupyter notebooks. Please do it along with me, guys. Let me reprint my array D. Here I'm using the iterator as temp. You can use any name of your choice. As you can see over here, I've initialized my iterator to 0 and then I've specified a condition wherein I have told whenever the value of my temporary variable is less than d of 2, then print that value. And then I have iterated the value of temp. I can also use temp plus equal to 1, which is same as temp equal to temp plus 1. Now let's try to use the while loop using the len function. Here I will use my array A. So let me reprint it over here. As you can see over here, when I use the len function, my temporary variable will go to all elements present in my array A and print them one after the other.
What is inheritance in Python? If we take a look at a real-life example, inheritance is when a child inherits properties from their parents. It can be the genes or it can be any other property characteristic. So looking at it from the programming point of view, inheritance is when a class inherits properties from another class. The class which inherits the properties is known as the child class or the derived class, and the other class is known as the parent class or base class. Now let's take a look at a few advantages of using inheritance in Python. So first of all, it is mainly used for code reusability so that you don't have to write the same code again and again. And it provides a transitive property and also resembles a real-life relationship between classes. So these are the advantages of using inheritance in Python, guys. So let me take a simple example to explain what is inheritance and how you can do it in Python. So let's take it up to PyCharm, guys. And now I'm going to enter the presentation mode for better visibility. So now what I'm going to do is I'll just take one class, guys, and name it as parent, let's say. Now give it a function. So I'll name the function as function1. And after that, let me give it a statement, let's say print function number 1. Okay, let's say this is a parent function. Now what I'll do is I'll take one more class, guys, and name it as child. And for this, in the declaration, I have to specify this parent over here. This is also known as subclassing, guys. We do the subclassing because a child class is not able to identify which class it is inheriting the properties from. So we do this by declaring the parent class inside the declaration of the child class only. Now what I'm going to do is I'll just make one definition of a function, let's say function number 2, and in this I'll give the print statement as, let's say this is a child function. Now when we are declaring a child class, it must understand from which class it is inheriting the properties from. So we have declared the child class with the parent class in the declaration, and that's how the child class differentiate between a parent class, guys. So now to call the parent class methods, we use the child class objects. So what I'm going to do is I'll just make an object of the child class, guys. Now to call this parent function, which is the function number 1, let's see if I can do that. And I'm getting function 1 and function 2 as well. So I can call both the functions. So first of all, I'll call the function 1, and after that I'll call the function number 2. Let's see what the output will be. Now the output is, this is a parent function and this is a child function. So basically what we have done is, we have taken two classes, named it as parent and child. And from the child class, we are inheriting the properties of the parent class here, which is the function number 1. And this is the basic example of inheritance, guys. This is how you can do it. Now that I've shown you a simple example, let's talk about the init function in Python. So what exactly is an init function? Init function automatically gets called each time an object is created for a class. Now when we add an init function to a parent class, a child class will not be able to access the parent class method. So to overcome this, the child class init function overrides the parent class init function. So now let's take a look at an example to understand this. Now to show how init function works, let me first clear this. We'll write a init function over here. Yes. And instead of self, I will add one more variable. Let's say fname and fage. Now what I'll do is, I'll just write self dot name is equal to fname and self dot age is equal to fage. Now I'll take one more function, guys. So I'll just name it as, let's say, view. And for view, I want to print the value of fname, self dot name and self dot age. So this is my parent function, guys. And for the definition in the child class, I will also make one init function. So I'll just write it as init self. And again, I have to add fname and fage. And let's say self dot name is equal to fname and self dot age is equal to fage. Now this init function is going to override the parent init function, guys. So let's make one more function. So this is going to be view as well. And in this, let's say I want to print. Okay, before we move on, we have to specify the parent function with the init function as well. And we don't have to mention these variables. Instead, I'm going to add one more. Let's say I want to add last name as well. And I'm going to add it as, let's say, Edureka. Now I'm going to print over here self dot age, self dot last name and self dot, let's say, name. All right, I have to remove these. Let's make one more object and give it the value. Let's say I want the age to be 23 and last name is going to be Python in the inverted commas. Name we have already specified, so we don't have to give it again. And I'm going to just call the function. Let's see what happens, what is the output will be. So as you can see, I'm getting the output as Python, Edureka and 23. So this is how you can override the parent class init method using the child class, guys. So this is all about the init function. Now let's talk about the next topic that we have, which is the types of inheritance. So depending upon how many types of parent class and child class are going to be there inside the program, following are the types of inheritance in Python, guys. So there is single inheritance, there is multiple inheritance, then there is multi-level inheritance, hierarchical inheritance, and there is hybrid inheritance as well. So we are going to talk about each of them in detail, guys. So first of all, let's talk about what is single inheritance. So when the inheritance involves one child class and one parent class only, it's going to be a single inheritance. The example that I showed you before is the example of single inheritance, guys. And talking about multiple inheritance, it is going to involve more than one parent class, which means we are going to have at least two parent classes and the child class is going to derive properties from both of them. And this is called multiple inheritance. Now talking about multi-level inheritance, let's say we have a single inheritance going on. We have a parent class and we have a child class. But the child class also act as a parent class for another child class. That is going to be a multi-level inheritance, guys. And talking about hierarchical inheritance actually involves multiple inheritance from the same parent class. And talking about hybrid inheritance, if a program has more than one types of inheritance, let's say we have a single and multiple inheritance going on simultaneously, it's going to be a hybrid inheritance, guys. So let's take a look at examples for each of them. So let's go to PyCharm, guys, and I'll remove all this. So I'll start with single inheritance, guys. So I'll just take a parent class and give it a function, let's say function1, and give it a statement, let's say this is function1. Now let's take another class, guys, class child, and give it the value of the parent class. And after that we can move for another function, let's say function number 2, and give it a statement, let's say print this is function2. Now make a child class object and call the function. So we can call both of these functions. So I'll just call function1, give it the output, and we are getting the output as this is function1. So this is a basic example of single inheritance, guys. Now talking about multiple inheritance, what I'm going to do is I'm going to make one more class over here. Let's say class parent2. Now what happens is, let's say give it a function number 3, let's say, and print statement this is function3. And in the declaration over here I'm going to just specify two classes, and when I call the functions I can call function number 1 and I can call function number 3 as well, guys. So let's see what is happening here in the output. I'm able to call the function number 1 and function number 3 as well from the child class object. So this is the example of multiple inheritance, guys. Now talking about multi-level inheritance, so what I'm going to do is I'm just going to specify parent over here, and from this, let's say it doesn't have any declaration of parent1, which is this class, so it is not able to inherit any properties from that. But what I'm going to do is I'll just specify parent2 over here, and I can still call these functions because there is an inheritance going on between them, which is multi-level inheritance, which basically means this class, the parent1 class, is actually giving properties to parent2 class, and parent2 class is giving properties to the child class. So this is example of multi-level inheritance, guys. Now talking about hierarchical inheritance, guys, what I'm going to do is instead of parent2 over here, I'll just specify parent. So for these two child classes, I have the same parent class. And now let's see if I can have the same output or not. I'm not going to get the properties from the parent2 because I have not specified it in the inheritance. So I'll just remove this and let's see what happens. I'm getting the output as this is function1. Okay, let's make the object for parent2 as well. Alright, give it 1 and ob1 dot, let's say what functions we can have. I can have the function number 3 and I can have the function number 1 as well. So I'll just print function number 1, and from both the child classes I'm able to print the function number 1. So this is the example of hierarchical inheritance, guys. I'm using the same parent class to give the properties to both parent2 and child class as well. And now talking about hybrid inheritance. Hybrid inheritance actually involves more than one inheritance going on in the single program. So we have a single inheritance over here. So let's say I want to have multiple inheritance as well. So I'll just specify parent2 now. And this is the example of hybrid inheritance, guys, because we have a single inheritance going on over here. And in the child class, I'm inheriting both the parent1 and parent2. And this is the example of multiple inheritance. So this is a hybrid inheritance example, guys. Okay, we are getting a type error which is saying cannot create a consistent method resolution order for base parents, parent1 and parent2. Okay, let's say instead of this, I'll make one more class over here. Give it a value, let's say parent number 3. Give it a function, let's say 4, and print statement. This is function 4. Now instead of parent number 2, what I'm going to do is I'll just take parent number 3, guys, and with the child class operator, let's see if I can actually get the function number 1, and let's say I want function 4 as well. I'm able to do that. So in the output, let's say what I get, I'm getting the function 1 and function 4. So this is a simple example of hybrid inheritance, guys. Now that we are done with the type of inheritances, let's take a look at what all we have now. So we're going to talk about the super function, guys. Super function actually calls the parent class method directly. So let's take a look at a simple example, guys, how it works. So I'll just remove all this. Now what I'll do is I'll make a, let's say, parent class and give a function, function1. Again, the print statement. Now what I can do is, instead of calling the parent function from the object, I can just use the super function, and over here I can just call the function 1. Now I'll just print this is function 2. Let's make a child class object. Now let me see if I can call the function 2 or function 1. I can do that. So I'm going to call the function 2, guys. Let's see what the output will be. So I'm actually able to call the function 1 directly from the super function over here. So this is the function of super function, guys. It can directly call the parent method. And now that we are done with the super function, let's take a look at the next topic that we have, which is method overriding in Python. So method overriding can also be achieved to change the functionality of the parent class function. So let's take a look at an example to understand how we can actually achieve method overriding in Python, guys. So instead of naming them separately, I'll just name them as same. So when I create the child class constructor, and if I call the function now, okay, function 1, which is, so when I'm calling this function, technically it should call the parent function, but what happens is it overrides the parent method. Okay, to specify this, run it again. Now I'm getting the output as this is function 2, even though I'm calling this function 1, which should be ideally calling the parent function, but it is printing out the function which I have specified in the child class. So this is how I have overridden this parent class method, and this is how we can perform method overriding in Python, guys.
Why we need exception handling? Well, to understand the concept, let me quickly walk you through a very simple scenario. Consider the case where you're dividing any number. What will happen? Can you divide a number by 0? You cannot, correct? But how would a kid approach this problem? The kid would think that you can actually use regular division to divide something by 0. So you're dividing something by nothing, so it stays the same. Something like this, right? Little does the kid know that this is wrong. Now check out how a programmer would approach the same concept. Well, it is established that dividing by 0 is not possible mathematically. So as we know, it is not correct. So this basically is either an exception or an error. So a Python program terminates as soon as it encounters an error. Well, in Python, an error can be either a syntax error or an exception. And it is as simple as that. Well, let us actually divide by 0 for fun, guys. So this is what happens in Python. Python presents us with this beautiful error message saying something. Well, PyCharm, which is my IDE for coding in Python, so we can actually walk through this practically. So guys, here I am in my PyCharm. So let me quickly go over and type out some simple code for you guys. So let us start with y equal to 10. We can actually print y by 0 now. So and run this in the console. So as you can check out, it says 0 division by 0 visible, not divide anything by 0. So let's establish that at this point, guys. That was good enough, right? So let's get started then. Let us quickly check out what exception handling actually is. Well guys, to get a clear picture of what that is, we need to start with understanding the definition for both exception and exception handling. Well, what is an exception? An exception is an event which occurs normally during the execution of a program that disrupts the normal flow of the program's instruction. So instead of the program actually executing evenly and nicely, there is actually a disruption in between the code. So this we basically call as an exception. So next, what is exception handling? Guys, this is the process of actually responding to an occurrence of an exception. As simple as that. So basically the process of responding to the occurrence during compilation of exceptional statements which require special processing is actually what is exception handling, guys. So this is basically done because of the change in the normal flow of the program execution. Well, it is a very simple concept and I'm sure at the end of this session you guys will agree. Well, at this point, what do you think of exception handling in Python, guys? Head to the comment section and let me know what you think so we can interact there. And now that we know what exception handling is, we need to understand how the entire process of exception handling works. So let us check it out. First, let us walk through what happens in Python. So let us say the user makes an error. What happens next? Guys, when you think about it, it is either the user that finds out the error or Python will actually tell you what the error is, correct? So once you know what the error is and you know where it is, you can basically start analyzing it to know if it is fixable or not. Well, if it is fixable, how can you go about doing that? Well, if it isn't, nothing to worry. Guys, Python is so good that no matter on what level you mess up, there is always a way out of it, guys. So now if it's fixable, how can we handle the exception? Check out the image on the right side. So we need to first find the error. If we cannot do it, Python will find out for us. Well, next is to make sure you take caution while coding if you think that there is going to be an error in that particular piece of code. Well, remember the word try at this point, alright? And later we'll actually fix the error and we call this as catch. Just remember the keywords for now and we'll be walking through these in detail in the following slides. In fact, let us begin by checking it out right now. So guys, these are some of the important terms that you need to take a note of before starting to code and understanding exceptions. So first we have try. Well, try is basically the keyword which is used to keep the code segment under check. So whatever code you put under try is actually the code under scrutiny, guys. And next we have except. Well, except is a segment which is actually used to handle the exception, guys. So how do we know that the exception has occurred? If our piece of code in the try block has actually caused an exception, then we can handle it in the except block. And how do we use else? Well, else is basically run when no exceptions exist, guys. And lastly, we have finally. Finally will run even if there is an exception. Finally will run if there is not an exception as well. So I want you guys to note this at this point of time, and this will help you a lot on the coming slides, guys. So now coming back to Python, this is what it visually looks like. We first have the try block where we run a piece of code. And next we have the except where the code actually runs only when there is an exception in the try block. And if there are no exceptions, then we run the else block, guys. And lastly, no matter what, exception or no exception, we run the finally block always, guys. Sounds simple, right? Well, it actually is. And now that we're familiar with the process of exception handling, let us check out how we can go about understanding this using Python practically, guys. Well, syntax errors occur when the parser detects an incorrect statement. Well, check out the tiny arrow on the left side here. Well, this is basically to indicate where the parser ran into the syntax error. Well, in this particular example, there were too many brackets, right? So there was an extra closing bracket. Well, if you actually remove it and run it, you will actually get a different error this time. Well, check on the right side part of the code. Well, this time you actually ran into an exception error. Well, this type of code occurs whenever syntactically correct Python code results in an error, guys. So the last line of the message indicated is what type of an exception error that you actually ran into. Well, in this particular case, it is zero division error, and it says that the integer division or modulo by zero is not possible. So this is basically the same case that I showed you in PyCharm a while ago. But instead of showing the message exception error, Python details what type of exception error was encountered. Well, as I mentioned, in this case, it was a zero division error, right? Well, Python comes with various built-in exceptions as well as the possibility to create self-defined exceptions as well. And now that we are clear with that, let us check out how we can go about raising an exception on our own. So we can basically make use of raise to throw an exception if a condition occurs. The statement can be complemented with a custom exception. Well, if you want to throw an error when a certain condition occurs using raise, you can actually go about it like the following piece of code you actually see on the screen. And when you run this piece of code, you'll be greeted with the following output, guys. So it says exception x should not exceed 5 and the value of x was 10. So let me quickly jump back to PyCharm and we can execute this there. So guys, I'm in my PyCharm right now, so I've quickly typed out the code for you guys. So let me quickly go ahead and run it and we can check out the error. As you can see, it says exception x should not exceed 5 and the value of x was 10. Perfect, right? So let's quickly jump back to the presentation to check what's next. So the program basically comes to a halt and displays our exception to screen, right? So this basically offers clues about what went wrong. And now that we're clear with that, we can actually proceed to checking out the assertion error, guys. So instead of waiting for a program to crash midway, you can actually start by making an assertion in Python. Well, we assert that a certain statement is actually met. And if this condition turns out to be true, then excellent, the program can continue. But if the condition turns out to be false, you can have the program to throw an assertion error exception for you guys. Well, have a look at the following example on your screen. Well, this is basically where it is asserted that the code can be executed in a Linux system, guys. So if you run this code on a Linux machine, the assertion passes. If you were to run this code on a Windows machine, the outcome of the assertion would be false. And what would happen? Well, definitely the result would be something like this, right? So it would basically present us with an assertion error and says that this code runs only on Linux, right? So I'm using a Windows desktop in this particular case. So let me quickly open up my PyCharm and then we can actually run this piece of code to check out our exception, guys. So I'm back in my PyCharm and I've typed out the code, guys. So let me quickly go ahead and run this. As you can check out, since this is a Windows machine, it says this code can run on Linux only. But this particular case, this assertion would be true if you were actually running this on a Linux machine, guys. So if any of you guys are using Linux machine, make sure to try it out. And on that note, let's quickly come back to the presentation, guys. Well, in this particular example, throwing an assertion error is the last thing that the program will do. The program will definitely come to a halt and it will not continue, guys. But what if that is not what you want? What if you want something different from this, or that you want the program to continue while displaying an exception for you guys? Well, now that we actually have a fair idea about how we can go about understanding exceptions, let us dive right into the heart of exceptions now. Yes, I'm talking about the try and except block, guys. So basically, the try and except block in Python is used to catch and handle exceptions. Well, Python basically executes code following the try statement as a normal part of the program. The code that follows the except statement is the program's response to any exception in the preceding try clause, guys. Well, as you saw in the earlier example that I actually showed you, when syntactically correct code runs into an error, Python will throw an exception error. And this exception error will actually crash the program if it is unhandled, guys. So the except clause determines how your program responds to these exceptions, guys. So instead of actually crashing our program, we can actually tell Python what to do when this particular exception occurs. Well, check out the following function, guys. So this function can basically help us understand the try and the except block. Well, the Linux interaction function can only run on a Linux system. The assert in this function will actually throw an assertion error exception if you're using it on any other operation system apart from Linux. Well, we can actually give this a try in PyCharm. So let me quickly open up that. So guys, I'm quickly here in my PyCharm. So let me quickly go ahead and select this and run it. Well, this won't say anything right now because, well, if it was actually a Linux platform, the message would have been printed, right? So let's quickly jump back to the presentation. So basically, if we run the tiny piece of code you see on the bottom, the way we actually handle the error in this particular case is because we gave out a pass, right? Well, if you were to actually run this code on a Windows machine, you would get the following output, which is already on your screen, right? So it is a blank output. You get nothing. Well, the good thing here is that the program actually did not crash, but it would be nice to see if some sort of exception occurred when you actually ran your code. Well, to this end, you can actually change the pass into something that would generate an informative message like this. Check it out. So let me quickly go ahead and run this in PyCharm. Well, as you can check it out, it says the Linux function was not executed, right? So basically this happened because I am on a Windows machine, guys. So let's quickly go back to the presentation. And guys, when an exception occurs in a program running this particular function, the program will continue as well as inform you about the fact that the function call was not successful. Well, what you did not get to see was the type of error that was actually thrown as a result of this function call, guys. So in order to see what exactly went wrong, you would need to catch the error that the function threw. Well, check out this particular piece of code I have for you guys. So here is basically where we actually capture the assertion error and we print the output message to the screen. So we have a try block, we have the same function, and we have except as error, right? So we're going to print what type of an error it is, followed by a message for us, right? So running this particular case on a Windows machine will actually give us this following output, guys. So it says function can only run on Linux system, and whatever you have chosen in the print block is actually being printed for us. So let me run this in PyCharm. So as you can check it out, we have the message printed, right? So it was the same as I told you. So it was the same message as I told you before. So heading back to the presentation. Well, in the previous example, we actually called a function that we wrote ourselves, right? And after that, when we actually executed the function, we caught the particular assertion error exception and then we printed it on the screen. Well, I have for you another example where you actually open a file and use a built-in exception, guys. In fact, let us dive into PyCharm and we can actually run this and we can come back and take a look at the output. So guys, I actually came into PyCharm and I actually ran that particular piece of code. Why does it say could not open file log? Well guys, basically if the file.log does not exist, the block will give you this output, right? So it says the file could not be opened. Well, this is an informative message and our Python program is actually still able to continue to run. It has not crashed, right? Well, actually in the Python documentation, you can see that there are a lot of built-in exceptions that you can make use of. And here is one exception that I have for you guys that you can check it out. So it says exception file not found error, right? So basically this is raised when a file or directory is requested, but that doesn't actually exist. And this is just one among many that Python offers to us, guys. Well, to catch this type of an exception and to print it on the screen, we would actually use this following piece of code, guys. So in the try block, we're actually going to open it as file and we're going to read something present in it, guys. We're going to accept it by pushing a file not found error as an object, and later we actually end up printing that object, right? So let me quickly go into PyCharm and we can check it out. Well, as you can check it out, we have error number 2, which says no file or directory, right? So it's perfect. Well, you can have more than one function call in your try clause actually, guys, and anticipate catching various exceptions as well. Well, a thing to note here is that the code in the try clause will actually stop as soon as an exception is encountered. But there is one important thing that I want you guys to note down is that while catching an exception, it basically hides all of the errors, guys. Well, definitely there are some unexpected errors in your program, right? When you're catching an exception, and even these are completely hidden from you. Well, this is why basically you should avoid using bare except statement clauses in your Python programs, guys. So instead, basically what you can do is you can refer to the specific exception class that you want to catch and then handle those particular exceptions, guys. So look at this following piece of code I have for you. So here basically you first call the Linux interaction function and then later actually try to open a file, guys. So let us quickly jump into PyCharm and we can actually check it out. So as you can see, I actually executed the program, guys. Again, if the file doesn't exist, running this code on a Windows machine will give you that output, right? So it basically says that the function can run only on a Linux machine, and then we have actually printed something, guys. Well, what we actually did here is inside the try clause, we directly ran into an exception immediately, and we did not get to the part where we'll actually try to open our file.log, right? Now, basically, when you actually run it on a Linux machine, it's going to say no file or directory found. Check it out here, guys. So this is the Windows output that you get, and this is the Linux output, guys. Well, at this point, let us take a quick break and check out what are the key takeaways of this particular module, guys. So basically, a try clause is executed up until the point where the first exception is encountered. And inside the except clause or the exception handler, what we basically call it, we can actually determine how the program actually should respond to that particular exception. And we can actually manipulate multiple exceptions and differentiate how the program should respond to each of them, right? And lastly, we actually learned why we should avoid using bare except clauses, guys. And now that you're clear with this, next up I have for you is the else clause, guys. So basically in Python, using the else statement, you can instruct a program to execute a certain set of code only in the absence of exceptions, guys. Well, check out this following diagram on your screen. So basically in the try part, we have the code except when we actually want to handle the exception, or else in case there is no exception, we're going to run the piece of code that comes in under else, guys. So let me quickly walk you through the code, guys. So here is basically the same Linux interaction function, and we have an assertion error here, and we actually are going to print the error, right? So else, if there is no assertion error, so we're going to have an else clause and we're going to print saying executing the else clause, right? So let me quickly open up my PyCharm and we can run this piece of code, guys. So as soon as I go ahead and run this, it says function can only run on a particular Linux system, right? So as you can check out the output, it says the function can run only on Linux systems, right? So in this case, I have a Windows machine, so we are actually not printing the except clause here. But if you were running this on a particular Linux machine, this is the output that you would get, guys. So it says doing something and executing the else clause, correct? This happened because the program did not run into exceptions, any exceptions, right? So else clause was actually executed. Well, you can actually try to run the code inside the else clause and catch possible exceptions there as well. Well, again, we have the same Linux interaction here. We're going to print it, right? So the Linux output says doing something and no such file or directory found. Well, this is basically for the else clause and we're using the same file example here, but then we're actually trying to catch an exception in the else block as well. So the output is pretty much straightforward as well, right? Well, from the output, you can actually tell that the Linux interaction function actually ran. Well, because no exceptions were encountered, an attempt to open file.log was actually made. And that file did not exist. And instead of opening the file, you actually caught the exception, which is the file not found exception. Pretty simple, right? And I hope you guys are clear with all of the concepts that we discussed until now. And next up, we need to check out how we can actually use the finally clause, guys. Well, to begin with, imagine that you always had to implement some sort of action to clean up executing your code, guys. Well, Python basically enables you to do so using the finally clause. Have a look at the following example, guys. Check out the workflow on your screen. I'm pretty sure we're all familiar with try, except, and else at this point of time, right? So this is the chronological order that you need to go into. First, we have the try to check for an exception. Then we actually handle if there is an exception using the except, or else if there is no exception, we're going to print whatever is there in the else block. And lastly, we have something called as finally, guys. So no matter what, we're going to execute this. In case if there is an exception, the finally block is going to run. In case there is no exception, finally block is going to run there as well. So let us quickly check out a coding example, guys. So basically, this is the particular code I have for you guys. And let me jump back into my PyCharm and we can actually execute this. So guys, I'm back into my PyCharm. So let me quickly go ahead and run this. Well, as you can check it out, it says that the function can only run on Linux machines. This is because I'm on a Windows machine right now. And no matter what, right? So exception or no exception, we have this message which is cleaning up irrespective of any exception, guys. So this is basically the use of finally, guys. And that is as simple as it gets. So it's pretty much simple, right? Well, try, except, else, finally, all of this is a really simple concept. And once you understand what it actually does, you can go about doing a lot using Python, guys. Well, no matter what the Python application is, there is a very good chance that you'll actually make use of exceptions, guys.
What is Python requests? Request in Python is a module which can be used to send all kinds of HTTP requests. It is very easy to use and has features like passing parameters in the URL and passing custom headers as well. It is a human-friendly HTTP library, as it also suggests on the official documentation page as well, and it is one of the most downloaded Python library with more than 400,000 downloads every day. So you can imagine the popularity of Python request, guys. It was written by Kenneth Wright and has a license under Apache 2.0. So this is about Python request, guys. I hope you are clear with what exactly is Python request. So now that we have learned what is Python request, let's take a look at the advanced features that Python requests come with. So first of all, we have keep alive and connection pooling, and then we have elegant key value cookies. Then coming on to the next one, we have international domains and URLs and automatic decompression as well. And then we have sessions with cookies persistence and Unicode response bodies. Then we have browser style SSL verification and HTTPS proxy support as well. There is automatic content decoding and multi-part file uploads. And then there is basic authentication and streaming downloads as well. And last but not least, we have connection timeouts and chunked requests. So these are all the advanced features, guys. Don't worry. We'll be learning about how we can use Python requests. So let's talk about why exactly do we need Python requests, or why are we using Python requests? So the reason behind this is pretty simple, guys. We use Python requests because you don't have to manually add the queries to your URLs and form encode post data. And that is a reason enough to use Python requests, guys. And if you're not able to understand this reason behind using the Python request, you'll be able to understand this later on in the session when I'll be showing you the use case. So hang in there. Now that we are done with the reason behind why we are using Python request, let's try to understand how you can install Python request on your system or on the project that you're working on. So first of all, you have to install the pip environment on your system, and then you have to run this command that I'm going to tell you inside the terminal, which is pip install request, guys. So let's take it up to PyCharm and I'll show you how you can install request on your project or on your system, guys. Now, as you can see, I have a new project over here inside PyCharm. So I'll show you guys how you can install request on your system. So you have to open the terminal here. Just write pip install requests, and you will see that the files are being installed here. It will take some time, guys. And there is one more approach to this. If you are using PyCharm, you can open the settings, and inside the settings, you will find the project interpreter. And over there, you can simply add the request library, and that will do the job for you guys. It is same as running this command inside terminal. Okay, I'll show you that as well. So you open settings, and here you will go to the project where you will find the project interpreter. And over here, you can simply just add your file. Let's search requests here. And this is by author Kenneth Wright that I have told you guys. So I'll just install this package, and it will not take so much time because we have already installed it. And as you can see, we have requests over here inside the, so you can see request over here, which has all the files and everything for our project. So I'll just type OK, close the terminal, and over here I will make one demo file, guys, to show you how you can make get and post requests. So we have this file. Let's enter. Okay, let's first of all talk about making get and post request, guys. So we have installed request on our system, guys. So let me talk about get request. What exactly are they used for, and how are we going to use them inside the tutorial I'm going to show you, or the use case as well. So get requests are basically used to request the data from the server. So what you have to do is, I'll show you the syntax as well. So you just have to import the request library, and then you will have to make one response object, in which in this case R is the response object, and you are going to use the request library and make the get request. And inside the get function, you have to mention the URL that you're going to make the request from. So let's take it up to PyCharm, guys. I'll show you how you can make the get request. So let's enter the presentation mode for better visibility. So I'll just import the request library. Yes. And I'll make one response variable or response object. and inside this I will use request.get, and inside this I will have to specify one URL, guys. So I'll just show you what URL I'm going to use. So what I'm going to do is I'll just copy the URL over here, and when I make the print statement I will use the response object, and let's get the text over here using the response object whatever we have on the server. And when I run this, I will be getting the text for this URL that I've just provided, as you can see over here. So this is how you can make a GET request, guys. Now let me show you how you can actually pass parameters inside your URL also. So what I'll do is I'll just make one variable, let's say payload, and inside this I will specify a dictionary with some values, let's say key1 and value1. Okay. So when I pass this inside the get function with the parameter, that is params is equal to, that is the parameter variable, guys. So I'll just pass payload over here, and when I get the URL now, I should be getting this parameter that I have just passed inside the URL. So you will be getting this dictionary of the value that I've just passed as a parameter inside the URL. So this is how you actually pass parameters inside your URL, guys, while you're making the GET request. Similarly, you can also pass custom headers as well. I'll be showing you that later on in the session. So we have talked about making GET request, guys. So let me just talk about how you can make the POST request as well. So we'll talk about what exactly POST requests are used for. So basically POST requests are used to submit the data to be processed to the server. So let me show you an example with the syntax. First of all, you have to import the request library, and then you have to use the POST function as well using the request keyword. After that, you have to mention your URL and the data that you want to give it as a payload or something like that. And then you have the response variable as well, or response object. So let me take it up to PyCharm, guys. You will be able to understand this better in PyCharm. So instead of get request, we'll get post over here, and instead of parameters, we'll just pass this as data. So instead of text, okay, we'll just get the text again. So let's see what are we getting. So we don't have post request allowed inside this. So instead of get, we'll just write post over here, run it again. As you can see, so we have this dictionary that I added using the post request, guys. These are the headers, and then we have cookies as well. No, we don't. And this is how you can actually make a post request, guys. I hope you are clear with making the post request and get request, guys. So this is all about making a post and get request, guys. Also, I want to show you what are all the content or the response content that you get using these requests. So let me just take one response object again. I'll make a get request. So I'll just pass the URL over here, and we're good to go. So we will print whatever we'll get. So using the response object, let's see the content type or what all content we can get. So we can get text, we can get headers, cookies, and then there is status code. Let's check the status code first, guys. If the status code is 200, we are good to go. It is 200, guys. So we'll get some more content from this. So we'll get cookies now. It will be showing us the cookies inside a cookie jar. Yes, we are getting the cookies inside the cookie jar, and we can also pass our own cookies. I'll be telling you about that later on in the session. Don't worry, guys. So then there is headers as well. You'll see all these headers inside a dictionary, guys. So this is how you actually access the headers inside a URL. And then there is the content format also. You can get the content in the format of JSON. As you can see, we're getting the content as JSON objects. So this is all about response content, guys. Now let me get to the next topic that we have, which is cookies and headers, guys. So I've just shown you how you can get the cookies and headers inside using the response variable. So let me just talk about what are cookies and headers, guys. So we can view the server's response headers using a Python dictionary, which I have just shown you, guys. So the dictionary is special though. It's just made for the HTTP headers. And similarly, you can get the cookies as well. If a response contains some cookies, you can quickly access them, and to send your own cookies to the server, you can just use the cookies parameter, and cookies are returned inside a request cookie jar, which acts like a dictionary but also offers a more complete interface suitable for over multiple domains or paths. So let's try to understand this inside PyCharm, guys. So what we'll do is we'll just get some cookies here, and when I run this, we're getting a cookie jar. Okay, guys, what I've done is I have actually changed the URL. So what I'll do is I'll run this command now, and you will be seeing the cookies over here, which is inside the request cookie jar. And what I can do is I can also pass my own cookies. So I'll take a variable, name it cookies, and give it a dictionary, guys. And inside the dictionary, I'll specify some values. Let's say key1 is equal to value1, and then over here using the cookies parameter, I will just pass cookies here. So I'll just write text over here, and when I run this, I should be getting a dictionary with the cookie jar, which actually has the cookies named as key1 and value1. So this is how you can actually make your own cookies inside a web server, and then I'll show you what you can do with headers as well. So let's get the headers here. When I run this, I should be getting the headers inside this URL, which are all these headers over here inside the dictionary. So this is how you can actually access the headers inside the URL, guys. So let me talk about session objects, guys, which is the next topic that we have. So session object actually allows us to persist certain parameters across requests. So it also persists cookies across all requests made from the session instance, and will use the URL library 3 connection pooling. And if you're making the several requests to the same host, the underlying TCP connection will be reused, which can result in a significant performance increase. And also a session object has all the methods of the main request API as well. So let's try to persist some cookies across the request, guys. So we'll move to the PyCharm again. So we have come to the PyCharm now. What I'll do is I'll make one variable, let's say session object, that is. So I'll use request.session, and after that I'll just use a get statement where I'll just use s.get, pass the URL, and we're good to go. Then what I'll do is I'll make a response object, and inside the response object I will pass one more variable or URL, which is this one. Now what I'll do is I'll just print response.text. Let's see what happens. As you can see, we have persisted one cookie. So this was all about session objects, guys. And any dictionaries that you pass to a request method will be merged with the session level values that are set, and the method level parameters override the session parameters as well. And you have to consider that method level parameters will not be persisted across requests even if making a session as well. So now that we are done with session objects, let's take a look at errors and exceptions that we have for Python request, guys. So first of all, in the event of a network problem, for example, a DNS failure or a refused connection, request will raise a connection error exception, and it will raise a HTTP error if the HTTP request returned an unsuccessful status code, which is actually 405 or 404 as well. Now, if a request times out, a timeout exception is raised, and if a request exceeds the configured number of maximum redirections, a too many redirects exception is raised. So this is all about errors and exceptions that we have in Python request, guys. So now that we are done with errors and exceptions, let me talk about a small use case that I have made using the Django app. So we will exit the presentation mode over here, and I will open the project that I had made. So as you can see, I have a Django file over here with all the init settings.py, urls.py. So I have over here the URL configurations and everything. And I have a views.py file inside my app that I had created. So this has the code for making a request to a web API. And inside that, I will be able to search for a particular city, and I will be getting the description of the weather and the temperature over there and the condition of the weather over there. So I will show you this, and this is my template, guys. So let me run the server, guys. And if you're wondering how you can actually make a web app, I suggest you check out the Edureka tutorial for Django web applications, where you will be able to learn how you can make a web app from scratch, guys. So when I run my server, I should be getting a URL, guys. So that's where I have to actually make the request. So as you can see, I have a city, London, over here specified first of all. So when I open this, first of all, I have a heading which is saying what is the weather like. Then I have the icon which is saying it has broken clouds. Then there is London city name and the temperature in Fahrenheit. So let's see if I can do that. Since I'm making request to the API, when I change the city over here, I should be getting the temperature of the city again. So when I refresh this, now as you can see, I've changed the city as well, but I'm getting the temperature of the city that I have just specified, guys. So as you can see how easy it is to make request to a web server and get these values. So I'm making this request to this URL, guys, which I have specified over here, Open Weather Map API. This provides us the API, and I'm able to search for cities over there inside the request that I'm making. And this is how you can actually make a simple Django app for calculating or getting the weather of a city using the request library, guys.
let's take a quick look at the time module and its built-in methods. The time module consists of all time-related functions that are required to perform various operations using time. It also allows you to access several types of clocks required for various purposes. The time module begins recording time from the epoch. Epoch literally means a time in history, and it begins on 1st January 1970. As you can see on the screen, I've listed down some of the most important functions that are available in this module. So talking about the first function, which is time, it returns the number of seconds that have passed since the epoch. The cTime method returns the current date and time by taking the elapsed seconds as its parameter. Sleep stops the execution of a thread for a given period of time. The local time method returns the date and time in the struct time format by taking the number of seconds passed since the epoch as the parameter. GMTime, on the other hand, returns the current date and time in the UTC format. The mktime method is inverse of local time. It can take a tuple of maximum 9 parameters and returns the seconds passed since the epoch. And finally, the ASC time method, which can also take up to 9 parameters and returns a string representing the same. Okay, so now I'll jump on to my Jupyter notebook and show you all how this works. So the first thing that you'll have to do is import the time module. So I'll say import time and I'll hit run. Okay, so first I'll be making use of the time method present in the time module. So I'll just say time.time and I'll hit run. So like I've already told y'all, this method returns the number of seconds that have passed since the epoch. So I'll hit run. Okay, so here is the number of seconds that have passed since the epoch. Now, if I want to convert it to the current date and time, I can make use of the ctype method. So I'll just have to use time.ctime. Now, if I want to convert this into the current date and time, I can make use of the ctime method. To do this, I'll just use time.ctime and I'll have to pass the number of seconds as a parameter to this. So as you all can see on the screen, I've passed the number of seconds which was returned by the time method to the ctime method, and I've got the current date and time. If you want more information about these functions and methods, all you can do is use the help method. So I'll just say help time, and if I want to fetch data about the time method, I'll just say time.time and I'll hit run. So as you all can see, it says that this method returns the current time in seconds since the epoch. Similarly, if you use help on any method or function, it will return the corresponding information about that function. Okay, so moving on, I'll be making use of the local time method and see what it returns. So I'll just say time.localTime and I'll hit run. So as you can see on the screen, I've got the current date and time in the struct time format. Now to make y'all understand what this struct time class is, let me get back to my presentation. Okay, so as you all can see, the struct time class basically has 9 attributes, starting from the year, whose value starts from 0 and goes up to 9,999. The second attribute is month, whose value will be anything from 1 to 12. After that is mday, which means the day of the month, and the values can range anything from 1 to 31. Similarly, hour, minutes and seconds have the values 0 to 23, 0 to 59 and 0 to 61. The weekday value can be from 0 to 6, where 0 is Monday. Yday or year day can be anything between 1 to 366, and the final attribute is daylight saving time. It's 1 if it's summer, 0 if not, and -1 if unknown. Okay, now that you're aware of what this struct time format is, let's come back and see what our output actually means. Year is 2019, month is 8th or August, the date today is 8 as well, and so on. So I hope you're clear with this. Okay, so now, in case you want to fetch the number of seconds that have passed since the epoch. So to do this, you can make use of the mktime method. Okay, so all I'm going to do over here is first store the local time in a variable, say a, and after that I'll take another variable b, wherein I'll be using the mktime method, and I'll pass the parameter to it as a. Finally, I'll just print out b. So as you can see on the screen, the mktime method has returned the number of seconds that have passed since the epoch till now. So now, in case you want to fetch the current date and time, from the struct time format and return it in local format, you can make use of the ASC time method. So like I've already told you all before, the local time method returns the current time in the struct time format. I'll be using the variable a, which stores the struct time format of the current date and time to convert it to the local format. And to do this, I'll create some new variable, say c, and then I'll use ASC time method. So time.asc time, and I'll pass a parameter to it as a. And then I'll just print out c. Okay, so as you all can see over here, it has taken the struct format and has returned the local format of date and time. Python also allows you to format and pass strings using the strf time method and the strp time method. The strf time method can take a tuple containing 9 parameters and returns a string representing the same depending on the format code used. The strp method passes a string and returns it in the struct time format. To show you all what these format codes are, I'll just use the help method and I'll pass time.strf time as a parameter to this, and I'll hit run. Oh, I've made a spelling mistake over here. Sorry guys. It's strf time. So as you all can see over here, I have a number of format codes which I can use to format my date time strings. Okay, so first let's make use of the strf time method. So as we all have seen, I've created a variable a in which I've stored the current time in the struct time format. So let me just print this out again. Okay, so now I want to format this output in a manner which is convenient for me. So to do this, I'll use the strf method. So I'll just say time. I'll take another variable, say x is equal to time.strf time. I'll use the strf time method, within which I'll be using the format codes to format the date as per my choice. So first I want to print out the month. So I'll use the format code mod m. It's small m guys, please be careful because this is case sensitive. And then between this I just want to see a slash. After this I'll just print the date. I'll use mod d and then the year. So I'll use mod y. Sorry for the spelling mistake. I'll just print x. So as you can see on the screen, I've returned the current date in the month, day, year format. Similarly, you can also pass a string and return it in the struct time format. To do this, you can make use of the strp time method. To do this, I'll take another variable, say y, and I'll pass a string to this. I'll say 8th August 2019. And then I'll make use of the strp method to pass this string. So I'll just say time.strp time. And I'll pass y as a parameter to this and the format of it, which is day, month, and year. Capital B means the full name of the month. And now hit run. Okay, so as you all can see over here, I've passed a string using the strp method and returned it in the struct time format. So now let's get back to our presentation and take a look at the datetime module. The datetime module is similar to the time module, consisting of all the required methods that are essential for working with date and time. Some of the important methods present in this module are the datetime method, which is a constructor, and it consists of two methods, which is today and now, that will return the current date and time. The date method will help you create a date, and the time method will help you create time, which includes hour, minutes, seconds, microseconds, and the time zone information. The datetime module also consists of a from stamp method, which converts the seconds to return the corresponding date and time. Another very important function that's present in this module is time delta. Time delta basically returns a duration, which will be the difference between two different times. Okay, so now let's get back to our Jupyter Notebook and see how this module actually works. I'll just create a heading over here. Say date time. And I hit run. The first thing that I'll have to do is import this module. So I'll say import datetime. After this, I'll be making use of the datetime constructor to create some date. So I'll say datetime. And then I'll pass some values to this, starting with the year, which is 2019, and the month as 6, date as 7, time as 4, minutes, seconds, and milliseconds. And then I'll just print this out. So as you can see on the screen, I've created some random date using the datetime constructor. Now, in case you want to fetch the current date and time, all you can do is use the today and the now methods like I've already told you all previously. So I'll say datetime. So I'll just copy this. And then I'll use the today method. So as you can see over here, it has returned the current date and time along with milliseconds, which is very precise. I can also use the now method instead of today method over here. So I'll just say now and I'll hit run. So as you can see, both these methods return the current date and time. Now in case you want to access some particular value from this date, all you can do is use the attribute name to access that particular value. So in case I want to access the year and the month, all I can do is save this into a variable, say v, and then I can use v.year to access the year. So as you can see, I've accessed just the year from the current date. Similarly, you can access anything of your choice. So if I say print v.month, and then I'll say print v.r, and I'll hit run. So as you can see, the month and the hour have been returned. Similarly, you can access any values of your choice using these attributes. Now in case you want to set only date without time, you can use the date method. So you just say date time dot date and then pass the date as a parameter. The time method can be used to create time without date. So I'll just say it's 3 hours, 45 minutes and 23 seconds. So now moving on towards time delta, which is a very important method that's present in this module. Like I've already told y'all, this method represents a duration which can either be the sum or the difference between two different dates. Now to make use of this method, I'll just take some variable, say b1, and I'll say date time dot time delta, and I'll pass the number of days as 20 to this. You can also pass other parameters like microseconds, minutes, etc. Okay, I'll take another variable, say b2, and I'll use the same method again. And to this, I'll pass the number of days as 30. Now, I'll take another variable, say b3, within which I'll just store the difference of b1 and b2. So I'll say b1 minus b2, and then I'll print what is b3 and the type of b3. So as you can see over here, the difference between b1 and b2 is minus 10 days, and the time, since I've not specified anything, is 0. And the type of b3 comes under the time delta class.
Why exactly we use regular expressions? We are going to focus on various problems that regular expressions helps us to solve. So this is the first problem, guys. So over here what happens, you have a log file. And from that log file, you want only date and time. And as you know, with the format of the log file is not understandable to everyone. So here's a guy who only wants date and time from that log file. So what he can do, he can make use of regular expressions, identify the pattern, and he can actually get the date and time for that particular log file. So this is the first problem. We'll see a lot of more problems which irregular expressions help us to solve. So we'll move forward and we'll see the second problem. Now this is the second problem that it helps us to solve. Imagine yourself as a salesperson and you have a lot of email addresses and many of them are fake. So what you can do, you can make use of regular expressions, and all the email addresses have a particular pattern. They have a format. So with the help of regular expressions, you can verify that format and you'll get to know what all email addresses are correct and what all email addresses are fake ones. So as you can see, obviously schash.com is a fake email address. So using the pattern that is there in all the email addresses, you can verify whether that email address is correct or not with the help of regular expressions. Alright, so let's move on and see what are the other problems. So this is the third problem that it helps us to solve. We'll take the same sales guy's example that we have taken in the previous slide. Now over here, that guy has a data of various customers' phone numbers. And we know that a lot of time people don't give the correct phone number because nobody wants a sales guy disturbing them at odd timings, right? So that salesperson has a problem. He wants to know that what all phone numbers are correct and what all phone numbers are fake. So every correct phone number will have a particular pattern or a format. So using regular expressions, he can identify what all phone numbers are correct and what all phone numbers are wrong. And at the same time, different phone numbers that belongs to different countries or different location will have a different format. So again, taking that thing into consideration, he can again use regular expressions and identify to which area it belongs to. Now in this particular example, what I've shown you is, I've shown you two geographical areas. One is India, another is USA. So with the help of regular expressions, you can actually find out what all phone numbers belong to USA and what all phone numbers belong to India. So I hope this is clear to you. So this is the fourth problem, guys. Now over here, what happens, you have a student database and that contains name, age, address. Now what happens, there are a lot of students who live in a particular area and the area code of that area is 59006. But what happened, the area code has been updated and it has become 59076. Now, if you go manually update that for all the students, that'll take a lot of time. So instead of that, what you can do, you can make use of regular expressions and find out all the area codes from the student database. And after that, you can replace it with the updated area code or the pin code. So as you can see, with regular expressions, you can even replace a particular string. We'll move forward and we'll see one more reason of using regular expression. So now this is one more reason to use regular expression, because even if you don't have a Python background, if you have any other programming background like Java, PHP, C#, Groovy, Swift, Ruby, you can use regular expressions because it is compatible with all of these programming languages. And it is even compatible with JavaScript, although it is not written here, but yeah, it is even compatible with JavaScript. So till now we have seen various reasons to use regular expressions, but I know you guys must be wondering what exactly regular expressions is, right? So don't worry guys, we'll move forward and we'll see what exactly regular expression is. So a regular expression is basically used for describing a search pattern. So you can use regular expression for searching a specific string in a large amount of data. You can even verify that that string has a proper format or not. You can find a string and replace it with another string, and you can even format the data into a proper form for importing, for example. So these are all uses of regular expressions. Now over here I've shown you an example. Here there's a string which is present in which they have written Janice is 22 and Theon is 33, Gabriel is 44 and Joe is 21. So as you can see, what all useful data that I can find from here? Only name and age. I don't want the rest of the things that are present in this string. So what I can do, I can identify a pattern, and with the help of regular expression, I can convert that to a dictionary, and in that dictionary only the name and age will appear. Now my question is to you all guys, can you identify a pattern in order to get the name and age? Just give a guess. You just need to identify the pattern. Alright, so Sarah says all the ages are in the form of integers. Alright Sarah, that's a very nice observation, but what about the names? Alright, so I've got a couple more answers and they say the same thing, that the age is represented with the help of integer numbers, so you can get the integers. For the name, they have no idea how to get it. Don't worry guys, it's totally fine, just give a guess. Alright guys, so let me tell you. So basically if you notice that every name starts with an uppercase first letter. So the first letter of all the names is an uppercase letter. And when we talk about age, all of the age are represented in numbers. So what you can do with the help of regular expression, you can actually find out the 2-digit numbers, and at the same time you can find out the words that starts with an uppercase letter and then it goes on to lowercase letters. And the star actually represents all of them. So you don't need to worry about the syntax that is there in front of your screen. I'll be actually explaining you these things in detail. So you don't need to worry about that. So I hope you have understood the pattern that I'm telling you. Alright, so we have a question from Devon. He's asking, what if this may contain a name of a place? Alright Theon, so this string does not contain a name of a place. That's all I can say right now. If there was a place present here, then we have to look for a different pattern at that time. So basically with RegEx, you have to make sure that you identify the pattern for the string that you want. So it is very important. So let us move forward, and I'll open my PyCharm and I'll tell you how to get age and name. Alright, so let's do it. So this is my PyCharm, guys. So over here what I need to do is I need to first import the module for regular expressions. For that I'll type import RE, and now I'm going to type in the string that was there in the example. So I'll type in name age equal to, and now I'm going to write it Janice is 22 and Theon is 33. Now the next line I'll write Gabriel is 44. So I forgot the space. And Joey is 21. Now close it. So now for age, I'm going to type in ages equal to. Now you don't need to worry about the syntax that I'm going to write. I'm going to tell you all these things in detail. So this is just an example that I'm giving you, that with the help of regular expression you can actually get the name and age. After that I'm going to discuss each and every operation in detail. So what I'm going to type in, you don't need to worry about that. I'm just showing you that you can actually do it. I'm just giving you an example. re.find all are 1, 3, because all of my ages are 2 digits, and then write the name of the string. And for names, what are you gonna do? You're gonna type in names equal to, similar to that, re.find all are, and my first letter is an uppercase letter, that is between A to Z. After that I have lower cases, so I'm going to type in A to Z in lower cases, and then I'm going to put in a star that will actually include all of those, and finally the name of that string, that is name age. Now what I'm going to do is I'm going to define a variable, and I'm going to name it as agedict equal to curly braces. Let's keep it empty right now. And now one more variable I'm going to define, that is x is equal to 0. Now I'm going to use a for loop. I'll type in for each name in names agedict, each name ages x plus equal to 1. Now print this agedict. Yeah. So if you're not able to understand what exactly for loop is and what are dictionaries, so you can go and watch the previous tutorial videos on Python and then come back again. Now let's go ahead and execute this. So yep, you have got the dictionary that includes only name and age of that person. So what I've done here is, what is a pattern? I'm repeating it again. So for all the names, the first letter is an uppercase letter, and all the ages are expressed in terms of numbers. So using that pattern, I have got only name and age. So this is just an example. We'll actually see how to perform various operations using RegEx or regular expressions. So I'll go back to my slides. Now let's move forward and understand the cursor operation of regular expression. So basically in both strings and regular expression, both of them have their own cursors. So what happens is, suppose you are searching for R and your regular expression includes R. So your cursor is at R in the regular expression, but for text it will check for B, it is not equal to R, then E, then again when it comes to R it will see that this is what you are searching. So it will stop right there. The moment you search for S, it will go on and it will come towards S. And same goes for N as well. So this is a pretty basic operation, but it will really help you to visualize how things work with regular expressions. So we'll move forward and we'll look at various operations that you can perform with regular expressions. So first we'll find a word in a string. So we have a string that says we need to inform him with the latest information, and we need to find the word inform. So let us go ahead and execute this practically. I'll again open my PyCharm. So yeah, this is my PyCharm, guys. Let me just first clear it. So let's begin by importing our regular expression module. So for that I'll type import RE, and now we have a sentence and we want to find a word inform there. So what I'll do, I'll just type in if re.search inform, and our string is we need to inform him with the latest information. So this is our string, give a colon, and now I'm going to type in print there is inform. So let me tell you what I've done here. First, I've imported the regular expression module, and after that I've defined a condition which says that if it is able to search inform in this particular string, that is we need to inform him with the latest information, then it will print there is inform, otherwise it won't print anything. So as you can see that inform is present here, so it should print there is inform. So let us go ahead and execute this. So yep, you can see that it has printed there is inform. Now let's be more specific and suppose we want to find all the matches here. So let's write a method that will do it for us. So for that I'm going to use find all, which will return a list of matches for me. So for that what I'm going to do is I'm going to write in here, let me first remove this. And now what I'm going to do is I'm going to write in all inform, which is nothing but a name that I've given. You can give whatever name you want. re.findAll, and I've told you earlier as well, find all will return a list of matches. Now over here what I need to find inform, from which string? The string is we need to inform him with the latest information. Alright guys, and so now I'm going to type in a for loop which says that for I in all inform, give a colon, print I. That's it. So now what I've done here, you can see that I've imported the regular expression module. Then I'm using find all, in which it will return all the matches. And what I'm finding inform, and from which string I'm finding inform, this is the string that I'm using. And finally I've used for in order to find all the matches. So let's go ahead and execute this. So yep, it has found inform twice, because you can see that it is available here as well, inform, and even information over here you can see that inform is present. So this is how basically you find a word in a string by the help of a regular expression. So let me first go back to my slides. So we have seen how to find a word in a string. Next, we are going to understand how to generate an iterator. So basically what I'm going to do is I'm going to get the starting and the ending index for the word that I'm searching. Over here I'm searching inform, so it'll give me the starting as well as the ending index for all the matches that it finds. So let us go ahead and execute this practically. I'll open my PyCharm once again. Let me remove all of this. And over here I'm going to define a string. So what I'm going to write here is I'm going to write here we need to inform him with the latest information. Yeah. So now what I'm going to do is I'm going to generate an iterator by using find iterator, and it is going to return the iterator of the matching objects. So basically I'll be printing the starting and the ending index of the matching object. So for that I'll use the for loop. So I'll write in for I in re.find iterator, and I want it for inform, so I'll just type in inform, and now I'm going to type in the name of the string, that is str colon. Now I want that to be converted into a tuple, so for that I'm going to type in lockup equal to I.span, and finally print lockup. So basically it will print the starting and the ending index of the matching object. So let us see if it does that. So yep, so as you can see that for inform the starting index is 11 and the ending index is 17. For information it starts with 38 and ends at 44. So this is how you can actually generate an iterator by using find iterator. And this will return the starting as well as the ending index of the matching object. So if you have any doubts you can write it down in your chat box. It's pretty easy guys. So we'll move forward and we'll have a look at the other operations that you can perform with RegEx. So now what I'm going to do is I'm going to match words with a particular pattern. So we have a string in which we have sat, hat, mat and pat. So now my question is to you all guys, what is the pattern that you can see in this particular string, that is sat, hat, mat and pat? So let me go ahead with it, and I'm going to show you how you can match words with a particular pattern using RegEx. So first I'm going to open my PyCharm. Let me remove all this. So let me define a string once more. I'll type in str. So we have sat, mat, hat, mat, and we have pat. This is our string. Now I want to match anything that ends with at. So for that I am going to define a variable all str, and now what I'm going to do is re.findAll. Now what I want words that start with S, H, M and P. Alright, and after that it should end with at. So I've written at. It's very simple, guys. And now what I'm going to type in, I'm going to type the name of the string, that is str. So this bracket where I've written SHMP, it shows that I'm matching specifically for the words that starts with S, H, M and P. Now I'm again going to use a for loop in which I'm going to type in for I in all string, give a colon, print I. It's that simple. Go ahead and execute this and see what happens. So yep, it prints hat, mat and pat. But one thing to notice here, guys, it will not print sat. Why it is not printing sat? Because it is an uppercase letter. So if I go here and I make it as capital S and go ahead and execute this, so yep, you can see that even sat has been printed. So let me go back to my slides and see what all other operations that we can perform with regular expressions. Now over here, what I'm going to do is I'm going to match series of range of characters. Now what does that mean? Let me explain you with the example that is there. So now what I want here is, I want all the words in which the first letter is between the range H to M. So all the words whose first letter comes in the range H to M should be printed, and it should be ending with at. So basically it should print hat and mat, because P comes after M, so does S. So it won't print sat and pat. Now let's go ahead and see in our PyCharm whether this happens or not. Now over here what I'm going to do is I'm going to remove this S, so does P. Throw in a hyphen here and execute this. So yep, it has printed hat and mat. So if I want all these things to be printed, what I can do is I can write in here Z and execute this. So yep, it has printed hat, mat and pat, but it has not printed sat. Why? Because it starts with an uppercase S. So if I make it as S and I'm going to print this, so yep, it has printed sat as well, because between H to Z all S, H, M and P lies. So it has printed all the range of characters whose first letter is present in the range H to Z. So now I can use a caret symbol that will include all the words apart from ones which have the first letter between the range H to M. So let me first make it as M, and now I'm going to use a caret symbol. Yeah. So when I use this caret symbol, this means everything apart from this range, that is H to M. Go on and execute this, and you can see it has printed sat and pat, but not hat and mat, because of the caret symbol that I've just shown you, right? So I hope you all are clear with how to actually find a range of characters in a string. And now what I want to replace a particular string. So as you can see in the example, I have a string in which we have hat, rat, mat and pat. But I want to replace this rat. I don't like rats. Alright, so jokes apart, I want to replace this rat and I want to replace it with the word food. Now let me show you how actually you can do that. I'll again open my PyCharm. Let me first remove all of this. I'll define a string. I'll name it as food. Although there won't be any food items in it, but yeah, just for the demonstration purpose. Hat, rat, mat and pat. Now I want to replace rat with food. So now I'm going to compile our regular expression into what are called pattern objects. And pattern objects provides us with additional methods, and one of which is substitute. Let me show you how you can do that. Just type in RegEx, for example. Yeah, RegEx equal to re.compile, and I want to compile R, which ends with at, and now in the string food I want to substitute it. So I'll type in regex dot sub. What I want to substitute food, in which string I want to substitute. I want to do that in the string food itself. So yeah, and now finally go on and print it. So as you can see, we have hat, food, mat and pat. So we have replaced rat with food. So this is a pretty simple examples that I'm giving you right now, but with these basics you can actually go on and find out a pattern and you can perform a lot of operations. Now there's one very important thing that I want to talk about. It is called solving the backslash problems. Now let me show you what I'm talking about. So I have a string, let me name it as a random string. So I'll write it rand str equal to, here is Drogba. Alright. So when I go on and print this, let me show you what comes. So we got only single backslash, but we have typed in here double backslashes. So this is what I'm talking about. Now in order to solve this problem, what I can do is I can make use of regular expressions. So let me show you how you can do that. So all you need to do is you need to type in re.search. So this is re is basically, we call it as a raw string. So raw string will treat backslashes as special. So let me show you how it will do. I'll just type in re.search, then r quotation Drogba, comma, and the name of the string, that is random string. Go ahead and execute this. So yep, it has solved our problem and you can see that double backslash appears over here. So this is what I'm talking about, the backslash problem. Alright, so we have no doubts. Let me open my slides again and we'll have a look at the other operations that you can perform with random strings, that you can perform with regular expressions. Now what I'm going to do is I'm going to match a single character. So I have 1, 2, 3, 4, 5 as my string, and now I want to print only the 5th digit, so it should print 5. But before that, we'll have a look at a couple more examples in which I'll be telling you about how to deal with white spaces. So let me open my PyCharm again. Let me remove all of this. Yeah. So now I'm going to define one more string. Let me name it as random string equal to keep the blue flag flying high, and Chelsea, this is nothing but my favorite club. And let me just print this random string. So that's printed, keep the blue flag flying high. Now let's go ahead and remove the new lines with a space. So for that, what I need to do is, again, I'm going to define a variable. Let me name it as RegEx equal to re.compile. We have talked about compile in the previous example, so I hope you can remember it. So the symbol for new line, that is a \n. Then I'm going to type in the random string equal to regex, substitute it with what? What do you want to substitute it with? Just a space, right? So just give a space in between. That's pretty easy, and just type in here random string. Now go ahead and print this random string. Yeah. So as you can see earlier, it was like this: keep the blue flag in one line, flying high in one line, Chelsea in one line. But with the help of regular expression, I have replaced the new lines with a space. So this is how you can work out with white spaces. So this is how you can work with white spaces. Now there are other white spaces that you'll be able to work with. For example, let me just show you. So you have a \b that stands for what? It stands for backspace. Then you have \f for form feed. Then you have \r for carriage return. Similarly, you have \t for tab. And you have vertical tabs as well. So for that we have \v, vertical tab. So these are the white spaces that you can work with. Now let's see how to match a single character that we have discussed in our slides. So let me first remove all of this. Alright, so let me define one more variable. I'll name it as random string again. And I'm going to type in here 1, 2, 3, 4, 5. And now what I'm going to type in print matches. I'm going to give a colon, and then I'll type in length re.findAll \t in a random string. Now over here you can notice that we have \t. So basically this \t will match any numbers, any numbers which are present. But if I write a capital D over here, so it will match anything but a number. So let me keep it as \t and print this and show you what it will give us. So we have 5 matches. As you can see that we have 5 digits. Now if I make it as capital D, so that will return me everything but the digits. So let me just show you. I've converted this to capital D. Go on and execute this. So we have 0 matches now. So now if I want to match a specific digit, I'll be using curly braces. So let me show you how you are going to do it. So in the curly braces, just type in 5 and it should print that for us. So yep, it has found one match that is present over here. So what I'll do, I'll clear this again and I'm going to define in one more variable. Say let it be num. Over here I have 1, 2, 3. Then I have 1, 2, 3, 4. Then I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 and 7. Now we can even match digits with a certain range. Let's say our range is between 5 to 7. So for that what I'm going to type in, I'm going to type in the print statement, and again I keep it as matches, give a comma, and now I'm going to type in length re.findAll. What I'm searching for digits, so \d. And what is my range? Range is between 5 to 7. Give a comma and then type in the string name, that is num. Go ahead, execute this, and it finds 3 matches because over here we have 5, over there we have 5 and 6, over here we have 5, 6 and 7. So it has found the 3 matches that we were talking about. So this is how you can perform basic operations using regular expressions. Now we have seen all basic operations that you can perform with regular expressions. Now how about I show you what are the various applications of regular expressions. I'm going to take in some use cases, a problem statement, and I'm going to show you how you can use regular expressions in order to solve those problems. How about that, guys? Alright, so I see a lot of people are interested in that. So without any further ado, let us move forward and see how you can do that. Alright, so we have a first problem in which we need to verify the phone numbers. So we have a list of phone numbers, and the general format of a phone number is it should start with 3 digits, then a hyphen sign, then 3 middle digits, and the 3 digits in between and a sign, and then 4 digits in the end. So this is what our basic format of a number is. So let us go back to our PyCharm and verify these numbers with the help of regular expressions. Let me remove all of this. So before I start writing down the code, let me explain you something. So we have \w. So basically what it does is, it is same as writing down lowercase a to z, uppercase a to z, even numbers, and underscore. So lowercase w is actually equal to this thing that I've typed here. So it will match anything that is inside the brackets. When we talk about uppercase \w, it will match anything but the things inside the braces. So it is similar to using a caret inside the brace. So I'll just show you. So it will match everything but the things that are present inside the braces. So this is what I'm going to use in order to write the code for validating phone numbers. So let me just make a string that has my phone numbers. So I'll just type in as phone, and I'll put here 412 555 and say 1212. Alright. Now I'm going to use a condition statement that says if re.search So anything that has 3 digits, then it should have a hyphen sign. Then again, anything that has 3 digits, then again a hyphen sign, and anything that has 4 digits, give a colon, go on and print it is a phone number. Now basically, instead of \w, I can even use as \d because all of these are digits. But let me just keep it as \w only and go on and print this. So yep, it is a phone number. But what if I am going to change here and I'm going to make it as 5551? Let me show you. It is not printing anything because our regular expression says that it will take only 3 digits. Now, as I've told you earlier as well, W takes A to Z, lowercase and uppercase as well. So even if I replace it with D, it won't matter. Let me show you. Go on, execute this. So yep, it has not printed anything, but if I go on and remove this 1 and print it again, so yep, it has printed a phone number. Now if I would have added here A as well, it won't print that. So yeah. So basically I wanted to tell you what \w is. That's why I've written it over here. Now let me tell you a use case of this \w as well. So if you want to see that a full name is a valid full name or not, so what you can do is you can use \w at that time. So basically why I've explained you \w is this is how you can use \w. Alright, I'll give you one more example. So now let me remove all of this. And now we'll see if the full name is valid or not. Basically there should be a space between first and last name. So for that I'm going to use a \s, which is same as writing down \f, that is form feed, or a \n, that is a new line, or a \r, that is a carriage return, or a \t, that is tab or vertical tabs. So it is pretty much similar to that. So it is exactly the same. Similarly, if I write here an uppercase S, can you guess what it will be? Alright, so everybody almost guessed it. So basically it will be equal to a caret and form feed, new line, \r, tab, as well as vertical tabs. So it will include anything but \f, \n, \r, \t, and \v. Let me just comment this. Alright. So now let us go ahead and validate whether a valid full name is present or not. So for that what I'm going to do is I'm going to type in a condition if re.search. Now over here what I need to do is, can you guys tell me? Alright, so first I'm going to type in W, and range of W should be between 2 to 20. Then in between I want a space, so I can just type in as, now in between what I want, I can have either a new line or a tab or a vertical tab, anything like that. So I can give a \s and one more \w for the last name, and the range of the last name can be from 2 to 20. And finally I'm going to write the name. I'm going to write my own name, give a colon, and print full name is valid. Go ahead and execute this. So yep, as you can see that it has printed the full name is valid. So if I convert this lowercase s to an uppercase s, it will basically be equal to a caret and form feed, new line, vertical tabs. So anything apart from all of these. So I hope you have understood the concept that I've explained to you till now. Alright, so we have no doubt. So now I'm going to move back to my presentation again. So now this was one use case. Now a second use case is we need to verify the email addresses. So our email addresses should have 1 to 20 lowercase and uppercase letters, numbers, plus, period, underscore, percentage, plus, minus. It should have an @ symbol. Then again 2 to 20 lowercase and uppercase letters, numbers, plus, period, and a hyphen. Then we should have one more period, and then 2 to 3 lowercase and uppercase letters. So let me go ahead and show you practically how you can do it. Let me remove all this and first write a list of emails. So you can write it as sk@aol.com. I can have md@.com @seo.com. Now I can have one more and I can name it as dc@.com. Let me just remove the space. Alright. So now what I'll type in print email matches, give a colon, and after the space I'm going to type in length re.findAll, open the parentheses, and over there in the square braces, what I want first, I want anything, then I want a period, I want underscore, percentage, plus, hyphen, close the braces, and it should range between say 1 to 20. After that what I want @. After @ I want anything, so for that I'll type \w dot, that is period, then I want a hyphen, and what should be the range? It should be between 2 to 20 characters. After that I want a period, and then I want uppercase and lowercase letters, then it should range between 2 to 3. Email. Alright guys, go ahead and execute this. So it has found only one match, so which is sk@aol.com. Now if I actually copy paste this once more in the end and print this, so yep, we have two matches. So this is how you can match the email address. You just need to identify the format of it and you can do it. Alright, so we have no doubts. Now let us move forward and see the third application of Python regular expressions. So you can perform web scraping using regular expressions. Now what is web scraping? Let me explain you with a flow diagram that is there in front of your screen. So we have websites, right? And obviously these websites contains multiple web pages. Now if I want to scrape some useful information from those web pages, I can use web scraping and extract that content, and I can save it wherever I want. I can save it in an XML format or a CSV, basically however I want to save. So you can do that with Python regular expressions. So in our case, what we are going to do, there's a website, and on that website we have phone numbers, we have addresses. So what we are going to do, we are going to write a code in order to get only the contact numbers from there. And how are we going to do that? We are going to do that with the help of a regular expression. So for that, I'm again going to open my PyCharm. So guys, I've already written the code. So over here, I've imported a couple of libraries in the beginning, which are used to perform web scraping. I mean, they are used basically to read the web page. Then we have findAll, which we have discussed earlier as well. Now this is the URL that I'm talking about, right? So let me just copy this, and I'm going to show it to you in my browser how it looks like. So this is how our web page looks like. So we have name here, we have the address, then finally we have the phone numbers. Now notice the pattern in the phone number. We have 3 digits inside the parenthesis, then again we have 3 digits, then we have a hyphen, and then finally we have 4 digits. Just keep this pattern in mind, and we are going to write a code in order to scrape only the phone numbers from this particular website. Now let me close right now. Alright, fine. So now you've seen the URL, right? So apart from that, whatever things that are there, actually we have covered that in the web scraping tutorial, so you're pretty much aware about it. So what is this? We are basically reading the content that is there in our particular website. Now we'll focus on the regular expression part. So you know what exactly findAll is, we have discussed that. Now since we want only digits, so we are going to make use of this particular identifier, and inside the curly braces I have written 3, which means that there'll be 3 digits inside the parenthesis. After that there's a space, then again we have 3 digits, then we have a hyphen, and then finally we have 4 digits. Then save it in HTML str, and then finally print it. Now let us go ahead and execute this and see what happens. So we have scraped all the phone numbers that were there. This is how it looks like, and we made use of regular expressions. So you can use regular expressions for web scraping as well.
why we require file handling. Well guys, think about this situation. You have a server running and you need to give access to someone who needs to access it remotely, right? Or basically you need to work with these files in general and say you need to have some import into your program where you're actually configuring an input for it. Well, if I had to answer this personally, how would I go about it? I would be using files for a lot of my deep learning models to import my datasets into the program at all the time. So basically by doing this, I'll be making use of files a lot. So coming back to the basics again. How can we input something into Python? The standard input? The usual keyboard input, right? So you can key in anything you want. Well, there's another case as well. Maybe even command line arguments to input some parameters into the code, correct? But what if you had to read lots and lots of data, which is not practical to type in at every point of time, or even that it doesn't make sense at all to type it all the time? The easiest way out of this here is to actually store whatever input you want in one place and keep using it as long as your requirement is met. So what's the answer? The answer is files, guys. So guys, this concept is actually very easy. I'm sure everyone who's joined will take away some really interesting stuff about Python that you can practically use. Working with files basically opens another door among thousands. And each door with Python opens up to n number of opportunities again. So now that we're good with this and we started off on a really high roll, let's keep it going. Next, we'll be taking a look at some of the types of files available in Python. So guys, let's keep this session very interactive. Head to the comments section and keep the energy going. So can you quickly name all of the types of the files that you know? So again, let me help you here. So we have images, we have audio, we have video, we have text, we have script, and so much more, right? There is a key difference here I want you guys to note. Check this out. Windows supports all of these files that I told and more. Well, virtually unlimited to be honest. But again, I won't get ahead of myself here because there are limitations here as well. Now check out Python. There are two types of files, binary and text. So whatever is not text is binary, as simple as that. So either a file gets to be a binary which contains obviously zeros and ones, or it can have some literal text. Well, text as in strings or anything valid for that matter. Text files are structured as a sequence of lines where each line includes a sequence of characters. And this is what we call as code or syntax, right? And every line is terminated with a special character, what we call as the EOL. What is the EOL? Guys, it's the end of line character. A binary file is any type of file which is not a text file, as I mentioned. And because of their nature, binary files can only be processed by an application that knows and understands this file system structure. In other words, they must be applications that can read and interpret binary, right? And now that we know what are the types of files are, so we can start looking into more of this. Guys, formally speaking, I think it can be consolidated as the operations performed on a file, right? So what all can we do? Check this out. It's called as the CRUD operations. What is CRUD? Well, create, read, update, and delete, guys. These are the operations which can be done with files. Well, again, there are many other operations as well, such as copying a file, changing the properties of a file, or anything. But for simplicity's sake, I have planned to keep this session really easy for all of the audience. So let us dive into Python now. So let us quickly see how we can go about understanding the file handling capabilities of Python. Check out this flow diagram to give you a quick picture of what needs to be done. First, we create a file and later we open that file. We work on the file. Well, working on it is basically reading or writing or anything for that matter. And lastly, we close the file when we are done using it. Coming to Python now. creation of a file can be done manually by the user or through Python. For now, let us consider that we will do it manually by going into the location and creating a file, say like a text file. Later in this session, I'll show you how easy it is to make Python create the file for us. So make sure you stay tuned till the end. So now we concentrate on how we can open a file with Python. Guys, it is very simple. So we have an inbuilt function called as the open function, which is used for this exact purpose. The open function takes in two parameters as seen here. One is the file name and other is the mode. And this on your screen is the syntax for the open function. So what do the two parameters mean? One is the file name that you want to open. It can be anything at this point of time, right? So it has to contain the extension of the file type as well. So this is compulsory and important. So make sure you keep this in your mind. And second, we have the mode. We know this means something that has to do with opening the file, right? So check the screen. So basically, these are various modes available to open a file. We can open it in the read mode, the write mode, the append mode, and even the create mode as well. Pretty straightforward. But do note that the default mode is always the read mode. And guys, note that you can open a file in read mode only if it exists as well. If you try to read a file or something that doesn't exist, then Python will greet you with a beautiful error message. And in addition, if we want to specify if the file should be handled as a binary or a text mode, then along with the mode as well, we can actually push in two categories for it. Check this out. So we have T for text and B for binary. T is the default value and B is for binary modes. So we can have something as WT. So what does it mean? So it basically says that the file needs to be opened in the write mode and the file that the Python opening is a text file. So we're basically making the job of Python to be really easy in this case. So check out the example code I have here for you guys. Even if we do not give a mode, as I said, the default is the read mode. So these two tiny snippets I have for you are one and the same. And yet, make sure something exists before reading that, guys, or else you're sure to hit that error. So check this out, right? So I have f equal to open and the file name is demofile.txt. I don't have a mode here. This is exactly equal to having the read mode in the next example. And it is as simple and straightforward as that. So now we know how we can actually create a file and open it, right? So let's begin working on it. Let us start with creating on how we can actually do a read operation using Python. So the read operation is very easy, guys. So basically, just like all the other functions and handling files in Python, we make use of the read function for this very purpose. But then again, there are so many ways to read a file too. So let me break it down for you, all right? So we can do many things here. We can read an entire file, or read a few characters, or read a few lines, or any number of characters and lines together, and so on. Check out this example code here. So we have a variable, right? We call it file. And then we are opening the file. It's called textfile.txt and opening it in the read mode. Later, we are actually going to make use of the print function to read the contents of the file and print the same on the Python console. Now, similar to the previous code that I just showed you, we have something slightly different here. Can you notice that 5 on your screen? What do you think the 5 indicates here, guys? Let me help you out. So it basically tells the Python interpreter to read the first 5 characters from the file and nothing else. Now check the old syntax. So here we don't have the 5. So we are basically telling the interpreter to read every single valid character present in our file and print it out for us. So you got a good picture of what is happening with the file now? Well, let's quickly take a tour into seeing this practically. So I'll open up my PyCharm now, which I use as the IDE to work with Python, where I'll show you the code for all of these. Guys, you can basically make use of any IDEs that you're comfortable with and even the console as well. It is your call. I am comfortable working with PyCharm, so I'll go ahead with that. So let me quickly open up the IDE and we can see the basic code to read the file. So as you can check out, I'm here in my PyCharm right now. Importing the OS module is the first line. This is currently being unused right now, but I'm going to talk about this in the future session. So basically, we're opening a file, right? So we have a variable file. We're going to open it and we're providing the entire path to the file present. So here, the file is demofile.txt. This is the name of the file. W is the write mode that I already told you about. Let me quickly go ahead and run this. That ran fine. But you cannot see anything on the output, right? That is because we just opened it, overwrote everything that is present in the file, and we just closed it. So we're not seeing absolutely anything here. Check out example 2. Importing the OS module, file equal to open. Again, we are providing the same file. Here we had write mode and now we are having the read mode. And here we are actually printing it using the file.read. Again, I'll be walking you through file.read in a second, but right now all you need to know is this will print the output on the screen for us. If I go ahead and actually run it, nothing is going to be printed. Why do you think this happened? This happened because we actually used the write mode and we actually blanked out the entire file. Quick fix is to actually open the file. As you can see, nothing is present there. So let me type in something. So we love Edureka. Let me save that, quickly minimize it, go back to my PyCharm. Now as soon as I run this, it is supposed to give me that exact output which says we love Edureka. Perfect, right? So with absolutely 3 to 2 lines of code, you can actually print something on your screen. How simple is this, guys? Well, check out the next case. So again, it's the same thing, opening the file using the read mode, and then you're printing file.read of 5. Guys, file.read of 5, right? So I actually explained this to you. So let me just go ahead and run it. We'll check the output. We got the first 5 character, right? So W, E, a blank space, L and O. Let us try to make it more nice to look at. Let me just quickly open up the file. Hello world. This is a perfect candidate for our example. Yep, the quick typo. Save it. Exit, back into the code. Now I'm going to run this old code, right? So you're going to get the entire output here. Check it out. Hello world. Perfect, because we have read of blank. Now we're going to actually run this. Because we're telling the interpreter to read only the first 5 characters of the first line for us, it is just printing hello. How simple is this, guys? So now that we are actually done with this, let's quickly jump back to the presentation to see what's next. Well guys, next I want you guys to check out this syntax, right? So this is what I love about Python. Amazing readability, and you can almost guess what it means, and you can be certain of it, say 90% of the time. So we saw how to read characters. Now let us look at how we can read lines. Well, readLine will actually read each of the lines and give us a line by line output. ReadLine of 3 will tell the Python interpreter to read only the third line and absolutely nothing else. But what if we wanted to return every line in a file which is properly separated and nice to look at? Well, you can actually use the same function only in a new form. This is called as file.readLines function. Again, let's take a quick jump back into the code so we can see this in action. So check out example 4 on your screen. I have the same file demofile.txt. I'm opening it in the read mode and I'm using readLine. As soon as I go ahead and run this, I will have the same output as hello world. Okay, let us step it up a little. Let me just change this. Hello world. We love Python. And we love Edureka. So I have 3 lines here. All good, right? So I'm going to save it. I'm going to close it. I'm going to come back here. I'm going to run the read line. Again, we're reading only the first line. Cool. Check out example 5 now. This is where things get interesting. Import again, it's all the same, guys. So basically, instead of the read line, I have read lines over here. So the S is extra and it's going to read all of these lines and it is going to put it in a really beautiful way for us to see. Check this out. Hello world is an entity. We love Python as an entity. We love Edureka as another entity. And that's nice to look at, right? So instead of just getting a gibberish output of everything in the line, separating it actually makes a lot of sense. So now that we're done with this, another quick hop back to our presentation. So guys, next we need to check out a tiny concept on how we can actually loop over a file object. Well, this is another simple concept, so let me teach you this. We're using the for loop for this very purpose as shown. But why would we want to do this? When you want to read or return all the lines from a file in a more memory efficient way and in a faster manner, you need to use the loop over method. So the advantage of using this method is that the related code is both really simple and easy to understand, right? So let me take another quick jump into PyCharm and check the single snippet out. So we are back into PyCharm and check out this for loop example I have for you. So again, we're sitting on the same file, demo file.txt, reading it in the mode. So for every line in our file object, print read lines. So it is going to print the output for us containing all of the documents of our file. As you can see, we love Python and we love Edureka. That's really simple, right? And with this, we are actually done understanding how to open the files and read them in multiple ways. Next, we need to actually take a look at the write operation, which is again very simple and almost similar to the read method. Let's start. Writing to a file is as simple as using the write function, guys, similar to the read again. So to write to an existing file, we make use of two modes. One is the append and the other is write, which we already checked out earlier. By append, we actually add the contents of the write to a new existing content. And with write, we just add it to the blank file. Now, I am sure there is a question in your mind right now. So what if the file that I'm trying to work on is not blank? What if it contains some previous data and we make use of W instead of append? Guys, this will basically delete everything in the file and overwrite it with what we've just put. And this is exactly the first example case that I actually showed you. So make sure that you use the mode very wisely in every situation, right? So here's a quick example before we dive right back into code. As you can see, we open a file in the write mode and we write 2 lines into it and we close it. It is as simple as that, right? Now again, taking you back to PyCharm and let me walk you through the code. So guys, we are back into PyCharm right now, so check out the first example I have for you. Import OS, I already explained. Opening it in the mode of write. So since we already have some content, all of that content will be overridden with hello world and hello world again. So we're opening it, we're using file.write to write 2 content into it, and then we're going to close it. Let me run this. Again, no output because we are not printing it to our console. How do we check if everything is working? Open the demo file. Hello world and hello world again, right? So this is exactly what we wanted. But then again, this looks a bit gibberish as I told you, right? So we use read lines to actually make it look nice for us. Heading back to PyCharm again. Check out the next example I have for you. So now this is to prove that we are actually overwriting it again, which I've already told you and it is simple, but still let me walk you through this. So we're working on the same file, we're using the W mode and then we're writing it to it saying, oops, we have overwritten it. Run it, it ran, no output. But in the sense the file is changed. So it says oops overwritten instead of hello world and that old message that we printed. Let me head back to the PyCharm again. And this is for creation and we'll be coming back to this in just a second. So let's quickly go back to our presentation and then we're going to be coming back to PyCharm again. So we're down to the last 2 concepts that we will check out in this session. The first one among that is for us to create a new file using Python. Well guys, even for the creation of the file, we need to make use of the open method. We already know that A is used for append and W is used for write. And now we have X, which is used to create a file. But do note that you cannot create two files of the same name, guys. So basically it means that you cannot create a file which already exists. Check out the example on your screen and you will definitely get a better picture of it right there. So you cannot have two files with the same name, testfile.txt. This is not right. So again, Python will give you a beautiful error message and it won't be so beautiful at the end of it. Let me dive back to PyCharm and we can check out the example over here. Let me change this. We have something else, right? So let me type edureka.txt. I'm going to print new file into Edureka. Opening it, we are opening it in the X mode, so we are actually creating this file physically. Write mode to write something into it and close it. So as I run it, no output. Check out the file. Where is the file called Edureka? It is here. New file of Edureka. So it's perfect, right? Let me quickly head back to the presentation and we can check out what's next. And then the next simple concept I have for you guys is showing you on how deletion operation works with respect to files using Python. Guys, deleting a file is very simple and straightforward. We'll require the os.remove function just for this purpose. So yes, importing the os module is a compulsion here. I've been using it all along because it is just a good programming habit to use the os module when you're playing around with the file system. The biggest mistake I have seen people do is that they usually go on to delete a file which doesn't exist. Again, Python pushes in an error message and that is not good at the end of the day, right? So it is very vital to know for sure that the file exists. To do this, we just check if the path exists and if it does, cool, remove the file. Else, print that the file doesn't exist so you cannot remove it. What does this say? Guys, this is a very simple case of an exception handled by the user and this is a really good programming habit too. So all good, but can we delete a folder? Yes, we definitely can. A folder with all the content inside it can be deleted using the rmdir command. What does rmdir stand for? It basically stands for removing directory and the parameter here is basically the path. And by the path, it includes the name of the folder which needs to be removed. And this is all of the operations you can do with Python by making use of files.
Introduction to Python and MySQL. Well, as you already know, Python is one of the most widely used programming language and in demand among developers. But you can't merely develop any application without having to know where to store the data. So this is where database management system comes into picture, and one of the most widely used DBMS server that is also used in the industry practices is MySQL DB server. Let me move ahead and talk a bit about integrated connection. Alright guys, this is just a glimpse of how the bigger picture will look like. What I'm trying to do is I'm basically trying to integrate my Python with my backend database server and then do the further manipulations. Now let me move ahead and explain you the internal working logic behind when you establish a connection between Python and MySQL DB server, or I can say that I'm basically going to explain you the internal working logic that how does it actually connect or work. So as you can see, there are numerous pictures given in this slide. On my extreme right hand side, there's a picture of a database, and on my extreme left hand side, there's a picture of a Python application, and in between lies the MySQL connector Python API. So MySQL connector Python API is nothing but acts as a bridge between my front-end Python application and my back-end database server. Now when I say this word Python application, think of any Python application. Let's say suppose think of a website which a user has developed, which lies in the front end. Now my front-end Python application will basically send a connection request to the MySQL connector Python API. Then the API will forward the same request to the database, further which the database will accept the request and send the connected message, and then my Python application will send a cursor connection request. So over here, think of connection as a method and cursor as an object which basically lets you communicate through your entire MySQL DB server and also lets you create your own database. Finally, my Python application will execute a certain SQL statement or a certain SQL query, and for that my backend database server will fetch the result data. So guys, this was it with the internal working logic that basically works behind when the Python and MySQL DB server connection is taking place. Now let me move ahead and talk a bit about operations which I'm going to perform with Python and MySQL. So guys, I'm basically going to perform CRUD operations, which simply means create, read, update and delete with my Python and MySQL. So let me move ahead and show you the implementation of CRUD operations from coding point of view. So let me quickly open my PyCharm. Alright. Guys, before diving deep into the coding perspective, my first and foremost step is to basically import the MySQL connector package. And how do I do that? I'll click on File, click on Settings, click on Project Interpreter. On the extreme right hand side, there's a picture of a plus sign. And then type here MySQL-connector. Alright, click on MySQL-connector, click on Install Package. It will basically take a minute or two to get installed. Essentially, our first step is to install the MySQL-connector package, which forms the stepping stone for our further operations, which I'm going to do. Again, it'll take a minute or two to get installed. Alright, so as you can see, our package MySQL-connector has been installed successfully. Now, one of the other approach to install the same thing is, suppose this is for those set of users who don't use any Python IDE. Suppose you're using a Python command line. So for them, quickly open command prompt. Once your command prompt is opened, quickly go there and type pip install MySQL-connector, which is the package, and press enter. Well, it is going to show me or give me a message that is requirement already satisfied, since I've already imported the package on my PyCharm IDE. But this demonstration I'm showing for those set of users who simply use Python command line. So for them, you can go to your command prompt, type pip install MySQL-connector. Your MySQL-connector package will be installed, and then you can import your same package on your Python command line, and then you can move on with the further operations. So now it's saying me a warning. This is none of our concern, guys. Let me just quickly close it. And as I've already created a file under the name of Python DB creation, I'll move on with my coding demonstration. So let me enter the presentation mode and start off by writing my first line of code. So the first line of code which I'm going to write over here is, I'm simply going to import the package which I installed just now, that is MySQL-connector. I'm sorry, it will be MySQL.connector. Now I'm going to create a local DB instance, that is MyDB, under which I'm going to write MySQL.connector.connect, under which I'm going to pass in the three parameters that are host, which is equal to your local host. Then comes the username, that is equals to root, and then comes the password, which is equals to password 123. So root is the default username which I had given, guys, and password 123 can also be customized. So this is the password which I gave. Now I'll merely print this local DB instance, that is MyDB. Quickly go ahead and run this code. Yeah. All right. Yeah, so as you can see, the connection has taken place, but how do I verify whether the connection has been established successfully or not? So in order to do that, I'm just going to write two more lines of code, that is if MyDB, then print, that is if it false or if there's a local DB instance, that is MyDB, then I'm going to print connection successful, else I'm simply going to terminate this, or I'm going to write print connection, that is if there's a local DB instance, that is MyDB is coming, or under MyDB it is coming, or the parameters are there, then my connection will be successful, else my connection will be unsuccessful. Let me move ahead and run this code. Give me a minute, guys. Well, as you can see, our connection is successful. Now I'll just change one parameter and see whether it's verifying that the connection will be established successfully or not. Now I'm going to change a parameter. Suppose I'm changing the root, which is the default name of user, to Ram, and let's see if the connection is being established successfully or not, or it is being verified or not. Well, as you can see guys, it shares access denied for user Ram, as because our default username was root, which I had given, so it will not be getting connected to our MySQL DB server. Now let me quickly write back root over here and move on by creating a database. So in order to do that, I'll quickly open file. I'll create a new Python file with the name as Python DB creation. Let me just name it Python DB1 creation. Now I'm going to write my first line of code, that is importing mysql.connector, which is the package. Then I'm going to write mydb is equals to mysql.connector.connect, under which I'm going to pass in the three parameters that are host, which is equals to your local host. Then comes your username, that is equals to root, and then comes my password, that is equals to password 123. Finally, I'll move on and I'm going to show you what I'm going to do over here. So I'm going to create an object with the name as myCursor, under which I'm going to pass mydb.cursor, which is pointing towards the location. And finally, I'm merely going to print this object, that is myCursor.execute, under which I'm going to write create database, and let me say my database name is HarshDB. Alright, and then I'll quickly move ahead and run this code. Let's see what is the output. Alright, so it says that the database has been created, that is HarshDB has been created. Now I'm going to show you whether this database is existing in our MySQL workbench or not. So in order to do that, I'll just change few parameters and add a for loop. I'll explain you about the for loop part later. So let me just omit this part, HarshDB, and instead of create, I'll simply write show over here, and then over here I'm going to write show databases. Now I'm going to write for db in myCursor. I'll simply print the database. Alright, move on and run Python db1 creation file. Well guys, as you can see from the output, the reason why I used a for loop over there is because once my code enters the for loop, it is basically printing all the databases which are existing in our MySQL workbench along with the database HarshDB that we have just created, which is there in our output. So it's very clear. Now I'll quickly open my MySQL workbench and I'll write the same SQL query over there so that it's crystal clear to you. Alright, let me quickly maximize it. 1 second. Now let me simply write show databases and click on execute. 1 minute guys. Well, as you can see, our database HarshDB has been created along with all the other databases which are existing in our MySQL workbench. Now let me just refresh the schemas. Alright, so let me just minimize this and I'll move ahead by creating a table under the database. So I think you guys are pretty clear with the concepts which I explained just now. I basically started off by creating or by establishing a connection between our Python and MySQL DB server. Further, I moved on and created a database, and now I am moving on and creating a table under the database HarshDB. Now how do I do that? Well, let me create a new file first. 1 second, I'll name it as create tb and python. Alright guys, before moving ahead, I'm going to tell you one thing. The first 3 or 4 lines of code are going to be same everywhere. I don't find it useful by repeating the same first 3 lines of code everywhere again and again. I don't want to bore you guys with the same thing. So let me just copy paste it into the presentation mode. Yeah, Control V. Now I'm going to write myCursor.execute. It's going to be create table. Suppose I give my table's name as employee, under which let me pass 2 parameters. They'll be name varchar 200, salary integer 20. We just close it, move on, execute this code. Well, I have done a very silly mistake guys, and the error is also very self-explanatory. It says no database selected. I'm going to pass a parameter over here. It's going to be database is equals to HarshDB, and let me quickly move ahead and run this code. 1 second. Yeah, Alright, so when I run this code, our table has been created. Now I'm going to show you the table which I've just created in our database HarshDB. So I'm going to write the same code what I wrote while I was showing you the database. So let me just omit these things and add an S over here. And instead of create, let me just add a show. And let me type a for loop. So it will be for tb in my cursor print your table. Alright, now let me move ahead and run this code. So as you can see, we have created only one table under the database HarshDB. So it is showing that table, which is employee. Now I'll show you the table in our MySQL workbench. So 1 minute, guys. So instead of databases, let me just write tables. Let me just select the HarshDB thing over here. Instead of databases, let me just write tables, select HarshDB, and then execute this. Yeah, so once I execute this, well, as you can see, it is fetching the table, and our table employee has been created on the extreme left hand side under the schemas column. Now I'll quickly minimize this and I'll move ahead by doing the read operation. So before I dive deep into the read operation, guys, let me give you a small introduction about this. So our read operation will basically happen in two stages. In my first stage, I'm going to populate my table with some values. And in my second stage, which will be the main stage where I'm going to do the read operation consisting of two fetch functions. So I'm going to talk about the fetch functions later. First, let me just, in order to populate my table, I'm going to make use of insert command from the SQL query. So let me just name it as insert op table and move ahead. Yeah, Control V. Before, there's one more parameter which I left. It's going to be database is equals to HarshDB. Now moving on, let me create a new variable with the name as SQL form, and under SQL form I'm going to write the SQL query insert into employee. 1 second, guys. Pass in the two parameters which I declared, which were name and salary, values, and make use of, or I'm going to write %s, comma, %s. Well, guys, these %s are nothing but placeholders. You can replace them anytime you want with any other value. Now I'm going to create a tuple. Now the reason why I'm creating a tuple is because, again, in my second stage where I'm doing the read operations, I'm going to make use of two fetch functions. So there's one fetch function called fetchAll. So when I'm making use of fetchAll, I need not populate my table with a single value because that will not look good. That's the reason why I'm creating a tuple over here, so that to give you more clarity into what actually happens. Now, let me just name it as Harshit. Let me give my salary as 20,000, comma, Amit, salary as 30,000, comma, Ankita, and her salary as 40,000, comma, space. Yep, I think I need to put this back. Yeah. Now when I move on, I'm going to simply write my cursor dot execute many, because if I use execute, it is just going to execute a single value. But since I'm making use of a tuple over here, I need to write my cursor dot execute many and call in SQL form, comma, employees. And finally, I'm going to write my db dot commit, which is going to save my changes from my last executed SQL statement. Now let me quickly move ahead and run this code. So as you can see, our insert operation has taken place and our tuple has been inserted into the table employee under the database HarshDB. Now, I'll quickly exit the presentation mode and show you the same in our MySQL workbench. It's going to be the same thing. I'm going to write select star from employee and click on employee, click on execute. 1 second, guys. Yeah, I'll click on the result grid over here. Well, guys, as you can see, this select star from HarshDB.employee, well, it changes nothing. Our concern is to basically view the tuple which we have created, and that tuple is being viewed in the result grid. That is under name and salary, the values which we pass, that are Harshit, Amit, Ankita, with the salary as 20, 30, and 40,000. Let me quickly minimize this, and moving ahead, I'll be creating a new file and let me just name this file as readop table. Alright, now into the presentation mode once again, copy the first 3 lines of code over here. What I'm going to do is, let me pass the parameter database, which is equals to HarshDB, and then I'm going to start off my read operation by the first function, that is fetch one. So let me write my code, and then side by side I'm going to explain you also why am I writing that part. So I'm going to simply write my cursor.execute. Let's say I'm going to write a SQL query, that is select name column from employee. Okay, this is a very simple SQL query, and let me create a new variable and let me name it as my result. Under my result, I'm going to write my cursor dot fetch one. Now guys, this is one of the most important part of my code because this is the first function of read operation. What fetch one is going to do is it is going to fetch me one value from the column name under the employee table. Alright, now when I move on, let me write the for loop, that is for row in my result, print the row, and when I run this code, as you can see, it has fetched the value Harshit from the row name under the table employee, which is again under the database HarshDB. As you can see, this code is pretty self-explanatory. When I make use of the fetch one function, it basically fetches a single value from the column name under the table employee. Now, let me just quickly move on with my next function of fetch. In order to do that, let me just make few changes in this code. So instead of name, suppose I'm going to fetch the whole tuple. It's going to be select star from employee. And instead of fetch one, let me write here fetch all. And let me run the for loop. So it will be for row in my result, print row. Alright, now when I run this code, I'll explain you why am I doing it or what does fetch all do. Well, as you can see from the output, the whole tuple has been fetched. Now when I make use of the fetch all function, guys, it basically fetches the whole tuple for us, as because we are writing the SQL query select star from employee. So all the values which are there in the employee table, which was in the form of a tuple when we inserted it a while ago while we were writing the insert code, that whole tuple gets fetched. Now I'll exit the presentation mode. I'll go to the MySQL workbench and rerun this code once again. Well, as you can see, there are no differences. The name is still there with the values Harshit, Amit, Ankita, and salary 20,000, 30,000, and 40,000. Suppose I write this thing, select name from employee. One second. I'm going to show you the changes of the fetch one functions. In order to do that, let me just write name again over here, name, and instead of fetch all, let me write fetch one. Alright, let me quickly go ahead and run this code. So as you can see, it is fetching here. Now I'll go to the MySQL workbench and click on same thing. Well guys, these changes are not taking place over here because we were showing you the changes in the PyCharm, and since we applied a for loop over there, that's the reason why it is doing it. But since when we are using the backend database server, we need not do that because we are not using any loop or we are not doing anything. We are simply fetching the name whole column from the table employee. Now I'll move on and do the update operation. So in order to do that, let me just create a new file, a new Python file, and name this as update pop table. Let me close this. Let me just click on this, enter presentation mode. Control V. Let me pass the parameter, which was database, that is equals to HarshDB. Moving on, let me create a new variable with the name as SQL, under which I'm going to write update employee set salary. Let me set the salary to 70,000, making use of the where clause, where name is equals to, let's say I'm updating Ankita's salary to 70,000. And finally I'm going to write my cursor dot execute, call in the SQL thing, and then write mydb dot commit. You quickly go ahead and run this code. Our update operation has taken place, and in order to see the changes, let me quickly go back to the read operation. I'll show you the changes on both places, in the PyCharm and MySQL Workbench too. So the last code which I wrote, let me remove this and right here select star from employee. This was fetch all. Okay, enter the presentation mode once again. Yeah, run this code. As you can see from the output, the changes have taken place and Ankita's salary is updated to 70,000, which was 40,000 before. I'll quickly move on and show the same changes in the MySQL Workbench. So it's quite easy. Let me just rerun this code. This should be star over here. Yep, and then execute it. As you can see, Ankita's salary over here is again updated to 70,000. Now I'll move on and do the last operation, that is delete operation, which will also conclude my tutorial. It's going to be delete op, let me name it as table. Alright, enter the presentation mode once again. Copy the first 3 lines of code. I'll pass here the database parameter. Database is equals to HarshDB. I'll move on and let me make use of the same variable which we used that time. Say suppose delete from employee where name is equals to, suppose I'm deleting my record guys, which is Harshit, and then my cursor dot execute all in SQL and then write mydb dot commit, which is gonna save the changes from my last executed SQL statement. Let me quickly go ahead and run this code. Well, the database spelling which I use is wrong, I guess. Well, as you can see from the error, it's quite justified. It says unsupported argument database. So the database spelling is wrong. Let me quickly rectify that. 1 second, guys. Yeah, I'm gonna write A over here. I missed it. My bad. And run this code once again. So as you can see, our delete operation has taken place, and I'm going to show you the changes. Exit this. We'll go to read op. I'll enter the presentation mode once again. Run this code. Well, as you can see, the record Harshit has been deleted from here, and the same thing would be, or the same changes would have taken place in the MySQL Workbench. Let me quickly open it and run this code once again. Well, as you can see, the record Harshit is deleted from here too.
What are frameworks in Python? Python is a general purpose programming language. It is one of the most popular programming language nowadays. We can use it for so many applications, including web development. Now, a framework is a collection of modules or packages which helps in writing web applications, or it helps in web development. Now, we don't have to worry about the low-level details such as protocol, sockets, or thread management when we are working with a framework. Frameworks make the developer's life easier by giving them a structure for app development. They automate the implementation of common solutions, which gives the flexibility to the developer to focus only on the application logic instead of the routine processes. They provide common patterns for faster, reliable, scalable, and easily maintainable web applications. Now let's take a look at a few operations that are used to run web applications using frameworks. So I have listed down all the operations here. So first of all, we will talk about URL routing. So URL routing is the mechanism of mapping the URL directly to the code that creates the web page. The next one is the input form handling and validation. Coming on to the next operation is output formats with templating engine. Now you must be wondering what a templating engine is. A template engine allows developers to generate a desired content types, for example HTML, XML, or JSON. We also have the data connection configuration and persistent data manipulation through an ORM. ORM is also known as Object Relational Mapper. Now you must be wondering what is the function of an ORM. An Object Relational Mapper or an ORM is a code library that automates the transfer of data stored in a relational database table into the objects that are most commonly used in an application code. We also have the web security against cross-site request forgery, also known as CSRF, SQL injection, cross-site scripting, and other common malicious attacks as well. The last but not the least is the session storage and retrieval. So these are only a few operations we can perform using the frameworks in Python. Now let's try to look at a few advantages of Python frameworks. First of all, Python frameworks are open source, which means you don't have to spend any money while working on a Python framework. The next one is it has a very good documentation. All the frameworks in Python have a very good documentation, which means you can learn easily the functionalities and the key features of any framework using the good documentation that it has. The next one is the security, where it provides security against the malicious attacks, and then there is integration and efficiency as well. So these are the advantages of using a Python framework for web development. Also, there are a few limitations when we are working on a Python framework, which is it is open source, so the code is going to be public. So that is one issue here. Also, there are a few limitations when we are using a framework, because the difference between a library and a framework is it adds to a few rules and regulations when it comes to a framework. Now let's try to understand why we are using a framework. Now we know that frameworks make it easier to reuse the code for common HTTP operations and to structure projects so other developers with the knowledge of the framework can easily build and quickly maintain the application. So these are the advantages, which is why we are using a Python framework. That is easier implementation, we have the maintenance, and the readability is pretty good, and then there is code reusability as well. So these are the reasons why we are using Python framework instead of a library, right? So now that we have understood what are frameworks and why we are using them in Python, and also we have discussed the key features and advantages of Python frameworks, now let's try to look at the top 5 frameworks that we have in Python. So first of all, let me talk about Django, guys. Django is a free, open source, and a full stack Python framework which includes all the necessary features by default. It follows the dry principle, which says don't repeat yourselves. Also, Django uses ORM to map objects to the database tables. Some of the exemplary features of Django are authentication, URL routing, template engine, and the ORM. Also, there is database schema migrations as well. Now, the main databases that Django works with are PostgreSQL, MySQL, SQLite, and Oracle. Also, it follows the MVC-MVT architecture. So let's try to understand what is an MVC-MVT architecture. The model view template, or MVT, is slightly different from MVC, which is the model view controller. In fact, the main difference between the two is that Django takes care of the controller part itself. The controller part is basically the software code that controls the interactions between the model and the view, leaving us with the template. Now, the template is a HTML file mixed with the Django template language. Now, looking at the diagram, we can understand that the developer provides the model, the view, and the template, and then just maps it to a URL, and Django does the magic to serve it to the user. So this is the MVC-MVT architecture, guys, and this is all about Django. Now let's try to understand the next framework that we have, which is actually Web2Py. Web2Py is a scalable, open source, and a full stack Python framework. However, you should know that it does not support Python 3. Now, what is so great about Web2Py, right? It comes with its own web-based IDE, and among other things includes a separate code editor, a debugger, and one-click deployment as well. Now, looking at the other valuable Web2Py features, it includes no requirement for installation and configuration. It has the ability to run on different platforms. It has the ability to read multiple protocols. It also provides us with data security that prevents such vulnerabilities like cross-site scripting, injection flaws, and malicious file execution. It also has an error tracking system through error logging and ticketing systems. Also, it has the ability for role-based access control. And last but not the least, it has a backward compatibility that ensures user-oriented advancement without the need to lose the ties with earlier versions. So this is all about Web2Py, guys. These are all the features that we have in Web2Py framework. Now let's talk about the next framework that we have, which is Flask framework. So talking about Flask, Flask is a micro framework, guys. Now the difference between the full stack framework and a micro framework is the full stack framework does the heavy lifting for the application that we are making, but the micro framework is small and very easy to use. Also, when we are using the micro framework, the URL routing is going to be RESTful for many of the occasions. So this is the basic difference between a full stack and a micro framework, guys. Now let's try to look at the features of the Flask framework. So I've already told you it is a micro framework. It is lightweight and it has a modular design which makes it easily adaptable to developers' needs. It also includes a number of useful out-of-the-box features which include a built-in development server and a fast debugger. It also has an integrated support for unit testing and the RESTful request dispatching. One more thing guys, Flask supports the Jinja 2 templating. Now you must be wondering what is a Jinja 2 templating, right? So Jinja 2 templating is nothing but a modern day templating language made after the Django's template language. Coming on to the next features, we have a Flask. It has secure cookie support, that is the client-side sessions. Then we have WSGI compliance as well, which is the web server gateway interface. Now you must be wondering what is WSGI guys. It actually implements the web server side of the WSGI interface for running the Python applications that we are making. Now Flask is also Unicode based and also has the ability to plug in any ORM. Last but not the least, we have the HTTP request handling as well. So these are all the key features of Flask framework guys. Now that we are done with Flask, now let's move on to the next framework that we have, which is Bottle. Talking about Bottle, Bottle is also a micro framework guys. Originally it was meant for building APIs. Bottle implements everything in a single source file. It has no dependencies apart from the Python standard library. Now its default features include routing, templating, utilities, and a basic abstraction over the WSGI standard. Bottle is a perfect solution for prototyping, learning the organization of web frameworks, and building simple personal apps. So these are the features of Bottle framework, which is also a micro framework guys, just like Flask. So now that we are done with the key features of Bottle, let's take a look at the next framework that we have, which is CherryPy. CherryPy is an open source minimalist web framework. It makes building Python web applications no different than building any other object-oriented program. It allows you to use any type of technology for templating, data access, and so on. However, it's still able to handle sessions, statics, cookies, file uploads, and everything else that a web framework typically can. Now let's try to take a look at some default features of CherryPy. It has an HTTP compliant WSGI thread pooled web server. It has the simplicity of running multiple HTTP servers at once. It also has a powerful configuration system, a flexible plugin system. It also has out-of-the-box tools for caching, encoding, sessions, authentication, static content, etc. Now CherryPy also has a built-in support for profiling, coverage, and testing. And last but not the least, it also has the ability to run on different platforms. So this is all about CherryPy guys. Now that we are done with the top 5 frameworks and we have discussed the key features of all these frameworks, let me take you to PyCharm guys, where I have a sample project that I have made on Django and Flask. So this is actually where my project is saved guys. So I'll go to my project, and this manage.py file is actually the file which helps with the management of the site, and we can start a web server without installing anything else. So I'll copy this path guys, and I'll go to the project that I made over here. And if you want to know how you can make a project or install Django on your system and then make a web app, you can simply go to the Edureka YouTube channel, where we have the detailed tutorial about Django, in which we have a detailed tutorial about Django web development, and where you can actually learn to build a simple app from scratch. So what I'll do is I'll just write the path that I have copied. So now that I'm in my directory where I want to run my server, I'll just write python.manage.py to run my server. I'll just write run server. Now you have to pay a little attention to these files that you get while creating your project in Django. So these files are there. So settings.py file actually has the configuration of your website, and url.py have the list of patterns that will be used by the URL solver. And then you have the database, the time zones, and everything else that you can actually edit in your settings.py file. So I'm not going to go line by line explaining everything. So I'll just explain you that I have one more directory polls over here, which is actually my app. And in this I have migrations and the template. Inside the template I have the HTML file where I have actually written the code of my survey form that I have made, that I will show you guys. So when I run this server, what is going to happen is I'll get address. Wait, let it run. So I'm getting this address guys. So when I go on this address and write polls, that is the name of my app, I will get this survey form that I have made and stored inside the template that I had made. So this is actually a very basic survey form that you can make from using the Django app. So let me show you guys what the same thing you can do using Flask. So I have also made a project using Flask as well. So in this we have the main file, main.py. When you install Flask, you can simply import it, and there is no, I'll show you guys in the project interpreter. So inside in project interpreter, you can just add Flask over here. If you don't have installed it in your system, you will find it over here. You can install the package and you are good to go. So now that I have told you about the main.py, then we have a render template in which we are going to store the HTML file, the template that we have. Inside this, I have also written the same code for the survey form. And to run this server, we are just going to run this main file, and you will get an address, see over here. And when you go over here and type the name of your app, that is profile, you will get the same survey form that I had got. So this is a sample project, guys, that you can make for practice. Although it is a very basic thing that you can do, you can connect it to your database, and there are so many things that you can do while using these projects. So this is only a very basic project that I have done using this.
Why Python is used for web development? Guys, Python allows you to build web applications dynamically. It's a very stable language. It also grants you ease to build multi-protocol network applications. The fact of Python being flexible, easy to use, and its quick processing are just a few reasons to mention for its worth in web development. Now that I've explained about the features of Python, let's take a walk through some of the libraries that Python provides for web development. Guys, Python provides a number of libraries for web development. Some of the important ones are CherryPy, Django, Web2Py, Pyramid, TurboGears, and Flask. Among these, in today's session, I'll be using the Django framework. So now y'all might be wondering why Django and why not any other library. Django is truly the best Python library for web development. It's written purely in Python and it's fast. You can create websites within a matter of few hours. It's fully loaded with all the required tools to create websites, and it's very secure. Be it YouTube, your Dropbox, Google, or Instagram. All these internet giants rely on Django. So with this, I think I've given you enough for why I've chosen Django over the other libraries. So as you can see over here, web project has been created within the current directory. So after this, I'll just open up the terminal. And over here, I'll use the command pip install Django. It's going to take a while to install Django, guys. So when you're installing Django, along with Django, the SQL parse database and the pytz module also gets installed. SQL parse is actually a non-validating SQL parser for Python. It provides support for parsing, splitting, and formatting SQL statements. Now this is actually compatible with the versions of Python from 2.7. The pytz module is actually a third-party module that brings the Olsen TZ database into Python. TZ actually stands for time zone, guys. This library allows accurate and cross-platform time zone calculations using Python 2.4 or higher. It also solves the issue of ambiguous times. Okay, so once Django has been installed, it will throw a message saying successfully installed Django with its version and the version of the pytz module and the SQL parse. Now to cross-check the installation of Django, go to your command prompt and use the command python -m Django -- version. Now when you use this command, it should return the version of Django that's been installed. So I hope everyone's getting the same. Okay, so now let's close this. I hope everyone's clear with this. For any doubts, guys, please do let me know in the chat box because my team is always here to help you. So now to create a Django project, within this project, I'll use the command Django -admin start project, and I'll give a name to my project. Let me give the name as demo project. Okay, so now a demo project has been created within the web project directory. Let me open this directory, and here it shows the web project that's been created. Let me just go to the presentation mode and show you all. I'll go to view and I'll select the files that I want and the terminal. As you can see over here, within the demo project directory, there's another directory with the same name as my project, and there is a file created by Django called as the manage.py file. The manage.py file is actually a command line utility that lets you interact with the Django project. Don't worry guys, we'll be using this many a times, so you'll get familiar with this. Now let me just open this directory and see what's present within it. The first file that's created within this directory is the init.py. Now the init.py is actually an empty directory which is considered to be a package. After that, there is something called as the settings.py. This actually consists of all the settings that are necessary for the current project. After that, it's urls.py. urls.py consists of all the URL declarations for this project. And finally, the wsgi.py file, where WSGI stands for Web Server Gateway Interface. Now this is actually a calling convention, guys, for web servers to forward requests to web applications or other servers. So I hope everyone's clear until here. If you have any doubts, do let me know in the chat box. Okay, so now to check if I'm able to connect from my project to the web server, I'll just get into my project using the cd command. And after this, I'll use python manage.py run server. Like I told you, the manage.py file will help me connect to the server. So this will return an IP address. So when you click on that address, you will see a screen with a rocket which is ready to take off. So congratulations guys, your rocket is ready to move on, which means you're all set to create your own websites. So I know that after this, everyone would be excited to create their own websites. To do so, I'll just get back to my PyCharm and show you guys what exactly you must do to create your own websites. Okay, so to create my website, all I'm going to do is create an app within my demo project. I'll just return the control to my terminal using Ctrl+C, and over here, I'll create a new app within my project. Please make a note guys that one project can have n number of apps, which means you can include any number of apps within your project. To create an app, I'll use the same command which is python manage.py, and instead of run server, I'll use the start app command and I'll give a name to my app. Let me just give the name as demo app. So now an app has been created within my project. Let me just open this up to show you all what's present within this demo app. So just like how Django had created files for us within our project, when we created a new app, Django has created the necessary files for us. So this is what Django does. It writes all the necessary code, and all you have to do is write your website specific codes and just modify the files that are present and add your own files as per your choice. The first file that I'm going to open over here is views.py. And as you can see over here, Django has already imported render for me. Now I want to use the HTTP response function. So I'll use from django.http import HTTP response. Please be careful with your spellings, guys. Now within this file, I'll create a new function using the def keyword, and I'll give the name of the function as hi. To this function, I'll pass one parameter which is request. Within this function, I'll just write one return statement using the HTTP response function. I actually want this function to return a message saying that this is the homepage of my website. I'll just put it as a string and I'll use the h1 tag for this. This is my homepage. And I'll close the h1 tag /h1. So as you can see over here, PyCharm has highlighted this line because I'm using the HTTP response function. The first line of my code is not highlighted because I'm not using the render function anywhere. As of now, I'll not be using the render function. However, I'll be showing y'all how to use this later on. Okay, now I've created views for my project, but I will not be able to connect this file to the urls.py which is present in the demo app. To connect views.py to this urls.py, I'll have to create another urls.py within the demo app directory and connect that urls.py to the urls.py which is present in the demo project. Don't get confused, guys. I'll be doing it over here, and the video will be available after this. In case you have any doubts, you can go through it again. So I'll just create a new file within this app. It's going to be a Python file. I'll give the name as urls.py. And I'll say OK. This urls.py is actually very similar to the urls.py which is present in the demo project. So I'll open the urls.py present in the demo project directory. And I'll copy the from statement, which is from django.urls import path and the URL pattern list. I'll just copy this and I'll go to urls.py present in my app and I'll paste it over here. Now over here, since I want to map the views.py into this urls.py, what I'm going to do is use from dot, which means from the current directory, import views. And within the URLs pattern, I do not want this admin path, so I'll just remove this. And I'll leave the name as blank because I want this to be mapped to my home page. And over here, I'll use views.high, which is the name of my function. And I'll give a name to this path. You can give any name of your choice. Let me just give the name as homepage, home-page. Okay. So after this, what I have to do is map this urls.py to the urls.py which is present in the demo app. So I'll open the urls.py present in the demo app, and over here I'll create a new path and I'll give an empty string because I want it to be mapped to my home page like I already told y'all. Sorry guys, I'll have to import the include function also. So from django.urls, I'll import the include function. And over here, I'm going to use the include function. I'll map the urls.py present in my demo app. And I'll close this. So after this, let me just go to my terminal and use python manage.py run server. I've just made a name mistake. This is demo app. Okay. So as you can see over here, it has returned the IP address again. I'll click on this IP address. Congratulations guys. Instead of that rocket which we were seeing previously, which was the default page, my website is displaying whatever I want it to display. So this was the message I wanted to display on my home page, and it shows that this is my home page. So now I'll get back to my PyCharm and I'll see how I can modify this page to create a website. I'll return the control back to my terminal using Ctrl+C. So to write HTML code within this project, all you have to do is create a new directory within your app directory. And that will be the templates directory. Now these will be the templates that are specific to this project. And instead of looking elsewhere, Django will look into this directory for the necessary templates. Within the templates directory, I'll create a new directory with the same name as my app. Don't get confused with this guys. This is actually the Django convention which helps you write project specific code. So within this demo app, I want to write the HTML code. So I'll create a new HTML file to write all the HTML code that I want. I'll just give the name as hi.html and I'll say OK. So as you can see over here, Django has already written the minimum HTML code for me. I'll just change the title to Edureka guys. You can give any title of your choice. And within the body, I'll just write hi. And after this, I'll open the apps.py file. I'll copy the name of this class. And then go to settings.py present in my demo project. And over here, I'll look for installed apps. Remember that whenever you create new apps, you'll have to add it over here. Then within a string, give the name of the app, which is demo app. Please be very careful with the spellings because if you make any mistakes, it's going to throw a lot of errors and you'll not be able to understand why it's throwing such errors. And for beginners, it sometimes gets very confusing to debug these errors. So just be careful over there. So let me get back to this. Name of my app, which is demo app, dot apps, dot the name of the class that we've copied from there. I'll just paste it over here. And I'll specify a comma after this. Now from here, I'll go back to my views.py file. And instead of this HTTP response, I'll be using the render function. So I'll just remove this. I'll return render. And I'll specify the request function. And then within a string, I'll specify the HTML file which is present in the demo app. So demo app / hi.html, which is the name of my file. Guys, please write the same name which you have given to your file. I'll run my server again after this. So python manage.py run server. Let's go back to our server and see what happens. So as you can see over here, guys, the title has changed from the default address to Edureka. And my homepage now shows a message saying hi. So I hope everyone's clear with everything until now. Now all I'm going to do is go back to my HTML file and do some modifications to create my own website. So now to create my own website, I'm just going to modify this HTML page. Guys, if you're done till here, you've been successful in creating a website. Now all you have to do after this is specify your project specific HTML code. Let me just show you a few basic things that you can do using HTML over here. So I hope everyone knows some basics of HTML. Let me just change the message from hi to welcome to Edureka. Okay, I'll just specify the second line of my page to be some h2 tag and a new message saying that this is my website. Let me save this and rerun my server. I'll just go back to my server and I'll reload the page. So as you can see over here, the h1 tag says welcome to Edureka and the second h2 tag says this is my website. So this is how you can write your own HTML code to your program, guys. So now let me create some list over here. To create a list, I can either specify it to be an ordered list or an unordered list. For ordered list, I'll have to use OL tag, and for unordered list, I'll have to use the UL tag. Over here, I'll be using the unordered list, and within this list, I'll specify the list elements. First element is Python, and the second element I'll give as Java or something. Okay, let me save this, go back to my server and reload this page. So as you can see over here, guys, it has created an unordered list over here. So now let me show you all how to create a table over here. So to create a table for your website, you can use the table tag and specify whatever style you want for your table. In my case, I'll just give the width to be 30% and I'll close this. So within the table, you can have the TR, the TH and the TD tags. The TR tag is actually for the table rows, TH is for table headings and TD is for the table columns. I'll just write a TR tag over here and within this TR tag, I'll specify the TH tags. Let me just give the heading as Python and I'll give another heading as Java. So after this, I'll create another row using the TR tag. And within this, I'll specify the columns. So for that, I'll use the TD tag. And I'll just specify which IDE you can use for Python and Java. So for Python, you can use PyCharm. Let me just copy this. And for Java, you can use Eclipse. So I'll change the name from PyCharm to Eclipse over here. And I'll save this. So as you can see over here, a table has been created. But guys, my table over here does not have any borders. To add borders to my table, I'll go back to my HTML page. And over here, within head, I'm going to use the style tag. And within this tag, I'll specify what border I want for my table. Let me save this and reload my page. So as you can see over here, guys, I included the style tag and specified what kind of border I want. So the same way on my server over here, a table has been created with a specified style. To know more about HTML and learn how to create beautiful websites, you can just go to the Bootstrap website. And from here, you can take any code that you want for your website. So I'll just show you what happens when you use this. So let me just use the style from the Bootstrap, and it should be present within the head. So I'll just paste it over here. Let me save this. I'll go back to my server and I'll reload this page. As you can see over here, guys, using the small bit of code that was present on the Bootstrap website, my website looks so much more better than what it was looking before this. You can use this Bootstrap website to create your own beautiful website.
Choosing the right programming language is crucial in web development, as it influences the efficiency, scalability, and success of your project. Each language has its own strength and is suited for different aspects of web development. Let's dive into the unique roles and advantages of Python and JavaScript in this field. So let us first have a look on the overview of Python and JavaScript. So, Python is a widely used programming language known for its simplicity and readability. It's a go-to choice for many developers due to its ease of learning and extensive libraries. In web development, Python plays a key role in backend development. Frameworks like Django and Flask make it easy to build secure, flexible, and efficient web applications. Django follows the batteries included approach, providing inbuilt features like admin panel, an authentication system, and ORM for database management. It's ideal for large, full-fledged web applications. Flask, on the other hand, is lightweight and flexible, allowing the developers to build web applications with more customization and control. So Python finds widespread use in API development, automation, and the integration of AI and machine learning into web applications. Its extensive libraries and strong community support make it a powerful choice for modern web development. But Python isn't the only player in web development. Another major language that dominates in web is JavaScript. JavaScript is the backbone of web development, playing a crucial role in both front-end and the back-end development. Unlike Python, which is mostly used for back-end tasks, JavaScript is a full-stack language, meaning it powers both client-side and the server-side web applications. So on the front end, JavaScript works with HTML, CSS, and creates the interactive and dynamic web pages. Popular libraries and frameworks like React.js, Vue, and Angular make building modern UI components easier. On the backend, JavaScript with Node.js allows developers to handle server-side operations efficiently. Express.js is a popular backend framework, simplifies API development and server management. Since JavaScript runs directly into the browser and on the server, it offers seamless development, making it preferred choice for building real-time applications like chatbot, online gaming, and streaming services. With its vast ecosystem, cross-platform capabilities, and asynchronous programming features, JavaScript remains an essential language for full-stack web development. So now that we have discussed how Python and JavaScript contribute to web development, let's explore their roles, starting with front-end development. So front-end development is all about user-facing side of web application. It includes everything user interacts with, like buttons, forms, animations, layouts, and overall UI/UX design. The goal is to create smooth, engaging, and responsive experience for the visitors. So now let's see JavaScript in front-end development. JavaScript is the foundation of front-end development. It enables the client-side scripting, which means it runs directly into the browser to handle user interaction and dynamic content updates. Unlike the static web pages, JavaScript allows the developers to build highly interactive and responsive websites. So popular JavaScript frameworks like React.js, Angular, and Vue makes it even easier to create modern web applications. These frameworks offer reusable components, better state management, and optimized performance, making front-end more efficient. JavaScript also works seamlessly with HTML and CSS, allowing the developers to manipulate the document object model in real time. This enables features like form validation, live search suggestions, and interactive animations. So that's it about JavaScript in front-end development. Now let's move on to Python in front-end development. So Python is not commonly used for front-end development. Since web browser only understands JavaScript, Python code cannot be executed directly into the user's browser. However, there are some workarounds. PyJS, Python to JavaScript compiler, converts Python code into JavaScript, enabling the front-end-like functionalities. And the next one is Python, the browser's Python, a Python implementation that runs in the browser, offering an alternative way to write web applications in Python. So now that we have covered front-end development, let's move on to the back-end development. So back-end development focuses on handling data, authentication, and server logic. It ensures that the user requests such as logging in, submitting forms, and retrieving data are processed correctly. The backend communicates with the databases, manages API, and ensures secure and efficient data flow. So now first let us see Python in backend development. Python is widely used language for backend development due to its simplicity, readability, and extensive libraries. It is known for Django and Flask frameworks. These make backend development faster and more efficient by providing built-in tools. The next one is database management. Python integrates well with the databases like PostgreSQL, MySQL, and MongoDB, making it easy to store and retrieve the user's data. And the last one is API development. Python frameworks allows the developers to create RESTful APIs to connect front-end applications with the databases and other services. Now that's it for the Python in backend development. Let's move on to JavaScript in backend development. So JavaScript, a traditionally front-end language, has become more powerful backend tool with the rise of Node.js. And the key aspects includes first, Node.js runtime. Node.js runtime enables JavaScript to run on the server, allowing the full-stack development with a single language. The next one is Express.js framework, a lightweight and fast framework used to build scalable web applications and REST APIs. The next one is non-blocking architecture. Node.js handles multiple requests efficiently, making it ideal for real-time applications like chat apps and live notifications. So now that we understand Python and JavaScript role in web development, let's explore their real-world example where they are most commonly used. So first, let us see the Python use cases. The first one we have is backend development. So it is used with frameworks like Django and Flask to build scalable web applications. And the next one is API development, ideal for creating RESTful and GraphQL APIs for web services. The next one we have is AI and data-driven web apps. It powers machine learning-based web applications such as recommendation engines and fraud detection systems. And the next one is web automation and scripting. It automates the repetitive tasks like web scraping, testing, and data extraction. The next one we have is content management system. It is used in platforms like Wagtail and Blown for dynamic website content management. So that's it for the Python use cases. Now let's move on to the JavaScript use cases. So the first one is front-end development. It is essential for building interactive UIs using frameworks like React, Angular, and Vue. The next one is full-stack development. It enables full-stack development with Node.js, handling both front-end and the back-end. The next one is real-time application. It powers chatbots, gaming platforms, and live notifications using WebSockets. The next one we have is single-page applications. It ensures smooth, fast-loading web apps without page reloads. And the next one is progressive web apps. It helps to create web apps that work offline and feel like a native mobile app. So now that we have explored the use cases, let's quickly summarize the pros and cons of Python and JavaScript when it comes to web development. So first we will cover the Python pros and cons. So let's focus on the pros first. So the first one is easy to learn and readable. So Python's simple syntax makes it beginner friendly. The next one is powerful backend development. So frameworks like Django and Flask streamlines the backend workflows. The next one that we have is great for AI and data-driven web apps. It seamlessly integrates with the machine learning and data science tools. So the next one that we have is strong security. It is often preferred for secure applications like fintech and healthcare platforms. Now let's move on to the cons of Python. So the first one is not ideal for front-end. Python is not natively supported by the browser. The next one is slower execution speed. Compared to JavaScript, Python can be slower for web applications that require real-time interaction. The next one is limited full-stack capabilities. Unlike JavaScript, Python lacks direct front-end counterpart, making it less flexible for full stack development. The next one is fewer front-end libraries. Python has limited front-end focused libraries compared to JavaScript, which reduces its versatility for interactive UI development. So now that's it for the pros and cons of Python. Now let's move on to the pros and cons of JavaScript. So first, let us focus on the pros. The first one that we have is full stack development. That is, JavaScript can handle both front-end and the back-end with Node.js. The next one is highly interactive and fast. It powers the dynamic real-world web applications with frameworks like React and Vue. The next one is widespread industry adoption. It is used across almost every modern web application. The next one is large ecosystem and community. With extensive libraries and frameworks, it simplifies the development process. Now let's move on to the cons of JavaScript. First one is it can get complex. JavaScript's asynchronous nature and multiple frameworks can be challenging for the beginners. The next one is security risk. It is more vulnerable to attacks like cross-site scripting if not handled properly. The next one is heavy client-side processing. It can slow down the performance if it is not optimized properly. The next one that we have is browser capabilities issues. Different browsers may interpret JavaScript code differently, requiring additional testing and debugging. So which one would you choose? Well, it depends upon your project needs. If you are focusing on backend, automation or AI-driven web application, Python is a great choice. However, JavaScript is preferred for building interactive real-time web applications or working as a full-stack developer.
Now let me begin with the very first topic, that is the need of scraping, or why do people actually scrape a website. So scraping is basically extracting data from various websites. Now there are many ways to collect data online, but let's say I just want to collect data for comparison. So here let me take an example of My Smart Price, which is known for best price comparison. So what they do, they collect data directly from merchants. Now the larger stores generally provide the feeds which are listed on their stores. But what about the smaller stores? Now, one way of doing it is to either copy the prices from different websites and then paste it to your local system, which will in turn be a very tedious job and it will consume a lot of time as well. So what you can do, you can simply scrape the prices from different websites. Now, apart from these, there are many use cases, or you can say real life examples where people do scraping. So here first is your e-commerce portals. Now here what you can do, you can build your own website and then scrape products from retailer, or you can say manufacturing websites. So basically you can scrape prices, ratings, images or any other specifications as well. Then you have market research. So here scraping can help you in providing important information to identify, to analyze the market, to analyze the need, its size and the competition of market as well. Now it can be any kind of industry. It can be your travel areas, where you can scrape reviews, or you can scrape products, or any places, hotels, restaurant, or it can be anything. Then you have social media. So here people scrape business profiles from social networks and track their online presence and reputation. And hence the list goes on. So people generally use web scraping to build the best marketing strategies, monitor them and hence upgrade their business. So in a way, web scraping provides them a way to get information, whether it can be a website prices, it can be images, it can be data for any analyzing purpose as well. So also you do scraping because many websites do not provide an API, unlike Facebook, Twitter and all. But in many cases, you will find that web scraping is the only alternative to get data out of them. So we have discussed the various real life use cases which uses web scraping. But here the question is it actually legal? Well, maybe. Scraping is fine till you are not causing any considerable damage to the target website and you are doing it responsibly. So website is legal as long as there is no attempt to change the article or blog or anything. You should not try to override the restricted access of the website or play around with the security mechanism. Now let me tell you the companies who have faced problems while web scraping. So you all must have heard about LinkedIn. So in 2014, there was a case where they sued a group of dependents in California. Now this case was based on Digital Millennium Copyright Act, where they used a series of bots and fake profiles to scrape the data from other member profiles. So that is why you should always know the difference and respect the fine line between collecting information versus stealing it. So now let's understand what exactly is web scraping. Now, as I've already explained you the need, it will be very easy for you to understand this concept. So web scraping is a method where you pull data from different web pages, extract the useful information, and then store the same data to your local storage. Now this local storage can be in any form. It can be in XML form, it can be CSV, or it can be any database as well. So web scraping is a technique where you automate the procedure within a fraction of seconds instead of manually copying the data from websites. Now we know scraping is when you extract any information. Now if you want to extract through a browser or a website or a web page, so that process is known as a web scraping. So let us see the basic steps which are involved while scraping. So the very first step is document load. Now in our case we are doing web scraping, so we have to load the entire document, which is your HTML page. Next is your parsing. So parsing is basically where you interpret your document to make your searching possible. So in HTML, there is your DOM by which you interpret all the HTML code. Next is your extraction. So here you simply extract anything like the name, like the price, or any specification of the product. And the last is your transformation. So here it basically converts the data into useful formats. Like for example, you can change the type here. Now if you have a date string and you want the output as date, so you can transform it in any form. So these are the steps which are involved to do simple scraping. Now let us see what are the different packages that are used for web scraping. Although I would recommend Python because a lot of people use it for web scraping. Well, the good part about Python is that it has libraries for everything. Now this is why it is the go-to language for many developers. Now as you can see here, there are a lot of libraries which are used for web scraping, such as Pattern, Scrapy, Mechanize, Beautiful Soup, and Request. So I have only used scraping. I have only used Python for scraping because what I like about Python is that it makes a string manipulation very easy. So string manipulation basically is the key where you parse any information from a page. Along with this, it is also compatible with various databases such as your NoSQL databases like MongoDB, and MongoDB is what we mostly prefer to use for data storage in web scraping. Now as you can see, there are different Python packages. Now these are not enough. We also have some other Python libraries such as XPath, you have PDF, you have Miner, and many more. But here if you see, Beautiful Soup and Request are the most popular libraries in this lot, and later in the demo we'll be implementing them as well. So Beautiful Soup is a Python library which is used for pulling data out of your HTML and XML files. Now it provides you simple, in fact very simple ways of navigating, searching, and modifying the HTML and many more things like that. Next is your Request. So Request is a library which is widely used for sending and receiving information over HTTP. Well, that's all for the theory part. So now let me move on to a demo part where I'll be scraping a website from the scratch. Excuse me. So here we'll be scraping Flipkart. Now let's see what all we can scrape from it. So we all know Flipkart is an e-commerce company. So what I'll do first, I'll simply search a product on Flipkart. Let's say an iPhone. So here, as you can see, the list of all the iPhones will be displayed. Now what I do, I have to fetch the name of the iPhone, what are the configurations, what are the ratings, and what is the price of the iPhone. So fetching all these details, I need to first view the HTML page. Now how will I do it? I have to simply right click it and go to the inspect. So this will basically open up my HTML code. Now this is my HTML code. So to understand this HTML, let me open my PyCharm and let's understand each component one by one. So this is my PyCharm community, guys, and as you can see, this is the code for scraping Flipkart. Well, it is not that big code because Python makes it very easy. It has small syntaxes and it is very much similar to your English language as well. So what I have done in the beginning, I have simply imported two libraries which are Beautiful Soup and Request. So these libraries I have already discussed. So how you can import them? You can simply go to File, then go to your Settings, open your project interpreter, and here all your packages will be present. Now here, as you can see, we have Beautiful Soup 4. So we just click on that and just click OK. So these packages will be imported automatically. Now I have named my Beautiful Soup as soup and request as uRequest, because I don't want to use Beautiful Soup and request again and again. Next, also I have used URL-lib, which is a package. Now if you're using Python 2, you have a different package. You will be having URL-lib 2. Since I am using Python 3, so this will work for me. And then I have a function which is URL open. So this function will basically import all the dependencies. Next, what I've done, I've simply specified the URL which I have to scrape. So let me just copy this URL and let me show you what does this explain. Or in fact, if you don't want to copy it, just simply type in flipkart.com. You can search the product. Now in my case, it's iPhone. So as you can see, there is a list of iPhones are displayed. So here we have all the necessary details of it. We have the title, we have the ratings, we have the reviews, we have the price as well. So this is all the Flipkart page. Now let me go back to PyCharm and let's understand the code. So here what I have done, I have my uRequest, which will basically opens up the connection, and this will grab the web page or the Flipkart page in our case, and then it will directly load it. And then what I have done, I have simply saved it to a variable which is uClient. After that, what I have done, I have passed the same variable to the read function. So this read function will dump all your data which is gathered and then store the same in the variable which is page_html. And then I have closed the connection. Then what next I have to do? I have to parse my HTML because it's a large HTML file. So let me show you the HTML. Now to see HTML, you just have to right click, go on inspect. So here on the right hand side, you see your HTML code. Now if you move your cursor, you will see the left side, the pointer will be changing. So here if you want to see which part it is showing, you have this title, then if you go down you have the reviews and the ratings, and then if you'll go down, you have the content, or you can say the description, and after that you have the price. So what I have to do, I have to first search for the main class in which all these features are present. So if I go up, so this is my main class, or you can say the main div class, which covers all the element. It has title also, it has price also, it has ratings, reviews, and everything. So I'll just copy this class. I'll go back to my PyCharm. So here I have written this, pasted this, the same div class which is over here. So here I have page soup, which will help me to pass my HTML, and then I've used the function which is find all. So here it will find all the div tag which is a class. Now in some cases it may be ID also. So here we have div tag, which is a class, and the name of the div tag, and then I have stored it into containers. So next what I'll be doing, I'll be printing the length of these containers, which will basically tell me how many products that I have on this web page. So I'll comment the whole code for now. So here, as we see, there are 24 products on the very first page of Flipkart. So let me show you again. So here, as you can see, there are many products. Now using this length function, I have calculated that there are 24 products which are displayed on the very first page of Flipkart site. So this was for the one div class, or you say just one container. But let's say I have to fetch details of each product which is present on the web page. So what I have to do, I have to traverse the DOM elements. So first of all, I will first see the containers, or you can see the HTML code for the very first index. So here I'll be writing print soup.prettify containers and the first index. So prettify is a function which is used to beautify your HTML, or basically it will bring your HTML in a structured, or you can say an organized format. So let me just run this whole HTML. So here my HTML, so this is my basically HTML. Now what I'll do, I'll copy the whole HTML and I'll place it somewhere else. Let's say I'll place it in my notepad, so that we can see it simultaneously. Now let us try to read this HTML a bit. Now here first we'll figure out what things we need to scrape from here. So here the first thing that it is visible that we need a title of this. We need the title of the phone, which is Apple iPhone SE space gray, and it is 32 GB. Now this title is present inside a div tag, inside another div class, and then it has an image tag. Then let's see what else we can scrape from here. So here we have 4.5 rating. So this is the rating. So we can scrape this as well. And then moving on, we have the price as well. So these are three things that we can scrape. We have many more things, but for now we'll just be scraping these three things. So let me go back to my PyCharm and let's see what is the first thing that we'll be going to scrape. So here what I have done, I need a loop for traversing these elements. So for that I have stored the elements of containers in a variable called as container. So this containers is my main div class which has all the elements present. So now what I'll be doing, I'll be first printing the title, or you can say the product name. So for that, let me open my HTML. So here, as you can see in this container, I have a div class, and inside that div, we have another div, and inside that div, we have an image tag which has a title alt, and this is basically the attribute of it. So attributes are always written in the square brackets. So here, as you can see, I have print the container, and inside container there is div, and inside div we have image, and then we have a attribute which is alt. So let me just print this and let me see what does it display. So here we have the first name, or you can say the first phone, or you can say the first title of the phone. So this is my Apple iPhone SE space C that we have already seen in the HTML. Next, what I have to do, I'll scrape some other thing. Let me just comment this thing. So next I'll be scraping price. So let's see where this price is present. So here is my price. Now I have to see that in which div class this price is present. So in this div class which has the title this, so I'll just copy this and I'll go back to my code and I'll paste it over here. So this is the exact same div class which I'm talking. This. Now inside this I have container which find all the div which is a class, and then the name of the div class. Now here if you see I have print price 0.text. Now why text? Because as you can see here I have React ID, I have data React ID, then I have React text, then I have a rupee symbol, and we have many more tags, but this price is not enclosing any of the tags. So for that this becomes my text. Now similarly I have 21,000 as text, and I have 26,000, and all these things will become as text. So let me go back, and here I have print price 0, which is the first element, and then the text. So let me just print it for you. So as you can see, all the text has been displayed. So it says 21,000, which has some 19% off, and then it tells me the EMI option which starts from this price. So this is how I have fetched my price. Now what I have to do, I'll be printing ratings as well. So it will be the same procedure. First I'll just comment the price. And for ratings, let me again go back to my HTML and let's see where is my rating. So this is my rating. Now again I have to see which class it is present in. So this is present in this class. So I'll again copy this class. I'll go to my PyCharm. I'll paste this, and then I'll say rate container, which find all the div class, div tag, which is a class, and then the name of the class. Here also I've done the text, because if you go ahead and see HTML, you will see a lot of things. You have 4.5, then you have stars and all these things. So it will be very easy if you write text. So if I go ahead and run this program, so as you can see, 4.5 star 3, this rating and this reviews have been printed. Next, I have all the details like title, price, ratings. So let me just print them once again for you. So we have your title, we have price, and then we have ratings. So let me just print it together once more. So as you can see, I have the title, I have the price, and I have the ratings. So now what I have to do, this is showing in my terminal, but what if I want to show this in my file? So now I'll be creating a file. So I'll just again comment this, and here I'll be creating a file. So here I have created a file which is named as products.csv, and then using the open function I have instantiated a mode that is write, and then stored the same in f. So this f is a normal convention of fwriter. Then what I've done, I have created some headers to it. So because CSV do have headers, so I have added manually headings to it. So I have written product name, or you can say title, then the pricing, and then the ratings, and then I have simply write it. So I have these three things for one containers. Now I have to do the same for all the containers, or you can say all the div classes which is present on the web page. So for that I need a for loop. So what I'll do next, I'll create a loop. Now here it will say for container in containers. So containers is the main class where all your element is present, all your features are present. So here I want the same things. I need the product name, I need the price, and I need the rating. So here I'll just simply copy the same things which I have already showed you. So here for printing the title, I have written container.div.image and alt. So I have copied it here, and then I have saved it into a variable which is product name. Similarly for price. Similarly for price, I'll be copying this thing and this, and I'll be saving it to a variable which is price. And similarly for rating. So here if you see, I have added one more function, that is strip. So strip basically eliminates all your unnecessary commas or unnecessary spaces which are present on the website, because every time the spacing is not present. So in this case your extra spacing was there, so I have written this strip function. So let me now print all of these, and let's see whether my loops work or not. So as you can see, I have the title, price, and rating for all the products. So this is my first product name, then I have the price for the same, and then I have the rating. Next, I have the second product name, I have the price, and then I have the rating. So similarly, we have 24 products, ratings, and price for the same. Next, what you can do, let's say I don't want the entire price, or I don't just need the discount or EMI options that it provides. So what I can do, I can simply pass my string. So let me just again show you. So if you see here, I just don't need the whole price. I just need 44,999, but I don't need how much discount it has, how much EMI exchange it has, and everything like that. So for that you need to pass your string. So here if you see I have passed my string. I'll just remove the comments. So here I have first split my price. So for that I have used a function split, which will basically split my prices, and then I have again use the same function for the rupee symbol. So here as you can see, I have this rupee symbol, and in spite of this rupee symbol, I want to add RS. So here I have added rupees RS, and then I've added the same variable. Next, I have again split it with the E. Now why E? Because there are some features where it does not provide any discount. It just provides your EMI option. So here for that, just to look a bit clean, I have again split it with respect to E, and then the final price, or you can say the split price, has been saved in a variable which is final price. Similarly, I've done it for rating. So if you see the ratings as well, I have 4.5, I have ratings, and then this much reviews, but I just need 4.5. So again, I have split the string, and then I have stored the final rating in the variable which is final underscore rating. Now what I have to do, I have to concatenate all these three features. So I'll be concatenating the product name, my price, and the rating. So I'll be concatenating it with the comma operator. Now if you see here, now this I'll be storing in CSV as well. So you should keep in mind there should be no extra commas, because every time it finds a comma, it will create a new column for it. So if you look at it closely, you have product name is this, which has a comma as well. So rose gold, comma 32 GB. Now for that, if you want to eliminate this comma, what you have to do, you have to write replace function, which will basically replace your comma with a pipeline. And for final price and for rating, it is fine for me. So I will simply print these things, and let's see what it says. So this is my concatenated string. Since I have not removed the previous one, so let me just remove the previous one so that it will not confuse you. So let me just comment these, and I just want to show the final version, which is the concatenated string. So as you can see, I have the title of the phone, which is this, and then I have the pricing, and then I have the rating. Similarly, for all the 24 products, I have the same. Next, what I have to do, I have to put the same in my file also. So I'll use the function write, and I'll display the same. I'll just copy the same print statement over here, and then I'll close my file also. So we have already seen the output over here. Now let's see what this file display. So where this file will be created. So wherever your project is, you will directly go to that folder, and the file will be saved automatically. So it's in my D drive, it's then into Ayushi, and then in the web scraping, I have my products.csv. So let me go and click it. So here, as you can see, I have the product name, I have the pricing, and then I have the ratings. So this is what my CSV file looks like. Now let me go back again to code. So as you have seen, we have fetched all the details from the Flipkart website, and these details are automatically fetched and then stored in a CSV file, which is named as products.csv. This was the code that we have just discussed. So here we have scraped the prices, the title, and the ratings of Flipkart.
For the purpose of developing games in Python, we need the Pygame library, which is used to create games with attractive graphics, animation, and sounds, and also provides the same game experience across multiple platforms. And for this, we need a basic programming skill. Now we will see some of the key features of Pygame. First one, graphics, then events, sound and music, sprites, collision detection, and finally game loop. Today, in this session, we are developing a code for Snake game, where we are dividing it into 4 main parts. First one is a cube class, second one snake class, and then function, and finally main function. Now we will begin with the Pygame module installation. To install Pygame, just type pip install Pygame.
Hit the enter button. Now it is showing requirement already satisfied, which means I have already installed Pygame module. For those who have not yet installed Pygame, it will get installed in this. Then to view a Pygame is properly installed or not, just type pip show Pygame. Hit the enter button. It will show you the version of Pygame and summary details as well. Here you can see name Pygame and version 2.5.2 and summary Python game development and also some other details. Now for every game at least we need 3 modules. So first one is a Pygame window, second one event handling, and third one is main logic behind the game. Let's begin with the coding for Pygame window. Open your Visual Studio and take a new file. Let's begin with the coding. To import Pygame, just type it as import Pygame, and then to initialize Pygame.initialize, and then now we will declare a variable for screen which defines width and height. So for that, screen equals Pygame.display.setMode with a 400 as width and 500 as a height. Just save this file. Snakegame in Python. Okay. We are saving this file in the form of Python. Just click on save. Now let's run the code. Yes. Can you see the Pygame window screen which blinks for a second and goes off? So, to keep the screen on, we will write code now. Let's declare boolean variable and set it to false. Done equals false. Basically, we have 3 loops in Python, but for now, we are using while loop. To initialize the while loop, we are writing while not done. Now we will use the for loop for event handling in the form of for event in Pygame.event.get method. This will iterate over a list of events that have occurred, and also next if we have a current event as a quit, so which is triggered by the user. If that person is clicked on close window, so it has to close the Pygame window. So for that, if event.type equals Pygame.quit, then done true. This helps in exiting a main loop when a window is closed. And then Pygame.display.flip. This line of a code helps you Pygame window updating according to the code changes that you will make. Just save the code and run it once. Yeah, now you are able to see Pygame window. Just will minimize this. As you all know that the snake game is one of the popular simple game that we were supposed to play in our childhood days. That too on keypad phones. Yeah, your assumption is right. Now we are going to develop a same game. This is how it looks when I execute the code. I can play the game in Pygame window now. Basically, we are dividing the whole code into 4 main parts. That is first one cube class, snake class, function and main function. We'll just remove this code and we'll begin with the snake game. Guys, if you want to develop this kind of a game, please don't watch. Take up your laptops and start practicing with me, because just watching you can't get expertise in Python. So yeah, let's begin. First we will go through the cube class. In this class, we are going to declare a variable for background board, color and position as well. First we'll import all the modules which are needed. Import Pygame. Then we'll import math. Next import random, then import tkinter as tk, and then from tkinter import message box. Now we'll begin with the cube class. Let's declare class cube. Then we'll declare rows and width equals 500. Okay. Now we will define one instance for cube. Let's initialize. Define initialize start direction x equals 1, direction so next self dot position equals start and then self dot direction x equals 1, self dot direction y equals 0, and then self dot color equals the given color. So here start is the initial position of a cube, and next direction x and direction y are the default direction for the movement, and then color is the RGB color code for the cube. Now we will define the move method for the movement of snake in a cube's form. So we'll define move method first. Define move self in the form of direction x and direction y. Self dot direction in the x-axis equals direction in the x-axis itself, same as it is for direction y. Here, the move method updates the cube's position based on a provided direction. Either it may be an x-axis or a y-axis, which means direction towards x-axis and direction towards y-axis. The two attributes are updated and the position is adjusted accordingly. Next, we will define a draw method which is responsible for rendering the cube on a game surface. So for that, we'll define a draw method. Define draw surface ice equals false. Then this equals self dot w, which means width, divided by self dot rows, number of rows, I comma j equals self dot position with a 0, self dot position of 1. Now we will design eyes on a cube, where we can use this code snippet for a snake's head. So if eyes, then we are declaring center variable as center equals distance divided by 2, and then we are assigning radius value equals 3, and then circle middle and circle middle 2 are the shapes of eyes, and then we are drawing the circles on the cube surface. So this summarizes the functionality of cube class, which represents the individual segment of a snake in the game. And the next step is creating a snake class for the snake. Class snake object. Here we defined a class with the name snake that inherits from the object class, and then initializing a class variable as a body in a list form and turns as a dictionary form. Now we will initialize a new instance of a snake class with a color and initial position. So define initializing self color and then position, and then self.color equals color, and then self.head equals cube, position, and then self.body dot append, self.direction x-axis equals 0, and then self.direction y-axis equals 1. So here for the snake head we are using a cube class. You can see here we already defined the cube class with a direction in both x and y axis. Next we will write a code for movement of snake. For that, define move method. So to move a snake based on the user input, we will write a for loop with the event handling. For event in pygame dot event dot get, and then we'll check for the quit event also. If event dot type equals pygame dot quit, then it has to close the pygame window. Next, keys equals pygame.key.getPressed method. So this line of a code will get the list of members which represents the state of all the keys, and each element in the list is either 0 or 1. So to iterate through all the elements of the list, we are writing here for loop for key in keys. Now we will see how arrow keys is used in the snake movement. So here you can see if keys pygame.key left. This line to check if the left arrow key is pressed or not. If so, then we'll write self.direction x assigned to -1. So this will set the horizontal direction and indicating the movement to the left. Then self.direction y equals 0. So this line indicates that we are setting a vertical direction to 0, which means we are also ensuring a no vertical movement here. And the next line, self.turns self.h.positions is assigned to self.direction x-axis and self.direction y-axis. This line indicates the turns dictionary with the current position of a snake's head and also the new directions. This is used to handle turning points in the snake's movement. So we are writing 3 other form of codes for other 3 directions with the same logic. Next. Now let's write a code to ensure that the snake remains within the grid boundaries. So this part of a code handles a scenario when a current cube does not encounter the turning point. It also ensures that the snake remains within a grid boundaries. Okay. So after that, we'll write a else part. And the else part is to check whether if a snake is moving a left and has reached or crossed the left boundary, if that is true, it wraps up the snakes to the rightmost column. So for that, we are writing code as if c.direction equals to negative and c.position equals to positive or a lesser than 0, then it has to wrap up the rightmost or a leftmost depending upon the previous direction given. So I have written a same kind of a code for all other 3 directions. Okay, let's move forward. Suppose if you lost the game and want to restart the game on a point of time, we just have to reset all the stored values in it, right? So for this, we will write reset method. So here you can see define reset of self and position. After that, self.head equals cube of position. Here it will create a new head for a snake at a specified position, and then self.body. This line to indicate or to reset the snake's body to an empty list. And then we have self.body.append of self.head. This will add a newly created head to the snake's body list. And then we should also reset the turns which are stored in a previous game. For that, we have to write self.turns_of dictionary. This will reset the turns dictionary, which stores the turning points for the snake. And also it is important for handling the snake's movement direction. Now we are setting the initial direction of a snake move when the game begins. So we are assigning self.direction x-axis equals to 0 and y-axis equals to 1. Now we will write a code to increase the length of snake when snake consumes the food. For that, we'll define addCube method. Here we have defined addCube method and then tail equals self.body of -1. This will retrieve the snake's last cube of the snake's body, which represents the tail of snake. And then we have defined direction x-axis and y-axis equals tail.direction x-axis and tail.direction y-axis to retrieve the current direction of a tail's cube. Then we are checking the condition. If the snake is moving right, then adding new cube to the left of the tails. So for that we are checking the condition this and then we are adding tail. Following this, I have written the similar code for all other 3 directions. Now we will write a draw method in a snake's class, which is responsible for drawing the snake on the game surface. So for that, here we have defined a draw method and then for I, c in enumerate self.body, which indicates that to iterate over each cube in a snake's body using enumerate where I is a index and c is a current cube. And then if I equals 0, this will check if the current cube is a head of a snake or not. And then it will execute the else part. But here, if I equals to 0, if that is satisfied, this will call a draw method of a cube class to draw a head cube on a game surface and also passing a true value as an argument to indicate that eyes should be drawn in the cube. Then if the current cube is not a head, then it will go for else part. And here also it will call the draw method of a cube class to draw a body cubes. Next we will write a draw grid function which is responsible for drawing a grid on game surface. So for that, define draw grid with the width and rows and surface as a parameter. Then we have written size between equals w divided by rows, which means this will calculate the size of each grid square by dividing a width of the game surface by the number of rows. And then we assigned x equals 0 and y equals 0 to initialize the starting coordinates for drawing the grid. And to iterate through each row, we need for loop. So we have written for L in range of rows. Then we have to update the x and y coordinates for next horizontal and vertical lines in the grid. For that we have written x equals x plus size between and y equals y plus size between. After that, we will draw vertical and horizontal line using draw.line method. Next we have to write a code for redraw window. Basically, redraw window function draws the snake and food on the surface and also adds a grid clarity and then also shows the updated cubes. So for that, first we have to define the redraw window and passing a parameter with the surface. Then next, global rows width yes snack or a food we can say. Here we declared the variable rows width yes, which means snake, and snack as a global variables. And then we have surface.fill with the values, which fills the entire surface with a green color, and the numbers 0, 128 and 0 represents the RGB value for green color. Next, yes.draw, we are passing a surface as a parameter. So this calls a method draw on a snake to draw it on a surface again. And then we have snack.draw and passing the surface as a parameter. This calls a method draw on the food, which means snacks to draw it on a surface. Next we have draw grid and passing the parameter with the width, rows and surface. So here the grid is likely used for better visualization in a game. And finally we have pygame.display.update. This line of a code represents to update a display to show all the changes made on the surface, and this is necessary for the player to see the updated state of the game. Now we have to write a code to generate food randomly. So for that we are defining here random snack and passing a parameters with the rows and items. Then to get a body position of a snake, we are declaring a position as a variable equals item.body. And then to start an infinite loop to keep generating a random positions, for that we have written while true. And then we should also generate a random coordinates for both x and y coordinates. For that we have written a x equals and y equals random.randRange of rows. Then we have to check for the overlap. So we are checking a condition if length of list, filter lambda and the following code. This will help in checking if a generated position xy overlaps with any part of the snack. So we are using here filter. So using a filter and lambda to create a list of positions that match the generated coordinates. And then we are going to continue this. So here we have written continue to just check if there is an overlap, and continue is the next iteration to generate a new position, or else we have to break. And then finally it will return a valid position of x and y coordinate. Lastly, we have to define message box. This function is responsible for displaying a message box using tkinter message box module. Here we have written root equals tk.tk module. So which means this is necessary for creating a tkinter based GUI elements. And the next line will indicates that this will set the root window to be always on top of other windows, and also ensures that the message box will be visible if there are any other windows are open also. Then we have window.withdraw. So this withdraws the root window, and this is done to prevent the actual root window from being displayed. Following this we have message box.showInformation. So this is to display an information message box using a showInformation method from a tkinter message box module. And here we are passing subject and content as a parameter for the title and content of message box. Next we have written a try block to attempt to close the root window, and also we have written except and pass block. This is used to handle the case where if window is already closed. And finally the main functionality of code. So we have already written a main function. This function initializes the game related variables, create game objects and runs the main game loop, which also handles the user input, update the game state and also check for the collisions, and if collision occurs it displays a message box and reset the game. So here we have written global width, rows, yes and snack. This is nothing but we declared a variables as width, rows, yes and snake as a global variables, as we all know that global variables accessible throughout the program. And then we have assigned a values for width and rows as 520. And then we have created a variable win to display the dimensions as win equals pygame.display.setMode width. Here we have declared a yes variable to display or to assign the snake's color and starting position of the snake. Next we have written snack equals cube random snack of rows snake and color of with the yellow color values. With this we have created a cube of a snack with the yellow color at a random position that is not occupied by the snake. Then we have flag equals true to control the main game loop. And then what about time? So to control the time frame rate of a game, we are writing a code as clock equals pygame.time.clock module. And then we have written while flag. This starts a continuous loop that runs as long as the flag is true. And we will add a short delay time to control the speed of a game loop. Next, yes.move, which calls a move method of a snake and also handles user input and update the snake's position. Then we have written a if condition to check if the snake's head is at the same position as a snack, and if that is a true, it adds a new cube to the snake's body and making it longer. Then a snack is created at a random position, ensuring that it does not overlap with the snake and has a yellow color of cube. Then we have written a for loop to iterate through each segment of a snake's body and check if the position of a segment matches any position in the remaining body. If that matches, then it indicates a self-collision and prints the score or displays a loss message. Then begin with the resetting the snake's position, next exit the loop, and then finally the game window is redrawn. Let's execute this code once. Yes, you are able to see the Pygame window and the snake is moving horizontally from left to right. So we'll just play once.
The first question is, what are the common built-in data types in Python? The common built-in data types in Python are numbers, list, tuple, string, set, dictionary, and boolean. Coming to numbers, they include integers, floating point numbers, and complex number. List, an ordered sequence of items, is called a list. The elements of list may belong to different data types. Tuple, it is also an ordered sequence of elements. Unlike list, tuples are immutable, which means they can't be changed. String, a sequence of characters, is called a string. They are declared within a single or double quotes. Set, sets are a collection of unique items that are not in order. Dictionary, a dictionary stores value in key and value pairs, where each value can be accessed through its key. The order of items is not important in case of dictionary. Boolean, there are two Boolean values, true and false. Now, moving to our next question, what are the key features of Python? Python is an interpreted language. That means, unlike languages like C and its variants, Python does not need to be compiled before it's run. Other interpreted languages include PHP and Ruby. Python is dynamically typed, which means that you don't need to state the types of variables when you declare them or anything like that. Python is well suited to object-oriented programming, in that it allows the definition of classes along with composition and inheritance. Python does not have access specifiers like C++, public, private. In Python, functions are first-class objects. This means that they can be assigned to variables, returned from other functions, and passed into functions. Classes are also first-class objects in Python. Writing code in Python is fast, but running it can be slow compared to other languages that are compiled. Luckily, Python lets you use some parts written in C to speed up things where it is really important. A great example of this is NumPy, a tool that works quickly because it handles heavy math tasks outside of Python. Python finds use in many spheres: web application, automation, scientific modeling, big data applications, and many more. It is also often used as a glue code to get other languages and components to play nice. Moving to our third question. What are Lambda functions in Python? Lambda functions in Python are small anonymous functions that can have any number of arguments, but they can only have one expression. Think of them as tiny disposable functions that you create on the fly without giving them a name. Here is the basic syntax that you can see on the screen. For example, if you want a function that squares a number, you can create a Lambda functions like this. You can use square 5 to get the output as 25. Moving to our next question. Is Python a compiled language or an interpreted language? Python works in two ways, partly compiled and partly interpreted. When we run our code, Python first compiles it, creating something called bytecode. Then the Python virtual machine changes this bytecode to work properly on our computer and its operating system. Moving to our fifth question. What are Python namespaces? In Python, A namespace is like a label box where Python keeps track of names you give to the things you create, like variables and functions. There are 4 types. Built-in namespace holds all the default stuff in Python. Next is global namespace, where things you create in the main part of the program go. Third, enclosing namespace. If you have functions inside other functions, the inner functions can access the outer function stuff. Fourth one is local namespace. Inside a function, Python creates a separate box for its stuff. Think of namespaces as organized boxes, where Python stores your stuff based on where you create it. It helps Python keep track of everything you have made. Moving to our 6th question. What are local variables and global variables in Python? Moving to global variables, variables declared outside a function or in a global space are called global variables. These variables can be accessed by any function in the program. For example, you can check this code. This code initializes a global variable x to 0, then uses a function increment to increase its value by 1. By employing the global keyword, increment modifies the global x, ensuring it affects the variable globally. The program first prints x as 0, then calls increment, and then prints the updated value of x as 1, demonstrating how a global variable can be modified and accessed throughout a program. Coming to local variables, any variable declared inside a function is known as local variable. This variable is present in the local space and not in the global space. For example, you can check this code. In this example, the local count is a local variable defined within the showCount function. Each time showCount is called, local count is initialized to 0, incremented by 1, and its value is printed. The local variable scope is limited to the function in which it is defined, so it gets reinitialized with each function call, demonstrating how local variables maintain their scope and are not preserved across function calls. Moving to 7th question. What is self in Python? Self represents an instance or object of a class. In Python, it is explicitly included as the first parameter, but in Java, it's optional. It serves to distinguish between a class methods and attributes from local variables. In the init method, self points to the newly created object, while in other methods, it points to the object that called the method. Moving to our next question, how are arguments passed? By value or by reference in Python? In Python, arguments are passed to functions by assignment, which is often described as pass by object reference or pass by sharing. This means that the function receives a reference to the actual object, not a copy of the object. If the object is mutable, changes made within the function can affect the original object. However, if the object is immutable, it cannot be changed within the function. Any attempt to modify it will result in the creation of a new object, leaving the original unchanged. Moving to our 9th question. What is a pass in Python? To pass signifies executing no action or serving as a placeholder within a compound statement. It essentially indicates a blank space where no specific action is required or written. You can check this code. In this code, the do nothing function uses the pass statement as a placeholder, indicating that no action is taken when the function is called. The pass statement is useful in scenarios where a statement is syntactically required but you don't want any command or code to execute, effectively serving as a do nothing operation. Moving to our 10th question. What is a dynamically typed language? Dynamically typed languages are languages that do not require any predefined data type for any variable as it is interpreted at runtime by the machine itself. In these languages, interpreters assign the data type to a variable at runtime depending on its value. Moving to our 11th question. What is PEP8? PEP stands for Python Enhancement Proposal. It is a set of rules that specify how to format Python code for maximum readability. Moving to our next question. What is Python path? It is an environment variable that is used when a module is imported. Whenever a module is imported, Python path is also looked up to check for the presence of the imported modules in the various directories. The interpreter uses it to determine which module to load. Moving to the next question. What are Python modules? Name some commonly used built-in modules in Python. Python modules are files containing the Python code. This code can either be a function class or variables. A Python module is a .py file containing executable code. Some of the commonly used built-in modules are OS, sys, math, random, datetime, and JSON. Moving to next question. What is break and continue in Python? The break statement is used to exit the loop prematurely when a certain condition is met. The continue statement is used to skip the current iteration of the loop and continue with the next iteration. You can check this example. In the first loop, when I equals 3, the break statement is encountered and the loop exits. In the second loop, when I equals 2, the continue statement is encountered and the loop proceeds to the next iteration without executing the print statement for 2. Moving to the 15th question. Can we pass a function as an argument in Python? Yes, in Python, you can pass a function as an argument to another function. This is possible because functions in Python are first-class objects, meaning they can be treated by any other object such as an integer, string, or list. You can assign them to variables, store them in data structures, and yes, pass them as arguments to other functions. Check this piece of code. In this example, shout and whisper are functions that are passed as arguments to the greet function. The greet function then calls the passed-in function with a name argument, demonstrating how functions can be dynamically passed around and invoked within Python. Now, moving to our 16th question, what does hash symbol do in Python? Hash is used to comment on everything that comes after on the line. Hash symbol in Python is used to denote comments. For example, hash, this is a single line comment in Python. This line is not being executed when the Python runs the code. Moving to our 17th question. What is type conversion in Python? Type conversion refers to the conversion of one data type into another. Int converts any data type into integer type. Float converts any data type into float type. ORD converts characters into integers. Hex converts integers into hexadecimals. Oct converts integers into octal. Tuple, this function is used to convert to a tuple. Set, this function returns the type after converting to set. List, this function is used to convert any data type to a list type. Dict, any function is used to convert a tuple of order key value into a dictionary. Str, it is used to convert integer into a string. Moving to the next question. What is docstring in Python? In Python, a docstring is a string literal that occurs as the first statement in a module function, class, or method definition. Its purpose is to provide documentation about the object such as its purpose, usage, parameters, return values, and other relevant information. Docstrings are typically enclosed in triple quotes and can span multiple lines. They serve as a form of inline documentation and are accessible throughout the object's doc attribute. Docstrings are essential for code readability, maintainability, and understanding as they help developers and users to understand how to use and interact with the code effectively. Moving to the 19th question, what is slicing in Python? Slicing is used to access parts of sequences like tuples and strings. The syntax of slicing you can see on the screen. It's start, end, step. This step can be omitted as well when we write start, end. This returns all the elements of the sequence from the start inclusive till the end minus one element. If the start or end element is negative I, it means that the ith element is from the end. The step indicates the jump or how many elements have to be skipped. Moving to the 20th question. What is pickling and unpickling? The pickle module accepts any Python object, converts it into a string representation, and dumps it into a file by using the dump function. This process is called pickling. The process of retrieving original Python objects from the stored string representation is called unpickling. Now, let's move to the intermediate level questions. Explain inheritance in Python. Inheritance allows one class to gain all the members, say attributes and methods of another class. Inheritance provides code reusability and makes it easier to create and maintain an application. The class from which we are inheriting is called a superclass, and the class which is being inherited is called the subclass or child class, or it is also known as a derived class. There are 4 different types of inheritance supported by Python: single inheritance, multi-level inheritance, hierarchical inheritance, and multiple inheritance. when it comes to single inheritance, where a derived class acquires the member of a single superclass. Multi-level inheritance. A derived class C is inherited from base class B, which is derived from class A. Hierarchical inheritance. From one base class, you can inherit any number of child classes. Coming to multiple inheritance, a derived class is inherited from more than one base class. Does Python make use of access specifiers? Python does have mechanism for controlling access to attributes and methods of objects, but it does not have explicit access specifiers like some other programming languages such as Java or C++. In Python, attributes and methods can be accessed freely from outside the class definition unless you explicitly make them private. Conventionally, attributes or methods that start with a single underscore are considered to be protective, meaning they should be accessed only within the class or by subclass. Attribute or methods that start with double underscore are considered private and are name mangled, meaning the names are changed to include the class name, making them harder to access from outside the class. Discuss different ways of deleting an element from a list. There are two ways in which we can delete elements from the list. One is the remove function and one by using the pop function. Let's check the remove function first. The remove function deletes the mentioned element from the list. The pop function deletes the element mentioned at specific index from the list. How are classes created in Python? In Python, classes are created using the class keyword, followed by the class name and a colon. Inside the class, methods and attributes can be defined. The init method is a special method called a constructor used for initializing newly created objects. Here is a basic example. In this example, my class has two attributes, attribute 1 and attribute 2, and one method as my method. The self parameter is a reference to the current instance of the class and is used to access variables and methods associated with the current object. Moving to the next question. Write a program in Python to execute the bubble sort algorithm. Bubble sort is a straightforward sorting algorithm that repeatedly steps through the list, compares adjacent elements, and swaps them if they are in wrong order. The pass through the list is repeated until the list is sorted. Although it is not the most efficient algorithm for the large data sets, it's a classic example for learning sorting algorithms. Let's check this example to understand bubble sort. We have a list of numbers. Here in iteration 1, first the sorting will compare 11 and 7. We can see that 11 is larger than 7, so a swapping of the positions are being done. Similarly, the bubble will move forward and it will compare 9 and 15. Since 9 is already smaller than 15, there will be no change. And similarly, the process will go on. After that, for the iteration 2, we have 11, 7, 9, 15, 23, 21 and 26. Again, the same process will continue. The number of iterations will take place until we have a fully sorted list. Over here, you can check the code for bubble sorting. The program first defines a bubble sort function that takes a list array as its parameter. It then uses two nested loops to traverse the list and compare each pair of adjacent elements. If a pair is in wrong order, either the first is greater than the second, the elements are swapped. This process repeats until the entire list is sorted. Finally, the program demonstrates using the bubble sort function with an example list of integers and print the sorted list. Write a code snippet to generate the square of every element in a list. If you want to generate the square of every element in a list, you can use list comprehension in Python, which is a concise way to create list. Here's the simple code snippet to achieve that. The code takes each number in the numbers list, squares it, and then the squared value are collected into a new list called squared number. When you run the code, it will give the output as 1, 4, 9, 16 and 25. Moving to the next question, write a program to produce the Fibonacci series in Python. The Fibonacci series is a sequence of numbers where each number is the sum of the two preceding ones, usually starting with 0 and 1. Here is the code, and let's understand how it works. We first start with the first two Fibonacci numbers, which are 0 and 1. Then, in each iteration, starting from the third term, we calculate the next Fibonacci number by adding the last two numbers in the series. We append the new calculated Fibonacci number to the list. We repeat this process until we have generated n terms in the Fibonacci series. Finally, the program takes user input for the number of terms and prints the Fibonacci series up to the number of terms. What is the difference between a shallow copy and a deep copy? The difference between shallow copy and deep copy is primarily about how they handle these nested objects. A shallow copy creates a new object, but instead of copying the nested object, it just copies the references to them. This means that the original and the copy will share the same nested objects. Changes to the nested object in the copied object will affect the original object and vice versa. However, changes to the container object will not affect the other. You can create a shallow copy of an object by using the copy method. A deep copy creates a new object and recursively copies all the objects it contains. Unlike a shallow copy, the copy and the original do not share any nested objects. Changes made to any level of the copied object will not affect the original object and vice versa. You can create a deep copy of an object using the copy module's deep copy function. Write a program in Python to check if a sequence is a palindrome. A palindrome is a sequence of characters which reads the same backward as forward. Examples of palindrome include words like radar or level, or numbers like 12321, or sequences of characters that form the same sequence in reverse. To determine if a sequence is a palindrome in Python, we can write a function that compares the sequence to its reverse. If the sequence matches its reverse, then it's a palindrome. This program defines a function isPalindrome that takes a sequence as input and returns true if the sequence is a palindrome and false otherwise. It works by first converting the sequence into a list to ensure the reverse operation works uniformly across different types of sequences like strings and tuples. Then it compares the original list with its reversed version to determine if the sequence is a palindrome. Moving to our next question. How is multithreading achieved in Python? Multithreading allows different parts of program to run simultaneously, making the program faster and more responsive. Multithreading in Python is achieved using the threading module, which provides a way to create and manage threads. Threads are smaller units of execution that runs concurrently within a process. Python's threading module allows you to create multiple threads, each performing different tasks simultaneously. Here is a simple example demonstrating the usage of multithreading in Python. In this example, we create a subclass, myThread, of threading.thread and override its run method with the code we want to thread to execute. We create two instances of myThread, start them and wait for them to complete using the join method. Meanwhile, the main thread continues to execute. This program will output the message from both the threads concurrently. How is memory managed in Python? Python utilizes a private heap space to store all objects, with the Python memory manager overseeing different aspects of this heap, including sharing, caching, segmentation, and allocation. Control over the heap remains solely within the Python interpreter, leaving users with no direct access or influence over its operation. Whenever Python exits, why isn't all the memory deallocated? Python does deallocate most memory upon process exit. But there are scenarios where memory may not be immediately reclaimed due to the factors such as garbage collection overhead, external resource management, and memory leaks. However, from the perspective of the operating system, all memory and resources allocated by the Python process are eventually reclaimed when the process exits. Now, if you want to know more about garbage collection overhead, external resource management, and memory leaks, then you can refer our Python programming certification course, the link to which is in the description box below. Which is faster, Python list or NumPy arrays, and why? NumPy arrays are faster than Python list for numerical operations. NumPy, an open source library designed for array manipulation in Python, furnishes efficient functions for numerical computations on arrays. The swiftness of NumPy arises from its implementation in C, which facilitates quicker executions compared to Python list. Python list, being implemented in Python, an interpreted language, lack the speed advantage of NumPy arrays operations, which is executed in a compiled language. What is the process of compilation and linking in Python? In Python, compilation and linking process are somewhat abstracted from the developer due to the nature of the language being interpreted rather than compiled. However, there are still compilations and linking processes that occur behind the scenes when working with Python modules, especially those containing C extensions or when used external libraries. Coming to compilation, for pure Python code, there is no separate compilation step. Python code is compiled to bytecode by the Python interpreter when it is executed. However, when using Python modules containing C extensions, there is a compilation step involved. These C extensions need to be compiled into machine code that can be executed by the computer's processor. Compilation of C extensions is typically handled using a compiler such as GCC on Unix-like systems or MSVC on Windows. Moving on to linking, after the compilation of C extensions, the resulting object files need to be linked together to form executable files or shared libraries. During the linking process, references between different object files are resolved and necessary libraries are linked to the final executable or library. Linking is handled by the linker, such as ID on Unix-like systems and link.exe on Windows. How to add new column to Pandas data frame? Adding new column to Pandas data frame is being demonstrated in the following code. The code imports the Pandas library to create a data frame from the dictionary that maps first and second to the Pandas series with specified indices, resulting in different lengths and NN for missing values. It then adds a third column to DF using a new series with values 10, 20, 30 indexed by A, B, C. The attempt to add a fourth column aims to the sum of the first and the anonymous reference into third, which would sum values from the first and third columns. The code imports the Pandas library and creates a data frame from the dictionary data info that maps the first and second to Pandas series with specified indices, resulting in different lengths and NN for missing values. It then adds a third column to DF using a new series with values 10, 20, 30 indexed by A, B, C. The attempt to add a fourth column aims to the sum of the first and an anonymously referenced info third, which would sum values from the first and third columns. The code concludes by printing df after each column addition, demonstrating how to dynamically expand a data frame. Now, let's finally move to the advanced level interview questions. And here it comes, the first question from advanced level. Write a code to sort an array in NumPy by the n-1th column. You can sort a NumPy array by the n-1th column using the numpy.arg sort function to obtain the indices that would sort the array along the specified axis. Here is how you can do it. The column will output the original array and the sorted array based on the n-1th column. Firstly, it selects the last column of the array. Then, it returns the indices that would sort the last column of the array. ARR sorted indices uses the sorted indices to rearrange the rows of an array based on the sorting from the n-1th column. How do you compute the Euclidean distance between two series? To compute the Euclidean distance between two series in Python, you can use the scipy.spatial.distance module, and here is how you can do it. In this code, we import NumPy as NP and the Euclidean function from the scipy.spatial.distance. We define two sample series, series 1 and series 2 as NumPy arrays. We use the Euclidean function to compute the Euclidean distance between series 1 and series 2. Finally, we print the computed Euclidean distance between the two series. How do you get the items not common to both series A and series B? To get the items that are not common in both Pandas series A and B, you can use the pandas.series.isn't method combined with Boolean indexing. This method allows you to filter out the items present in one series but not in other. You can then concatenate the unique elements from both series to get the full list of items that are not common to both. Here is how you can do it. The script performs the following step. Firstly, it uses a.isInB to find elements in A that are not in B, and vice versa for b.isIn A. It then concatenates the result not in B and not in A into a single series containing all unique items not common to both original series. Finally, it prints out the concatenated series containing the items that are not common to both A and B. The result will be a series containing all the items that are unique to each series, effectively showing the items not common to both A and B. What is Flask, and explain its benefits? Flask is a micro web framework written in Python. It is classified as micro because it is lightweight and requires minimal setup to get a simple application up and running. But it is also extensible enough to support complex applications as well. Flask provides the tools, libraries, and technologies necessary to build a web application. This framework allows you to build web applications rapidly with minimum lines of code. It is a modular and flexible design, making it adaptable for developers to tailor their applications with the required components. Coming to the benefits, Firstly, it comes simplicity. Flask, straightforward and easy to understand syntax makes it accessible for beginners. The framework is easy to set up and get started with, which is ideal for small projects or when learning web development basics. Then it comes to flexibility. Unlike more comprehensive framework that dictates specific ways to achieve tasks, Flask is unopinionated about how the thing should be done. This flexibility allows developers to use the components they prefer and structure the application in the way that works best for them. Third one is lightweight. Flask does not automatically include tools and libraries that your project may not need, making it very lightweight and efficient. Its simplicity and lack of overhead make it a performant for many types of objects. Then it comes to extensibility. While Flask is minimalistic out of the box, it can be easily extended with a wide variety of extensions available for tasks such as validation, user authentication, database integration, and more. This means you can start simple and add more functionality as needed. Lastly, it comes to the robust ecosystem. Despite its simplicity, Flask is supported by a large and active community. There are numerous extensions and packages available that can help to add functionality to Flask applications quickly. Is Django better than Flask? Django and Flask both serve to translate URLs or web addresses inputted into browser into Python functions. Flask offers a more user-friendly experience than Django, but it requires you to define more details yourself, as it provides less out-of-box functionality. On the other hand, Django automates many aspects of web development, reducing the need for manual configuration. Django comes with pre-existing code that users need to understand, while Flask gives users the flexibility to write their own code, potentially making it simpler to learn. Each framework excels technically and comes up with its unique strengths and weaknesses. What is the use of sessions in Django framework? In Django framework, sessions are used to persist information across user requests, enabling the server to remember data about a user's activity and preferences. The mechanism is crucial for functionalities like user authentication, where sessions keep users logged in as they navigate different parts of the web application. Sessions also store user preferences or shopping cart contents, enhancing the user experience without compromising security, as the data is stored server-side. Django simplifies session management by providing a secure and customizable system that can use various backends to store session data, making it a powerful tool for developers to maintain the state and user-specific data efficiently. Write a one-liner that will count the numbers of capital letters in a file. Your code should work even if the file is too big to fit in the memory. So first, let us check how normally the code would look like. In this code, we open the file file.txt in read mode. We iterate through each line in the file using a for loop. For each line, we iterate through each character using another for loop. We check if each character is uppercase using the isUpper method. If a character is uppercase, we increment the count variable by 1. Finally, we print the total count of capital letters in the file. Now, the equivalent one-liner. This one-liner does the same thing as the previous code, but is written in a condensed form using list comprehension and the sum function. It iterates over each line and the character in the file, checks if the character is uppercase, and sums up the count for the uppercase. Discuss Django architecture. Django follows a model view template architecture, which organizes web applications into 3 main layers: model, view, and template. The model layer represents the application's data structure and interacts with the database using Django's object relational mapping, which is also called as ORM. Model defines the data schema, including fields, relationships, and behavior, allowing developers to work with database records as Python objects. The view layer handles the application's business logic and user interaction. Views receive HTTP requests, process data from the model layer, and generate HTTP responses. They encapsulate application logic, handling tasks such as data retrieval, processing, and rendering. Views interact with the model layer to retrieve or modify data and use templates to render dynamic HTML content for the user. The template layer manages the presentation of the data to the user. Templates are HTML files with embedded template tags and filters that generate dynamic content based on the data passed from the viewer layer. Django's template engine supports template inheritance, reusable templates, and powerful template tags for processing data and rendering HTML output. List out the inheritance styles in Django. In Django, there are three main ways models can inherit from each other. The first one is abstract-based classes, the second one is multi-table inheritance, and the third one is proxy models. Coming to abstract-based classes, think of abstract-based classes as templates for other models. They don't create their own tables in the database. Instead, they are like blueprints that other models can use. You mark a model as abstract by setting a special attribute to true in the model's meta class. Coming to multi-table inheritance is when you create a new model that is based on the existing one, and each new model gets its own table in the database. Django makes separate tables for each new model, and these tables are linked together. This type of inheritance lets you add more features to an existing model without changing it directly. To use multi-table inheritance, you just make a new model class that is based on the existing one. Coming to proxy models are like shadows of existing models. They have the same fields and methods, but you can change how they work in Python without affecting the database. They don't create new tables, they just act as alternative views of the original data. Proxy models are handy for adding extra functionality or organizing code without changing the original database structure. You can create a proxy model by setting a special attribute to true in the model's meta class. These different ways of inheritance gives you flexibility in how you organize your models and customize their behavior in Django. Each one has its own purpose and advantages, depending on what you're trying to do with your models. Create a program to add two integers greater than 0 without using the plus operator. You can add two integers without using the plus operator by using bitwise operations. Here is a Python program to add two positive integers without using the plus operator. This program defines a function add without plus that takes two integers a and b as input and returns their sum without using the plus operator. It uses bitwise operations such as AND, XOR, and left shift to perform addition bit by bit. The program prompts the user to enter two positive integers and then displays their sum. How to save an image locally using Python, whose URL address I already know. To save an image from website using Python, you need to know the web addresses of the image. With Python, you can use a library called request to download the image from the internet. Then you can store it on your computer, and here is how you can do it. We use the request library to fetch the image from the web addresses you provide. If the image is successfully downloaded, that is status code 200, it gets saved to your computer with the name you choose. If there is any problem with the download or saving process, the program will let you know. You are required to scrap data from IMDb top 250 movie pages. It should only have fields, movie name, year, and rating. To gather information from IMDb's top 250 movie page, you will need Python and some tools like Request and Beautiful Soup, and here is how you do it. We import the necessary libraries, Request for getting web data and Beautiful Soup for sorting through HTML. We define a function scrape IMDb top 250 to fetch IMDb's top 250 movie pages. Pick out the movie names, years, and ratings and return them as a list of dictionaries. Inside the function, we use request to get the IMDb page and Beautiful Soup to handle the HTML content. We loop through the table rows on the page, extracting movie details from the appropriate cells. We remove any extra spaces and formatting from the extracted data and store it in the dictionaries. Finally, we call the function to get the data and print out the movie titles, years, and ratings. How to send an email in Python language. Sending an email in Python can be done using the built-in SMPTlib library for SMTP, which is Simple Mail Transfer Protocol, and email library for composing and formatting email messages. Here is a basic example how to send an email in Python. Firstly, we imported SMTPlib and relevant classes from email.my module. Set up the sender's email addresses, receiver email address, and email password. Then we created a MIME multipart object to compose the email message. Set the sender, receiver, and subject of the email. We created the body of the email messages and attached it to the MIME multipart object. Then we connected to the SMTP server. Log in to the sender's email using SMTP authentication. Then we send the email using sendMail method of SMTP server object. Then it handles exceptions and closes the connection to the SMTP server using the quit method. Create a program to convert dates from year, month, day to day, month, year. You can achieve this conversion using the datetime module in the Python. Here's a program to convert dates from the format year, month, day to day, month, year. We define a function convertDate that takes a date string in year, month, day format as input. Inside the function, we use datetime strptime to pass the input string into a datetime object, specifying the input format. Then we use strftime to format the datetime object into a string with the desired format. We handle the case where the input string is not in the correct format by using try-except block. Finally, we test the function by taking user input for a date string and printing the converted date. How you can get the Google cache age of any URL or web page. To find out how old a web page is in Google Cache using Python, you can send a special request to Google Cache server. And here is a simple way to do it. We create a function called getGoogleCacheAge to find out the age of a web page in Google's cache. We send a special request to Google Cache URL for the web page we are interested in. We analyze the response from Google to extract the age of the cached web page. If everything goes well, we return the cache age, otherwise we show an error message. Finally, we set the function by asking up for a web page URL and printing out the cache age information.
And with this, we have come to an end to this full course on Python. If you enjoyed listening to this full course, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists, and subscribe to Edureka's YouTube channel to learn more. Thank you for watching and happy learning.